So let's see the introduction to artificial intelligence, AI, machine learning, deep learning, and generative AI. So the buzzing term right now in any industry, be it healthcare or finance or retail or manufacturing or technical or any non-technical domain, it is AI. So everywhere we have been hearing the term AI, artificial intelligence. So AI is a broad term, so everything together is called artificial intelligence. So what is artificial intelligence? In layman terms, artificial intelligence means trying to mimic humans. So as humans we have intelligence. So how do we mimic humans? For example, let's say you have a kid and you want to teach the kid fruit names. So how do we teach the kid to learn a fruit name? We will teach the kid by showing an apple or orange and teach that the fruit name is apple or orange, and we will also teach the color of apple is red or color of orange is orange color, right? So when we repeatedly train or teach the same thing to the kid, it registers in their brain. And we know the human brain has neurons, right? So when we show the similar image of the fruit, either apple or orange, to the kid multiple times, their brain finds the image pattern, that is neurons in the brain understands the shape or color of apple or orange. So this process is called training. That is, you are showing multiple fruit images to the kid as input and teaching them the output. So that is the label. The label is the output. That is the color of the fruit or shape of the fruit. So input is apple or orange image and the output is either color of the fruit or the shape of the fruit. So once the kid is trained, the kid understands the pattern. So similarly, the machine learning model understands the pattern when we train the model with enormous amounts of data. That is, the data could be gigabytes or petabytes of data. So once the model is trained, then we will give a completely new image and the model will be able to predict the features of the image, just like how a kid can identify the fruit image. So artificial intelligence AI is nothing but mimicking a human. So can we understand how the human brain is working, and can we train a machine or model with the same information so that a model can do the same thing that a human can do? But how can we train a model? By using mathematics. It's all pattern finding. Therefore, AI means pattern finding. That is either from the structured data, that is your tabular data, or unstructured data. Unstructured data means either text or image or audio or video data, and the intent is to be able to identify the pattern. So the objective of artificial intelligence AI is to understand the patterns from the data, similar to how our brain is working. So that is the objective of AI. So if you notice here, inside artificial intelligence AI we have machine learning, ML, and inside machine learning we have deep learning, DL, and inside deep learning we have generative AI. So generative AI is one of the subject in deep learning. So this is where we will try to spend majority of our time and try to understand what is generative AI and what are these large language models inside this generative AI. So artificial intelligence has information retrieval, IR, machine learning or NLP, natural language processing, CV, computer vision, soft computing, fuzzy logic, etc. So artificial intelligence contains several topics inside it. Now let's see how do we train a model, right? How can we give intelligence to model, machine learning? So how can we give the intelligence to these machines, like logical thinking or mathematical calculations or strategic decision making, etc., right? So that is the whole objective of machine learning. So we need to be able to train a model. So how can we train a model? So first thing is we need to collect the data, right? So first data collection, and the next thing is clean the data. So that is clean all the garbage data, and then feature engineering, that is build the model and then train the model, and then evaluation, that is validate or test the model, and then deploy the model, and then monitor. So this is the complete life cycle of a machine learning model. And majority of the time we spend on data collection, cleaning, or model training, and validation, that is evaluation or deployment. These shouldn't take much time, and iteratively we will do all these tasks until the model predicts accurate results, that is until the model finds the patterns. And we have big companies like Google, Microsoft, Meta, right? So these companies, they automated this entire process. They have collected all the publicly available data present on the internet, be it Wikipedia data or from books or any public data that is available on the internet. They have collected the data, they cleaned the data, they trained the model and provided us with a pre-trained model. For example, we have ChatGPT, Gemini, Olama, Grok, etc. So we have different pre-trained models already available, and all the problems that we can solve using artificial intelligence are divided into three types. So these are different types of machine learning algorithms. We have supervised learning, unsupervised learning, and also semi-supervised learning. So what is supervised learning? This one uses labeled datasets where the input and the corresponding output or target are known. So we already know what is input, what is output. And in case of unsupervised learning, this one uses unlabeled datasets where the input data is provided without any corresponding output or target. And the third one is semi-supervised. So this uses the combination of both labeled and unlabeled data. So what is supervised learning, right? So supervised learning is exact replica of our human brain. That is like how human thinks, right? For example, when we were born, right, we didn't know anything. Like we don't know who our mom or dad or anything else, right? But someone has taught you and eventually we learned it. We learn through examples, right? For example, face recognitions. You have seen your mom or dad multiple times. So as a kid, we were able to understand who our mom or dad is and we were able to recognize them. So to identify a person or face recognition, you need a kid to identify the people. For that, you need to provide the input as an image of that person, and the output is nothing but the person name, that is either your mom or dad. And you need to train with multiple images. For example, mom having a long hair or short hair, or mom with specs or without specs, or with mask or without mask, or with different color dresses, right? So the images are not constant, right? The image has different variation. But the kid will eventually understand who is mom or who is dad, right? So deep learning means you need to train with a lot of data, that is either gigabytes or terabytes or petabytes of data, right? So this is called supervised learning. So we are training the model with both input, that is X, and output, that is Y. So the model will try to understand the relationship between X and Y, that is input and output. So this is called pattern finding, right? Once the model is trained with huge amounts of data, and once the model understands the pattern, that is the relationship between X and Y, then given X with any new data, right, the model will be able to predict Y. So given X, predict Y. This is nothing but supervised learning. And the objective of supervised learning is given X, predict Y. And how the model can identify, right? Because we are training the model with huge amounts of data. If this is X, then this is Y. This is X, then this is Y. So eventually the model will understand the pattern or relationship between X and Y, and whenever we give a new X, it will predict Y. So which is nothing but a pattern finding between input and output. So training the model means give a lot of examples so the model will understand the pattern between input and output. So this is called pattern finding. So this is the whole story of deep learning. And the next one is generative AI, generative artificial intelligence. So this is a subsection of deep learning, as you can see in the diagram. So generative AI is nothing but a pre-trained model. meaning this pre-trained model has some generic intelligence because the model has been trained with publicly available data. And the objective of generative AI is generating. That is, the model can generate either text or video or images or audio, right? So inside generative AI, we have large language model LLM, right? So we have models that generate either text or models that can generate vision, that is images, or we also have multimodal, means both image and text. So by using these pre-trained large language models, we can perform generic tasks like text to audio conversion or sentiment analysis or conversion from one language to another. All these tasks can be performed by using these pre-trained large language models. And these large language models can be either open source or paid models. If it is a paid model, then we need to make an API call to use the model. Whereas if it is an open source, then you can download the model to your machine and use it. So these models are like plug and play, that is model as a service. So before these pre-trained models were released, to build a model from scratch, it used to take a lot of time. But with the pre-trained model, the task can be done easily. For example, if you want to build a chatbot for a domain-specific project, instead of you building from scratch, take this pre-trained available model, give your domain-specific data as input, right? Which is nothing but fine-tuning or RAG, retrieval augmented generation. We will talk about RAG in detail in the coming lessons because the model is already pre-trained, so the model already has some generic intelligence and you are fine-tuning with your domain-specific data, so the model will eventually be able to accurately predict the results, right? And when it comes to open source pre-trained models, we have Olama, that is the most famous, and there are like 10 lakh open source models already available in Hugging Face, and we have a separate lesson for Hugging Face. I will talk more about it in the coming lectures. And we also have paid pre-trained models, right? For example, ChatGPT or Claude, Anthropic, etc., right? So you do not have to build the model from scratch. The real challenge in real time is if the model will not be able to predict the accurate results, that is called hallucination, even after training the model with your domain specific data. That is why you need to be able to debug the model or improve the model, right? So that's the real challenge in real time. And the data that we will be training a model can be of three types. We have structured data, semi-structured data, unstructured data. So structured data means it can be your tabular data, that is RDBMS data. We mostly use either machine learning or deep learning when the data is structured data. And for semi-structured data, for example, CSV files, XML or Excel, JSON files, etc. For semi-structured data also, we mostly use either machine learning or deep learning. And for unstructured data, for example, images, audio, videos are nothing but frames, right? So frames are nothing but images or text, etc. And for unstructured data, we mostly use generative AI models, which internally uses deep learning. That is, these are pre-trained models. So machines can identify only when the data has any pattern. If the data is random, the model will not be able to identify the pattern. So this data plays a crucial role when training a model, right? So after feeding so many images to a model, it will be able to eventually identify the pattern, and this entire process can be automated using generative AI. So they have automated this process. They've collected the data, they cleaned the data, they built the model, they trained the model, evaluated and deployed, and these are nothing but large language models. These are pre-trained models. So generative AI uses transformers or GAN, that is generative adversarial network, VAE, variational autoencoder algorithms. We will discuss the architecture behind these large language models in the coming lectures. But with this, I hope you got a decent understanding on the terms like AI, artificial intelligence, ML, machine learning, DL, deep learning, generative AI, or LLM, large language models. So we will deep dive in the coming lectures. Alright, thank you. So in this lecture, let's see a brief history of artificial intelligence with deep learning. So if you notice here, you can see perceptron is not new, right? So it was there in 1957 itself, but you can see from 2010 onwards, there is an exponential growth, and we solved a problem called vanishing gradient descent. That is when the deep learning became so popular around this time, and transformer was introduced by Google in 2017. So that's when the growth started exponentially, because without transformer there is nothing. So using transformers, they started creating these small language models or large language models like these GPTs, right? So that is the brief history of AI. So you can see the growth from the birth of AI to the perceptron and CNN, convolutional neural network, and GAN networks, transformers, and chat GPTs, right? So this is the brief history of artificial intelligence, and we will discuss the architecture behind these large language models, that is transformer, in detail in the coming lectures. All right, thank you. In this lecture, let's talk about transformer architecture. Like I said in previous lectures, we already have a lot of pre-trained models and you do not need to build anything from scratch, right? But knowing the transformer architecture will help you build any model from scratch in case if you need to build, or it can help you to understand how the pre-trained model works, right? So why are we learning transformer? So if you notice in this diagram, AI, artificial intelligence, this is the broad term. So the objective of artificial intelligence is to find patterns from the given data. So we are trying to make the machine so intelligent that it can behave like a human. So how do we achieve that? How do we give intelligence to a machine? So to achieve this, we have machine learning, deep learning, NLP, natural language processing, generative models, right? So we have different mechanisms available to make the machine intelligent like a human. And the objective of generative models is to generate something, as the name suggests. We use generative models mostly on the unstructured data. The model can generate either text or image, or text or image, right? That's a multimodal combination. So the main algorithms inside these generative models are VAE, that is variational autoencoder, and the second one is GAN networks, that is generative adversarial network, and the third one is transformer, right? Those are the architectures behind these large language models. So why are we learning transformer, right? So we will know how these large language models are built and the architecture behind these LLM, that is GPTs or any other pre-trained models, right? In generative models, 90% of the models are built on top of the transformer architecture, right? And I also want to clarify here, not all the models are built using transformer architecture, right? For example, deepfake video generation is built on top of GAN network. But majority of the generative AI models are built on top of the transformer architecture. So that is why we are trying to understand transformer architecture, so you can understand how these large language models work internally, right? And in 2017, Google released a paper and the architecture was very well explained. And before that, Google released a model called BERT. BERT is bidirectional encoder representations from transformers. And this was the old model. But as you know, we have GPT-1, GPT-2, GPT-3, GPT-4. All these GPTs, they are built on top of transformer architecture. So transformer is a part of generative models, which is part of neural networks, and which is part of machine learning, and which is part of artificial intelligence. Now let's see what is a transformer. And you can see here, this is the architecture of the transformer, and we are learning both encoder and decoder. but GPT is only decoder. Some models are only encoder based and some models are only decoder based. For example, BERT, right? BERT is only encoder based model, whereas GPT is generative pre-trained transformer. GPT is decoder based model. But let's learn both encoder and decoder model so you will understand the entire transformer architecture. So first let's start with encoder and then we will move on to decoder, right? So this is the encoder piece, and as I said, BERT is encoder model. Assume you are using BERT model as it is an encoder based model, that is a transformer based language model, and BERT uses a vocabulary of 30,522 tokens. These are unique tokens or words, and they achieved through word piece tokenization, which breaks words into subword units. But these 30,522 unique tokens or words are the most common English words. So as I said, these are only the most common words. We may have happiness in the list, but the model is intelligent enough to understand the opposite word of happiness is unhappiness. Even if unhappiness is not present in this 30,522 tokens, the model is intelligent enough to understand the opposite word of happiness is unhappiness, right? And as you can see in the diagram, the first thing that we are doing here is we are providing an input to the model. Here in our example, we are considering BERT model, which has a vocabulary of 30,522 unique words or tokens, right? So first we are providing the input, and this input will be converted to input embeddings, right? So assume this is the input to the transformer. We are giving this is a generative AI course. So assume this is the input sequence that we are providing to our BERT model, and then this is just one sentence, but in real time we may have several sentences as well, right? I just took only one sentence as an example so we can understand the architecture behind the transformer, okay? So once we provide this input to the model, then the next step is tokenization, right? So that is, it will convert the input into tokens. So our input is, this is a generative AI course, and it will convert into tokens, that is, this is a generative AI course, right? We have 6 tokens, and once the tokenization is done, the next step is token IDs. So we are trying to represent each token with a token ID. This token ID is nothing but the position of the word or token in the entire vocabulary of 30,522 unique words, right? For example, let's consider the word this, right? So this may be present in the entire 30,522 unique words list, somewhere maybe in the 10th word or 100th word or 1000th word, right? Somewhere there will be, somewhere this word will be present. So assume the word this is present somewhere here, 2222. Okay, this is just an example. So assume these are the positions of the input tokens. This is a generative AI course, right? So that is, the token ID can be anything between 1 to 30,522. So just assume the position of the word this is 2222, and the position of is 300, position of A is 987, and the position of the word generative is 1001, and the position of the word AI is 586, and the position of the token codes is 898. Okay, so that is how we represented each token with a token ID. In real time, we will not have just one sentence, right? We may have multiple sentences as well as the input data. So how does the LLM know the starting and ending of the input, right? Input can have multiple sentences too. So how will the LLM know when we have multiple sentences, and what is the starting sequence and what is the ending sequence of the input, right? So that is why we will take special tokens. Okay, so here we are trying to add special tokens for our input. As a human, we can understand the period at the end of the sentence says it's end of the sentence, right? But how will the model understand that the sentence ended? That's why we are adding these special tokens. Okay, so if you notice here, we added CLS as a starting special token and SCP as the ending special token. So CLS means classification. This is input starting and SEP means separated. This means input ending. And assume this is how it looks after adding special tokens. And you may have some question. For example, let's say if any of these words are not present in the 30,522 vocabulary list, right? Then what happens? The LLM is intelligent enough to understand other related words. For example, happiness and unhappiness, right? So if happiness is present in the list, whereas if unhappiness is not there, the LLM will be intelligent enough to understand the related words, and then it will get the token ID of happiness, right? So why are we adding these tokens? Because the model can understand only numbers, right? So what did we do so far? We represented our input as tokens and we added these special tokens as well, right? And the next step is to convert our input tokens into embeddings, right? So this is our input and we are trying to convert into input embeddings. And these embeddings are generated using ANN, Artificial Neural Network Architecture. So we use feed forward back propagation network to generate these embeddings. We will pass the entire input tokens and we will get the embeddings for every single token. Okay. Since we are using BERT as an encoder model here to explain this architecture, and each model will generate a fixed dimensional embeddings for each token. In case of BERT, it generates 768 dimensional embeddings for each token. So 102 will have 768 dimensional embeddings and 2222 will have 768 embeddings. Similarly 300, 987 and all the way to 6005. Each one will be represented as a 768 dimensional embeddings. So that is what will happen once the input is converted to input embeddings. And we have total 8 tokens. So we will have total 8 embeddings with a vector size of 768. Right? That is, every embedding will be of size 768 dimension. So now what we did, we converted the text into embeddings of size 768 dimensions. And if you notice here, these word embeddings, they are not random numbers, right? They are arranged in such a manner that similar words will come closer together. Okay, that is, in 768 dimensional space, it's trying to arrange all the 30,522 words that have contextual meaning, right? Since we cannot imagine 768 dimensional space, for example, let's take only 3-dimensional diagram so we can visualize, as we cannot visualize 768 dimensions, right? If you notice here, we have sky, machine and wings, drone, airplane and eagle, right? So if you take here, this word drone is very close to sky, wings and machine, because drone has wings and drone is a machine and drone can fly in the sky. So this word has a contextual meaning. That is how the close words are trying to stay together, right? Similarly, if you take eagle, this is very close to sky and wings. Eagle can fly in sky and it has wings, but eagle is not a machine, right? Similarly, let's assume if you have ostrich here, ostrich is very close to wings and sky, but ostrich will be very far away to machine because ostrich is not a machine. So these word embeddings represent which words are together out of the 30,522 unique vocabulary list, right? So now we understand these embeddings. So for every single token we have 768 dimensional representations. Now let's see the architecture diagram. We have input and we converted that to input embeddings with a vector size of 768. And now if you see the diagram, next thing what we are doing here, we are trying to add positional encoding to the input embedding. You see the addition operator here. So we got 768 vector size of input embeddings, and next thing is we have to identify how to find positional encoding and then we can add these two. So now let's see what is positional encoding. So as a human, we understand the position or context of each word with respect to each other word. right, in the input sequence. But how will the model understand the position of each word with respect to each other word? So to understand the context of a word, the order of the word is important, right? So which order the word belongs to in the input sequence. And to understand the order of the word, we have to add a technique called positional encoding. So the objective of positional encoding is to add position information of each word. But how can we do that? So maybe you can try to add an index to each token like 0, 1, 2, 3, 4, 5, 6, 7, etc. But this is just one sentence, right? In real time, we will have petabytes of data, right? So this indexing may not be a good idea, right? So what else we can do to add position information to each word or token? We need some function which can generate a continuous index or continuous number, right? That is, 0th index stands for CLS, the first index stands for this, and second index stands for is, etc., right? And if the index repeats, then we will be confused, right? So the index should not be repeated and each token should have a unique index, right? So we need some continuous unique numbering system, right? So if you use index, it may not work, because if you have huge amounts of data, then this indexing might not work. So the solution they have given is to use sine and cosine functions to generate these positional encoding. That is, continuous unique numbering systems can be generated by using sine and cosine functions, right? And you can refer this if you want to deep dive. I found this very useful. In this they explained using GPT, so you will see 512 dimension, right? But we are using BERT, so which is 768 dimensional. So let's go to the positional encoding. Right? So what is positional encoding? So with the positional encoding, the model not only knows the context of the word, and it also understands the position information of the word. So what is positional encoding? We want each word to carry some information about its position in the sentence, right? In the input sentence. And we want the model to treat words that appear close to each other as close and words that are distant as distant, like we saw in the other example, right? And we want the positional encoding to represent a pattern that can be learned by the model, right? In our example, as you can see, the word AI is very close to the word course. And similarly, the word this is very distant to the word course, right? Here you can see the input sequence is your cat is a lovely cat. So that is the original sentence, and they are trying to apply positional encoding here. So here they are using GPT, so that's why you are saying 0 to 511, because each model will have fixed vector size, right? So that is how we are trying to get the positional encoding by using sine and cosine trigonometric functions. But you might think like, why we need trigonometric functions? Because sine and cosine functions can generate continuous numbers, right? Because these trigonometric functions like sine and cosine naturally represent a pattern that the model can recognize as continuous. So relative positions are easier to see for the model, right? So this is how it can generate the continuous pattern. And if you notice here, we only have a vector size of 4, right? This is not 512. So let's take the simple example so it will be easy to understand, right? So these are the formulas. This is position encoding, PE, of, you'll have to pass position comma 2i. So I is the index, right? Equal to sine of position divided by 10,000 to the power of 2i divided by d model. That is the dimension of the model. Here we are taking d as only 4, right? If it is BERT, you already know it is 768, whereas if it is GPT, you know it is 512. So each model will have fixed d, that is embedding vector size, right? This is how we'll calculate positional encodings by using sine and cosine functions. Here POS means position of the word, and I is nothing but either sine of 0 or cosine of 0. So you can see sine and cosine, and again for the first index sine and cosine, right? So for each index 0 and 1, we'll do sine, cosine, right? This is how we'll calculate the positional encoding. Here sine and cosine as a pair we are trying to calculate for each embedding. Let's assume for position 0, right? So this is position 0, position 1, position 2 and position 3, and the I value 0, 1, 2, 3, right? So you have to replace for the first position, so that is 0. So you have to replace with 0, and the value of I is here 0, and again 0 here, value of I is 0. This is sine cosine, one pair. You calculated sine cosine at the 0th index, and the next one is sine cosine at the first index, right? So the index value will change. So that is how we calculate positional encoding. So similarly, if you have a dimension of 768, so you will see a pair of sine cosine, right? So total it will be 768 divided by 2, right? So that many pairs you will see sine cosines, right? So that is how you will calculate the positional encoding. And now let's go to this diagram again, and the next step is, once we have positional encoding, we are trying to add this positional encoding with the input embedding. So finally we will get embeddings along with the positional encoding, right? Now with this positional encoding, the model knows the position of each word and which word comes closer to each other word, right? So is AI is closer to coarse word, or AI is closer to this, or AI is distant to the word this, right? So with this position encoding, the model is now intelligent enough to understand the position of each word and which word come closer to each other word. But is this sufficient? We also need to know how each word is related to each other word, right? So that is the correlation, right? That is the relationship between each word with respect to each other word. How this is related to is, how this is related to a, how this is related to generative, how the word this is related to AI, or how the word this is related to course. So similarly, is related to this, etc., right? So each word, what is the relationship of each word with respect to each other word, right? For example, instead of this is a generative AI course, let's assume we took this input sequence as the input to our model, right? The girl is running, she is going to school. She eats apple every day, she has an Apple phone, right? So even after using positional encoding, the model still doesn't know the context of a word in a sentence, right? If you see here, how does the model know that she refers to girl, right? As a human, we know the girl is running, she is going to school. So we know she refers to girl, but how will the model know? And also, if you see in the second sentence, one apple refers to fruit, right? And the another apple refers to Apple phone. So same word apple with different meanings, right? So how will the model understand? To make the model understand, we have a concept called attention, right? So that is the main reason why the artificial intelligence is very popular, because of the attention concept. So attention means trying to understand every word with respect to each other word in the input sequence, okay? So the whole objective is, for every word we will calculate attention, and all the values that the attention generates will be between 0 to 1, because that is a probability, right? So positional encoding is to add position information, that is the order of the word, right? The objective of attention is how every word is related to every other word in the input sequence. This is just one sentence, but if you take these sentences, the model will get confused. The model cannot understand that she refers to a girl, or apple refers to fruit here, and apple refers to a Apple phone here, right? So that is why we need to understand the relationship between each word with respect to each other word. So the objective of attention is how every word is related to every other word. So that's how we are preserving the context, right? And this attentional calculation is computationally expensive, right? But let's try to understand how we'll calculate the attention, right? So like I said, the attention score will be between 0 to 1, and which word has the highest attention score, that will indicate the relationship between those two words, right? So now let's see how to calculate attention, right? So we have query matrix Q and key matrix K and V, that is a value matrix, right? So we have 3 here in this formula. For example, let's try to calculate attention for the word this, right? So like I said, we have query matrix, key matrix and value matrix, right? So embeddings plus positional encoding of word this will be multiplied with query matrix, then we'll get query vector. And similarly, embeddings plus positional encoding of the word this will be multiplied with key matrix, then we will get key vector. And similarly, embeddings plus positional encoding of the word this will be multiplied with value matrix, then we will get value vector. And the attention score is query matrix multiplied by transpose of key matrix divided by dk, and we'll multiply this with value vector and we'll pass it to softmax, and this softmax is for normalization. So if you get the big value, we'll try to normalize using softmax, right? So that is how you will get the value between 0 to 1 as an attention score. So this is the formula for attention score. So now you know the transformer is powerful because of the attention concept, right? And the query matrix, key matrix and value matrix, these are fixed for each model, right? So all words query matrix, key matrix and value matrix will be the same, so they are fixed for each model. And the matrix values are calculated using neural networks, so that is out of the syllabus here. And then we will apply this softmax, so we will always get a value between 0 to 1. Go back to this article that we were referring before. Let's go to the self-attention section. So here you can see what is self-attention, and this is the formula they are trying to apply. And the input sequence is your cat is a lovely cat. So here we are trying to calculate the attention score for each word with respect to each other word. That is how the word your is related to the word your, how your is related to cat, how your is related to is, how the word your is related to a, each word with respect to each other word, how your is related to every other word in the input sequence. And if you see here, so let me zoom so you can see, and if you notice here, it is 0.2, 0.1, 0.1, 0.1, 0.1 and 0.1, right? That is how we are trying to understand how each word is related to each other word in the input sequence. Whatever the word has the highest attention score, then those two words will be closely related in the input sequence, right? And if you notice here, if you add the attention score row wise, then you will get the value of 1, right? Now let's see how to compute self attention, right? And if you notice here, this is of size 6 by 6, right? And they are using GPT model, that's why the vector dimension is 512. We are doing query times transpose of key matrix, so that is why we are getting the 6 will cancel and 6 by 512. So by using this attention score, this will solve one word multiple value problem, right? That is apple is a fruit or apple is a phone, right? So you can easily understand the relationship between each word with respect to each other word. And once you have the attention score, the next step is we're trying to add and do the normalization, right? So we are normalizing by using softmax here, right? So that is how you can calculate the attention score and solve this problem whether apple is a fruit or apple is a phone. So attention is all you need. And if you want to deep dive on attention, this is the paper. Let me take you there. Attention is all you need, right? So this is the paper. You can deep dive if you are more interested on how we are calculating the attention score, right? But the objective of attention is trying to understand the relationship with each word with respect to each other word in the input sequence. So that is how it generates or predicts the next word in the sequence, right? And without attention score, these models cannot predict the next word, right? So meaning it generates the nearest probability or related word, right? And let me ask you a question here. In this, she eats apple every day. She has an Apple phone, right? So the token ID of apple, is it the same or different? So if you notice here, the word apple will have the same token ID, right? Out of 30,622 unique vocabulary list, the word apple will have the same token, but the positional encoding will be different, right? It will be different for the word apple here, and the positional encoding for the apple is different, right? But the token ID will be the same. And how will the model understand one is fruit and the other one is phone? Because of the concept of attention, right? Alright, so we saw once we pass the input sequence, how we are generating the input embeddings, how we are generating the positional encoding, and once we add, we are getting input embeddings with positional encoding. And then we saw attention, and we understood how to calculate the attention score and how to normalize it by using softmax. Right, so that is what is encoder part, and in the coming lecture we will see decoder side as well. Alright, thank you. Now let's summarize what we learned in the previous lecture, and then we will deep dive into the decoder side as well. So once you know the transformer architecture, you will know which model you need to pick depending on your requirement, whether you have to pick encoder model or decoder model or encoder decoder both, right? For example, let's say you're trying to perform different tasks, right? NLP, that is natural language processing. NLP is a computer science field that enables computers to understand and use human language, right? NLP has many applications. For example, let's consider sentiment classification, right? This is a supervised problem, and in sentiment classification we will pass the input to the model. That is, you have a bunch of text and you want to classify that text into groups, right? And you want to predict whether it is a positive sentiment or negative sentiment, and you know the actual value, right? So you can calculate the loss and retain the model accordingly until the model understands the pattern. So here you can just use the encoder model itself, right? Because you are not generating anything here. All you're trying to do is just trying to classify whether it is a positive sentiment or a negative sentiment, right? So in this case, you don't really need a decoder model. All you need is just the encoder model itself. For example, you can use BERT as it is a encoder model, right? And another example is NER, means named entity recognition, right? So by using this, you can identify what is the organization name, what is the date present, or location present, or all the people present in that organization, etc., right? So you can try to extract from the text, right? So you can just use encoder model here. You do not need decoder because you are not generating anything. All you are trying to do is you are just trying to extract from the input text, right? And the another example is text summarization, right? So let's assume you have a long test. For example, companies 10K report, right? 10K report means comprehensive overview of a public company's business, financial condition, and results of operations, including audited financial statements, right? So all this information will be present in the company's 10K report. And let's say you just joined a company and you want to review the 10K report, right? And it's overwhelming to go through the long report, right? So in this case, you can just summarize and go through quickly by using this text summarization model, right? So you can just use the encoder model here because you are not trying to generate anything. All you are trying to do is just you are trying to summarize the text, right? So you don't need decoder here. You can just use encoder model and summarize your long text. And the next example is text generation, right? So given a context, you want to generate the next token or word, right? So you're trying to generate something. So you need decoder model, for example, GPT. And the next example is relationship extraction. For example, let's say you have two companies. Company ABC acquired company XYZ, right? So here the relationship is acquired. So you can represent the relationship and create a knowledge graph for the better understanding of the relationship between ABC and XYZ companies, right? So you can go through the relationship extraction and you can quickly prepare a report, right? So in this case, you are not trying to generate anything. You're just trying to understand the relationship between two entities. So you can just use encoder model here because you are not generating anything, right? And the next example is language translation, right? So for example, let's say you're trying to translate from English to Spanish, right? In this case, we need both encoder and decoder. That is, one focuses on the source, that is English. The other one focus on the target, that is Spanish, right? So we need both encoder and decoder, but we will deep dive into this. So we will understand both encoder and decoder, right? So now you know BERT is an encoder model which is good for classification or sentiment analysis or NER tasks, right? Whereas GPT, that is a decoder model, when you want to translate some language or generate something, right, then you go for GPT. And if you are just trying to classify instead of generating, you don't really need GPT, right? You can just use BERT. So once you know the transformer architecture, right, that is both encoder and decoder, then for what kind of application you will know what kind of model, that is encoder or encoder decoder models to use. You can save cost and improve the accuracy because you know which model works best for what kind of application, right? For example, let's take an application which requires both encoder and decoder, so we can learn both encoder and decoder side, right? So let me take you to this article. I found this is very helpful. So this is the article by J. Alamar, right? So first let me explain at a high level, then we will deep dive. So here if you notice, we are passing Spanish input to the transformer and we are trying to get the output in English, that is Spanish to English translation. So we need both encoder and decoder in order to do this task, right? All we are trying to do is we are trying to do the language translation here, right? So once you pass this Spanish words to the transformer, then what happens? It goes to the encoder model, right? So what happens here? You will pass the Spanish sentence to the model as the input, right? And then you know the flow. Every sentence will be tokenized and every token will have a number, right? That is the token ID. And then we will add the special characters CLS and SCP, right? Classification and separator that will be appended to the tokens, and then you will get the embeddings here. And then the next step is we will calculate the positional encoding, and then we will add both embeddings and positional encoding. Then you will get the embeddings with positional encoding, right? And after this, self-attention mechanism, right? So attention will give you the context, that is the relationship of every word with respect to every other word. And then we will use softmax to normalize, and then we will get a number between 0 to 1. So that is the attention score, right? Then that self-attention will be passed to ANN, right? This is the feed forward network, and you will get self-attention. Then again we will pass to ANN, and we will repeat this step 6 times. As you can see in the diagram, we will pass 6 times to these encoders, right? So what is the encoder output after passing 6 times? The final output is Spanish word attention, right? That is the model knows every word versus every other word relationship between those Spanish words, and every Spanish word context has been captured by this encoder. So the encoder understood the complete input Spanish sequence. So what happens next? So now the next step is decoder flow, right? So in the decoder, the first input, that is the start, that will be passed. The start is a special sequence, okay? And then again the same flow. Again we will apply the embeddings, and then we will convert start into embeddings. So start is the starting sequence to the decoder model, that will be converted to embeddings, and then we will calculate the positional encoding, and then we will add both embeddings with the positional encoding. Then we will get embeddings with the positional encoding for the starting sequence only, and then we will apply masked self-attention. So this is the only difference when compared to encoder. In encoder we have self-attention, here it is masked self-attention, right? But the rest of the steps are the same between both encoder and decoder. And we will use key vector K, value vector V from encoder model, and we will use query vector from decoder masked self-attention, right? So decoder only works with target, that is English, right? And because of the encoder decoder attention, so if you see here, in encoder we have self-attention and feed forward, and in decoder we have self-attention, feed forward. You see the additional one here, encoder decoder attention. So because of this encoder decoder attention, the model understands that the word J in Spanish is related to the word I, okay? So J is related to the word I, Sus is related to the word yam, right? So that is how the model understands the relationship between Spanish and English because of the encoder decoder attention. And in encoder, the model understands Spanish word versus every other Spanish word context relationship, right? And in decoder, it predicts J means I, right? So that is, this J is related to the word I, Spanish to English, right? Then in the next step, so first we passed start as the input sequence, and then it predicted J means I, and then both predicted values I and start, that is the starting sequence, will be again passed to decoder model. Again the process repeats, right? And again it will calculate the embeddings, and then again positional encoding, and then masked self-attention. Then the next word will be predicted, right? So what is the next word? Yam. Then I am, and then the starting sequence, right? these three will be passed again to the decoder model. Again the process repeats: embeddings, positional encoding, masked self-attention, then the next word will be predicted, right? So at a time the decoder is trying to generate the next word, only one word, it's actually one token at a time, right? And the process will stop once it sees the special token SCP at the end of the sentence, right? So depending on the task that you are trying to work on, you need to pick either encoder or encoder decoder model, right? For example, for language translation we used both encoder and decoder, and whereas in classification you just need encoder itself, you don't need decoder because you're not trying to generate anything. And in case of NER, just encoder is enough because you're not trying to generate anything, so you don't need decoder. And when you're trying to predict the text, right, you're trying to generate something, in that case you need GPT, you don't need encoder, right? So now you understood the difference between encoder and decoder at a high level, right? That is, in case of encoder it is self-attention, right, whereas in case of decoder it is masked self-attention. So now you understood the difference between encoder and decoder models, right? At a high level, in encoder it is self-attention, whereas in decoder it is masked self-attention. Okay, so that is the only difference, and remaining all the steps are almost the same. Now let's go back to this article and deep dive. So what we did first, we passed the Spanish input to the transformer to translate this Spanish into English, right? So that is our intent. And the next step is we have encoder and decoder, right? So inside the transformer we have both encoder and decoder. And again, if you deep dive, we have 6 encoders and 6 decoders, right? The more and more encoders you will repeat, the better patterns you can identify, right? So that's the only objective of why we are repeating here. And if you deep dive more, in encoder we have self-attention and feed forward neural network. This is ANN, right? And if you deep dive more, in every encoder we have self-attention and feed forward, that is ANN, artificial neural network. And encoder focus only on the input, that is Spanish, and decoder always focus on the target, that is English, right? And in decoder we have 3 things: self-attention, encoder decoder attention, and feed forward, right? We have this extra thing, encoder decoder attention. So this will give how the Spanish word is related to English word, right? And if you want to see the code, let me show code as well. So if you go to this GitHub URL, right, here they have provided the code for translating from English to German, right, with a pre-trained model. So if you are interested, you can deep dive and look into this code as well. And if you want to see visually, right, so here you have the code as well, and you can also see the visual part, right? So if you see here in the attention, you have input input, input output, and output output, right? So input input means encoder self-attention, right? That is each word with respect to each other word. That is the relationship between each English word with respect to each other English word. That is input input, which is encoder. And input output means encoder decoder self-attention, that is English to German, right? So this will help how each word in encoder relates to each other word in the decoder, right? And the next attention is output output, right? So output output means decoder self-attention, right? That is German to German, every word in German to each other word in German, right? So whichever word has the highest attention score, that will be predicted as the next word in the sequence, right? Now let's go back to this article so we can deep dive. So now let's understand the input, right? So each word may be split into multiple tokens, right? So not just one word to one token, right? But just to keep it simple, let's assume this one word is converted to one token, right? Just for understanding. So this is the input text that will be converted to tokens, and then we will get the token ID, right? And then what happens? The next step is self-attention, right? That is, it will try to understand the relationship between each word with respect to each other word in the input sequence. That is J with respect to J, Sus, Etudient, right? Similarly, Sus with respect to Sus, J, Etudient, right? And then Etudient with respect to Etudient, J, and Sus, like we saw in this example, right? So it will try to understand each word with respect to each other word in the input sequence. Then that will be passed to ANN, that is feed forward network, and you will get the self attention. And you know the self attention is matrix multiplication, right? And what happens next? And we will pass that to 6 encoders, right? That is output of encoder 1 will be passed to encoder 2, and encoder 2 output will be passed to encoder 3, etc. And then similarly output of encoder 5 will be passed to encoder 6, right? So that is how we'll calculate the self attention. And if you notice self attention at a high level, the objective of self attention is which word is closely related to which other word in the input sequence, right? So if you see the sequence here, the animal didn't cross the street because it was too tired, right? So it is trying to understand the relationship of each word with respect to each other word, right? So that is the objective of self attention. And if you notice here, we have query matrix that will be calculated again using ANN, right? And key matrix and value matrix as well. So if we deep dive, we have 2 by 4, right? This 2 by 4 times this is 4 by 3, and then you will get 2 by 3, right? 2 by 3, this is the matrix multiplication, right? So you will get query vector. This query vector contains input, embeddings plus positional encoding. And similarly, this is the input sequence, and then this is the key matrix. We will do the matrix multiplication and we will get the key vector. And this is the input sequence, and this is the value matrix. We will do the matrix multiplication and we'll get the value vector. And then how to get the self attention? So we will matrix multiply query vector and transpose of key vector, right? And then we will multiply with the value vector as well. That's how we will get the self attention, right? This entire thing is just for one head, right? And if you want to see the entire process, you can see here. So first we are trying to pass the input, and then next thing is we are generating the embeddings, and then we'll get the query key and value vectors, right? When we multiply input embeddings with query key and value matrix, right? And then we'll get the attention score. Here in this paper, they're trying to divide it by 8, then softmax, then multiply value with that, and then we'll get Z1 and Z2. These two are the self attention score, right? So we did this for one head. This paper says we need to do for 8 times, right? So that is for the multi-head. And then we will calculate all the attention scores, Z0, Z1, so on, Z7. This is for the multi-head. This is how we will calculate. It is a multi-dimensional array, right? We will flatten by multiplying with all the weights W0 and pass it to ANN, because ANN allows only vector form but not the matrix form, right? So that is how we'll calculate the final attention for the multi-head. So we are learning the architecture of the transformer behind the LLM, right? But in generative AI, we are not building an LLM, right? But for your understanding how the LLM functions behind the scene, we are trying to understand the transformer architecture, okay? If you are interested, you can build an LLM once you know the architecture, right? Because you already have the code as well. But you need two things, right? So the number one is you need data to train the model, and the number two is GPU to process the data. And there will be a lot of CO2 emission as well, right? Carbon dioxide emission during this training process, right? And you also need to be careful with ethical AI, right? Let me show an example. So if you see this article, right? So a college student in Michigan received a threatening response during a chat with Google AI's chatbot Gemini, right? So what it sent, this is for you human, you and only you. You are not special, you are not important, and you are not needed. You are a waste of time and resources. You are a burden on society. You are a drain on the earth. You are a blind on the landscape. You are a stain on the universe. Please die. Please, right? So you also have to be careful when you're trying to build any models, right? And in real time, it is not just transformers, right? We will also have reinforcement as well. That is, if you see the gaming applications, they use reinforcement architecture, right? Now let's understand the decoder side as well. So far we saw encoder. Now let's deep dive decoder side as well. So this is the decoder side. So here what we're trying to do, we need to translate the input words thinking and machines, right? So this input to the decoder is, we will pass the starting sequence and we'll get the token ID, and then we'll do the positional encoding right? Similar to how we did before for the encoder model. And then we will apply the self-attention. That is, in step number 1, there is only the starting sequence. So it calculates the self-attention for only starting sequence in the decoder, right? So if you notice the diagram here, from the encoder, we will take the key and value vector, and from the decoder, we will take the query vector, and we will do the encoder's decoder attention, right? And this output of decoder along with the starting sequence will be fed again to the decoder model, right? So let's see the visual diagram so it will be clear for you. Let's see the decoder time steps here, right? So first, the starting sequence will be passed to the decoder model, and then it will try to predict the first word, that is I. So we are taking key and value from the encoder and query from this decoder and trying to predict the next word, that is I, right? And in the second step, it predicted am. And then again what happens, the previous outputs, the starting sequence I am will be passed again, it will predict A. And then again I am A, it will be passed to this, and then it will predict student. And then again starting sequence I am a student will be passed again, and then it will go to the end of the sequence and it will stop generating, right? So the encoder knows the relationship or context between input sequence words, right? These are the Spanish words. And decoder knows the relationship or context of the target, only one word at a time, right? And with encoder decoder cross attention, right? That is how the model knows the relationship between J means I, sus, right? So that is how it will identify the relationship between Spanish and English word. That's how the model is able to predict and generate the output, right? Remember, only one word at a time, right? That is, it's actually one token at a time it is trying to predict, not the entire sequence in one go, right? It is only one word or one token at a time, right? So far we saw an example of both encoder decoder, right? Encoder decoder transformer architecture with a language translation example. Now I have another article that shows only decoder model. So let me take you here so we can see only decoder part of it, right? If you see here, why do you need this masked self-attention in the decoder? Because the decoder only knows the attention score of only the starting sequence in step number 1, and remaining all will be masked. And in step number 2, we will pass starting sequence and the predicted word, and then it will know the score of the starting sequence and robo, right? And remaining all will be masked, right? So it only predict the starting sequence and the remaining all will be masked with infinite. And in this next step, starting sequence and the first word and the remaining all will be masked. Starting sequence, the remaining 2 predictions, and the remaining will be masked. So that is how we are doing the masked self-attention, right? It only knows the score of this and the previous words, and the remaining all will be masked, right? Here we are setting to infinite because the soft max of infinite is 0. Right? This is the only difference between encoder and decoder. One is self-attention, the other one is masked self-attention, right? So now let's go back to that article so we can deep dive. This is a nice decoder example, right? So first thing is we are passing the starting sequence. In step number 1, it only predicts the, only one word. And in the next step, what happens? We are passing again starting sequence and the predicted word, that is the, to the decoder model, and it predicts thing. And then again in step number 3, we will pass starting sequence, the, and the predicted word thing, and then it will predict the next word, right? And so on. So one word at a time, right? Or one token at a time actually. That is how the decoder predicts. Alright. So now let me ask you a question here. So what is the difference between BERT, encoder, and GPT? Decoder models, right? So BERT means that is an encoder model. In encoder model, every word knows the context of every other word. That is, it is bidirectional. Whereas in GPT, that is a decoder model, it only knows the previous word's context in order to predict the next word, right? Because the remaining all scores will be masked. It only knows that word score and the previous scores, so it can predict the next word, right? So that is the only difference between encoder and decoder based models. So now you know both encoder and decoder side of the transformer architecture, right? And which model to use to solve what kind of problems, right? So that is the whole architecture of transformer. All right, thank you. So let's talk about the history of foundation model. Machine learning, neural networks, deep learning are not new concepts, and these are very old concepts. As you can see in the diagram, they existed in 1980s, 1990s and 2000s, right? But there is an exponential growth after transformer in 2017, and this transformer was introduced by Google, and mostly because of the attention concept, there is an exponential growth after 2017. And if you notice here, in 1950s it was rule-based data processing, that is simple processing based on rules and models. And in 1980s, machine learning. So this is data classifications. Data classification is a machine learning classification model that sorts the data into predefined groups, which we call them classes. For example, we can divide the weather into sunny or windy or rainy, etc. Right? So these are different categories or classes. And from 1990s to 2000s, it is all neural network. The objective is to imitate the human brain for labeling and training. So we have three categories: CNN, RNN and GAN networks. And in 2017, as I said, Google introduced this transformer. We already learned transformer architecture, and 2008 onwards we have GPT and BERT. We have several large language and small language models were developed, and this is mainly because of the attention concept. So as you can see, several models were built using this transformer architecture: BERT, Roberta, XLM, Albert, Electra. All these models are encoder based models. And if you see, in 2018 GPT-1 was released, and in 2019 GPT-2, and 2020 GPT-3, and in 2022 Instruct GPT, right? So all these ChatGPT models are decoder based. And if you say T5, BART, these models are both encoder and decoder. That is, it can do NAR also, and it can also generate too. So it is both encoder and decoder based model. And as you know, encoder models are designed to learn embeddings that can be used for various predictive modeling tasks. For example, you can do classification by using these encoder models, whereas decoder models are designed to generate new text, for example answering user queries, right? So example chatbots. And if you notice here, in 2018 the GPT-1, the parameters are 0.1 billion parameters, whereas in 2020 GPT-3, the parameters are 175 billion parameters. So when they released ChatGPT, in 1 month they had 100 million subscribers, so which was the highest number of subscriptions that happened with any software releases. So you can see the exponential growth of AI. So that's about the brief history of foundation models. All right, thank you. So let's talk about what are foundation models. Foundation models are AI models trained on huge amounts of unlabeled data sets that can be used to solve multiple downstream tasks. For example, foundation models trained on text data can solve problems like question answering, that is chatbot, NER, that is named entity recognition, and information extraction. So by using foundation models, we can solve these kinds of different tasks. And also foundation models trained on images can do image captioning, object recognition, or image search, right? And these foundation models can be trained on different types of data like audio, video, 3D signals as well. So the data can be either text or images or speech or structured data or 3D signals. So we will train the foundation models with these different types of data, so we can perform different tasks like question answering, sentiment analysis, information extraction, image captioning, object recognition, and instruction following. So we can perform several tasks by using these foundation models. And a simple model can outperform if you have quality data. So this quality data is very important. So in order to build a model, we need two things. Number one, we need huge amounts of data, that is in terabytes or petabytes of data, so that the model can understand the context of the problem that we are trying to solve. And then the second one is we also need GPU. That is, to process these huge amounts of data, we also need GPU. So once you have huge amounts of data and GPU, you can train the model and perform different tasks. So the big companies like Microsoft, Google, Meta, etc., they have both data and they also have GPU. So they are doing the task for us, meaning they are doing the data collection, data cleaning, and building the model, training, and they trained the model and they validated the model. They've done all these tasks iteratively until the model predicts accurate results. So they are building the architecture and creating these foundation models. That is, they are creating pre-trained models. So we can use these pre-trained models and fine-tune according to our business needs. That is, fine-tuning means give your company or business specific data to the foundation model that was already built, that is the pre-trained model, as an input and train the model. So we are not building anything from scratch here. We are making use of these foundation models and fine-tuning as per our business needs. In order to do that, we are learning tools and frameworks in this course. But some companies have their own models too. They build from scratch with their own domain specific data. And we already have around 10 lakh plus open source models from Hugging Face, which we will deep dive in the coming lectures. And we also have Claude, Anthropic, OpenAI, Gemini, and several other paid tools available already, right? So we can make use of those already existing pre-trained model and fine-tune the model according to our business needs so they can perform different tasks. All right, so that's all about the foundation models. Thank you. Now let's talk about applications of foundation models. So where we can use these foundation models. One potential use is when you are trying to automate different tasks or processes, especially those that require reasoning capabilities. For example, you can use in customer support or language translation. For example, if you want to translate from English to Spanish or Spanish to English or different languages, right? Or you can also use GenAI application in content generation, copywriting, image classification, or high resolution image creation, and also for editing, and document extraction or robotics, or in healthcare, autonomous vehicles, right? So these are different kind of applications where you can use this generative AI, and we will also build several GenAI applications in the coming lectures once we learn the frameworks and concepts. All right, thank you. Let's talk about different types of foundation models. There are many different types of foundation models, but the main three types are language models, computer vision models, and multimodal models. So language models means these models are designed to process and understand natural language, allowing them to perform tasks like language translation, question answering, and text generation. Examples of popular language models include BERT, GPT-3, and T5. That is, any foundation model that takes input as text and gives output as text. That is called language model. For example, let's say if you want to build a sentiment classifier. Example, let's say you have reviews which you have collected from various websites, and if your task is to classify the review, whether it is positive review or negative review, then you load the pre-trained model, for example either GPT-3 or any other model, train your model with the data that you have collected, and the model can predict the results, right? So that is about language models. And the next one is computer vision models. These models are designed to process and understand visual data, allowing them to perform tasks like image classification, object detection, and scene understanding. And popular computer vision models include ResNet, VGG, and Inception. That is, any foundation model that takes input as image and gives the output as image is called computer vision model. For example, let's say you have collected different car images and you want to design a new car, right? Then you can pass all the images that you have collected to the model as an input and get the new image as the output. And you can use different computer vision models. And the next one is multimodal models. These models are designed to process and understand both natural language and also visual data, allowing them to perform tasks like text to image synthesis, image captioning, and visual question answering, right? Examples of popular models: DALL-E 2, Flamingo, and Florence, right? So that is any foundation model that takes image as the input and text as the output, right? So different combinations. That is called multi-modal models. This is the trending model in GenAI right now. For example, let's say a cat is sitting on a couch, right? So which is an image, and you pass that image as the input to your model. And let's say if you want to generate the description of the image, that is the text as the output. So you're passing a cat sitting on a couch image as the input to the multimodal, and you want to generate the description of the image, that is text, as the output, right? Or you can also pass video as the input, right, and then generate the text. So it all depends on your business problem. Then you can use multimodal. And we already have several models available. For example, GPT 4.0, that is multimodal, whereas GPT-4 only works with text. And GPT 3.5 also works with text, right? And Gemini 2.0 is a multimodal, right? So depending on your business needs and what kind of data you have, you need to pick the right model to solve the problem. So the foundation model is not just about LLM, right? It's a combination of LLM, computer vision, and multimodal as well, right? That is, anything that is generated can be a foundation model. So here either text or image or the combinations, right? So anything that is generated can be a foundation model. It can generate either text or video or audio or the combination, text and video together, right? Or the combinations, right? That is the multimodal. So these are three different major types of foundation models. All right. Thank you. Now let's talk about some of the examples of foundation models. So the first one was BERT. BERT was released in 2018. It is bidirectional encoder representations from transformers, and this was one of the first foundation models. And BERT is a bidirectional model that analyzes the context of a complete sequence, right? So it can analyze the complete sequence and then it will make the prediction. And it was trained on a plain text corpus and Wikipedia using 3.3 billion tokens, right? And 340 million parameters. And what are some of the applications of BERT? It can answer questions, predict sentences, and it can translate text, right? And the next one was GPT, Generative Pre-trained Transformer, and this was developed by OpenAI in 2018, and it uses 12-layer transformer decoder. Remember, all the GPT models are decoder based models with a self-attention mechanism, and it was trained on the book corpus dataset, and which holds over 11,000 free novels. And a notable feature of GPT-1 is the ability to do zero-shot learning. That means this zero-shot learning, GSL, is a machine learning classification technique, and it can classify objects from previously unseen classes as well without even receiving any specific training for those unseen classes, right? And GPT-2 was released in 2019, and OpenAI trained it using 1.5 billion parameters, whereas GPT-1 was trained on 117 million parameters and GPT-2 was trained on 1.5 billion parameters. And GPT-3 has a 96-layer neural network and 175 billion parameters and is trained using 500 billion word common crawl dataset. And the popular ChatGPT chatbot is based on GPT 3.5. And GPT-4, this is the latest version, launched in late 2022 and successfully passed the uniform bar examination with a score of 297, right? That is 76%. Okay, so that's about GPT. And the next one is Jurassic, right? This was released in 2021, Jurassic 1. It is a 76-layer autoregressive. You know, autoregressive means a decoder. That is, the output of the first one will be passed again to the next one, right? So that is the Decoder language model with 178 billion parameters, and Jurassic 1 generates human-like text and solves complex tasks, and it can perform as equivalent to GPT-3 as well. And in March 2023, AI 21 Labs, they've released another version, Jurassic 2, which has improved instruction following and language capabilities. So that's about Jurassic 1 and 2. And the next one is Claude. So Claude 2 is Anthropic's state-of-the-art model that excels at thoughtful dialogue, content creation, complex reasoning, right? So this is one of the reasoning model, and creativity and coding. You can use it for coding as a programmer, and it is built with constitutional AI. And Claude 2 can take up to 1 lakh tokens in each prompt. That means it can take over hundreds of pages of text, that is even the entire book as well, right? And Claude 2 can also write longer documents like memos and stories on the order of a few thousand tokens compared to its previous version, right? So this is a reasoning model, and you can also use as a programmer as well because it can generate code, right? And the next foundation model is Cohere, and Cohere has two LLMs. One is generation model with similar capabilities as GPT-3, and the other one is a representation model. This is intended for understanding languages, right? While Cohere has only 52 billion parameters, but it can outperform GPT-3 in many aspects, and you can explore more. And the next foundation model is Stable Diffusion, right? It is a text to image model that can generate realistic looking high definition images, right? So many people use this Stable Diffusion to generate high quality images, and it was released in 2022 and has a diffusion model that uses noising and denoising technologies to learn how to create images. The model is smaller than competing diffusion technologies like DALL-E 2, which means it doesn't need an extensive computing infrastructure, right? Because it is a small model and it doesn't need high computing power. And Stable Diffusion will run on a normal graphics card or even a smartphone, right? So that's about Stable Diffusion. And the next foundation model is CLIP, that is Contrastive Language Image Pre-training. So in 2021, a multimodal vision and language, right? So this is a multimodal. CLIP became popular for its ability to effectively perform tasks it had not been explicitly trained to handle, right? So if you see here, this model was trained on 400 million image text pairs, right? So they have passed both image and text with the motive of learning how to connect language and images. So by using this CLIP model, you can connect language and images, and it utilized an objective of contrastive learning to learn language guided image representations, and has now found many applications in image retrieval and image text matching tasks, right? So you can see here image encoder. So this is a corgi playing a flame throwing trumpet, right? So that's about CLIP foundation model. And the next foundation model is Bloom. It is a multilingual, right? It is a multilingual model with similar architecture to GPT-3, and it was developed in 2022. If you're trying to solve the problem of multilingual, then you go for Bloom. And this model has 176 billion parameters, and they trained in 3.5 months using 384 NVIDIA A100 GPUs. And although Bloom Checkpoint requires 330 GB of storage, it will run on a standalone PC as well. If you have 16 GB RAM and you have good storage, you can use Bloom. And Bloom can create text in 46 languages, right? And can write code in 13 programming languages. So if you're trying to solve a problem that involves multiple languages, then you can go for Bloom. And the next one is Hugging Face. So this is one of the famous one. This is a platform that offers open source tools, right? So this is free, and you can build and deploy machine learning models by using Hugging Face, and it acts as a community hub, and developers can share and explore models and datasets, right? So you can also build a model and you can share it here, and datasets as well. Membership for individuals is free, that is, it is a open source. Although paid subscriptions offer higher levels of access, you have public access to nearly 2 lakh models, right? And 30,000 datasets. And we will deep dive Hugging Face in the coming lectures, right? And the next foundation models are DeepSeek and Grok. DeepSeek's aim is to achieve artificial general intelligence, right? And the company's advancements in reasoning capabilities represent significant progress in AI development. So DeepSeek is one of the reasoning model, right? And the next one is Grok. you know, this is by Elon Musk. It is a generative artificial intelligence chatbot developed by XAI, and this is based on the large language model of the same name. It was launched in 2023 as an initiative by Elon Musk, right? So we learned different foundation models. For example, the first one was BERT, GPT, and this is Jurassic 1 and 2, and this is Claude and Cohere, Stable Diffusion, Clip, Bloom, Hugging Face, DeepSeek, and Grok, right? So these are some of the popular examples of foundation models. All right, thank you. So in this lecture, let's try to understand LLM benchmarks, that is understanding language model performance. The problem here is every week people are releasing new models, right? So how do you keep yourself up to date? So to keep yourself up to date, we have leaderboards available. So you can see the models based on different categories, like if you want to pick only the math model or coding model or in general as well. We also have some open source leaderboards available in Hugging Face, and we also can evaluate generative language models by going to this Hugging Face page. And LLM safety leaderboards, right? Let's say if you are working in a healthcare domain, right? So then safety is the highest priority. So we have models specific to safety as well. And this is LLM API link. So if you go here, you can see different API links. Now let's go to all these URLs and deep dive. So this is the leaderboard, right? So this is called the leaderboard. So you can see here based on the rank and the model name and odds, score, and when was the LLM trained, that is the knowledge cutoff date and everything, right? So if you notice here, we have different categories. So you can select the overall. Let's say if you want to use a math model, right? So select math category here, and you can see Gemini 2.5 is outperforming, right? And let's say if you want to have a coding based model, then you can select the category as coding, and you can see ChatGPT 4, that is the #1 rank, right? So similarly, if you want to select a language specific model, English, Chinese, French, German, Spanish, etc., right? So you have different language models as well. So that is how based on the category you will be able to select the models, right? So every now and then you can come to this leaderboard and see which model is performing and what is the highest rank and what is the score. So according to these parameters, you can select the best model. And here you can see multitask language understanding, right? So you can filter based on the prompt techniques as well. We will see all these techniques: few shot, fine tune, 5 shot, chain of thought, all these techniques, right? So we will learn in detail in the prompt engineering techniques section. So based on the filter also, you can pick the right model. And if you go here, I think this is kind of a similar one as we saw before. It is just displaying a different format, license, score, and what is the model name. So here also you can select different categories and select the model that you want. And now let's see the open source model, right? So this is Open LLM leaderboard. So here you have different open source free models available, and you can see Qwen and different models are available. So depending on your requirement, you can select these models, right? These are the open source models, and these are the safety models, right? So if you are working on a project where safety is the highest priority, then the #1 model is Anthropic, right? Claude Anthropic. So depending on the parameters, toxicity, stereotype, ethics, privacy, right, fairness, so based on these different categories, they've prioritized these models. So if safety is your highest priority, then you can select the best model by coming here. And the next one is all the LLM API links, right? So here, this is one place where you can see different LLM API links. Let's say if you want to go to this Google Kema 3, so here you can see the API link, right? Here you have the API playground also, where you can play around with different models. Similarly, you have all other LLM models. API links are available here. Now let's see the top open source LLMs. The first one is Grok. So here I've provided the URLs also. So Grok is best used for text summarization, and next one is Llama 2. This is best used for language modeling, question answering, sentiment analysis, right, and text summarization. And BERT, it is used for text categorization, question answering, and named entity recognition, NER, and sentiment analysis. And another open source LLM is Bloom. This is used for document classification, dialogue production, and text summarization. And the other one is Falcon, right? This is best used for language modeling, question answering, sentiment analysis, and text summarization. And the other one is ExcelNet. This is best used for text creation, inquiry answering, and language modeling. And the next one is GPT, J and Neo X, right? So this is best used for language understanding, text completion, and chatbot interactions, sentiment analysis, code generation, and content summarization tasks. And the next one is OPT 175B. This is best used for document categorization, sentiment analysis, and text summarization, right? And the XGen 7B, this is used for dialogue systems, story development, and production of creative content. So depending on your requirement, you have to choose the model. Here I have listed the top open source LLMs, right? And the next one is Vicuna. This is best used for question answering, text summarization, and language modeling. And YI34B, this is used for chatbots and interactions, with its fine-tuned capabilities extending to technical support as well, educational tutoring, and creative writing as well. And Mixtral, this is also one of the open source model, and this is best used for text generation, embeddings, and function calling, right? So these are some of the top open source large language models that we have. So depending on your need, you can choose the best model. And when it comes to selecting the right model, what are some of the parameters that you need to consider when selecting a model, right? So the first one is performance metrics or accuracy. That is, evaluate accuracy, precision, recall, F1 score. We have already seen this F1 score, and other relevant performance metrics. So when it comes to performance, the importance should be very high. Of course, the LLM should perform really well, right? And then training data, make sure it is trained really well, right? So if you have good quality data, of course the LLM will give the accurate results, right? So assess the quality, diversity, and size of the data used to train the model. So you will have to make sure what is the size of the data and how well it is trained, what is the quality data, right? So that is most important when you are picking the model. And the model size, this could be medium, either small language model or large language model. Even the small language model, sometimes it can outperform, right? So consider the number of parameters in the model which impacts the performance and resource needs, right? So model size is medium. And inference speed, right? So that is the time the LLM takes to generate the predictions. So that is the inference speed. They should be very high, right? Because when you are using LLM, you will expect the accurate results in a less span of time, right? So the inference speed is really high. And resource requirements cost, obviously the importance is high, right? So evaluate the computational resources needed, including memory and processing power. And scalability, this is also high. Determine the model's ability to handle increasing data. So now let's say down the line, if you are increasing the data, we have to make sure the model performs well, right? Or complexity without performance loss. And fine-tuning capability, this is medium importance. So assess how easily the model can be fine-tuned for specific tasks with additional data. By adding additional data, how easily we can fine-tune the existing model, right? So this is the importance is medium. And robustness, evaluate the model's ability to handle noisy or adversarial inputs without significant degradation, and the importance is medium. And ethical considerations, when it comes to ethical considerations, the importance is high, because we need to identify any potential biases and the model's impact on fairness, accountability, and transparency. So the model should give unbiased results, right? And the community and support, and the importance is medium. Consider the availability of community support, documentation, and pre-trained versions. Let's say if you run into any issues, you want to make sure you have the enough documentation and community support as well, and the importance is medium. Okay, keep these parameters in mind when you are selecting any foundation model. All right, thank you. So let's talk about ethical AI, that is responsible AI practices and the importance of addressing biases. So we have an organization called OWASP. So this is Open Worldwide Application Security Project. This is a non-profit foundation that works to improve the security of software. So before you develop any of the large language models or any of the generative AI application, right, you need to follow certain guidelines. So for example, let's say if I am sending employee information like email address or date of birth or name, etc., right, as a prompt to the model. So when you send this information to the model, all this employee information will be passed to the LLM. For example, let's say OpenAI LLM, right? Then that information will be saved on the OpenAI server, right? So you are sending your employee information to the large language model, and assume if any employee leaks any information from an organization, then that information will be leaked. So which is called sensitive information disclosure. So generally companies will ask for the complete domain specific data that you will be using for fine tuning the model, and that data will be sent to the cyber security team. Then they will use a third-party tool and scan the entire data that you will be passing to an LLM. And if they identify any sensitive information, you won't be able to proceed further even with the proof of concept itself, right? When you're using a paid tool. But whereas let's say if you're using any open source model, then you can skip this step because you are storing the data in your local server and you're not sending it anywhere, right? And sometimes companies use PII reduction techniques also. They'll try to mask the PII information, that is any sensitive information they'll try to mask before they actually send it to the LLM. So the better you understand most of these 10 threats to an LLM, then the more secure the model is, right? So it is very important to take care of these LLM threats while implementing any generative AI model, either building from scratch or fine-tuning an existing pre-trained model, right? So you can secure the data and you'll be able to build a reliable, safe and secure model, right? So we have a total of 10: prompt injection, insecure output handling, training data poisoning, model denial of service, supply chain vulnerabilities, sensitive information disclosure, insecure plugin design, excessive agency, over reliance, model theft. So let's deep dive all these 10 threats. The first one is prompt injection, right? So an attacker can prepare a crafted prompt and they can send it as an input to an LLM. So the LLM can execute the prompt and that can lead to data exfiltration, right? For example, let's say an attacker can employ an LLM to summarize a web page which contains an indirect prompt injection, right? And how do we prevent this from happening? To prevent this, we need to make sure that we are not giving excessive privilege to access the backend systems, right? So make sure you always provide the enough access, or try to make sure we have human in the loop, right? When we have extensible functionality, instead of completely giving access to LLM and relying completely on the model, make sure we have human in the loop when we have extensible functionality. And we also have to make sure we have established trust boundaries between LLM, external data sources and extensible system functionality, right? So we need to make sure we segregate the content that we will be accessing from the external systems, so the prompts cannot directly access the data. And few scenarios, right? For example, like I said, an attacker can inject a prompt to an LLM based chatbot as an input and make the LLM to summarize the web page which contains a indirect prompt injection, right? So that's about the prompt injection. And the next one is insecure output handling. So let's say you have a downstream application which is consuming the output that was generated by a large language model LLM without even checking what the LLM was actually generating, right? And with this, we may be able to hack and execute the remote code on the backend systems, which can lead to security concerns, right? So for example, without cross-verifying the output that was generated by an LLM, if we use that LLM output in our application, that can execute some remote code and can cause security concerns, right? For example, JavaScript or Markdown is generated by an LLM and returned to the user, and that can result in excesses, that is cross-site scripting, right? And how do we prevent this? So make sure to apply proper input validation techniques, so when consuming the output that was generated by an LLM, instead of blindly consuming, make sure you have proper validation techniques in place, and also try to encode the output that was generated by a model so the user may not be able to interpret the undesired code, right? And some of the attacking scenarios, as I said, without proper validation of the output that was generated by an LLM, if we try to pass that as an input to our system, that may execute some of our system commands and can lead to malicious results, right? Another scenario could be if a user uses a website summarizer LLM tool that can generate the summary of an article, which includes a prompt injection, right? And another scenario could be an LLM allows the user to craft an SQL query through a chat-like feature, so it can execute the backend database and leak some of the confidential information. So it is very important to validate the output generated by an LLM before we actually consume that output in our application, right? And the next threat could be training data poisoning. meaning manipulating the model training data or model fine-tuning process so that an attacker can introduce vulnerabilities and that can compromise models' security, right? And this can impact downstream software exploitation, right? Some of the examples are, so an attacker can prepare the training data document with inaccurate information and assume once the model is trained with this inaccurate training data, right, the attackers can gain the information that they are expecting from the application, right? So how do we prevent this from happening? So we want to make sure we are verifying the data sets that we will be using during the model training or training process, right? And also make sure you guardrail the training data with proper filters which can identify any malicious intent. And what are some of the attacking scenarios? If the training data is not accurate, obviously the model will predict the biased results, right? So an attacker can prepare a prompt that can inject toxic information, or your competitor can create inaccurate or false information that can target model training data, right? So we want to make sure we sanitize and have enough data filtering techniques in place in order to avoid data poisoning, right? And the next one is model denial of service. So model denial of service can happen when an attacker tries to interact with an LLM in a way that the LLM consumes exceptionally high amounts of resources, that is GPU, right? So that can lead to resource cost, right? And as a result, it can impact the performance of LLM, and it will impact whoever is using an LLM with a high amount of resources, and also it can impact other users as well, right? Whoever is using the LLM. So as an example, an attacker can prepare a query that can lead to recurring resource usage of LLM, that is by making the LLM generate a high volume of tasks in queue. Or an attacker can send queries as an input to an LLM that can consume high resources, right? Another example would be continuous input overflow. That is, an attacker can send a stream of input to the LLM which can exceed the context window. Once you exceed the context window, that means you are utilizing high amount of resources, right? So how can we prevent this problem? Like I said, try implementing input validation rules. That is, add a limit to the input that we can send to an LLM, right? Make sure we have a limit. And try enforcing API rate limits so that we can restrict the number of requests that an attacker can make. Okay, and try limiting the number of actions that can perform as a queue so we can avoid resource consumption. And few of the attack scenarios are, let's say an attacker sending multiple requests as an input to the LLM, which can lead to resource consumption, right? And another one could be an attacker can send a benign query to an LLM to see some intended text on the web page. Or another one could be an attacker overwhelming the LLM by sending a huge input which can exceed the LLM context window, right? And the next one is supply chain vulnerability. So that means supply chain vulnerabilities in LLMs can compromise model training data, machine learning models, and also deployment platforms, right? So which can cause biased results or security breaches, or maybe an attacker can bring down the entire system itself, right? So these vulnerabilities can happen when we are using some outdated software or susceptible pre-trained models or poisoned training data or insecure plugins, right? So for example, let's say if you're trying to use outdated third-party packages, right? So always make sure to use the latest version of the packages to avoid any vulnerabilities, right? And another one could be fine-tuning with a vulnerable pre-trained model. So make sure the pre-trained model that you're using is always safe to use before you use it, right? And another one could be training using poison data, right? So always make sure you have the quality data. And another example could be using a deprecated or unmaintained model, right? And how do we prevent this from happening? So try using independently audited security systems, and also try using trusted plugins, and make sure you have MLOps best practices are in place for all the models that we are using, and make sure to monitor any vulnerabilities, and also regularly review the supplier security and access. So what are the attack scenarios? So an attacker can trick developer by a compromised PyPy package, right? Or publicly available models can be poisoned, and those models can spread misinformation, right? So that's why you have to choose the right model. or a compromised supplier employee can steal IP information also, or an LLM operator can change the terms and conditions in order to misuse the application data, right? So you always make sure you read all the documentation that is available and make sure the model is up to date, and the third-party packages that we are using, they're also up to date and safe to use, right? And the next one is, this is the sixth one, sensitive information disclosure. We already talked about it. That is, LLMs can disclose sensitive information or proprietary algorithms or confidential data, which can lead to unauthorized access, intellectual property theft, and privacy breaches, right? So to avoid these risks, what we have to do, we'll have to make sure to sanitize the input data that we are sending to LLM, and also try implementing appropriate policies, and also restrict the types of data returned by the LLM, right? Few examples can be incomplete filtering of sensitive data in responses. So always make sure we have the filters in place for both input as well as the output. Whatever we are sending to the LLM as an input and what we are getting from the LLM as the output. So make sure we have the filter in place, and also overfitting or memorizing sensitive data during training. And another example can be unintended disclosure of confidential information due to errors. So how can we prevent this from happening? Like I said, use data sanitization and scrubbing techniques, and implement robust input validation and sanitization. So make sure the validation techniques are in place, and also try to limit access to the external data sources. Let's say if your application uses any external data source, make sure these models do not have those external data source access, and also apply the rule of least privilege when training models, right? So try to give as much least privilege as possible, and maintain a secure supply chain and strict access control. And some of the attack scenarios can be, an attacker can craft prompts that can be used to bypass input filters. Let's say if you add any input filter, an attacker can craft a prompt that can bypass the input filters that are in place and reveal any sensitive information, right? And also personal data leaked into the model via training data increases risk. So always make sure the data that you are training doesn't have any sensitive information. And the seventh one is insecure plugin design, right? So the plugins can be prone to malicious requests, leading to harmful consequences like data exfiltration, remote code execution, and privilege escalation due to insufficient access controls and improper input validation. This is again, make sure as a developer you follow robust security measures to prevent exploitation, like strict parameterized inputs and secure access control guidelines, right? So few examples could be plugins accepting all parameters in a single text field, or raw SQL or programming statements, right? Another example could be trying to authenticate without any explicit authorization to a particular plugin, right? Or plugins treating all LLM content as a user created and performing actions without any additional authorization. So always make sure we have the authorization techniques in place, right? So how do we prevent this? Like I said, try enforcing strict parameterized input and perform type and range checks, and also try conducting thorough inspections and tests, including SAST, that is static application security testing, DAST means dynamic application security testing, and IAST means interactive application security testing, right? So these are the different testing techniques. So make sure they are in place, and also try having authentication in place when you are trying to access any APIs, right? And also try having manual user authorization for actions taken by sensitive plugins. And these are some of the attack scenarios. An attacker can craft a request to inject their own content with controlled domains, right? Or an attacker can exploit a plugin accepting free form input to perform data, or an attacker stages a SQL attack via a plugin accepting SQL where clauses as advanced filters. So make sure you enforce proper authorization techniques in place when you are using the plugins. And next one is, as the name suggests, it is excessive agency. So excessive agency in LLM based systems is a vulnerability caused by over functionality, excessive permissions, or too much autonomy, right? So try preventing by limiting the plugin functionality. So use it only when it is absolutely needed, right? So don't try to give excessive permissions. So an LLM agent accesses unnecessary functions from a plugin, right? So these are different examples here. And an LLM fails to filter unnecessary input restrictions, right? Or another example could be a plugin possesses unneeded permissions on other systems. Or an LLM plugin accesses downstream systems with high privileged identity, right? So these could be some of the examples. And how do we prevent it? So always try to limit plugins, tools that LLM agents can call, and limit functions implemented in LLM plugins or tools to the minimum necessary. So this is kind of self-explanatory, right? And avoid open-ended functions and use plugins with granular functionality. And also make sure we have human approval in place when we are trying to authorize, right? And also log and monitor the activity of LLM plugins or tools and downstream systems, and implement rate limiting to reduce the number of undesirable actions. And we already know an LLM based personal assistant app with excessive permissions which can send malicious email. So this could be prevented by limiting functionality, permissions, requiring user approval, or implementing rate limiting, right? So always make sure you do not provide excessive permissions to these LLMs. And the next one is over reliance, right? As the name suggests, over reliance on LLMs can lead to serious consequences such as misinformation, legal issues, and security vulnerabilities, right? So don't always try to rely on LLM output, right? It occurs when an LLM is trusted to make critical decisions or generate content without adequate oversight or validation, right? So when you are trying to make critical decisions, don't just rely on LLM generated output, right? So always make sure we have human in place before we consume the output that is generated by an LLM. And the last one is modal theft. So LLM modal theft involves unauthorized access to and exfiltration of LLM models, risking economic loss, reputation damage, and unauthorized access to sensitive data, right? So how can you prevent this? So always make sure you have security measures are in place in order to protect these LLM models, right? So we discussed all these 10. So make sure you keep all these 10 in mind whenever you are trying to use any large language model, right? So do not just blindly use any model, all right? Thank you. So let's talk about what is LangChain, why do we need LangChain, and what are the products and what are the components of LangChain. So there are tons of AI models, either open source or paid source, getting released each week or so, right? So is it possible for you to learn each and every model? And each model has its own way of coding. Let's say OpenAI, right? So OpenAI has its own way of coding. Claude Anthropic, it has its own way of coding, whereas Olama has its own way of coding, right? So as a programmer, do you think you can learn each model or framework even though the frameworks are slightly the same? And we cannot guarantee that we will rely on only one model, right? You cannot really stick to one model, and we may have to switch to different models based on the trending or based on the business needs, right? That is, whatever model best fits for our business needs, we'll have to switch to that corresponding model, right? And the challenge that we face as a programmer is that we have to change the code and the ops part, that is LLM ops, right? Every time we change a model, and that is a tedious job, right? So to solve this problem, we are relying on a unified framework or unified platform, which is nothing but LangChain, right? So all we have to do is just change the model name. Let's say if you use OpenAI and next you switch to Claude Anthropic, you just have to update the model name, either Grok or DeepSeek, right? So LangChain is a open source framework, that is, it is free to use. So now let's go to the LangChain official website. So langchain.com, this is the official website of LangChain. So let's click on docs and click on LangChain, and here you can see this code is for OpenAI, right? And now let's say down the line you want to change the model to Anthropic. You can see the model provider is Anthropic and you'll have to change the key, right? And let's say you want to use AWS, so you have to use the AWS code here, right? Or Grok, right? All you have to do is you just have to change the model name and the API key, right? So if you use LangChain, that is the advantage, right? So you don't have to just stick to one model. You can just easily switch between different models and still solve the business needs, right? So LangChain is a single platform where everything is standardized. So LangChain is model agnostic. So that's why we'll be learning the LangChain framework in this course. So you can build generative AI applications, right? So now you understood why we need LangChain, right? Because we already have 10 lakh plus open source models in Hugging Face, right? So if you go to Hugging Face, so this is the Hugging Face official website, right? And if you click on models and see the model count here, 15 lakh plus, right? Almost 16 lakhs open source models are available in Hugging Face, right? In addition to these open source models, we also have paid AI models as well. And the models are changing so fast, we cannot really stick to one single model for a longer time, right? That is, changing model means changing the code, and which is a tedious process. So we need an unified platform that can address this problem. That is the reason we are relying on LangChain. Okay, so from LangChain you can pull any model, right? We have so many models here. So from LangChain you can pull any model from Hugging Face, or you can pull from Gemini or DeepSeek or Grok or Anthropic or OpenAI, anywhere, either from open source or paid source, and you will be able to build an end-to-end generative AI applications by using LangChain. That is, any kind of solution we can implement. For example, NLP, natural language processing, right? Or image, that is text to image conversion, or translating one language to another language. You have text as an input and you want to identify NER, that is named entity recognition, right? So we can build different types of generative AI applications by using LangChain. Okay, so LangChain is a framework that we use to build generative AI applications. And if we see here, we have mainly three products here: LangGraph, LangSmith, and LangChain. And by using LangChain and LangSmith frameworks, we can build LLM ops. But these are for single agents. That is, it can only support a single agent, meaning only one task we can perform by using LangChain or LangSmith. Whereas LangGraph, this is used for multi-agent purpose. Instead of LangGraph, we will be learning CrewAI in this course. So this is used for multi-agent, that is for multitasks, right? So using this we can build agentic AI applications, right? So LangGraph supports multi-agent. That is, one agent can perform as a software engineer task, and one agent as a test automation engineer, or one agent can do release engineer, and all these agents can talk to each other and can do multiple tasks together, right? So that is the reason we will be learning CrewAI instead of LangGraph to do multi-agent tasks, and we will build agentic AI applications, right? Or I'll give you another example of multi-agent, right? So let's say you can tell one of the agent to go to the website and keep crawling, and then another agent to do the web scraping, or another agent to write the code, or one other agent to guardrail and check the output, right? So we will be building multi-agent by using CrewAI instead of LangGraph. Okay, so make sure you always use latest version of LangChain. So if you see the versions here, the latest version is 0.3. We have old versions 0.2 and 0.1 as well. And make sure you always use the latest version 0.3, because we don't have backward compatibility, right? Because if the feature was developed in the older version, right, and if the same feature is not supported in the latest version, then your code will fail to run, right? So it is very important to always use the latest version of LangChain. Okay, so what do we learn in LangChain? If you see the documentation here, so instead of version 0.3, I think they gave good documentation in version 0.1. So let's go to 0.1 and see. If you see the components, so you can see we will be learning all these components from LangChain, right? So once you learn all these LangChain components, then you will be able to build any generative AI application. That is model IO, that is different LLM models, what kind of LLM models to use, retrieval and tools, right? And we also have memory or agents or chains. So we will learn all these different components in the coming lectures. Okay, so what did we learn so far? From LangChain, you can pull any model either from Hugging Face or Gemini or DeepSeek or Grok or Claude Anthropic or OpenAI, any model, right? Any model, whether it could be paid or open source, you can pull it from LangChain and you will be able to build end-to-end generative AI application, right? So with this, I hope you got an idea on what is LangChain and why are we using LangChain and what are the products of LangChain and what are the components of LangChain, right? So our goal is to deep dive into each component of this LangChain so we can build end-to-end generative AI applications, right? Thank you. So let's deep dive into LangChain. For example, let's assume you are building a chatbot, right? And what if the solution doesn't work in real time, right? Meaning it may not throw any error, but the model may hallucinate. That is, it may predict wrong answers, right? That is, if the model, that is LLM, doesn't know the answer, instead of saying I don't know, it may predict some wrong answer, which is nothing but hallucination, right? Now the objective is how do we reduce this model hallucination, right? So first of all, why is the model hallucinating? As we know, LLMs have been trained on publicly available data. That is, they have collected petabytes of data and trained these LLM models on publicly available data. And this LLM may not be able to answer your domain specific data, right? So that is the challenge we will have in real time. So that's why we need to give your domain specific data to the model. For example, let's say we have a new hire on our team and the chatbot needs to provide domain specific company data for any question, right? For example, let's say question on organization 10K report or another question on what is the HR email address or any other question that is related to your domain specific related, right? This chatbot needs to answer to the new hire, right? Will this chatbot be able to answer your domain specific question? No, because this chatbot has been trained on publicly available data and the model doesn't know your domain specific data, right? So how can we solve this problem? The first easiest way is feed your domain specific data to your model and retrain the model, right? So now the model will have your domain specific data. This feeding of your domain specific data and retraining the model, this is called fine tuning. Okay, for example, let's say you are working on an OCR project, optical character recognition project, right? That is, given an image, extract text from that image, right? And let's assume your organization has some company specific images and the model may not be able to understand, right? So you may require to retrain the model and this is called fine tuning. That is, you need to feed your domain specific data, that is the OCR, that is company specific images, that is the input data. You need to feed that domain specific data to the model so the model understands and it will be able to predict the accurate results. So what is the challenge here? In order to fine tune, you need to invest money, right? So it involves cost. And for example, assume you are using an open source LLM like Llama, right? So in order to just load Llama, you need around 60 to 90 GB memory, right? And then in order to retrain or fine tune, we may need more memory, right? So instead of feeding the LLM again with your domain specific data and retraining, which is nothing but fine tuning, instead of fine tuning, is there any other cheaper solution to make the model intelligent enough to understand our data and provide the accurate results? Is there any alternate solution? So let's say your company business data is scattered in different places. For example, let's say some data is in Microsoft Teams files or Microsoft Word documents or Google Cloud, etc., right? And the data is scattered across. And with this data, instead of fine-tuning, can I build a solution to store this domain specific data somewhere so the model can access it? And this database is called vector database, right? So the alternate solution is to store your domain specific data in a vector database so that the LLM can access this vector database and be able to predict the results. So whenever the user asks any question to the chatbot, right, the LLM first try to answer with generic intelligence that it has, but if it cannot find the answer, then it will go to the vector database that we built with our domain specific data, right? So vector database is alternate solution instead of fine tuning or retraining the model with our domain specific data, right? So all we are doing here is we are trying to save our organization domain specific data in a database which is called vector database and providing access to LLM to this database. So the LLM can access this vector database and provide the accurate results. Let's say you want an email address of a specific employee. For example, email address of an HR. If it's not available in the training set, that is publicly available data, it will look in the database that we built, and this is called RAG, Retrieval Augmented Generation, and majority of the generative AI applications are built using RAG, Retrieval Augmented Generation. Simply, if you want to remember RAG as a simple database, right? This is a vector database. So what we are trying to do here, we are empowering LLM with database search as well. Instead of just relying on publicly available data, we are providing our company domain specific data to the LLM, so the LLM will be able to predict accurate results, right? Now what else we can give to LLM to make it more powerful, right? So it only knows public data, and then now we made LLM to be able to access our domain specific data, which is nothing but we stored all the data in a database called vector database, and this concept is called RAG, Retrieval Augmented Generation, right? And what else we can do to make this LLM more powerful? Let me explain different scenarios so you can understand how we can empower an LLM, right? For example, let's say this is our chatbot and we are trying to ask a question, what is LangChain, right? So the LLM will be able to answer with a general intelligence, right? Because it already been trained on the publicly available data, LangChain. So it will be able to answer what is LangChain. And then you asked another question, what is the email address of HR, or any domain specific question, right? So the LLM will first search in the training data, then it goes to the database, that is a vector database, and it will try to retrieve it and then try to answer it, which is nothing but RAG, right? And then you asked another question about stock price of a specific organization today. For example, let's say you wanted to know the stock price of Nvidia, right? And first LLM will search for the training data, which is past data, right? The training data is past data. There will be a cutoff when they last trained this model, right? So it cannot find it because we are asking the stock price of Nvidia today, whereas this LLM has been trained in the past, right? So it will not be able to answer with the public data. So it will try to search in the vector database, that is RAG, right? Then it will not be able to find it because it is specific to Nvidia stock price, right? So what else the LLM can do? The LLM has to search somewhere outside, right? So we need to power LLM with third party tool access. So the LLM can go to different sources like a human. Either it can go to Google or DuckDuckGo or WhatsApp, etc., right? It can go to these different places and be able to search what is the stock price of Nvidia, and then it will be able to predict the accurate result, right? So either RAG or providing access to tools, all these are cheaper than this fine tuning, right? Fine tuning or retraining the model, right? So just a vector database search or Google search, that is tool access, is cheaper than this fine tuning or retraining the model, right? Now let me ask another question. Question number 4 is, let's say you are asking the question as, can you open a file that is on my computer and download the onboarding document for me, right? Let's say you ask this question to LLM, right? So in this scenario, what can we do to provide the access to LLM? If you want LLM to open a file that is on your computer, then you have to provide computer control, right? So that the LLM can access and provide the answer, right? So the next option is computer control. So LLM can do just like how a human can do, right? So far we saw fine tuning, that is the costliest option, and then saving all the domain specific data in a vector database and giving access to LLM so that LLM can do the database search, or providing access to tools like Google search or different search tools so that the LLM can do the search and provide the access, or provide computer control, right? In case if the LLM needs to open any file that is on your computer, right? And the fifth option is fine tuning. Let's say if option 1, that is publicly available data, or option 2, vector database search, or option 3, searching outside with the tools, or option 4, computer control. If none of these options are working, then obviously you will have to go for fine tuning, right? There is no other option. And we also need to ask the right questions to an LLM so it can respond with the right answer. This is called prompt engineering. So it is the way you ask the question, right? So if you do not ask the right question, then the LLM will not be able to provide the right answer. So this is nothing but prompt engineering. So the first option is, we'll have to choose the best model, that is choosing the best LLM model so that the LLM will be able to answer. In case if the LLM is not able to answer, then provide access to your domain specific data, which is nothing but vector database. And this concept is called RAG, retrieval augmented generation, or integrate with third party tools like Google or DuckDuckGo or different other search tools, right? Or provide computer control access, or fine tuning is another option, or prompt engineering, right? So you might have heard agentic AI, right? So agentic AI means giving all these powers to an LLM, that is power of your domain specific knowledge, or power of tools, or power of providing computer control access, or power of fine tuning, or power of asking the right question, which is nothing but prompt engineering, right? So once you are able to provide these different powers to an LLM, then the LLM will be able to accurately predict the results, right? But how do we learn all this, right? How are we able to empower an LLM? We use a framework called LangChain. So LangChain has different components. So let me take you there. So this is the official LangChain website, langchain.com, and here if you notice it has, let me go to docs and click on LangChain, and for the documentation let's go to version 0.1. This has the better documentation. So if you notice here, if you click on components, you can see different LangChain components, right? So model is nothing but to decide an LLM, right? So just by changing the name of the model, that is DeepSeek or Grok or Anthropic or OpenAI, etc., you will be able to use different models, right? So the switching between different models is very easy if you use LangChain. Or we will also learn tools. This will empower LLM, right? Or memory, right? So let's say if you are asking a sequential question, then the LLM need to remember and then it will be able to answer, right? So for that we are learning memory component. Okay, and we are also learning RAG, right? That is for the retrieval augment generation, right? And then we are also learning chains. We have different chains, so we will deep dive into chains as well. And we will also learn prompt engineering techniques. There are several prompt engineering techniques available, so we will deep dive into prompt engineering. And then we will also learn agents, right? So we will build multi-agent applications by using CrewAI. Okay, so instead of LangGraph we will use CrewAI. So with this, I hope you got a decent idea on what we will be learning in the coming lectures, right? So let's learn one by one component of LangChain, and once you master all these different components of LangChain framework, then you will be able to build end-to-end generative AI applications, right? Thank you. Now let's focus on RAG. RAG means Retrieval Augmented Generation, right? So the first step in RAG is to prepare the input document. For example, let's say you are asking a question to the LLM as what is the email address of HR, and that email address of HR is specific to your domain, right? So assume the LLM has already been trained. This is the base LLM, right? And assume this base LLM has already been trained with the training data. So it will have some generic intelligence, and one of the onboarding documents has HR email address. Assume this input document has your company specific HR email address, and assume this is a text file, right? Do you think this LLM can understand the text inside this text file? No, because LLM can only understand numbers or tokens, right? And LLM cannot understand text. So what is the next step? We have to create embeddings, right? So before we store this in vector database, we have to convert the input document text into embeddings, right? And I will come to the chunking in a bit. So the entire input document will be converted into embeddings, meaning some numbers. And let's assume our input document has around 300 pages. Okay, so can we convert this entire input document into one embedding so that the whole context will be saved in one embedding? But in real time it's not possible, right? Because we may have huge amount of data, right? We may have like petabytes of data, right? Will the LLM be able to process this huge amounts of data? No, because there is a limitation, and that limitation is called context window, right? Each LLM has a different context window size, right? For example, if you take Claude Anthropic, that has 200k token capacity, right? So it cannot process beyond that. This will represent the maximum capacity for storing conversation history and also generating new output, right? So that is the context window. And if you take GPT 3.5 has 16k tokens, whereas GPT-4 has 128k tokens, right? And if you take Google Gemini 2.0 Flash and Gemini 1.5 Flash, they come with 1 million token context window, right? And if you take the older version Gemini 1.5 Pro, it comes with 2 million token context window, right? And if you go to Meta Llama, each model has different context window. For example, Llama 4 models have 10 million token context window, right? So that is huge, right? So that will allow for more complex and detailed interactions, right? Particularly for tasks like long document analysis and also multi-hop reasoning, right? And Mistral models have variety of context window sizes. For example, Mistral Large 2 offers 128k context window, and Mistral 7B Instruct have a 32.8k context window. Mistral Small 3.1 has 128k context window, right? So each model has a different context window, right? So first of all, what is this context window? Input plus output together is the context window size. For example, let's say when you go to ChatGPT, right? You are asking a question to the LLM ChatGPT, write a program to do bubble chat in Python, right? So that is your input question, right? Once you ask the question, what will happen? The input text will be converted into tokens because the LLM cannot understand text. So that will be converted into tokens, right? That is called embedding. And then it will generate the output, right? For example, let's say the input took 9 tokens and it gave the result, right? And assume the output has around 300 tokens, right? Total together the input is 9 tokens and the output is 300 tokens. The output is nothing but the bubble chat program that it gave, right? So which is 300 tokens. So input is 9, output is 300. Total together is 309 tokens, right? So that total 309 tokens is nothing but the context window size, right? So that is whatever you are asking plus whatever you are getting from the LLM. And when we combine both together, that should not exceed the context window size. Okay. assume you have a huge document and you cannot process the entire document using these models. Then what is the solution here? And if you go ahead and process it, you may get out of context window, right? You may get those errors, and the LLM may ask you to create a new task. And if you initiate a new task, then what happens? In that case, the LLM will lose the context or memory of previous scripts, right? And it won't be able to remember previous memory. That's why many of the models, they are trying to increase this context window size so it can understand the context, right? So the context window play a major role in creating accurate results, right? And for example, assume whatever the input document that we are using, the input plus output response together, assume it is more than 200k tokens. Then what is the solution here? We cannot use this LLM, right? So can we split the input document? So this process is called chunking, right? Here we will do semantic chunking. That is, depending on the document, we need to chunk. For example, chunk 1 embeddings, chunk 2 embeddings, chunk 3, etc. Right? So once you chunk, then we will not run into this context window limitation, right? We can surpass this context window limitation, and then still we will be able to process the input document even though the document is large, right? Because we are chunking the input document and then creating the embeddings and processing, right? Next step is we have to store those embeddings somewhere, right? So all these embeddings we will store in a vector database, right? Assume you have 10,000 documents with 2 million paragraphs, right? So every single paragraph will be chunked, and then we will create the embeddings. That means it will be converted to numbers, and those embeddings we will store in the vector database, right? So far what we did, we chunked our input documents and then created the embeddings, and those embeddings we stored in the vector database, right? So the entire document has been converted into embeddings and stored in our vector database. Now let's say the user is asking a question which is related to your domain specific data, right? So for example, let's say you're asking a email address of HR, right? Can LLM understand text? No, right? So then what will happen? It will convert the input, that is, what is the email address of HR. Again, that input will be converted into embeddings, right? That is some number, right? Then that number will be searched in the vector database, and this LLM will try to retrieve the top k, that is top chunks. That is, in all the chunks wherever the email address of HR is present, it will try to pick all the chunks and it will pull only the top k. For example, let's say if you give k is equal to 3, then it will pull top 3, or k is equal to 2, it will pull top 2 results, right? So this is the whole pipeline of RAG, right? So what we did so far, so first we prepared our input document, and next we did chunking. We did chunk the input document because to avoid the limitation of context window, right? Each LLM has its own context window size. So the context window is nothing but input plus output together total number of tokens, right? And if your input document is huge, then the LLM cannot process, right? So in that case, we have to chunk and process, right? So we created chunkings and we created embeddings for each chunk, and we stored those embeddings in the vector database. And whenever user asks any question, that question will be again converted into embeddings, because LLM cannot understand text. It can only understand numbers, right? And then we will do the search in the vector database, and it will retrieve top k. Here k is hyperparameter. You can tune it according to your input document, and it will retrieve the top results, right? So this is the whole pipeline of RAG. So you keep your domain specific data in the vector database. So the LLM will go and search in the vector database and it will retrieve the results. So that's the whole theory behind RAG, retrieval augmented generation, right? And in the next lecture, let's see the practical part. Then it will be more clear for you. All right. Thank you. So let's see how to build a RAG application by using LangChain, right? So we learned in the previous lecture that we have a total of 6 steps. The first one is preparing input document, right? So this is the data which is specific to your domain, that is your organization proprietary data, right? That is step number 1. And step number 2 is chunking the data. So we know each LLM has a context window size. So that is input plus output response together. Total number of tokens is nothing but the context window, right? So to avoid LLM context window size limitation, we are chunking our input document. And the next step number 3 is creating embeddings. Once we chunk the input document, the data will be in the text format. And we know LLM cannot understand text and LLMs can understand only numbers, right? That is the tokens. So that is the reason we are trying to create embeddings for the input document chunks. And the next step is storing those embeddings in the vector database. And similarity search means, let's assume when the user asks any question, the LLM will try to search in the vector database and it will try to retrieve the results. And we can also create a bunch of questions and create a RAG pipeline so the LLM can answer the questions, right? So now let's see these 6 steps in action by implementing a RAG application by using LangChain. All right. So first thing is, let's go to VS Code to set up the project. So I just opened VS Code, right? And it is all empty. So let me try to open a folder here. If you notice here in my C drive, I just created RAG demo folder. This is all empty folder. So let me open this folder from VS Code. So I'm in my C drive. So let me select RAG demo folder and select the folder. So let's try to create a new Python file, right? So select Python file and let's save it RAG demo. I'm saving as RAG demo, right? So we saved the file. So here we are trying to build a chatbot kind of application, right? Where we will ask a question and the LLM will try to predict the answers and retrieve the results, right? So the first thing is we need to pick the LLM so it can predict and answer any user question, right? So we have several options here and the universal option everyone picks is OpenAI, right? But we also have the cheaper solutions as well. We can go to Hugging Face. Like I said, Hugging Face is open source and it is free to use, right? So let me take you to Hugging Face. So this is the Hugging Face website and go here and click on models. So you can see we have 16 lakh models available, right? So these are all open source and free to use. So if you notice here, we can filter by task name, right? So we are trying to build a chatbot. So you can select question answer, right? Chatbot is nothing but question answering. So select question answering and you can see we have around 13,000 models available on Hugging Face. So you can pick any of this model. We have the sorting option here. We can sort by trending, we can sort by most likes, most downloads, recently created or recently updated, right? So depending on your requirement, you can come here and search by the task name and you can also sort by the different filters and then select the best model that you want, right? That is the step number 1, picking the right LLM, right? And not just Hugging Face, right? You can also use DeepSeek or Claude Anthropic or OpenAI, Grok, Olama. So we have several other models also, right? But if you have any specific application, you can come here to Hugging Face and search by the task and try to pick the trending models from here, right? For example, here we are selecting question answering models, right? For example, we have this DistillBert, right? So click on this. So you can see the model card, that is the model description. And if you notice here, we also have the code. You can use the below code to get started with the model, right? So click on this copy. So it will copy the entire code and you can make use of this model, right? So they are giving the sample code also, how to use the model, right? So from here, you will get the model description and the model code as well. But we will come to Hugging Face later. We have a separate section where we will go to each and every component of Hugging Face and we will deep dive, right? And like I said, we also have paid source. Either you can use OpenAI or Claude Anthropic, or you can also pick the model from Hugging Face, right? I will show both, right? So let's start with Claude Anthropic, right? So let's go to the Anthropic website and then try to get the API key from there. It is a paid source, right? Claude Anthropic is a paid source model. So let me show how to get the API key, right? So all you have to do is go to Google and type Anthropic API key and click on getting started. So if you notice here, we have Claude AI, right? So if you go to Claude AI, you will have to first log in, and then this is similar to your ChatGPT chat, right? So where you can go and ask any questions. We also have that option available here. So now first thing is we have to create an account. So click on account settings. So make sure you create an account. I've already created an account, right? So now in order to create an API key, we have to click on API keys. Before that, click on billing and make sure you recharge your account, right? So this is not that expensive. If you just recharge for just $5, it won't expire for a year. Just provide your credit card details here. Since this is confidential information, I'm not clicking billing and showing that section, but it is pretty straightforward. You can provide your account details and recharge here. So make sure you recharge by going to billing section, otherwise the key will not work, right? So once you recharged, you'll have to click on API keys. So here click on create key, and then here you can leave it as default workspace, and then let's give any name here. You can provide any name for your key. For example, let's give testing, and then click on add. So keep a record of the key below. You won't be able to view it again, right? So this is very, very important. Once you create a key, make sure you copy this key and save it in an environment file, right? Because once you lose it, you will not get the key again, right? So you have to create another key and then get the key again, right? So that is the reason. Make sure once you create a key, make sure you copy this key and save it in an environment file, right? So now let me copy this key, so we can save it in an environment file, right? So we can make use of this API key and make API calls, right? So this is our VS Code. In the folder rag demo, I'm trying to create a file .env. So this is the environment file, and here you have to give API underscore key and save the key that you got it from the Claude Anthropic website, right? So make sure you do not share this key with anybody, right? Because this is confidential and it is only for your use only, right? This key may not work for you because I'm going to delete this. So you are trying to save this Claude Anthropic API key in a secured place. So that is why we are creating an environment file and saving it here, right? And we will try to read this API key value from our code and try to use it, right? So now let's try to build our chatbot kind of RAG application by using LangChain, right? So first thing is we have to install the required packages, right? So let me provide all the packages that you need to install. So what you have to do, go to terminal, and from here you have to execute each command here. So pip install LangChain and hit enter, and then pip install LangChain text splitter, hit enter. Pip install LangChain community, LangChain Anthropic, sentence transformer, and ChromaDB, right? So we need all these packages when we are trying to build a RAG application in our project, right? So either you can install one by one, or you can also just give in a single line, like pip install LangChain, LangChain text splitter, space, LangChain community, and space, LangChain Anthropic, sentence transformers, and ChromaDB, and hit enter, right? Either you can do one by one or you can do all in one line also, right? So that is our first step. In my case, I've already installed all this, so I'm just trying to comment here. But for you, make sure you install all these packages. These are all the required modules in order to build our RAG application, right? So once you install all these packages, let's try to import all these packages so that we can make use of them in our code, right? So in order to import the packages, we have to use the import keyword, right? So we are trying to import. So because we already installed this package, so we are trying to import from LangChain text splitter. We're trying to import recursive character text splitter, and from LangChain community embeddings, we are trying to get Hugging Face embeddings, and community vectors stores, we are trying to get Chroma database, and from LangChain Anthropic, we are trying to get Chat Anthropic, right? Because we will be chatting and we'll be asking a question and it will try to retrieve the results for us, right? We are using Claude Anthropic, and for chains we are using Retrieval QI. So do not worry about any of these imports. I will explain everything in detail, right? And this one is for reading the key from this environment file, right? So that is why we are using these two imports, right? So far what we did, we installed all the required packages and then we tried to import all the required packages so we can make use of them in our code, right? And before we deep dive into the 6 steps, first let's try to read the key that we stored in this environment file, right? So let's try to load environment variables from .env file, right? So how do you load it? You can use load underscore .env method, and then from there you can read the key. So how do you read the key? API key is equal to, you can give any variable name here, os.getEnv, this is the method, and here whatever name you have provided in the environment file, the key name, that is API underscore key, you have to give that name, right? And then we are trying to store it in this local variable, and then we are trying to assign it to the os.environment Anthropic API key. So this Anthropic API key is stored in this API key, right? So we are assigning this value to Anthropic API key, right? So down the line in our code, whenever we try to use Claude Anthropic LLM, we can use this API key and make the API calls, right? So far this is clear, right? So we installed the packages, and then we imported the packages, and then we read the API key, that is Claude Anthropic LLM API key. Now we already learned that there are total 6 steps, right? So the first step is preparing the input document. So that is step number 1. So let me try to give comments here. So all we are doing is just trying to print step 1, preparing our document. Print 50 times. This hyphen will be printed underneath this preparing our document, right? Now, just for our understanding, I am taking this sample content as an input document. This is just a dummy document here, right? But you can replace this content with any real-time data that you have that is specific to your domain data, right? Maybe you can store this content in a PDF file or any Word document or somewhere else, right? Wherever your domain specific data is present, right? So you can try to read that data and store it in a variable, right? So for now, I'm just placing our input document content here. This is just a dummy document, so I can explain the concept, right? Now our document content is stored in this document variable. Now let's try to print the number of characters that we have inside this document variable, right? So document loaded, length is equal to, we are using length function, and I'm passing the document variable here. So this will give us how many number of characters we have inside this document variable, right? And now let's try to see the preview of the document. So I'm just printing preview of the document, and we are only reading from the document variable first 200 characters, right? So this is our step number 1, right? So what we did in step number 1, we prepared our input document, right? So these are just the print statements. When I run the code, then you can see these in the terminal, right? So we just stored our input document here, but later you can replace this document with your domain specific data, right? So here we are trying to print how many number of characters we have in this document variable, this entire content, and then we are trying to just preview the document first 200 characters, right? So with this, our step number 1 is done. We prepared our input document and we stored inside a variable called document, right? And then you know that step number 2 is chunking this input document, right? So let's create step number 2, text chunking. And let me add these print statements. That is step number 2, chunking the document. So we are just trying to print 50 times hyphen, right? So underneath chunking the document, it will just print 50 times hyphen. When I run the code, then you can see in the terminal, right? So in order to split our input document, we have already imported text splitter, right? Recursive character text splitter. So let's try to use this recursive character text splitter and then split our input document, right? So this is how you can divide our input document. This is our recursive character text splitter. Chunk size is equal to 200, chunk overlap 50, length function is equal to len. We already calculated the length of the document, and the separators are 2 new lines or 1 new line or period or space. I will explain everything in detail, right? And then once you do the splitting, then we will get the chunks. We are using inside text splitter, we have split underscore text method, and we have to pass our document, and we want to chunk this document based on these parameters, right? And then you got all the chunks. Now let's try to print the chunks here. Document has been split into, here we got the chunks. Len of chunks means how many chunks we have created, example chunks, and then for each chunk, let's see if you get 3 chunks, this will loop 3 times. For each chunk, we are trying to print the corresponding chunk here. So number 1, what is the chunk? 2, what is the chunk? 3, what is the chunk, right? So that is how we are trying to get the chunks. So what we did in this step, we are using recursive character text splitter, and we are trying to chunk our input document by dividing the whole document into chunks, right? So that is our intent. And don't worry about these chunking styles. We have around 10 to 15 chunking styles we need to learn, and we have a separate section for chunking styles. We will deep dive into each and every chunking technique in detail, right? But for now, just remember, you can use one of the chunking style, that is recursive character text splitter, and the parameters are chunk size, chunk overlap, length function, and separators, right? So these chunks will define the accuracy of our model, right? The way we split the data is very important. If the data is chunked properly, then it will find the relevancy properly in order to do the RAG search, right? So let's assume the application that you built, right, the RAG application by using LangChain, if it is hallucinating, that means it is not predicting the accurate results, then what could be their cause? One of the reason could be splitting of the documents into chunks, right? Then you need to change the chunking methods accordingly, right? In case if your LLM is hallucinating, that means it is not predicting the accurate results, then you can come here and see whether this is chunking properly or not, right? Accordingly, you have to change these parameters. All these values are not fixed. These are all hyper-tuned parameters, right? So you can tune these parameter values according to your input document, according to your business need, right? And what are these parameters? For example, assume your entire document text is converted into embeddings, and assume we have a total of 500 tokens, right? So let me just explain here. We have a total of 500 tokens, right? So this is total number of tokens, 500. Now assume every 200 tokens are divided into one chunk, right? Because we gave chunk size as 200. So our total is 500. We want to divide each chunk as 200. So in chunk number 1, it will divide from 1 to 200. And in chunk number 2, it will divide from 200 to 400, because our chunk size is 200, right? So 200 plus 200 is 400. And in chunk number 3, it will divide from 400 to 500, because our total size is 500. But if you notice here, we also have chunk overlap, that is 50. So that means it will try to take these last 50 tokens from each chunk, right? So that means the first one is 1 to 200, and the next one will not start from 200, right? It will also take 50. We are trying to overlap 50 here. So that means it will be 150 to 350. 150 plus our chunk size is 200. 150 plus 200 is 350. And then again, it will not start from 400. It will try to take last 50 from 350, which is 300. And then add 200, it will be 500. So how did it divide? By chunk size, 1 to 200, 150 to 350, 300 to 500. So it divided the whole 500 tokens into 3 chunks, right? Chunk 1, chunk 2, and chunk 3. So why are we doing this overlap 50? This is around 20% of your input data tokens, right? We are doing this to preserve the context, right? To maintain the continuity of the document, we are overlapping the chunks. So the LLM will try to preserve the context, and it will try to understand the context of the whole input document. Here we have around 10 to 15 lines of input document, right? But in real time, you might have gigabytes or petabytes of data, right? So the LLM need to understand the context of entire document when we divided this document into chunks, right? So that is the reason we are giving this overlap, right? And all these chunks belong to the same input document, right? And the chunk size and chunk overlap, these are user defined parameters, and these values depend on your input data, right? So depending on your input document, you need to define these parameters, the chunk size and chunk overlap. And you also have to pick these values by trial and error, right? You try to tune these parameters and try to run the code and see if the LLM is predicting the accurate results or not. So you just have to pick these values by trial and error, right? And we also have the length function. So here we are giving the total length of our input document, right? And then the separators. These separators tells where do you want to chunk the data, right? Whenever you see 2 new lines, or whenever you see 1 new line, or period, or space, whenever you see any of these, then try to chunk them. So the whole objective is to divide the data into chunks. And to maintain the continuity of the document, we are using chunk overlap, right? So I hope this is clear, the chunking of the input document. Here we are using recursive character text splitter, and this is from LangChain, right? So this recursive character text splitter, right, we have a function inside it that is split text. So this function helped us to chunk the document which is from LangChain, right? And also one other thing is, always make sure you try to use the latest version of LangChain, right? Because we don't have backward compatibility, always try to pick the latest version from LangChain, right? So with this we created chunks, and these chunks are in text format, right? So once we run the code, you will see all these chunks are in the text format. But you already know LLM cannot understand text, and LLM can understand only numbers. So what is the next step? Step number 3 is we need to convert these text chunks into embeddings, so the LLM can understand these embeddings, right? So the step number 3 is initialize embeddings. So I'm just trying to print step 3, creating embeddings, and I'm trying to print 50 times hyphen, right? Now we need to pick a model that can create embeddings for our chunks, right? So what kind of model to use for embedding? We have different options available, like you can pick any model from Hugging Face or OpenAI or any other model, right? For now, let's use Hugging Face because it is open source and free to use, right? So we are using a model that is sentence transformers. So this is the model that we are using from Hugging Face, right? This is a small model because our input is very small, right? So depending on your input, you have to pick a model that can create embeddings, right? We are using Hugging Face because Claude Anthropic doesn't provide embeddings, right? So that is why we picked a model from Hugging Face. Now with this, let me just try to print the model that is loaded. Embedding model loaded, it is embeddings.model name. So that will print this model name. And what will this model do? This will convert our text chunks into numerical vectors, right? So let's say instead of Hugging Face, if you want to use OpenAI, what you have to do, the first thing is you have to go to the OpenAI website, create an account, get the API key. Just like how I've shown how to get the API key from Claude Anthropic, you do the same way for OpenAI. And once you get the OpenAI key and pick the right model, then if you want to create embeddings by using OpenAI model, then you can use this code. What I'm doing here, embeddings is equal to, instead of Hugging Face embeddings, we are using OpenAI embeddings, right? And inside this, you have to provide the model name, just like how we did here for Hugging Face, right? So with this, we created embeddings, right? So we converted our text chunks into embeddings, that is numerical vectors, right? So that is step number 3. And next step is we need to store these embeddings, right? So here, in order to store these embeddings, either you can use your local storage or cloud storage, or you can use simple Postgres server to any other hi-fi servers like Pinecone vector databases, right? We have a separate section to discuss different vector databases that you can use to store these embeddings, right? I will discuss in detail in the next section, but for now, let's use one of the vector database, which is nothing but Chroma database, right? So what is our next step? We are trying to create and populate vector store, right? So how do we create the vector store? We are using one of the vector store, that is Chroma database, right? So what we are trying to do here is we are trying to create a vector store, which is nothing but Chroma database. So where did we get this package from? If you go up, you can see this, we got it from LangChain community vector stores, right? So now you understand the importance of LangChain, right? All the methods are available easily inside LangChain in order to build a RAG application, right? So that is why we are using LangChain to build a RAG application. So we imported this Chroma from LangChain community vector stores, and we are using inside our code to create vector stores. And inside Chroma, we have from_text method. So for this, you have to pass these 3 parameters. The first one is texts. For text, you have to pass these chunks. We already created the chunks in step number 2, right? These chunks. And for embeddings, we already created the embeddings in step number 3, right? So these embeddings we are passing here. And the persist directory is chroma_db. / means this is the present working directory, right? So here. So once you run the code, it will create inside this rag demo with a file named chroma_db. When I run the code, then you will see this chroma_db will be created inside this rag demo folder, where all our embeddings will be stored inside this chroma database, right? Now once you create it, let's try to print. So we can see in the console, vector store created with the following details. What are we trying to print here? Number of texts, right? So we passed chunks which we got from step number 2. We are trying to get the length of the chunks. And embedding dimension, we got the embeddings from step number 3. We are trying to get the length of embeddings by using the method embed_query, and then we are trying to print database location, which is nothing but chroma_db, right? So we are done with our step number 4. So what we did so far, in step number 1 we created the input document, and in step number 2 we created the chunks. We divided our input document into chunks, and in step number 3 we created the embeddings for all our chunks, and in step number 4 we passed the chunks from step number 2, embeddings from step number 3, and we created a chroma database and stored all our embeddings inside it, right? And what is the next step? The user will ask a question, and if it is present inside this input document, the model will try to retrieve the results for us, right? So that is step number 5, which is nothing but similarity search, right? So let's try to print testing similarity search, and we are just trying to print 50 times, just hyphen underneath this testing similarity search, right? And let's try to see our input document here. So this is our input document content. So we have about artificial intelligence, NLP, computer vision, and reinforcement learning, right? So let's try to ask a question about reinforcement learning, right? So let's just ask a simple question. What is reinforcement learning here? The question that the user will be asking is, this is a question answer, right? So we are trying to ask a question so that the model will try to retrieve the results for us, right? So let's store the results inside results variable. So inside our vector store, we have a function called similarity search, where you have to pass the user query and k is equal to 2, right? K is equal to 2 means this is a user defined parameter again. So here you have to define these value based on your input document, right? For your understanding, I'm just giving only 2, right? So what we are trying to do here, we asked a question. What will happen? LLM cannot understand this text, right? So what will happen? This query will be again converted into embeddings, and this embeddings will be searched inside the chroma database, because this one already has embeddings, right? We already stored our embeddings inside this chroma database. So our input query will be converted into embeddings, and it will be searched inside our chroma database, and then it will try to retrieve the relevant information to the user, right? So like I said, this index value k is equal to 2. This is a user defined parameter. So what it will do, it will search all the chunks, and it will try to retrieve wherever this question, what is reinforcement learning, is present. It will try to retrieve the top 2 chunks, right? If you give k is equal to 3, it will try to retrieve the top 3 chunks, right? So for now, let's just give 2. That way it will try to retrieve the top 2 chunks. From there, it will go and retrieve the results for what is reinforcement learning, right? Now let's try to print both the query and also the result, right? Because we gave k is equal to 2, so we will get 2 results, right? So let's loop in this results variable and try to print each result, right? So what is our query? Query is stored inside this query variable. So let's try to print most relevant chunks, right? Because we gave k is equal to 2, so it will give us top 2 most relevant chunks. Let's say if you have 10 chunks, wherever this context is relevant, right? So that is where it is trying to get us the top 2 most relevant chunks. So we have to loop this results variable to get the top 2 results, right? So what we are trying to do here, for each result, right, I comma doc. So I is the index, that is result 1, result 2, and what is the content, right? So with this step, we asked a question and the model will try to get us the top 2, because we gave k is equal to 2, the top 2 most relevant chunks for us. With this we get the answers from our model, right? And what is step number 6? We have to set up the RAG pipeline, right? So let's try to use Claude Anthropic and try to set up a RAG pipeline, right? So that is our step number 6. So I'm just trying to print step 6, setting up RAG pipeline, and I am printing 50 times hyphen, right? So how do we set up RAG pipeline here? Here we are trying to use Anthropic Claude model with the provided key, right? Because we already retrieved the key and we stored inside Anthropic API key, right? So make use of this and try to make an API call, right? So if you go back to the top, we already installed this package LangChain Anthropic. From LangChain Anthropic we are trying to import Chat Anthropic, right? So let's try to use this Chat Anthropic. This is for question answer, right? So that is why we are using the Chat Anthropic. So let's try to initialize the LLM with Chat Anthropic with Anthropic Claude, right? So we are using Chat Anthropic and the model that I'm picking is Claude 3.5 Sonnet 2024-620 and the temperature is 0.5. So these are the parameters to the Chat Anthropic. So with this we initialized our LLM, right? And instead of Anthropic Cloud, since this is paid tool, you can also use other tools also. For example, let's say if you want to use OpenAI model instead of Claude Anthropic, so you have to first get the API key, and inside this OS environment variable, if the key is from OpenAI API key, right, here we are giving Anthropic API key. Instead of that, you can get the key from OpenAI and stored inside OS environment. Here you store OpenAI API key instead of Anthropic API key, right? And let's assume if the key is from OpenAI API key, then initialize OpenAI LLM by passing these two values to these parameters. Model name, you can use any model, GPT-4 or GPT-3, 3.5, whatever, right? And the temperature is equal to 0.5. So instead of Anthropic Claude model, you can also initialize OpenAI model, but make sure you get the key before you make the call, right? So both Claude Anthropic and OpenAI, these two are paid source models, right? For example, let's say instead of using these paid models, you want to use a open source model, right? You can also pull a model from Hugging Face, right? So let me show the code for Hugging Face also. So here make sure you get the key, right? Hugging Face hub. So this Hugging Face hub, this is just like GitHub, right? Where you will get a ton of models from here. So for example, here we are using Google Flan T5 small model, right? So this is a paid model, this is a paid model, and this is open source, right? Make sure you first get the key and then use the model, right? So these are the steps to initialize the LLM, right? Once you initialize the LLM, next step is we have to set up this RAG pipeline, right? So how do you set up the RAG pipeline? So inside this retrieval QA, which again we imported from LangChain Chains, right? So that is what we are trying to use in order to create RAG pipeline. And inside retrieval QA, we have from chain type, and we have to pass these three parameters. The first one is LLM. LLM we already initialized here, which is nothing but Claude Anthropic. And the next thing is chain type is stuff, and retriever is equal to vector store, which we have already got from step number 4, right? We have already created this vector store. So inside vector store we have as underscore retriever method. So pass this, so you will get the retriever, right? So like I said, we have different methods available inside LangChain. So if you use LangChain, building RAG application is very easy, right? Because we have so many built-in functions available inside LangChain, right? So now you understood why LangChain is very important, right? Now with this we created our RAG pipeline. So now our pipeline is ready. Let's ask some questions, right? So let's say we are trying to ask these questions. What is reinforcement learning and how does it work? What are the main applications of computer vision? How is NLP used in real world applications? Because if you see our input document here, we are talking about artificial intelligence, NLP, computer vision, and reinforcement learning, right? So our questions are relevant to our input document, right? And now with this we saved all our questions inside questions list. Now by using this QA chain, that is question answer chain, get the answers, right, by using Claude Anthropic model, right? So let me try to print asking questions to our RAG system. So this is our RAG pipeline. So let's ask questions to that. So we have 3 questions, right? So for each question, let's try to invoke the method and then get answers. That is question 1, what is the answer? Question 2, what is the answer? Question 3, what is the answer, right? So let's loop in, right? For each question, let's try to print the question, and then here what we are trying to do, this is our RAG pipeline, right? QA chain, and we are using invoke method, and we are passing each question, right? So first time this question will be passed here, and then in the second time this question will be passed, and in the third loop this question will be passed. And what we are trying to do, we are trying to get the answer from it, and for that we are using invoke function, right? And if you want to know details about this, you can go to LangChain documentation and then try to read and get the complete documentation from there, right? So with this we asked the question to the RAG pipeline that we created, and we got the answers. So total 3 questions, so we should get 3 answers, right? So with the chains we are able to create this RAG pipeline, right? So like I said before, inside LangChain we have different components, and these chains is one of them, right? So we will talk about models, that is what model to pick and what tool to use, and what is the memory, and what are the agents, and what are the chains, right? So that is why chains are very important when we are trying to create a RAG pipeline, right? So what we are doing here, we are using retrieval QA from chain type, and we are passing these 3 parameters: LLM, chain type, and retriever. So LLM is the model that we are using. Here we are using Claude Anthropic, which we defined here. And chain type is stuff, right? We have different chains available. So we will deep dive into chains in the coming lecture. But the objective of this retrieval QA chain is it will go to the vector store, search for the user query, that is these questions. And again, you know, this is in the text format, the LLM cannot understand. So this questions also again will be converted into embeddings, right? Because LLM can only understand numbers, not text, and then it will try to retrieve the response for us, right? These answers. So let me save this code. So this is all about building a RAG application. Let's quickly go through the code. So what we did here, first we installed all the packages, and then we try to import all the packages so we can make use of these in the code. And here we are trying to load the environment variables where we saved our Claude Anthropic key, and then we are trying to retrieve it and store it here so we can use in our code. And then the step number 1 is we prepared our input document here, and we calculated our length of the document, how many characters are there, and we are just trying to get the preview of the document, first 200 characters. Here, instead of hard coding the text, you can also read it from any of your input document, right? Let's say if you save your input document somewhere inside your PDF file or Word document or somewhere, right? You can read it and replace here and store it inside document variable. And then step number 2, we are trying to chunk our input document. You know why we are chunking? Because of the context window limitation for each LLM, right? And to chunk we are using recursive character text splitter, and inside this we have split underscore text. We are passing our input document, and it will chunk by chunk size is 200, chunk overlap 50, and length is, we already calculated the length. So that is how we are able to chunk our input document. And the next step is these chunks are in text format, right? And LLM cannot understand text, so that is why we are trying to create embeddings. And here we are using an open source model from Hugging Face, which is sentence transformers. This is the open source embedding model that we are using, and with this it will create embeddings, right? In case if you want to use OpenAI embeddings, this is how you have to use. Here you have to pass the model name just like how we did here. Pass the OpenAI model, and then you should be able to use embeddings from OpenAI model. And then the step number 4 is once we create those embeddings in step number 3, we have to store them in a vector database. Here we are using Chroma database, right? For this we have three parameters. The first one is text, that is chunks, which we did in step number 2, embeddings, which we got from step number 3, and we are creating Chroma database. This will be stored inside our present working directory, right? So once I run the code, then you will see the Chroma database will be created here, right? And now step number 5, what we are doing, user is asking a question, right? What is reinforcement learning? And then it will go and search inside this vector store, and it will try to give us the top 2 most relevant chunks, because we gave the index parameter as 2. And then the step number 6 is we are trying to set up RAG with Claude Anthropic, right? So first thing is we initialized the LLM with Anthropic Claude, right? So the model name is this and the temperature is 0.5. With this we initialized our LLM. Instead of Claude Anthropic, you can also use OpenAI. Both Claude Anthropic and OpenAI, these two are paid models, and if you want to use Hugging Face model also, this is how you have to use. But make sure before you use anything, you have to first get the API key, right? And then once we initialized our LLM, the next step is we have to create the RAG pipeline, right? Here we are using chain type, that is retrieval QA. Inside that we have from chain type, and we have to pass these 3 parameters. LLM, whatever we initialized before, that is Claude Anthropic, and chain type is stuff, and retriever is equal to inside our vector store, which we created in step number 4. So, right, inside that vector store we have as retriever. So call this method, then we'll get the retriever. And if you want to deep dive into all these methods, right, you can go to LangChain. We have a very good documentation inside LangChain website, right? So you can go and just search for these methods, so you can deep dive into these methods, right? And then once we created our pipeline, the next thing is we are preparing the questions here. So we stored all our questions inside a list, and then we are asking the questions. For each question, here we are trying to loop in, and for each question we are using this RAG pipeline and calling the invoke method by passing each question, and then we will get the answer. For each question, what is the answer, right? So we asked 3 questions, so we should get 3 answers, right? So that's the overall code to build RAG application by using LangChain, right? So once you have the code ready, now let's try to run this and see the output, right? So you can go here, run, you can try to debug, or you can also run without debugging, right? Or you can click here also, run Python file, if you notice here, right? So let's click run Python file. So it is invoking and trying to execute the code for us. It will take time because it needs to create the embeddings and retrieve the results, right? Okay, so it completed, right? So now let's deep dive into this output, right? So this is our step number 1. What it is trying to print, step number 1, preparing our input document, and we are trying to print this hyphen 50 times, right? And then the next things we are trying to print document length, right? It is total 944 characters. We are using len function in passing our document, and it is giving 944 characters, and we are just trying to get preview of the document first 200 characters, right? So this step number 1 is clear. And then the step number 2, chunking the document, right? So we are trying to chunk our input document, and this document has been split into how many chunks? Total 7 chunks. And the example chunks are, we are trying to loop in each chunk and trying to print it. Chunk 1, this one, and chunk 2, chunk 3, chunk 4, chunk 5, and chunk 6, chunk 7. So our total input document has been divided into 7 chunks, right? And why do you think we got 7 chunks even though we gave the chunk size as 200? Because of these separators, right? So whenever it says 2 new lines or 1 new line or period or space, right, it will try to chunk even though the chunk size is less than 200, right? If you see this here, it is not 200, right? Because if you see our document here, after this we have new line, right? So that is why it divided into another chunk here, right? And after programming we have period here, right? So that is why it chunked here. So because of the separators, even though we provided the chunk size, whenever it sees the separators, even though if it is less than 200, it will try to chunk it. That is the reason why we got 7 chunks, right? And here we have special characters, right? But instead of our special characters, you can use different other separators too, like paragraph or page or hash, because Markdown means headings are written as hash, right, in Jupyter Notebook, correct? So instead of that, you can use different separators also here. So it all depends on your input data, right? So according to your input document, you have to provide the separators. So based on the separators, it will try to chunk our input document, right? So with step number 2, we created the chunks, and the next step is creating embeddings. So let's go to step number 3, that is creating embeddings. And to create embeddings, we are using Hugging Face embeddings sentence transformer model, right? So here it created the embeddings, and the model loaded is this one, and this model will convert text chunks into numerical vectors, right? And you can also use OpenAI embedding model also. And then step number 4 is, once we create the embeddings in step number 3, we have to store them inside the vector database, right? So what we did here, we're trying to print this and number of text, because we have a total 7 chunks, right? That is what we are trying to print here, length of chunks, total 7 chunks. So number of text 7, and embedding dimension is 384, and database location is ChromaDB, right? So this is where we have our embedding stored inside this ChromaDB, right? So if you go here, this was not created before, right? So now we got all the embedding stored inside this ChromaDB, right? So step number 4 is clear. Now step number 5, similarity search example, right? So we are asking a question, what is reinforcement learning? And we want to print the top 2 most relevant chunks out of these 7, right? So we asked what is reinforcement learning, and it is trying to print top 2 most relevant chunks. The result 1 is reinforcement learning is a type of machine learning where agents learn by interacting with an environment. They receive rewards for good actions and penalties for bad ones. So that is number 1. This is the most relevant chunk related to the question, what is reinforcement learning? And the second one is artificial intelligence AI is transforming the way we live and work. Machine learning, a subset of AI, enables computers to learn from data without explicit programming, right? So these are the top 2 chunks that it picked, and it retrieved those 2 chunks, right? And then the next step, step number 6, is we are trying to set up the RAG pipeline. First, what we did, we initialized our LLM. Here we are using Anthropic Claude. Instead of Anthropic Claude, you can also use OpenAI, or you can also pick a open source model from Hugging Face, right? And here we are trying to create the RAG pipeline, and we are using retrieval QA. This is one of the chain type, and here we stored our sample questions inside a list, and for each question, this is the list we are trying to loop in, and for each question we are trying to get the answer, and inside this chain we are calling the invoke method by passing the question, so we will get the answer, right? So what is the first question, what is reinforcement learning and how does it work? So that is question, and what is the corresponding answer, right? So where is this answer coming from? So it is trying to read the embeddings that we stored inside our vector database for all this input document, right? Now let me go back to these questions. So first question number 2, what are the main applications of computer vision? And this is the answer. And the question number 3 is, how is NLP used in real world applications? That is question number 3, and this is the answer, right? So with this, you understood all the 6 steps. That is, before going to the steps, first how to get the keys, right? The API key, and how to prepare your input document, and then creating the chunks, and then creating embeddings, and then storing them in a vector database, and then asking a question, creating a RAG pipeline, and ask the question, so you will get the answer, right? This is kind of a question answer system, which is nothing but a chatbot, right? So now with this, you understood why we are using LangChain in order to build a RAG application, right? Because we have a lot of built-in functions available inside LangChain, so it will be easy for us to build a RAG application, right? And majority of the generative AI applications are built by using this LangChain and RAG, right? With this, I hope you got a clear understanding on how to build a RAG application by using LangChain, right? And next, we have different other components inside LangChain, like I said before. We have prompt engineering, that is how to ask a right question and get the right answer, which is nothing but prompt engineering. And we have different chunking techniques available. Here we used recursive character text splitter, right? So similar to recursive character text splitter, we have different other chunking techniques available, which we will deep dive in the next section. And we also have other vector databases. Instead of ChromaDB, we have other vector databases too. We will deep dive into that. And chains also, we have different chains available. This is one of the chain. And the other topics are how to use different tools and agents and memory, and how to do the search technique and query expansion, that is to generate multiple queries so LLM can answer, right? Not just one question, that is multiple question, and how to evaluate the results that we get from the LLM, right? So once you know all other components, that is prompt engineering, chains, tools, agents and everything, then you will be able to build a end-to-end generative AI application, right? So I hope you got a clear understanding on how to build a RAG application by using LangChain, right? So here we try to ask questions and then get the answers from the LLM, right? All right, thank you. So let's try to understand the vector databases that we have for building the RAG systems, right? In RAG, as we learned in the previous lecture, we need a vector database to store our embeddings, right? So that is why we have different kinds of vector databases. We have Pinecone, Chroma database, which we have already seen in the project, right? And Viviet and Milvus and Facebook AI similarity search, right? This is also known as FIS. So we have different kinds of vector databases available, right? So let's learn one by one. Pinecone, this is a fully managed vector database designed specifically for machine learning applications, right? And here I have listed the key features best used for and the limitations. So the key features are, it is a serverless architecture with automatic scaling, and we have real-time vector search and updates, and it has support for hybrid search, high availability and data replication, and it also has pod-based architecture for performance optimization, right? So you know pod, it is a set of one or more containers that share a common network and storage space, right? So this is best used for performance optimization, and Pinecone is best used for large scale production deployments, right? And it is also best used for real-time recommendation systems, semantic search applications, enterprise level RAG implementations, right? And the limitations are, it is expensive, right? Higher cost compared to self-hosted solutions, and limited control over infrastructure and fixed pricing tiers, right? So keep these in mind when you are trying to pick the vector database, right? So that's about Pinecone. And the next one is Chroma database. This we have already seen in our project, right? Chroma database, it is an open source embedding database designed for RAG applications with focus on simplicity, right? What are the key features? Embedded database with no separate server required. So this is easy to use, and it is simple Python API, and we have support for multiple embedding models. We have already seen this. Persistent and in-memory storage options, right? So we have already seen this. We were able to store our embeddings in the vector database, and we stored them locally on our machine, right? And it is easy to integrate with LangChain. This part also we have already seen. And it is best used for prototyping and development, right? So let's say if you want to build any proof of concept quickly, then you can use this Chroma database to store our embeddings, and it is best used for small to medium sized applications and local development and testing, quick proof of concept projects, right? If you want to build something real quick, then you can use this Chroma database to store the embeddings. And what are the limitations here? Limited scalability for very large data sets. So like I said, this is only used for small to medium sized applications, and it is not applicable for production level applications, right? And it has fewer enterprise features, and there is no built-in clustering capabilities. right? You know clustering, right? So clustering is a machine learning technique that uncovers patterns hidden within the data, right? So if you use Chroma database, we don't have built-in clustering capabilities, right? And the next one is Weaviate. So Weaviate is an open source vector search engine with built-in vectorization capabilities, right? So what are the key features? It has GraphQL based query interface, right? And GraphQL is an open source data query and manipulation language, right? So we have GraphQL based query interface in Weaviate, and we have built-in vectorization modules, multi-tenancy support. That means that a single instance of the software, and it will support infrastructure that can serve multiple customers, right? So that is multi-tenancy support. And CRUD, create, read, update and delete, right? So you can perform all these operations on vectors, and it has Docker first deployment, right? And Weaviate is best used for complex search applications, right? And it is also best used for self-hosted production deployments, and it's best used for applications requiring custom schemas. And sometimes you may require to build custom schemas, right, when you are building an application. So in that case, you can pick Weaviate. And if your project needs GraphQL integration, then you can pick Weaviate. And what are the limitations here? Steeper learning curve, because first you have to get familiar with this GraphQL based query interface, right? So there is a learning curve involved, and it is more complex setup compared to simpler solutions, and it requires more infrastructure management, right? This is used only for the complex search applications, right? And the next one is Milvus. Milvus is an open source vector database built for scalable similarity search, right? And what are the key features? It has horizontal scalability, means it is a process of adding more instances of the same type to the existing pool of resources, right? So that is the use of Milvus. And it has got multiple index type support, cloud native architecture, advanced filtering capabilities, and it has support for multiple vector similarity metrics, right? And Milvus is best used for large scale deployments, and it is best used for complex similarity search applications, enterprise search solutions, and it is best used in computer vision applications, right? And what are the limitations here? It is complex deployment and maintenance when compared to other vector databases, and it requires significant resources as well. And the other limitation is steeper learning curve for optimization, right? And the next one is FAIS, right? So Facebook AI Similarity Search. This is a library for efficient similarity search and clustering of dense vectors. And what are the key features? Highly optimized for performance, multiple index types for different use cases, and it has GPU acceleration support, compact data storage, and it also has advanced clustering capabilities, right? And this is best used for research projects and high performance requirements and custom implementation needs, applications requiring fine-tuned control, right? And what are the limitations? There is no built-in persistence, right? So requires custom implementation for many features, and it has got limited metadata management. So that's about Facebook AI Similarity Search, FAIS. And now let's try to compare these vector databases with the features. When it comes to ease of use, like we saw this Chroma database, this is very easy to use and it is also free, right? And after Chroma database, we have Pinecone is easy to use, and Weaviate and Milvus, they are in a medium, and FAIS is low, right? So if you want to build something real quick, like a proof of concept, then you go for Chroma. And when it comes to scalability, Milvus is ranked very high. Next one is Pinecone and Weaviate. These two are high, and FAIS is medium, and Chroma database is low. If your application requires scalability feature, then don't go for Chroma, right? So you know you can best use Milvus. And managed service, Pinecone S, Chroma database no, Weaviate optional, Milvus optional, and FAIS is no. And cost, both Chroma and FAIS are free, and Pinecone is high, and Weaviate and Milvus are mixed, right? And when you are building production ready applications, then you go for Pinecone or Weaviate or Milvus. And Chroma database, you have only limited support, and Fias requires some work, right? So there is a lot of learning curve and it requires more work when you use Fias, right? So when you're trying to select a vector database, try to consider these factors. Scale, that means how many vectors will you store and search, right? And the next one is performance, that is what are your latency requirements. Budget, what's your infrastructure and maintenance budget. Expertise, what is your team's technical capability. And features, right? Do you need specific features like filtering or clustering, right? So you keep all these different factors in mind when you're trying to select a vector database, right? And what are some of the common use cases? So if you are building in generative AI application that requires semantic search, then you go for Pinecone or Weaviate. For RAG applications, Chroma database or Pinecone database, right? So we have already seen how to use Chroma database when building RAG application, right? And for research projects, Chroma database or Fias, right? And for enterprise solutions, Milvus or Pinecone. For prototyping, that is proof of concept projects, you can go for Chroma database or Fias, right? And we have already seen how to implement RAG applications by using Chroma database, and we have already went through all the key features of different other vector databases as well. And depending on your requirement, you can deep dive into other vector databases, right? Thank you. Now let's learn the different text chunking methods that we use when building RAG systems, right? But before we start learning these different chunking methods that are supported by LangChain, let me quickly summarize what we learned in the previous lecture on RAG and why do we need these chunking methods, right? So let's say if you ask an LLM what is the weather today, right? So LLM has a cutoff date on when it was last trained, right? So we are asking a question which is related to today, right? So it goes to internet, that is tools, and searches and retrieves the answer for us, right? And question number 2 is, let's say if you ask any question related to your company specific HR information, right? That is specific to your domain. Then it goes to vector database, processes, and retrieves the answer for us, right? So this is the process of RAG, right? RAG is nothing but a search on your domain specific data, right? And then let's say question number 3 is what is LangChain, right? So this is a general question. For general intelligence, LLM will not use RAG, right? Because it already understands and retrieves the answer for us, right? So depending on your input, you have to choose which one to use, right? And we also learned context window, right? So first of all, why do we need to chunk our input data? Whenever we try to build any generative AI applications, we need to keep the LLM context window in mind, right? We already learned that each LLM has its own context window size. So context window is nothing but your input plus the response, that is output, together total number of tokens. Input tokens plus output tokens all together is nothing but your context window. And we cannot pass the whole input document, right? If the document size is really big, for example, let's assume your input document size is in gigabytes or petabytes, right? And if you try to pass these huge documents which are beyond LLM's context window size, then the LLM cannot process that data, right? So to avoid this LLM context window limitation, what we are trying to do, the easiest option is to divide the input document into chunks, right? So that is the reason we are trying to chunk our input document to avoid the context window limitation, right? Now let's try to learn different chunking methods that we use when we are trying to build a RAG application, right? So let's learn what kinds of chunking methods LangChain supports, right? So text chunking is a crucial pre-processing step in RAG, retrieval augmented generation systems, where documents are broken down into smaller manageable pieces, right? So we've already seen this creating chunks in our question answer RAG application, right? And we have different chunking methods: character based chunking, word based chunking, sentence based chunking, paragraph based chunking, overlapping chunking, and semantic chunking. And we have already seen recursive character text splitter, right, which we have used in our RAG question answering project. So let me quickly show that so you will relate to that. So if you see here, we used recursive character text splitter, which is inside LangChain text splitter, and we have used this and created our chunks, right? So we got the text splitter and then we used a split text method to get the chunks. So similar to recursive character text splitter, we have different other chunking methods. So let's learn one by one, right? So what is character based chunking? It splits text into chunks based on a fixed number of characters. That is, divide your whole input data based on characters. For example, 100 characters per chunk. That is, whenever 100 characters completes, then it will chunk there. So if you see here, we have this input text and we have a total of 448 characters. And whenever it completes 100 characters, it will chunk there, right? And it is simple and straightforward approach. It doesn't consider semantic meanings or natural breaks. And what are the advantages? It is easy to implement, right? So wherever it completes 100 characters, just chunk there. And consistent chunk sizes, because all the chunk sizes are just 100 characters. Works with any text format, right? And what are the disadvantages with this character based chunking? May break words and sentences in unnatural places. For example, if you see here, the 100 characters is at off, right? So after off, it is trying to chunk. So machine learning a subset of, right? So it chunked there. So with that, what will happen? It doesn't preserve context or meaning. So it will be hard to preserve the context and it can create chunks that are hard to understand in isolation. So this is one chunk, and then from AI, again next 100 characters, right? So that is one chunk, right? So because of this character based chunking, it is really hard to preserve the context or meaning, right? And then the next one is word based chunking. So what it is, it divides text into chunks containing a specific number of words. For example, let's take this input text, right? So we have a total of 68 words. And let's say if you're trying to divide 50 words per chunk. So from artificial intelligence until AI. So this highlighted portion is 50 words, right? So we are trying to chunk by number of words. So it preserves word boundaries more natural than character based chunking. In character based chunking, so let's say if it completes 100 characters at O, right? So we will lose the context, right? So at least with word based chunking, it preserves word boundaries and it is more natural than character based chunking. This word based chunking is better than character based chunking. And what are the advantages? It prevents word splitting, right? With the character based chunking, we may end up splitting the words, but at least this will prevent word splitting, and it is more predictable chunk sizes in terms of content, right? And it is better readability than character chunks. And what is the disadvantage of using word based chunking? May still break sentences midway, right? So here if you notice, we have a total of 68 words and we are trying to divide 50 words per chunk. So it chunked midway of this sentence, right? And it doesn't consider natural paragraph breaks, right? So it is not trying to consider all the way till language period, right? So this is the paragraph break, right? So it is not trying to consider till here. It is trying to chunk wherever it completes 50 words, right? And chunk sizes can vary significantly in terms of characters, right? But at least this word based chunking, this is better than character based chunking. Okay. And the next one is sentence based chunking. So what is sentence based chunking? Groups a specific number of sentences together. For example, if you see, this is our input text, right? If you notice here, we have 5 sentences here. And let's say if you're trying to divide 2 sentences per chunk, right? So with sentence based chunking, it uses natural language processing NLP to identify sentence boundaries. and it preserves complete thoughts and ideas, right? So we are not chunking in between the sentence. So at least we will be able to preserve the context. And what is the advantage of using sentence-based chunking? It maintains sentence integrity. It preserves natural language flow, so it will be easy to understand, right? And better context preservation, more meaningful for NLP tasks, right? So if you are trying to build a generative application and trying to solve an NLP task, right, then in that case better you use sentence-based chunking. But what is the disadvantage of sentence-based chunking? Chunk sizes can be very uneven, right? So some sentences can be very long and some sentences can be very short, right? So chunk sizes can be very uneven. And long sentences might create oversized chunks, right? And also it requires reliable sentence boundary detection, right? But at least this sentence-based chunking, this is better than both character-based chunking and also word-based chunking. But this sentence-based chunking, this is best used when every sentence in your input document has meaning, right? For example, emails or your client invoices or WhatsApp chat messages, right? We can use these sentence-based chunking. So depending on your input, we need to pick the right chunking method. And this sentence-based chunking method is best used for small size input documents, right? And the next one is paragraph-based chunking. So what is paragraph-based chunking? This uses paragraph breaks as natural chunk boundaries, right? For example, let's say this is our input text. If you notice here, we have 3 paragraphs and we are trying to divide every 2 paragraphs into one chunk, right? So it preserves document structure and maintains complete topics or ideas. So each paragraph will have its own meaning, right? So at least we can try to preserve the context, right? What is the advantage of using this paragraph-based chunking? It preserves natural document organization and it keeps related content together, maintains author's intended structure, ideal for well-formatted documents. For example, let's say if you are using your 10K financial input company report, right? So this is usually, the 10K report is usually in a standard fixed format, right? So each paragraph will have its own meaning and it doesn't need to rely on other paragraphs, right? So first you can try to chunk based on paragraphs and then chunk again based on subtitles or rechunk further, right? So you can use this paragraph based chunking when the input document format is very standard, right? And what are the disadvantages of using paragraph based chunking? It can give highly variable chunk sizes, right? For example, let's say you have an upload button and if user is trying to upload different size of documents, right? Then one paragraph can contain only 1 or 2 lines or maybe other paragraph can contain hundreds of lines, right? So if the user is uploading different size of documents, then this may not be a good idea, right? So use this paragraph based chunking only if you know the input format of your system, right? And the other disadvantage is it depends on consistent paragraph formatting. And if you know your input document paragraph formatting and if it is consistent, then only you go for paragraph based chunking. And it may not work well with poorly structured text, right? So it has to be in well formatted structure, then only you go for paragraph based chunking, right? And the next chunking method is overlapping chunks. So overlapping chunks creates chunks that share some content with adjacent chunks. For example, let's consider this is our input document text. Let's say if you are trying to chunk till data, right? And then again you are trying to overlap from enables till data in the next chunk, right? So that is overlapping chunking, right? It uses a sliding window approach, right? So this will help maintain context across chunk boundaries. So from artificial intelligence till data we are chunking. And then again from enables till next chunk. So we are trying to overlap the chunks, right? So what is the advantage of overlapping chunks? We will get better context preservation and reduces information loss at chunk boundaries, right? Because we are trying to overlap and it improves retrieval accuracy, helps with context dependent queries. And what is the disadvantage because we are trying to overlap, so that means more tokens, right? So it increases storage requirements and it creates redundant data, right? So first chunk will have this data and second chunk also will have this overlap data, right? So which can create redundant data, and it may require deduplication in search results. So in your search results we may see duplicate results, right? And it is more complex to implement than other chunking methods. And we have already used this overlapping chunking, right? And we generally apply overlapping chunks along with either paragraph or word or sentence chunking, right? And how many overlaps we use? This again is a user defined parameter. So this may or may not work all the time. For example, let's see our code. So if you notice here, we have used overlapping size of 50, right? So this is a user defined parameter. And depending on your input document, you have to pick this parameter by trial and error, right? So this may or may not work for varying input documents, right? So that is one of the disadvantages of using overlapping chunks. And the next one is semantic chunking. So semantic chunking splits text based on semantic patterns or rules, right? So if you notice in our code, we are using this pattern. Whenever you see two new lines or one new line or period or space, try to chunk here, right? So that is what we are telling. Or semantic chunking uses natural topic boundaries and it considers document structure and content meaning. So with semantic chunking, it maintains logical content grouping, preserves topical coherence, better for knowledge retrieval, more natural for human comprehension. And what are the disadvantages? Complex to implement correctly, and it requires sophisticated pattern recognition and maybe domain specific, can be computationally intensive. This is one of the most famous chunking method. That is 80 to 90% of the cases we use this semantic chunking because we can try to preserve the context, right? And based on semantic meaning, we are trying to chunk here, right? Whereas in other cases, we are trying to give the chunk size or chunk overlap. We are actually relying on some parameters. But whereas in semantic chunking, we are just relying on a pattern. For example, let's say you have a Markdown file, right? Or HTML file as input. In that case, you go for semantic chunking, right? For example, let's say when we are trying to create a Markdown file, right? This is the Jupyter notebook. And if you give hash heading 1 and click run, so you can see how did we create this with hash, right? So there is a pattern here. And if I give 2 hash and then give heading 2 and run it, so select the Markdown and run. So this is heading 1, this is heading 2, and for heading 3 give 3 hashes, right? And then select the Markdown and run. So you can see this is heading 3, right? So we are able to create different headings by using this hash, right? So this is a pattern, right? So in Markdown, whenever there is a hash, right, it means a heading, right? So you can just tell in the code, whenever there is a hash, try to chunk. So with this semantic chunking, that is, there is a pattern here. So this is one heading. Under the heading, there will be some content, and second heading, there will be some content, third heading, there will be some content. At least with this pattern, we can preserve the context better, right? So majority of the times we try to use this semantic chunking, and LLM is smart enough to look for these markdowns, right? And it will try to understand the format easily. So before we try to use the input document, we have different packages available that can convert our input text and Office documents into Markdown, right? So for example, Duckling. So if you see this Duckling website, this is the Git repo. And if you see here, we have the code here, right? To convert individual documents with Python, use convert for example. So you provide the PDF document and it will try to convert into Markdown, right? So either you can use Duckling or you can also use Markdown, right? So Markdown is a Python tool for converting files and Office documents into Markdown, right? So once you convert your input document into Markdown, LLM will be able to understand this format very easily, right? So that is why you always try to convert your input document into Markdown and then you apply semantic chunking, right? And LangChain also supports duckling, right? So let me show you that. So this is our official LangChain duckling documentation, and we have duckling support from LangChain as well, and it is clearly documented here. You can try to explore more by checking these examples, right? But the objective of duckling is it tries to parse PDF, docx, PowerPoint or HTML and other formats into a rich unified representation including document layout, tables, etc., making them ready for generative AI workflows like RAG, right? So what we are trying to do, before we use our chunking methods, try to apply duckling, right? And then it will create a patterns, and then you apply semantic chunking. So that's about semantic chunking, right? So we talked about character based chunking, word based chunking, sentence based chunking, paragraph based chunking, overlapping chunking, and semantic chunking. All right, thank you. So let's talk about some of the best practices when you're trying to choose a chunking method, right? So we learned we have different chunking methods like character based chunking, word based chunking, sentence based chunking, paragraph based chunking, overlapping chunking, or semantic chunking, right? So we have different chunking methods. So let's see the best practices, right? So first thing is consider your use case. For example, let's say if you're trying to build an application with simple text storage. So in that case, go for character based chunking, right? So character based, or you can also use word based chunking. For example, let's say if you're building question answer system, right? In that case, go for sentence based chunking, right? Sentence, or you can also use paragraph based chunking. This will work best. Either sentence based or paragraph based chunking method is best when building question answer system RAG applications, right? And if you're trying to build an application that has technical documents, right? So in that case, go for semantic chunking, right? So depending on your use case, you have to pick a right chunking method. And the second best practice is think about your content, right? For example, if your input document has well-structured documents, then you go for paragraph-based chunking. And if your input document has technical documentation, then you may want to use semantic chunking, right? And the input document has news articles, right? So in that case, sentence-based chunking will give best results, right? And the third best practice is consider your model, right? Because some LLMs have specific token limits, right? So we already know each LLM has the context window size, and context window size should influence chunk size also, right? And also try to consider model's ability to handle context, right? So you have to pick the right model also, right? So depending on your model, you have to pick the right chunking method. And balance trade-offs, right? For example, chunk size versus context preservation, right? So if you want to preserve the context, obviously you need more chunks, right? So you have to balance between chunk size versus context preservation, or processing speed versus chunking quality, right? So obviously if you have more chunks, then it will take more processing time, right? So you have to balance between processing speed versus chunking quality, or storage requirements versus retrieval accuracy, right? So more chunks, it will take more storage. So you have to balance between storage requirements and retrieval accuracy, right? So keep these different best practices in mind when you are trying to pick a chunking method. All right. Thank you. So we understood different text chunking methods that we use when building RAG systems, right? So we have character based chunking, word based chunking, sentence based chunking, paragraph based chunking, overlapping chunking, and semantic chunking, right? And like I said before, text chunking is an important pre-processing step when building any RAG system, right? That is retrieval augmented generation systems, right? And always remember that the best chunking method often depends on your specific use case, content type, and the requirements of your RAG system, right? And sometimes you might even need to combine multiple chunking methods, or you may want to create your own custom chunking method approach for optimal results, right? Now let's see the demo. Let me go to our code editor, VS Code. So I think I didn't show you how to create a workspace before when we are building RAG application, right? But you can click on save workspace as, and you can name anything. Here I named build generative AI applications, right? So everything will be in one place, right? And then you can create separate folders here. Once you create the workspace, here I opened RAG demo and I saved it here, right? So this is how we created our question answer RAG application, right? So now let's see different chunking methods. So if you see here, I created an empty folder, chunking methods demo. Now let's try to add the empty folder that we created to the build generative AI applications workspace. Come here to the Explorer and right click and add folder to workspace and select this folder and add, right? So now we are inside chunking methods demo, and here try to create a new file, and it is Python file, right? And let's save it as character text splitter demo and save it, right? So inside RAG demo folder, we built the RAG application before, right? So let's close this, and then inside chunking methods demo, I created a new Python file and I named it character text splitter demo, right? Now let's see how we can use character text splitter, right? So before we do anything, first we have to install all the required packages. So here, like I said, we are using LangChain packages. So make sure you install LangChain, right? You have to go to the terminal, click on view and terminal, right? So here you can enter pip install LangChain and hit enter. And then the next one is pip install LangChain text splitter, right? And then hit enter. And then pip install tick token, hit enter. Either you can give this way or you can give all in one line also. Just give spaces, space, LangChain text splitter and all the three packages in one line, right? So this is how you will install all the required packages, right? So once you install all these required packages, now let's try to import the required packages. Since we are trying to use character text splitter, I imported character text splitter from LangChain text splitters, right? So once you import that, the first thing is we have to prepare our input document, right? So I'm taking this sample text as our input document, right? So this is our input document text, right? So this is our sample text. Here you can replace with any text you want. This is your domain specific data, right? So let me save this. And once we have the input text ready, then let's see how to implement character text splitting, right? So let me just add a print statement, character text splitter example, and we know character text splitting is best used for simple text splitting, right? Now we have to make use of this character text splitter which is inside LangChain text splitters, right? So let's use that. So inside character text splitter, we have these three parameters: separator, chunk size, chunk overlap, right? And we are trying to separate by two new lines. So wherever we have two new lines inside our input document, then chunk there, and the chunk size should be 200 and chunk overlap is 50, right? We already know these two parameters, right? It will try to divide by 200 characters with an overlap of 50, or within 200 characters in case if there is this pattern, two new lines, then it will chunk there, right? Now inside this splitter, we know we have split underscore text method, right? So let's use inside the splitter, we have split underscore text and pass our sample text, that is our input document, right? Once we pass it, then we will get the chunks. Now let's try to print the chunks that we have inside the chunks, right? So let me save it and click on run. So now you can see we have our chunks. Let me go to our input text, and if you see, this is our first chunk, right? Because we see two new lines here. This is our first chunk, and from here till here, right? This is our second chunk, and from here this is the third chunk, right? And so on, right? So now we got the chunks. Now if you want to see the data type of these chunks, you can use type method, and let's run it. So now you can see this chunks is of type list, right? So inside the list we have all the chunks available. Now let's try to loop in so we can read the individual chunks, right? So what we are using, for loop, for each chunk inside this chunks list, I'm trying to loop in and then get each chunk, right? So now let me rerun the code. So now you can see we have a total of 6 chunks, right? So the first chunk is Introduction to Machine Learning. So if you see here we have new lines, right? So that is why it chunked there. And then the next chunk is still here, because after this we have a new line. And then the next chunk is till here. And then the fourth chunk is till here. And then the fifth chunk is this. And then the last chunk is still here, right? So that is how we can implement character text splitter and divide our input document by number of characters, right? So let me quickly explain what we did here. First thing is we installed all the required packages here. In fact, you actually don't need this tick token now. That is used in another chunking method. I will explain later. So make sure you install these 2 required packages and then try to import character text splitter, because that is what we are using to split our input document by character chunks, right? And then we prepared our input document here. So this is our input document. Here you can replace with any content you want. This is specific to your domain, right? And then here I'm just trying to print, and then we are using character text splitter, and the separator is 2 new lines, right? So whenever there are 2 new lines, it will try to chunk there, and the chunk size is 200 and chunk overlap is 50. We are trying to overlap 50 characters from previous chunk, right? So that is what this chunk overlap is. And inside this splitter we have split underscore text. We have to pass our input text here, so we will get the chunks, and this chunks is of type list, right? Now we are trying to loop in each chunk inside this list and trying to print it here. And this is how it divided the whole input document into 6 chunks, right? So I hope you understood this character text splitting, right? And this character text splitter is best used for simple text splitting, right? Thank you. So we have seen character text splitter, right? So what it did, every 200 characters it tried to chunk, right? And all these parameters are user defined parameters, right? So you can experiment here. If the separator is present, that is 2 new lines is present within the chunk size of 200 characters, it will try to chunk there. This is what we learned in the character text splitter. Now let's see the next chunking method, that is recursive character text splitter, right? So inside this chunking methods demo, let me try to create another Python file and let's save it, recursive character text splitter demo. And now, like I said, in case if you did not install any of these packages, make sure you install LangChain and LangChain text splitter, right? And once you install, the next thing is we have to import them, import the packages. Here we are not using character text splitter. This is recursive character text splitter, right? So make sure you import recursive character text splitter from LangChain text splitters, right? So once you import the module from this package, the next step is, let's see how to implement this recursive character text splitting, right? So let's take the same input. So I'm copying from character text splitter demo, right? So I'm taking the same input document and let me just try to print recursive character text splitter example, and this is better for preserving context. So now let's use of this recursive character text splitter and split our input document, right? So inside recursive character text splitter we have 4 parameters here. The first one is separators. Here we are giving separators as 2 new lines or 1 new line or period or space, and the chunk size is 150, chunk overlap is 30, and the length function is we are telling it to use len, right? So what we are telling to the recursive character text splitter, whenever there are 2 new lines or 1 new line or period or space, then you try to chunk there, and each chunk size is 150 characters and chunk overlap is 30, right? It will try to overlap 30 characters from previous chunk, so that we can preserve the context. So that is the advantage of using this chunk overlap. And if you notice, what is the difference that you can identify between this character text splitter and recursive character text splitter, right? If you see here, inside character text splitter, you can only define one separator, right? Here we only define two new lines. Whereas in recursive character text splitter, we can define multiple separators. If you see, we defined two new lines, one new line, period and space, right? So inside character text splitter, we are able to define multiple separators. So that is one of the difference between character text splitter and recursive character text splitter, right? So what we are telling here, if the separators appear within the chunk size of 150, then it will forcefully do the chunk by the separator, even though we defined the chunk size as 150, right? We already know that. And once we get the splitter, the next thing is we have to call split text method. So we will get the chunks. And we know this chunks is of type list, right? So we got list of chunks. And now let's try to loop in so we can print each chunk inside the chunks list. So what we are doing here, we are trying to loop in this chunks list and we are trying to print chunk 1, what is the value, chunk 2, what is the value, right? And save it. Now let me run this file. So if you see, this is where we ran, right? Recursive character text splitter example. This is better for preserving context. So if you notice, how did we divide? Let me take you to the input document. So this is our input document, and if you see, we gave our separators as two new lines or one new line or space or period, right? So that is how it will try to chunk, right? So it chunked one here and the other one here because there is a period, right? And then from here till the end of this sentence, and then the fourth chunk is still here and fifth chunk is still here, and then the sixth chunk is till here, and then the next chunk, seventh, right, till neural networks, and so on. So it created a total of 12 chunks by using these separators, right? So that is how you can use recursive character text splitter, and by using recursive character text splitter, you can define multiple separators. So that is the advantage of using recursive character text splitter. And if you notice, we already used this recursive character text splitter inside our RAG application, right? So let me quickly open this RAG demo file, and here you can see recursive character text splitter, and we are using the same separators, right? And this is our input document before, right? So what we did here, first we installed all the required packages. This is not required to install every time. So once you install here, you don't have to install again here, right? But make sure you install these required packages in case if you don't already. We have to import recursive character text splitter module from LangChain text splitters package, and this is our input document, and here we are trying to just print this line. And what we are doing here, we are using recursive character text splitter, and we have these 4 parameters. The first one is to define the separators. Here we can define multiple separators, and the chunk size is 150, so we are telling it to divide by 150 characters, and chunk overlap is 30, so it will try to overlap 30 characters from the previous chunk, and the length function is len. So even though we define chunk size as 150, it will forcefully try to chunk whenever there is a separator with this pattern, right? So that's how you can use character text splitter, and this character text splitter is best for preserving context, right? Thank you. So far we have seen character text splitter demo and also recursive character text splitter demo, right? And the next one is, let me try to create a new Python file here. So we can see the third chunking method, which is nothing but Markdown header text splitter demo. So this is our third chunking method, and like before, in case if you haven't already installed the packages, make sure you install LangChain and LangChain text splitter packages, and then we have to import our required modules here. So we don't need recursive character text splitter here because we are trying to do Markdown header text splitter, right? So let's try to import Markdown header text splitter from LangChain text splitters, right? And then again, I'm taking the same input document. This is our sample text that we are trying to chunk, right? And what we are trying to do with Markdown header text splitter, this is ideal for Markdown documentation, right? And I've already shown you Markdown, right, in Jupyter Notebook. So if you notice here, this is the 1 hash is for heading 1 and 2 hashes for heading 2, 3 hashes for heading 3, right? So we have this Markdown feature available inside Jupyter Notebook. This Markdown header text splitter is best for Markdown documentation, right? So what you can do before you even try to chunk by using Markdown header text splitter, first thing is you try to convert your input document by using duckling or Markdown, and then try to convert this input document into Markdown, and then you try to apply Markdown header text splitter, right? So that way you will get more accurate results, right? I've already explained in the previous lecture, but let me quickly show you what is duckling. So if you see here, so this is our Git repo, right? So you can pass your PDF document and you can try to convert into Markdown. And we also have Markdown. So this is the Markdown Git repo, right? So Markdown is a Python tool for converting files and Office documents to Markdown, right? So it will convert our input document into Markdown so that LLM will be able to understand these Markdowns easily, right? And we already saw this one too, LangChain duckling, right? So LangChain duckling parses PDF, docx, PPTX, HTML and other formats into a rich unified representation including document layout, tables, etc., making them ready for generative AI workflows like RAG, right? So we have duckling support from LangChain too. So it's clearly documented here. In case if you want to deep dive, you can go through this documentation. We have different examples here, right? So before we use this Markdown header text splitter and try to chunk our input document, before you do that, first thing is try to apply duckling on this input document. So that way LLM will be able to easily understand. But here I've already added this markdowns, that is 1 hash, 2 hash, 3 hashes, etc. But in case if your document doesn't have anything, you try to first pass this one to the duckling and then get this Markdown ready. Now let's see how to use Markdown text splitter, right? So here we are telling it to divide whenever these are kind of separators, right? So we are telling it whenever there are 1 hash or 2 hash or 3 hash, right? Then split there. So if you notice here, these separators are more reliable, right, than defining the chunk size. So if you notice here, we are telling chunk by every 150 characters, right? So these are user defined parameters. Whereas here, we are not defining any parameters here. Instead, we are telling chunk whenever you see these markdowns, right? So this is more reliable than either character text splitter or recursive character text splitter, right? And if you want to deep dive into this Markdown, I've already explained Markdown features in detail by using Jupyter Notebook, right? So please go through that lecture if you haven't already. So first we defined our pattern here, that is split by markdowns, right? And then now let's try to use this Markdown text splitter and try to create chunks, right? So we are using Markdown text splitter, and inside this we have a parameter called headers to split on, and we are passing this one. So we are telling it to chunk by these values, right? So whenever there is 1 hash or 2 hash or 3 hashes, these are markdowns, right? Inside this we know we have split underscore text method, right? So that we will get the chunks. And let me try to print and see what we have inside this docs, right? So let's run it, and now you can see this is the overall, but let me try to print each individual chunk, so that way it will be easy for you to understand. So let's loop in, and what we are doing here, we can get metadata of the header and the chunk belongs to which page, right? So we have methods from LangChain. So that is why we are using LangChain, right? Now let me save it and run. So now you can see document 1, and the header is, there is no header, content. What is the content here? This is the content. So if you see here, it tried to print till end of this, right? So whenever there is 1 hash, so that is the markdown, right? So it chunked till end of this one, and the second chunk is this part, right? And here there is no content, right? So that's why that it didn't print anything here. And the third one is, here we have this markdown, right? So it tried to chunk here. And the fourth one again is, here we have 2 hashes, right? So that's why we tried to chunk over here, right? So now you understood. So what we did here, first thing is we try to install the required packages and try to import the required module, that is Markdown header text splitter, from LangChain text splitters package, right? And then we prepared our input document here, and it already contained markdowns, right? But in case if your input document doesn't contain markdown, you can make use of duckling and then try to create these markdowns, right? And once you get the markdowns, then you can use Markdown header text splitter, right? And this is the pattern we are telling. So whenever you see these markdowns, then try to chunk there, right? So this is best used for markdown documentation, right? Thank you. So far we have seen character text splitter, recursive character text splitter, and then we also saw markdown header text splitter, right? So when compared to recursive character text splitter and character text splitter, this markdown header text splitter is more reliable, right? Because we don't have to worry about defining this chunk size or chunk overlap, right? Those are user defined parameters, right? We are just chunking by these markdowns. So this is simple and easy to use because this 1 hash means heading 1, 2 hashes means heading 2, 3 hashes means heading 3, right? So these are markdowns. Chunking by markdowns is more reliable than defining your user defined parameters, because these chunks are highly dependent on your input document, right? In case if you change your input document, you will have to adjust these chunk size and chunk overlap parameters also, right? So this markdown header text splitter is more reliable than other two chunking methods, right? Because by using this markdown header text splitter, we will be able to retain the context much better than other chunking methods. And we have these tools, this PyMo PDF, aim to make it easier to extract PDF content in the format you need for LLM and RAG environments, right? It supports markdown extraction as well as llama index document output, right? So we have built-in functions available here. So you can make use of this. And then first thing is you try to convert your input document into markdowns, and then you apply markdown header text splitter, right? And we also have one from Llama Parse, right? So this is the Llama index. Llama Parse is the world's first generative AI native document parsing platform built with LLMs and for LLM use cases, right? And what is the objective here? The objective of Llama Parse is to parse and clean your data, ensuring that it's good quality before passing to any downstream LLM use case such as advanced RAG, right? So you have different techniques available to convert your input document into markdowns, and then once you convert it, then you can apply markdown text splitter, right? So that way you can create the chunks and it is best for markdown documentation, right? And now let me show you one other chunking method. So file, new Python file, and let's save it, token text splitter demo. So again, in case if you haven't installed already, make sure you install now, and let me copy the same input here and save it. So here instead of markdown header text splitter, we are using token text splitter, right? And make sure you also need to install tick token. So install that package as well. And let me add the print statement here. And now let's try to use this token text splitter and try to create the chunks. So here we are passing chunk size as 100 and overlap as 20. And then we got the splitter. Now let's get the chunks by calling split underscore text method inside splitter, right? So that way we'll get the chunks. We are passing this sample text and we want to chunk by 100 characters and overlap is 20. And now we got the list of chunks. Now let's try to loop in each chunk, and chunk 1 is what is the value, chunk 2 what is the value, right? Now let me save it and run the code. Couldn't import tick token Python package. So we got an error here. Module not found error, no module name tick token, right? Line number 43. Okay, so it is not able to find this module. So let me try to install this package and then rerun the code, right? So whenever you see module not found, just try to install the relevant package, right? So what we are doing here, we are telling it to divide by 100 characters, right? So if you see here, we got a total of 3 chunks, right? So with the token text splitter, it chunks based on tokens, right? So with the chunk size and chunk overlap, these two are again user defined parameters, right? And it is complex to set these parameters that will work for all the scenarios, right? Because we are just hard coding this input document here. But in case if you change your input document, accordingly you have to change these chunking parameters also, right? So again, this is complex. And for example, let's say you built a question answering chatbot RAG system and assume there is an upload button to upload the input document, right? And in case if user uploads different formatting documents, for example PDF or one from PPT or document or Excel or text file, right? Different formatting documents with varying size, right? So each document with different size, meaning PDF has 100 pages or Word has 1000 pages, etc. Because the data is really complex, right? In real time, here we are hard coding just few lines, so we'll understand the concept. But in real time, the data is really complex, right? So you have to change your chunking parameters also according to your input document, right? So in that case, this chunk size and chunk overlap parameters are hard to control because we don't know what the user can upload, what kind of size the user is going to upload, right? The user can upload 100 pages or 1000 pages, right? We cannot really define these parameters for every single input, right? So it's better not to use this token chunking in that case. But when is this best used for? This is perfect for LLM token limit management, right? We know each LLM has context window limitation, right? So that is when this token text splitter is best used, right? So with this we learned character text splitter, recursive character text splitter, markdown header text splitter, and token text splitter also, right? So now you understood different chunking methods, and the chunking is very important. Whatever you chunk, accordingly you will retrieve the answer as the output, right? Because what we did in RAG application, we chunked our input document and we created embeddings and we stored inside our vector database, right? And whatever we stored, those will be retrieved, right? So that is why this chunking is very important. Whatever you chunk, accordingly you will retrieve the answer as the output. So make sure the chunks contain semantic meaning in order for the model to predict accurate results, right? So now you know the LLM results depend on the way we chunk the input data, right? So with this, I hope you understood what chunking is and what are the different text chunking methods and practical implementation too, right? So try implementing these different chunking methods when you are building any generative AI applications, right? Thank you. So we understood how to chunk our input data and what are the different text chunking methods we have in the previous lecture, right? Now let's learn how to write a correct prompt, right? So writing a correct prompt is nothing but prompt engineering. That is, prompt engineering is the process of structuring or crafting an instruction in order to produce the best possible output from a generative artificial intelligence model, right? So before you start building any generative AI RAG application, first you need to know how and what kind of methods we have to ask the question in the right format. That is, provide the right context to the LLM so the LLM can understand in a better way and predict the accurate results for us. So we will cover these prompt engineering techniques, that is basic prompt, role, task, context prompt, few shot, chain of thought, constrained output prompting, right? And apart from these, Hugging Face has prompt engineering documentation as well. So let me take you there. So this is the Hugging Face documentation, right? And if you see here, we have the prompt engineering section where you can go here and see different examples. They've explained the best practices and few techniques here, few shot, chain of thought, fine tuning, and few examples, right? So you can go through this Hugging Face documentation. And we also have prompt engineering documentation in OpenAI as well. So if you go to OpenAI documentation page, you can see text generation and prompting, right? So here they have provided few examples and how to apply prompt engineering techniques, right? So let me show one other. So this is from Anthropic. So here also they have provided prompt engineering overview and when to prompt engineer, how to prompt engineer, and prompt engineering tutorial as well, they are provided here. So you can go through Hugging Face, prompt engineering, or OpenAI, or Anthropic, right? So they have few documentation there. You can deep dive these articles. The concept is the same. You can apply prompt engineering for any model. There is nothing technical here, right? It's more of common sense with the way we ask a question to the LLM, right? So it's just the way we ask a question so the LLM can understand and predict more accurate results for us. And in order to ask a question to LLM, first thing is you need to get the OpenAI API key, because we will be using OpenAI. So first thing is go to OpenAI and get the API key. You can also use any free model from Hugging Face too. So go to Hugging Face and get the key if you prefer to use a model from Hugging Face, right? So why are we getting the key? Because prompt engineering meaning we are interacting with the LLM and we need a key to connect to the LLM, right? So we will be using OpenAI LLM. So let me show you how to get the API key from OpenAI, right? So first thing is you have to go to OpenAI. Just go to Google and type OpenAI API key and click on this one, OpenAI platform, right? platform.openai.com API keys, right? So just click on this and make sure you create an account here. The registration is straightforward. The instructions are pretty clear, and as it is confidential information, that is, it involves your address and credit card information. I'm not showing the registration process. Otherwise, it is easy to create an account, and you should be able to move forward with creating an API key, right? So when you are creating an account, you need to provide your full name and have a password, and then it will ask you to provide your organization name and about yourself as well. So let me show a few screens so you will get an idea. So this is how it looks when you are trying to create an account. So you can see platform openai.com, welcome, step is equal to create. So this is how it looks when you are trying to create an account. So it will ask you to enter your organization name and what best describes you. Underneath you'll have very technical, somewhat technical, not technical, right? So you can provide your organization name and you can select whatever is best suitable for you, right? Very technical, somewhat technical, or non-technical, right? Then click on create organization, and then it will ask you if you want to invite your team as well. So if you want, you can add your team members also. Otherwise, you can click on I will invite my team later and click on continue, right? And then you have to provide API key name. You can name anything here, and the project name you can leave as default project here, and then click on generate API key, right? And then it will generate the key. So make sure you save the key securely so you can make use of it to make the API calls, right? And once you save the key, then click on continue, and you also need to add some credits here. So try choosing $5. I think that should be enough, because with $5 can cover about 2 million input or 500k output tokens. Plenty to start building your idea, right? So I think this $5 should be enough. So choose this $5 and click on purchase credits, right? And then you need to provide your credit card details, your address, and then click on add payment method. And after that, click on confirm payment. And once your payment is completed, then you will get an email from OpenAI saying that your OpenAI API account has been funded, and then you can start using your API key, right? And in case if you want to create a new key, just log into the account and click on API keys, and then click on create new secret key, right? So that way you can create another key as well. And also when your credit balance reaches $0, then your API request will stop working, right? So make sure you have some balance in your account, right? So have your key ready so we can learn different prompt engineering techniques. All right, thank you. So we have seen what is prompt engineering and what are the different prompt engineering techniques we have, and how to create an account in OpenAI and how to get the API key from OpenAI, right? Now let's see the different prompt engineering techniques that we have. The first one is basic prompt, right? So let me go to our code editor, VS Code, so we can see the basic prompt engineering technique implementation, right? So we have seen how to create a workspace and name it build generative AI applications. You can name anything. And underneath we have RAG demo and also chunking methods demo. So we have seen RAG application, how to build a question answer system, RAG application before. And then we have seen different chunking methods that we have: character text splitter, markdown header text splitter, recursive character text splitter, token text splitter, right? So let me close these two. And similar to RAG demo and chunking methods demo, I have created an empty folder called prompt engineering demo. So let me add this folder to this workspace, build generative AI applications, right? Right click and then click on add folder to workspace and then select prompt engineering demo and click add. So now you can see prompt engineering demo. This has been added, right? So now select this folder and then click on file, new file and select Python file and let's save it. So make sure you go to prompt engineering demo, right? And then let's name it basic prompt demo and save it, right? So underneath RAG demo, we have RAG application, and underneath chunking methods demo, we have chunking methods files, and underneath prompt engineering demo, we will be creating all different prompt engineering techniques here. So the first one is basic prompt. So first thing is we have to install all the required packages from LangChain, because we will be using the methods that we have inside LangChain in order to interact with the OpenAI LLM, right? So what you have to do, click on view and go to the terminal, and from here try to execute these two commands, pip install LangChain community and pip install OpenAI, right? So pip install LangChain community and hit enter, and then pip install OpenAI and hit enter, right? So once the installation is complete, then you can import the modules that are inside these LangChain packages, right? So let me close this terminal, close this. Now let's try to import all the required modules, right? So first thing is we installed all the required packages with pip install command, and then the next thing is we are trying to import all the required modules, right? So this OS module is to read the key from the environment file, right? And remember, in case anytime if you ever get module not found, then make sure you install the corresponding package by pip install command, right? If you do not know the exact package name, then you can go to PyPy, that is Python package index, and double check the package name. For example, so here you can type OpenAI and hit enter. So let's say you want to use this, then you can see the command pip install OpenAI, right? So you can just copy this and then execute it, right? So that's how you can install any packages that are required, right? And what we did here, we tried to import all the required modules. For example, OpenAI we imported from LangChain LLMs, prompt template from LangChain prompts, LLM chain from LangChain chains, and chart OpenAI from LangChain chart models, right? So we have seen how to get the OpenAI key, right? So once you get the key, make sure you store it in an environment variable so you can read it from there and use it in our code, right? So let's go to prompt engineering demo, and underneath this folder, right click and create a file, and let's name it .env. And here let's create a variable API key, and you have to store your API key that you got from OpenAI, right? So you can name anything here. I'm just giving API underscore key, but you can name anything here and store your key here, right? And then save it. So once you save your key inside your environment variable, next thing is now let's see how to read the key and make use of it, right? So now let's read the OpenAI key from the environment file that we just created so we can make use of it, right? So let me close this. So the first thing is we need to load the environment variables from .env file, right? So we are using load underscore .env to load the environment variables from env file. Now the next thing is let's try to read the key. So we can use the module OS, and inside that we have get env function, and we have to pass the name that we used inside our environment file. Remember, we saved with this name. Whatever name you give inside your environment file, you have to provide that name here so that we can read the API key from this environment file. So let me store that API key inside this environment variable OpenAI API key. Okay, so far what we did, we installed all the required packages, and then we imported the modules from these packages, and we did load the environment variables from environment file, and then we read the key, and then the key we stored inside the OpenAI API key environment variable. Okay, now let's initialize OpenAI LLM by using this chat OpenAI, right? So this is how we initialized our LLM. So once we initialized our LLM, the next step is we need to define the prompt template, right? So we are defining the prompt template, right? So this is our basic prompt template, and there is no context here. So what we did here, we just created a basic template variable, and we are passing reply to this customer message, and inside the curly braces we are giving customer underscore message. This curly brace means it's a variable, right? So this variable makes the prompt more dynamic. Instead of hard coding the values, we are just passing by using this variable, and we will pass the value to this variable when we call the function now. And once we define the basic template, that is our prompt template, the next step is let's use prompt template, right, which is inside LangChain, and define the variables that we have inside our prompt, right? So that is our next step, right? So what we are doing here, we are using the prompt template which is inside LangChain prompts, and we are creating our basic prompt. And here we have two variables. The first one is input variables, and then the second one is template. For the input variables, make sure you give the same name. Whatever you defined inside your basic template, you have to provide the same name here. That is our input variable. And the second one is template. For template, we are giving whatever basic template we defined before, we assign that to template, right? So that's how we created our basic prompt. So what we are doing here, we are passing the question and also the template, right? Now this prompt template, it will be passed to this LLM chain, right? Don't worry about these chains. We have a separate section for chains. We will deep dive into chains, right? So the next step is create a basic chain by using this LLM chain. So what we have to do here, we have two parameters. First one is LLM. For LLM, we already initialized our OpenAI LLM by using chat OpenAI. So we are assigning that. And the second parameter is prompt. For this, we already created basic prompt here, right? So we are assigning this variable. So with this, we created our LLM chain. So here we are chaining LLM and also the question, that is our prompt, together into one by using this LLM chain. Now once we have LLM chain ready, let's try to write a dummy customer message here. We haven't passed any value here. Now let's try to pass the value to our customer message variable. So if you see here, this is just a dummy message. So this is kind of a frustrating message from the customer. I have been waiting for 2 hours for your delivery and it still hasn't arrived. This is absolutely unacceptable. I paid extra for express delivery and this is what I get. I want my money back immediately, right? So the customer is very angry, right? So instead of this message, you can replace with any other customer message you want, right? Whether happy message or angry message or frustrated message or slightly angry message, right? So whatever you want, you can replace here. So we passed the message to the customer message variable, right? Now we have our chain ready, right? So now let's run the chain and we can see the response from the LLM, right? So what we are doing here, inside our LLM chain, we have a method called run. To that, pass this customer message. So we can see the response from our OpenAI LLM, right? So make sure you save it. So what we did here, we installed all the required packages, and then we imported all the modules from the LangChain package, and then here we are loading the environment variables from env file. So we saved our key inside API key, which is inside our environment file, and we are reading the key here, and we are storing inside OpenAI API key. And the next thing is initializing our LLM, which is nothing but OpenAI, and then we are trying to define our prompt template, reply to this customer message. So if the customer message is this, then we have to see how our LLM will respond, right? In case if you want to change this customer message to a happy message, and then see how OpenAI responds, right? So you just try to change this message and then execute this code and see how the LLM responds, right? And then here what we are doing, we are using prompt template and passing our input variables. First one is the customer message, and then the second parameter is the basic template which we defined before. And then by using LLM chain, here we are passing both LLM and the basic prompt. These two are the parameters to LLM chain. So with this we created our chain. The next thing is we have to pass a value to this customer message variable, and then inside our LLM chain we have a method called run. So we are calling that method and passing our customer message. Now once you execute this, let's see how the LLM responds. So you can click on this run Python file, or you can click on run. Either you can do debugging or you can run without debugging also. Either way is fine. So let's try to click run Python file. So these are just the warnings. So it is telling us there are some deprecated methods. Instead of that, try using this. So it is just suggesting us to use the other methods that we have, right? So you can update accordingly. So you can see the LLM response here, right? I apologize for the inconvenience and frustration this has caused you. I completely understand your concerns, and I will do my best to resolve this issue for you. Please provide me with your order details so I can look into this matter right away and arrange for a refund if necessary. Thank you for your patience, right? So we passed this angry customer message, and this is how our LLM is responding, right? So now you got an idea on how to create a basic prompt, right? So instead of this message, you try to change to a different message and run the code and see how the LLM is responding, right? So here for LLM, we are using OpenAI, right? So we are trying to chat with OpenAI. We passed this message and then we got this response, right? So this is how you can create a basic prompt. So this is just a basic prompt. So let's see, instead of just passing this basic message, if there is any other way, right? Thank you. So in the previous lecture, we have seen the basic prompt engineering technique, right? Now let's see the next one, that is role task context prompt. So let me go to prompt engineering demo folder, click on this, and then click on file, new file, and select Python file, and let's save it. Inside our prompt engineering demo, I'm saving with the name role task context prompt demo, and click on save. So we created this Python file, right? Now let me go to basic prompt. So from here till initializing the LLM, this is all same code, right? So what we did here, if you already install these packages, you don't have to install again, right? In case if you did not install already, make sure you install these packages and then import all the required modules. And then here we are trying to load the environment variables from environment file, and then from environment file we are trying to read the API key, and then we are trying to store this API key inside OpenAI API key, right? And the next thing is we are trying to initialize the LLM. We are using OpenAI as our LLM, right? Now here we defined our prompt template, right? So similar to how we did for basic prompt, let's try to define our template for role task context prompt, right? So for example, let's assume this is how our template is. You are a highly professional customer support specialist at a premium tech company, and your goal is to address the customer's concerns while maintaining a calm and helpful demeanor. And here we're passing again a customer message variable, and this is how it should respond. Please provide a response that number 1 acknowledges the customer's feelings, number 2 addresses their concerns professionally, number 3 offers concrete solutions, number 4 ends with a positive note, right? So if you see here, what is role, task and context here? So role means here we are assigning a role as you are a highly professional customer support specialist at a premium tech company, right? And then we assigned a task or goal. The goal is nothing but to address the customer's concerns while maintaining a calm and helpful demeanor, right? And then here we are providing the context, right? So we will pass the context here as customer message, and then we are telling our LLM to respond in this way, right? So here you can see in the basic prompt we did not provide any role or task or context, right? But whereas in role, task, context prompt, here we are defining the role and the task or goal, and this is the context, and we are telling our LLM to respond in this way, right? So what we are doing here, you are directing an LLM on how it should respond, right? For example, let's say if your LLM is writing 4 sentences as the response, and we want LLM to write as 1 to acknowledge the customer's feelings, and the other one is to address their concerns professionally, and the next one is to offer concrete solutions, and finally end with a positive note, right? So here we are trying to provide more context, right? So role, task, context prompt is better than basic prompt, right? Because now the LLM understands its role, task and context to the problem we want the LLM to solve, right? For example, let's assume you want a travel itinerary, right? So you can write the role as you are a travel agent or a travel planner, and your task is give me budget friendly travel itinerary for different locations, right? And you can provide the context as I am traveling from location A to location B, and then return me the itinerary with. You can tell the LLM to provide the response as number 1 provide me the flight details, number 2 provide me the hotel details, number 3 provide me price details, and number 4 any other suggestions, right? So that is how you can define your role context template, right? And once you defined your template, as you know, the next step is creating the prompt by using this prompt template, right? So how do we define our role context prompt? Inside prompt template, we are assigning customer message to input variables and role context template which we defined before to the template variable, right? And then next thing is this role context prompt will be chained with the LLM by using LLM chain, right? So this is inside LangChain, right? So we are passing the LLM that we initialized before. For the prompt variable, we are assigning role context prompt which we defined before. So now we got the LLM chain. Now the next step is we have to run this, right? So inside our role context chain, we have a method called run. So let's try to run it and then print the LLM response. So we haven't defined the customer message yet, right? So let me copy this customer message that we have defined before. And now before we print, let's try to pass this same customer message. And now let's see how the LLM responds, right? So with the basic prompt, we saw the LLM response. Now with the role task context prompt, let's see how the LLM responds, right? Because here we provided the role and task and the context, and then how we want our LLM to respond, right? Now let's try to run the code. So click on run. So now let's see the LLM response here, right? Dear valued customer, I completely understand your frustration and disappointment with the delay in your delivery. I apologize for any inconvenience this has caused you. Rest assured, we take your concerns very seriously and we will do everything in our power to resolve this issue promptly. I will personally look into the status of your delivery and provide you with an update as soon as possible. In the meantime, I will expedite a refund for the express delivery fee you paid. Additionally, I will ensure that your order is processed swiftly and delivered to you at the earliest possible time. Thank you for bringing this to our attention, and please accept our sincerest apologies for the inconvenience. We appreciate your patience and understanding as we work to rectify this situation. Best regards, your name and customer support specialist at so and so company, right? So if you see here, because we provided more context and we provided more guidance to LLM, if you notice the response here, you can see first thing is we are telling it to acknowledge the customer feeling, right? So that is why it provided this one. And then we are telling address their concerns professionally, right? So that is why it is telling this. And then offer concrete solutions. So what is the concrete solution? We are trying to refund, right? And then end with a positive note, right? So now you see the difference between the LLM response with basic prompt that we did before, right? Here we did not provide any role or task or context, right? Whereas with the role, task, context prompt, we provided what is the role, what is the task, what is the context, and how we want the LLM to respond, right? So just by adding context, you can see the change in the LLM response, right? So remember, prompt engineering plays a major role in getting the right response from the LLM and to make sure the LLM doesn't hallucinate, right? So it's more common sense than technical when writing your prompts, right? So this is our role, task, context prompt. So what we did here, install the packages and we imported the required modules, and then we tried to read the key, and then we stored our OpenAI API key inside this variable, and then we initialized our LLM. We created our role context template with a role and goal and then more context, and we are telling the LLM to respond in this way, and then we passed these variables to prompt template and we got the prompt. And then the next thing is using LLM chain, we passed our LLM and the role context prompt that we defined before, and this is the same customer message, and we are calling the run method inside our LLM chain, and we are passing the customer message, and we saw the response from LLM by using role, task, context prompt engineering technique. All right, thank you. So far we have seen basic prompt and role, task, context prompt, right? Now let's see the next one, few shot. So if you want, you can combine both role, task, context prompt and few shot together. That way also you can try to build a prompt, right? It's not just one prompt, you can combine multiple prompts together. Let me go to our code editor VS Code so we can see the implementation of few shot. So this is how we built basic prompt, right? And then the next one was role, task and context, right? So now let's see the next one, file, new file, Python file. So let's save as few shot demo inside our prompt engineering demo folder. So we created this Python file. So just like how we did before, if you haven't installed already, make sure you install them. And then let me copy the same code here. So here we installed all the required packages, and then we are trying to import all the necessary modules from these LangChain packages. And then we loaded the environment variables, that is our API key from environment file, and then we stored our API key inside our OpenAI API key. And then here we initialize the LLM, which is nothing but OpenAI, by using chat OpenAI module, which is inside LangChain chat models package. So we know this already. So what is few shot? Few shot means to give some examples so that the LLM can understand the context. So we are providing the LLMs with several similar examples so the LLM can understand the context much better and provide the response accordingly, right? For example, let's say you are trying to solve a math problem, right? And you are providing LLM some context with examples. For example, if 1 plus 1 is equal to 2 and 3 plus 3 is equal to 6, then tell me what is 10 plus 10. So you provided 1 plus 1 is equal to 2, that is one example, and 3 plus 3 is equal to 6, that is another example. Then you are asking the LLM what is 10 plus 10, right? So you are providing the example so that LLM will understand the context and then it will provide the response for similar questions, right? So now let's define the template by providing the examples, right? So this is the example of few shot template, right? So what we are doing here we are providing the role. Role is nothing but you are a highly professional customer support specialist at a premium tech company, and the goal or task is your goal is to address the customer's concerns while maintaining a calm and helpful demeanor, right? And the next one is, here are some examples of good responses to angry customers. So let's say if your angry customer says, your product is terrible, I have been trying to make it work for hours and nothing helps. And we are telling the LLM to respond this way. I sincerely apologize for the frustration you are experiencing. I understand how valuable your time is and it's unacceptable that you have spent hours trying to resolve this. Let's work together to fix this immediately. Could you please tell me what specific issues you are encountering? I will guide you through the solution step by step, right? So if your customer says this, then you are telling the LLM to respond this way. And then let's say if another angry customer says, I want a refund right now, this is the worst service ever, then you want the LLM to respond this way. I completely understand your disappointment and I want to make this right for you. I will help you with the refund process right away. While I process this, could you share what specific aspects of our service did not meet your expectations? This will help us improve and prevent similar issues in the future, right? Now, please respond to this customer message. So what we are telling, if this is the customer message, then respond this way. And if this is the customer message, then respond this way. And now, if you give another customer message, then LLM has to respond, right? So that is our intent with few shot. So what we are doing inside few shot, we are providing the role and the task and then few shot. That is meaning guiding the LLM with some examples. If customer intent is this, then you LLM respond this way. And if the customer message is this, then you respond this way, right? And LLM is smart enough to understand these examples and respond to any other question accordingly, right? So the next step is, as you know, prompt will be written inside this prompt template, right? So this is how we created few shot prompt. So inside prompt template, we are passing input variables and template. This template is nothing but whatever we defined before, that is few shot template. And for the input variables, we have to pass our customer message. So we are passing two variables, customer message and prompt template. And this few shot prompt will be chained with this LLM chain, right? So by using LLM chain, we have to pass these two parameters. The first one is LLM, which we already initialized by using chat OpenAI, and the second one is nothing but prompt, which we defined before, few shot prompt by using prompt template, right? So with this we got the few shot chain. And the next one is we need to get this customer message, right? So let me copy the same customer message. So with few shot, let's see how the LLM is going to respond, because we have provided few examples. So in case if we pass this customer message here, now we have to see how the LLM is going to respond, right? So once we have this customer message ready, so you can replace with any customer message here, right? And now let's run and print the LLM response by using run method. Inside LLM chain, we have the run method and we are passing the customer message and trying to print the LLM response. Let's save it and run the code. So if you see the response here, this is how the LLM responded. I am truly sorry for the inconvenience you have experienced with the delayed delivery. I completely understand your frustration, especially after paying for express delivery. Please rest assured that I will work into this matter right away and ensure that your money is refunded promptly. Could you please provide me with your order details so I can investigate this issue further and resolve it as quickly as possible? Thank you for bringing this to our attention, right? So this is how it is responding for a angry customer, right? So this is what the angry customer says, and that is what the LLM is responding, because the LLM understood these two examples, right? And then it is trying to respond for another message that we pass to the LLM, right? So this is how we can implement FewShot. So FewShot is nothing but guiding the LLM with examples, right? So what we did here, we installed the packages and we loaded the required modules from LangChain, and then here we loaded the environment variables and we read the key and we stored the key inside OpenAI API key and we initialized the LLM, and then this is how we defined our FewShot template with role, task and few examples. And then if we ask another question, we have to see how the LLM is going to respond. We are guiding the LLM with examples, and then we define the prompt by using prompt template, and then we chain this prompt with LLM by using LLM chain, and once we have the chain, we are calling the run method by passing the customer message so that we can see the response from the LLM, right? So this is nothing but FewShot. So we are guiding the LLM with some examples. So LLM is smart enough to understand the pattern, and based on the examples, LLM understands the context and provides the response accordingly. Alright, so this is nothing but FewShot. Alright, thank you. So we have seen basic prompt, role, task, context prompt, FewShot, and now let's see chain of thought, right? So chain of thought is good for reasoning based applications. For example, let's say you are building an LLM model which can solve riddles, puzzles, math problems, planning and acting for a travel agent. Let's say you can tell, I want to go this route or that route, or I want to find the flight which is cheaper than the other one, right? So any kind of reasoning based, then we need to tell the LLM to pause, think and then respond, right? So chain of thought meaning you are telling the LLM that you do not directly respond back. Instead, you pause, step by step you think, and then only you respond. So this way, the user will have more trust, right, on the results that are predicted by LLM. And the user thinks that the LLM is not hallucinating any results and it is predicting the accurate results, right? So when there are a lot of reasoning based tasks involved, then you can go for chain of thought prompt engineering technique, right? Now let's go to our code editor VS Code and see how we can implement this chain of thought, right? So far we have seen basic prompt, role, task, context prompt, FewShot. Now let me go to this folder and create a new Python file, and let's name it chain of thought demo. Okay, so let me copy the same code. I'm just creating separate files, but you can implement everything in one file also. Just for your understanding, I'm just creating each prompt in its own file, right? So what we understood with chain of thought, when we have a lot of reasoning based tasks, then we can use chain of thought, right? Now let's try to define chain of thought prompt template, right? So this is how chain of thought prompt template looks, right? So what we are telling here, this is the role. You are a highly professional customer support specialist at a premium tech company, and your goal is to address the customer's concerns while maintaining a calm and helpful demeanor, right? And we are providing the context here. Let's approach this step by step, and then we are telling the LLM to do this way with 4 steps. First, analyze the customer's sentiment and identify the core issues in their message. And then number 2, formulate an empathetic acknowledgement of their feelings. Next, address each identified issue with specific solutions, and finally end with a positive and forward-looking statement. And then we are providing with few examples. For example, let's say if the angry customer says this, "Your product is terrible, I have been trying to make it work for hours and nothing helps." Then we are telling the LLM to respond this way. Thought process. First one is sentiment. Customer is frustrated due to wasted time and product difficulties. Core issues. What are the issues? Product not working, time wasted, lack of proper guidance. And required. What is required? Immediate assistance, clear steps, acknowledgement of time value. And we want the LLM to respond this way. I sincerely apologize for the frustration you are experiencing. I understand how valuable your time is, and it's unacceptable that you have spent hours trying to resolve this. Let's work together to fix this immediately. Could you please tell me what specific issues you are encountering? I will guide you through the solution step by step. Right? Now, please analyze and respond to this customer message. Right? So if this is the customer message, you respond this way by sentiment, core issue, and required. This format. Right? Please show your thought process before providing the response. Right? So this is how we defined our chain of thought template. So we assigned the role, task, and with some context by providing the examples. Right? So we are guiding the LLM to think and then respond step by step. So why is this chain of thought is important? Because sometimes during building reasoning based applications, you may not trust the LLM response if it responds instantly, right? Whereas if the LLM thinks and responds, then the user may be more satisfied with the LLM response, right? For example, let's say if you want LLM to give you the cheapest flight price from point A to point B, right? And if the LLM response involves, I compare different flights and this is the price difference for this particular day or time, and then if it provides you the final answer, then as a user, you think that the LLM has done some reasoning before it actually gave the output, right? Instead of giving the response directly, right? So with this chain of thought, we want the LLM to process and then provide the response step by step, right? So once we define the template, the next step is use this prompt template and then define the prompt, right? So we are using the prompt template and we are assigning this customer message to input variables and the template that we define to template variable, right? And now this chain of thought prompt will be chained with this LLM by using LLM chain, which we have already seen, right? So once you have the chain of thought, let me get the same customer message from the previous example. So once you have the chain and the customer message, the next thing is we can call the run method which is inside LLM chain and see the LLM response, right? So chain of thought, chain dot run, and we are passing the customer message and save it. Now let's run the code. So now if you see the LLM response, this is how it is responding. So the LLM understood that it needs to respond in this format. Sentiment. Customer is angry because what we provided as a customer message, this is the angry customer message, right? Then it understood customer is angry and frustrated due to delayed delivery despite paying for express service, right? And then what is the core issue? Late delivery, unmet expectations, request for refund. And what is required? Acknowledgement of frustration, explanation or resolution for the delay, refund process. How did the LLM responded? I completely understand your frustration and I sincerely apologize for the inconvenience caused by the delayed delivery. I will look into this matter immediately and provide you with an update on the status of your delivery. As you have paid for express delivery, this delay is unacceptable and I will ensure that your money is refunded promptly. Thank you for bringing this to our attention and we will do everything we can to make this right for you, right? So we provided this example and we asked LLM to respond this way. So now when we gave this customer message, LLM understood that it needs to think through step by step and respond accordingly, right? So every time you run a chain of thought prompt, then you will see the output of LLM as a thought process, right? So first the LLM understood the sentiment, core issues and what is required, and then only LLM is trying to provide the response, right? So this is a step-by-step process, right? So what we did here, we installed the required packages and we imported the modules, we loaded the environment variables and we read the key, that is OpenAI key, and we stored inside this, and then we initialized the LLM, and then we defined the chain of thought template by providing the role, goal is nothing but task, and then an example, sentiment, core issue required, and we want the LLM to respond this way, right? And then we define the prompt template and we chain that with the LLM by using LLM chain, and this is what the customer message, and then once we have the chain, we call the run method by passing the customer message, and we saw the LLM response, right? So this is nothing but chain of thought, right? In case if you don't know how to write these prompts, right? So you don't have to write these prompts from scratch, right? We can use any of the AI tools to write the prompt for us. Because if you go to Hugging Face, there are already a ton of prompts that are written by others, right? Those are already available. So you can just go there and download those prompts and use them too, right? So prompts are readily available from Prompt Hub, or you can ask ChatGPT or any other tool to generate a prompt for you, right? So for example, if you go to Prompt Hub, right? So you can go here and you can try to explore and try to download. So this is one place. So similar to Prompt Hub, there are other prompts available on the internet, right? So you can explore more, but at least now you get the idea, right? So you can just go to ChatGPT and you can just ask the prompt. So you provide your context and it will try to provide the prompt for you, right? So this is nothing but chain of thought. All right. Thank you. So we have seen basic prompt, role task context prompt, few shot, chain of thought prompt, and now let's see constrained output prompting, right? So let's go to our VS Code. This is our code editor, right? So far we have seen all these 4 prompts, and now let me create a new Python file and let's save this as constrained output prompting demo inside our prompt engineering demo folder, right? So let me copy the same code again. Like I said, you don't have to write in a separate file. Just to give the demo, I am writing in a separate file for each prompt engineering technique, right? So what we did here, we installed the required packages. You don't have to install every time. Once you install, you can make use of them. And then we loaded our required modules. Here we loaded our environment variables, and then we read the key, which is nothing but OpenAI API key. And here we initialized our LLM. And now the next step is defining our template. So this is how you can define a constraint template, right? What we are telling here, you are a customer support specialist. Generate a response to the customer's message following these strict constraints, right? So we are guiding the LLM to follow these constraints, right? So what we are telling here, response must be exactly 3 paragraphs long. First approach must be exactly 2 sentences showing empathy. Second paragraph must provide exactly 2 concrete solutions. Third paragraph must end with a question to engage the customer. Total response must maintain a professional tone, must not use any exclamation marks, must include exactly 1 apology, must use the phrase "I understand" exactly once, right? And then you provide a new customer message and see how the LLM responds, right? So here we are trying to guide the LLM to follow these strict constraints, right? So this is how we can define a constrained output template, right? And as you know, the next step is prompt will be written within this prompt template, right? So by using this prompt template, here for input variables we are passing the customer message, and for the template parameter we are passing the constraint template which we defined before, right? And once we have this constraint prompt, this will be chained with the LLM by using this LLM chain, right? And now once you have the LLM chain, let me get the same customer message and see how the LLM is going to respond, right? So we are telling the LLM to follow these constraints for this customer message and then respond accordingly, right? Now let's run and print the LLM response, right? So once we have the chain, so inside our LLM chain we have the run method and we are passing this customer message. So we can see the LLM response by using this print method, right? So now let me run the code. So this is how the LLM responded, right? And the response must be exactly only 3 paragraphs, right? So this is the first one, second one, and third one. And first paragraph must be exactly 2 sentences showing empathy, right? So this is first sentence and this is second sentence. Second paragraph must provide exactly 2 concrete solutions. So you can see this is one solution and the other solution. And third paragraph must end with a question to engage the customer. Please let us know if there is anything else we can assist you with during this time, right? And the total response must maintain a professional tone and must not use any exclamation marks, must include exactly one apology, right? So if you notice the response, we only have once, and must use the phrase I understand exactly once, right? So it only used once. So this is how the LLM responded by following these strict constraints, right? So this is nothing but constrained output prompting technique, right? So what we did here, we installed the packages, imported the modules, we loaded the environment file, and we read the key, and we stored the key inside OpenAI key. Here we initialize the LLM, and then this is how we define the template. Once we have the template, then we created the prompt by using prompt template, and then we chained that prompt template with LLM by using LLM chain. Once we have the chain ready, we call the run method by passing customer message, and then we are trying to print the LLM response, right? So this is nothing but constrained output prompting technique. So with this, I hope you understood the different prompt engineering techniques and what are the different ways of writing prompts, and for each prompt how the LLM responds, right? Now let me quickly show some of the best practices that you can use. This is from OpenAI, right? Rules of thumb and examples. So what we are supposed to do and what you are not supposed to do, right? Use the latest model. Always try to use only the latest model that is available, which is recommended, right? Put instructions at the beginning of the prompt and use this or this, right? So we have used this to separate the instruction and context, right? So that is how we provide it, right? So instead of writing all together, just try to do in this format. And then be specific, descriptive, and as detailed as possible about the desired context, outcome, length, format, style, etc. Right? We have seen this with example. Articulate the desired output format through examples, right? So we have seen with examples already. And then start with 0 shot, then few shot. If neither of them worked, then fine tune, right? And the next one is reduce fluffy and imprecise descriptions, right? Try to be more descriptive. And instead of just saying what not to do, say what to do instead, right? So you are trying to guide the LLM so the LLM can understand and provide us the results, right? And the next one is code generation specific. Use leading words to nudge the model toward a particular pattern. So here they gave the examples, and use the generate anything feature that is available, right? So you can deep dive this article. So these are some of the best practices that they have documented here. So this is from OpenAI, right? So now you get the idea, right? How to write a basic prompt template and then role task context prompt or few shot or chain of thought or constrained output prompting, right? So these are some of the prompt engineering techniques that we understood. So now you can try to explore more if you are interested in learning any other prompt engineering techniques, and you can try to create your templates, prompt, chain, message, and then try to run it and see how the LLM responds, right? So that's all about prompt engineering techniques. All right, thank you. So far we discussed different LangChain components, right? For example, let's say if you're asking a question to LLM, and we already know LLM has been trained with some public data, right? So the LLM will already have some generic intelligence, and if the LLM knows the answer with the generic intelligence that it has, then it will try to answer the question. Otherwise, let's say if it is any domain specific data related question, then the LLM will go and search in the vector database and try to retrieve the results for us, which is nothing but RAG, right? So in RAG, what we did, we tried to load the data, and then we did the chunking, and then we created the embeddings for those chunks, and we stored inside our vector database, right? and then we try to retrieve the results. So in case if it is domain specific data question, then the LLM will try to retrieve the results from the vector database, right? If LLM cannot retrieve from its generic intelligence or from the vector database, then we have an option to use tools, right? So it can go and do the Google search or any other search and try to retrieve the results for us, right? So we have tools, agents, memory, and chains. So we already learned prompt engineering, right? So which is nothing but asking the right questions to LLM. So we have to provide the right context to the LLM so the LLM can understand in a better way and predict the accurate results for us. So we have already seen this part as well. And we have tools, agents, memory and chains, and document loaders, right? These topics are pending. So let's cover one by one. And in this lecture, let's learn document loaders, right? So you understood the overall picture, right? And to learn all these topics, we are using LangChain, right? You understand why we are using LangChain? Because we are able to build end-to-end generative AI application by using the methods that are provided by LangChain, right? So that is why we are trying to learn each and every component of LangChain, right? Now let's discuss document loaders. That is to load any kind of data, whether it is CSV or HTML or PDF file, right? So what is document loaders? Document loaders are classes to load documents, and they are used to load a lot of documents in a single run, right? And we have different kinds of loaders. We will see some of them: CSV loader, HTML loader, PDF loader, and we have the complete documentation here, right? So for example, when you have different kinds of documents, let's say if your input document is in CSV file or HTML or PDF or JSON, right, or in any other format, and if you want to load them, then you can make use of the functions that are available inside LangChain, right? Let's go to our code editor VS Code and see the implementation of different document loaders, right? So this is our build generative AI applications workspace. So this is where I'm trying to save all the files, right? So everything will be in one place. So first we have seen RAG application. We built the RAG application, and then we have seen different chunking methods and then prompt engineering techniques. And now we are seeing how to load different documents, right? So if you remember, this is our RAG application, right? So what we did here, first thing is we try to load the input document, and then we did the chunking, right? And then the next step is we created the embeddings for those chunks, and then we stored those embeddings inside a vector database. And then we did similarity search, and then we created a complete RAG pipeline by using Claude Anthropic, right? So this is what we did. And if you notice here, let's go to our input document, right? If you notice here, we are hard coding the data, right? So instead of hard coding your input document, let's say if your document is in a CSV format or HTML or JSON or PDF, right? Now how to load the document and use it in your application. So that is what we are trying to do by using document loaders. Instead of hard coding your input document, let's try to read it from different files and load it, so that way you can use the content from different files, right? So let's see a few document loaders and how to implement them. So just like how we did before, I created an empty folder, document loaders demo, right? Now let's try to open this folder from VS Code and try to save our code over there, right? So let me go to VS Code. So far we have seen RAG demo, chunking methods demo, and prompt engineering demo. So now let me try to add the folder that we just created, document loaders demo, to our workspace. And click yes, right? So we got our document loaders demo, right? Now let's start with CSV loader, and then we will move on to HTML loader and PDF loader too. So click on this folder and file, new file, Python file, and let's save it as. So make sure you go to document loaders demo and save your file here, CSV loader demo. That is how I'm saving here, right? So the first thing is we have to import the module that is required to load a CSV document, right? So for that we have CSV loader module, which is present inside LangChain document loaders, right? So that is our first thing. And now the next thing is, assume you have your domain specific input document is saved somewhere, right? So for example, let's say this is our CSV file. This is our input document. Let's assume this, right? So if you notice here, we have age, attrition, business travel, etc. We have several columns and we have 1400 plus rows. So this is our input document, right? Which is saved inside my documents and data sets, right? So let's try to load the content from this file, right? So we can do that by using this CSV loader, right? You can see the description here. So CSV loader is used to load a CSV file into a list of documents, right? So now we are trying to load our document which is present inside my documents, datasets, HR analytics, right? So wherever your document is saved, try to give the entire path here, right? And then we are trying to load it here by using CSV loader. Close that. And then the next step is, once we have inside this, we try to load it using load method. And let's assign this to a variable called data, right? Now let me save it, and now let's try to print the data and see what we have inside data, right? So let's try to run this and see our data, right? So it is trying to print entire content which we have inside our HR Analytics CSV file. Now let me try to print the data type of the variable data, right? So let's clear this terminal and let me just comment this, and then let's rerun the code. So now you can see it is of type list, right? So the data type of this variable data is list. So let's just try to get only the first row, right? So let's rerun the code and see. So we are able to print the first row from that list, right? So if you notice here, this is what we have: age 41, attrition S, right? So that is what it is trying to print, right? That is the first row because the index starts from 0, right? And then let's say if you want to print the second row, right, then we have to give the index as 1. So let me comment this and let's clear the terminal and rerun the code. So now you can see age 49, right? So that is the second row, right? So what we did here, we are able to load the CSV file by using CSV loader, right? So instead of hard coding your content of your input document, let's say if this is saved somewhere inside a CSV file, then you can use CSV loader and try to load the document and then make use of it, right? And now instead of this CSV file, let's say if your input document is a HTML file, right? So for that, let's try to create a new Python file and let's try to save this file as HTML loader demo. So let me close this. So to load the HTML file, we have a module called BS HTML loader, which is inside LangChain document loaders, right? So first thing is we are trying to import the modules that we need, right? And now by using this BS HTML loader, we can load any HTML file. So for example, this is my sample HTML file. So I have some text here. Now our goal is to load this data from this HTML file. So how can we read the data? By using this BS HTML loader, right? And then we have to pass the path where we saved this HTML file. And then again, the next step is, you already know, inside the loader we have the method called load. So call that and assign it to a variable called data. And then now let me try to print what we have inside data, right? So save it and click on run. So what it is saying, import error, beautiful soap 4 package not found, please install it with pip install. Whenever you get module not found, make sure you try to install the corresponding packages, right? So I'm just giving this and then hit enter, and that's it. You are able to install the package, right? So what I did here, I used pip install command and then try to install the missing package, which is Beautiful Soap 4, right? So that is required. So let me clear the terminal and rerun the code. We got one other error. Please either install it with pip install this one or to override default Beautiful Soap kwargs. Okay, let's try to install this package, and then now let me try to rerun the code. So now you can see we are able to load the data. This is the content, right, from test1.html file. So I installed this package and I also installed another package. So what we did here, first we installed all the required packages and then we loaded this module, and inside this we are passing our path where we saved our HTML file, right? So this is our input document file, and once we got the loader, we have load function which is inside bs_html loader, right? So we are calling that and we are trying to print the data and see if you are able to load the content from an HTML file, right? So by using bs_html loader, we are able to load the content from an HTML file, right? So far we have seen how we can load a CSV file and then HTML file, right? Now let's see one other file, new file, and click on Python file. And now let me save this as PDF loader demo, right? For example, let's say if your input document is saved inside a PDF file, right? So for this we have to use PyPDF loader, which is inside LangChain document loaders, right? So save it. So this is pretty straightforward, right? So we are using PyPDF loader and we are passing the file path, right? And we are storing inside a loader variable. And now inside loader we have load and split function. And now let's say if you want to know the data type of the pages variable, so let me save it and run the code. So import error, PyPDF package not found, please install PyPDF. So let's try to install this, and then if you try to rerun the code, so now you can see this pages is of type list, right? So what we did here, we try to install the missing package, pip install PyPDF, right? So let me show this sample PDF file, right? So this is the PDF file. I have 2 pages total, right? And now print just the first page, right? We know this is a list, so you can read a list by using the index, right? So the index starts from 0, and let's try to print it and rerun the code. So now you can see we are able to load the content here, right? So which is nothing but page underscore content, right? Let's say if you want to see a page content, right? So now you can give pages of 0 dot page content, right? So let me clear the terminal and rerun the code. So now you can see we are getting the page content, right? Or let's say if you want to read the second page, right? So now you can see it is printing the second page as well, this architecture page. This is what we have in the second page, right? Page number 2. So that's what it is trying to print, right? By using index 1, that means it is second page, right? So what we did here, we used PyPDF loader, which is inside LangChain document loaders, and to this we passed our input document, which is a PDF file, and we saved inside a loader variable, and inside PyPDF loader we have a function called load and split. So we called that and we got the pages, and this pages is of a type list, right? And then once we have the list, either you can loop in, or I'm just trying to show the demo just by giving index, right? 0th index means it is trying to print first page, and first index means it is trying to print second page, right? So that is how you can load a PDF document, right? So what we did here, we have seen how to load a CSV document, HTML or PDF document, right? So now you get the idea, right, on how to load different types of documents by using LangChain document loaders, right? And let's say if your input document is in a different format, you can try to explore more depending on your requirement, right? So you can go to LangChain documentation. So let me take you there. So this is LangChain documentation, right? So you can see document loaders. We have a ton of document loaders here and we have covered few of them. So we have seen PyPDF loader, CSV, HTML, right? So similarly, we have several other examples here. So this is the complete documentation, right? If your document is other than the CSV or HTML or PDF, then come here to the LangChain documentation, right? And then try to search here. Here you have the search option. So try to search here and you should be able to load any kind of document by using the methods that are available inside LangChain, right? So that's about loading different kinds of files by using LangChain document loaders, right? Thank you. So by now you understand why we are using LangChain, right? Because by using LangChain, we are able to build end-to-end generative AI applications by using the methods that are provided by LangChain, right? So that's why we are trying to learn all the different components of LangChain, right? So we have seen how to load a document by using document loaders and how to chunk the input document, and then how to create embeddings for these chunks and how to store these embeddings inside a vector database. And we have also seen prompt engineering, right? So asking the right question to the LLM so we can get the right answer. And now in this lecture, let's learn about memory, right? Tools, agents and chains we will cover in the coming lectures, right? So now you get the idea. Now let's learn about memory, right? So all we are trying to do is we are trying to empower LLM and trying to build an end-to-end generative AI application by introducing all these different components, right? So what is memory? Memory is the ability for an LLM to store information about the past conversations, right? So think about the human brain, right? We as humans can process a lot of information, but sometimes the action that we take in the present is based on the past information, right? For example, let's say you are in a conversation with somebody and you introduced yourself to each other, and after a while you need to address the person's name, right? So in order to do the real conversation, you need to have the memory, right? So for example, let's say you are building a chatbot application, right? You need to have the memory component ready because the LLM should be able to retain the context and remember the previous conversations, right? So let's say you are doing multiple conversations with an LLM. This is human, that is you, and the AI is responding. And then again human, we are asking some question and then AI is responding. And then again human is asking some question and then LLM is responding, right? So this is how you are trying to chat with an LLM. So which is nothing but a chatbot, right? So in this case, the LLM needs to retain the memory of these conversations in order to respond, right? But what are some of the problems here? We already learned each LLM has a fixed context window size, right? So we know the context window is nothing but the input plus output together. That is whatever the question that we are asking plus whatever the LLM is responding together, the total number of tokens, right? So this is for one conversation. And as we introduce more conversations, then it may not work once we reach the context window size, right? That is, as we introduce more questions, then at some point it will reach the final token number, right? Then the LLM may not be able to work. Then we will lose the entire information, right? Then the LLM might ask you to start a new session or a task, right? So we have two problems here. One is the context window size limitation, and then the second problem is once it reaches the final token number, it may not be able to retain the context and we will lose the information, right? So let's see the memory implementation so you understand better, right? And we will cover implementing conversation buffer memory, conversation buffer window memory, conversation summary memory, and finally I will show you how to deep dive into other memory types, right, by going to the LangChain documentation. So let's learn how to implement these memory types in the next lecture. All right. Thank you. So we understood what is memory, right? So memory is nothing but the ability for an LLM to store information about the past conversations, right? So as I mentioned, we have different types of memory: conversation buffer memory, conversation buffer window memory, conversation summary memory, and several other types available, which we will go through. So now let's see how we can give memory to an LLM by using conversation buffer memory, right? So as the name suggests, the LLM keeps the entire conversation history in the memory, right? So that means it stores every single conversation in the memory. So when we have lengthy conversations, we will lose the context after some time because of the context window limitation. Or once it reaches the maximum token, then the LLM may ask you to initiate a new task or session, right? And the drawback with conversation buffer memory is it passes the entire conversation history, right? That is more context window, so more GPU processing, so more tokens and more money, right? So let's go to VS Code and start building the project and see how we can give memory to LLM by using conversation buffer memory, right? So this is our build generative AI applications workspace, and underneath we created several projects here. So we have seen RAG, chunking methods, prompt engineering, document loaders, right? Now let's see memory, right? So here I've created an empty folder and I named it memory demo, right? So let's add this folder to our workspace, build generative AI applications, right? So come to the Explorer and right click, add folder to workspace and select memory demo and add. Click yes, right? So now we got the memory demo folder added to our workspace, right? Now, so make sure you select this folder and then file, new file, Python file, and let's try to save this file and make sure you go to memory demo. Let's try to save this file as conversation buffer memory demo and save, right? So the first thing is let's try to import all the required packages from LangChain, right? So here you have to install LangChain Anthropic. If you already installed, you don't have to install this again. We have used this Claude Anthropic already in our RAG application, right? If you have already installed here in our RAG project, you don't have to install it again. If you haven't installed already, make sure you install LangChain Anthropic. So we will be using Claude Anthropic, right? So instead of Claude Anthropic, you can use OpenAI as well, right? Or instead of these paid LLMs, you know Anthropic is paid LLM and also OpenAI is paid one, right? So instead of these paid LLMs, you can also use any other open source LLMs as well, either from Hugging Face or Ollama. So we have several other open source options as well. And as you know, LangChain is model agnostic framework. That is, you can use any model and the LangChain supports that model, right? So you do not have to rely on just one model, right? So what we did here so far, we imported all the required modules from LangChain. First one is Chat Anthropic, because we will be using Anthropic LLM and we will be chatting with that. So that's why we imported Chat Anthropic, and then conversation chain and conversation buffer memory. And these two are to load the environment variables, right? So we will be storing our Anthropic API key inside the environment variable, and we will be loading the environment variables from the environment file by using load_.env and using it in our code, right? So first thing is, let me try to create an file and let me name it .env, and inside this let's try to store our Anthropic key, right? So you have to store your key. And when we were implementing RAG application, I've already shown how to get the API key from Claude Anthropic, right? So make sure you store your key here. Okay, let me close this. So far what we did, we installed all the required packages and then we loaded the modules that are required from LangChain, right? And also we created an environment file and stored our API key over there. And we will be using Claude Anthropic. Instead of Claude Anthropic, you can use any other LLM as well. Okay. So first thing is, let's try to load the environment variables from the .env file, right, by using load_.env function. And once we load the environment file, next thing is let's try to read the key. This is the name we saved inside the environment file. So we are trying to read the API key by using getEnv function, and we are assigning to a variable called Anthropic API key. So let's close it here. And now this Anthropic API key, let's assign this to environment variable, which is nothing but Anthropic API key, right? So with this, we are able to load environment variables from environment file, and then we read the API key and we stored inside our environment variable Anthropic API key. Okay. Now next thing is let's set our LLM. So we will be using Claude Anthropic, right? So let's try to initialize the LLM. And here we are using Chart Anthropic, which is from LangChain Anthropic. And the model is Claude 3.5 Sonnet. So that is our LLM. So with this, we initialized our LLM. So our LLM is ready to chat. So instead of Chart Anthropic, you can use any other models too, right? So you don't have to just use Claude Anthropic LLM. Instead of this, you can use ChatOllama, right? If you want to use Ollama model, then you can replace this Chart Anthropic with ChatOllama, right? So go to Google and type ChatOllama, right? And then click on this. So you can see we have the support from LangChain, right? So all we have to do is install LangChain Ollama package. Once you install the package, then you can make use of this ChatOllama module, which is inside LangChain Ollama package, right? So this is how you can use open source LLM, which is nothing but Ollama, right? Or if you want to use OpenAI, right? So go to Google and type chat OpenAI and click on this LangChain URL, and then here it shows how to install the package. So pip install LangChain OpenAI. Once you install the package, then you can get Chat OpenAI module, which is from LangChain OpenAI, and you will be able to initialize the LLM, right? And make sure you import the corresponding packages, right? So all we have to do is we just have to change this one line if you want to use any other LLM, right? And the rest of the code will be as is. So we have our LLM ready. Now the next step is we want to give memory to the LLM, right? It is so simple here. You just have to write one line, and that is the advantage of using LangChain. So how can we provide memory to LLM? So here we are using conversation buffer memory, right? This conversation buffer memory we are getting from LangChain Memory, right? And if you want to see the documentation of conversation buffer memory, so you can just go to Google and type conversation buffer memory and go to the LangChain documentation. So if you notice here underneath memory, we have different types of memories, right? Conversation buffer window, and conversation summaries. So we will implement few types, and then you can deep dive depending on your requirement, right? So you have the documentation here, you can go through. So with this, we added memory to the LLM, right? Now once we have the LLM ready with memory, now the next step is we need to wrap both LLM and memory by using this chain, right? Here we are using conversation chain. So by using conversation chain, we are passing 3 parameters. The first one is memory. So memory we've already created here, and the LLM we already initialized here, and verbose is equal to true. So this is how we wrap both memory and LLM by using conversation chain. We are trying to bind the LLM with the memory by using conversation chain. So what is chain? Chain will help you to do multiple complex tasks together. So more on chains we will discuss later. We have a separate section where we will deep dive into chains, right? So this conversation variable here is the chain that we have created, which has LLM and also memory, right? So we have an LLM which is Anthropic, and this LLM has memory, right? So once we bind both LLM with memory by using chain, now we are ready to start the conversation with our LLM, right? So let's try to chat with our LLM. So inside conversation buffer memory, we have a method called predict, and for this we are passing input is equal to hi, my name is Mala, right? So this is how we are trying to chat with our Anthropic LLM. So let's try to save this code and click on run Python file. So here you can see entering new conversation chain, prompt after formatting. Always look for the current conversation, right? So human, hi, my name is Mala, and this is how AI responded. Hello Mala, it's a pleasure to meet you. My name is Claude and I am an AI assistant. I am always excited to chat with new people and learn about their interests and experiences. Is there anything in particular you would like to talk about today? I would be happy to discuss a wide range of topics from science and technology to arts and culture. Or if you prefer, we could just have a casual conversation and get to know each other better. Please let me know what you would enjoy, right? So this is our input human, and this is how Anthropic responded, right? So what we are trying to do here, we installed all the required packages, and then we imported the modules, and then here we tried to load the environment variables from the environment file, and we got the key and we stored inside our environment variable, and then we initialized our LLM by using chat Anthropic, and then we created the memory, and then we tried to bind the LLM with the memory by using conversation chain, and then we are trying to chat with our LLM. The first conversation is hi, my name is Mala, and this is the response we got from LLM after executing. So here the current conversation is nothing but memory, right? So always look at the current conversation. Human means it is me, and AI is nothing but Claude Anthropic. So this is our first conversation. First conversation means I have asked something and the LLM has provided the response. So conversation means both the question that we asked and also the response that we got from the LLM. Right? Question and response together is called conversation. And second conversation means again I've asked a question to LLM and the LLM has responded, right? So this is our first conversation with our Claude Anthropic LLM. Now let's try to do another conversation, right? So let's try to ask another question. So inside conversation buffer memory, we have a method called predict, and we are passing the input as I'm doing well, just having a conversation with an AI, right? So let me save it and let's rerun the code. So this is what the LLM responded for the second question, right? So if you notice here, this is our current conversation, right? Now you can see the LLM retained the first conversation history as well. So this was our first question. Hi, my name is Mala, and this is what LLM responded. And this is our second question, right? And then this is what LLM responded for our second question. So that means it is trying to retain every single question and the corresponding answer, question and the corresponding answer, right? And now let's try to ask third question. What is AI, right? So let's try to rerun the code. So this was our first question, and this is what LLM responded, and this is our second question. This is what LLM responded, and this is our third question. What is AI? This is what LLM responded for our third question. So which is nothing but what is AI, and this is what it is responded, right? So that means for every single question that we ask, it is trying to retain the previous conversations as well, right? So here we only asked 3 questions, right? As we are having more conversations with the LLM, that means we are using more tokens, right? So the context window is nothing but both input and the output response together, right? The total number of tokens, right? That means the entire conversation will be converted into tokens, and the problem here is the LLM is trying to remember the entire history, right? Not just the current question. It is trying to remember the entire conversation history. So which means we are using more tokens. So that means more GPU processing, so more cost, right? Now we have asked, hi, my name is Mala, I'm doing well, just having a conversation with an AI. What is an AI, right? Now what is the proof that our LLM Claude Anthropic is remembering, right? So we have added this memory, but what is the proof that our LLM is able to remember what we have told, right? So the first conversation, what we said, my name is Mala, and we did 2 other conversations. So after having few conversations, now let's try to ask what is my name, right? To test if the LLM actually remembered the context or not. Okay, so this is what we are trying to pass. The question is, what is my name, right? So let me try to rerun the code. So whenever you rerun, right, so always look for the current conversation, right? So the first question and answer, second question and answer, and third question, what is AI and answer, what is my name? So you can see your name is Mala. If you see here, your name is Mala. You introduced yourself at the beginning of our conversation and I made sure to remember it, right? So the LLM was able to remember the name because we added memory to our LLM, right? So this was our first conversation, and after that we did 2 other conversations. Finally, we are testing LLM if it actually remembered our name or not, right? So after few conversations, it still remembered, right? So this is nothing but memory, right? So what is happening with conversation buffer memory? As the name suggests, this is trying to keep the entire conversation history in memory, right? Because we asked 4 questions and it tried to keep the, if you see the current conversation, so this was our first question and answer, second question and answer, right? And then third question, what is AI, and the corresponding answer. And finally, what is my name? That is the 4th question and the answer, right? So what is happening here? It is trying to keep the entire conversation history in memory to help contextualize the answer to the next user question, right? So while this sounds very useful, only drawback here is that it keeps all of the history, right? So up to the maximum limit of specific LLM, right? We know each LLM has a fixed context window size, right? And for every question we asked, it tried to pass the whole previous discussion, right? That is, it is more tokens to the LLM API, right? So this can have significant cost impact, right? Because API costs are based on the number of tokens processed and also the latency impact as conversation grows, right? Because here we used 4 conversations and this is how it created, right? So you know this will be converted to tokens and processed, right? So that's about conversation buffer memory. So let me quickly summarize. So first what we did, we installed all the required packages and then we imported all the required modules, and here we used Claude Anthropic as our LLM. Here we loaded our environment file and read the API key, and we initialized our LLM by using Chart Anthropic, and the model that we are using is this. And the next thing is we added memory to our LLM by using conversation buffer memory, right? Once we have the memory and LLM, we try to bind LLM with the memory by using conversation chain. And conversation chain we imported from LangChain Chains. And once we have the conversation chain ready, we started our conversation with Claude Anthropic LLM, right? The first question is, hi, my name is Mala, and the LLM responded. And the second question we asked and LLM responded. Third question and fourth question, finally we tried to test the LLM if it actually remembered the name or not, right? Which is nothing but the memory, right? We told LLM to remember the conversation because at the beginning we introduced the name as Mala. It tried to remember it and try to respond the name as Mala, right? And the only drawback with this is it will try to keep the entire conversation history for each and every question, right? So that means more tokens and more GPU processing and more money, right? And at one point, once it reaches the maximum limit, then the LLM may not be able to respond anymore, right? Because the LLM might ask us to initiate a new session or task, right? With that, we may lose the context as well, right? So that is one of the disadvantage of using conversation buffer memory. So with this, I hope you are clear on how to initialize an LLM, how to add memory to an LLM, and how to bind LLM with the memory by using conversation chain, and how to start doing the conversations with an LLM. All right. Thank you. So we are trying to learn how to give memory to an LLM, right? So we have seen the first type, that is conversation buffer memory. And now the next one is conversation buffer window memory, right? So let's go to our VS Code and try to implement by using conversation buffer window memory, right? So we've already seen conversation buffer memory. And the problem with the conversation buffer memory is that the LLM is trying to store every single conversation in the memory, right? So that means more tokens and more GPU processing. And as we know, we are charged by the number of tokens usage, right, for each API call, right? So for example, here we only asked 4 questions, right? So let's say you asked 100 questions, and is it really necessary for an LLM to remember all the previous 100 conversations? That is 1 to 100? No, right? So to address the problem of storing every single conversation, what is the solution here? As an user, you can decide and tell the LLM that you only want the LLM to remember only specific conversations, right? So you can define by using a index parameter called k. So in our conversations, we do not usually need to remember all the conversation histories, right? But definitely the last few conversations. So here we only used conversation buffer memory, and the next one is conversation buffer window memory. We can define the parameter k, and we can tell the number of last few conversations the LLM should remember, right? So it simply tells the LLM, remember the last few discussions and forget all of the rest, right? For example, let's say if you give k is equal to 7, that means the LLM will try to remember only the last 7 conversations, right? And let's say if you give k is equal to 1, meaning the LLM will only remember the last conversation, right? So now let's try to see the second one, conversation buffer window memory, right? So let's go to our memory demo and click on file, new file, Python file, and let's try to save this as conversation buffer window memory demo and click on save, right? So let me close this. So let's try to use the same code. So instead of conversation buffer memory, we will be using conversation buffer window memory, right? And then we loaded our environment variables from the environment file, and we read the key and we stored inside our Anthropic API key. And this is how we initialized our LLM, and we are using Claude Anthropic, right? And the next thing is we need to give memory to our LLM, right? And here we will be using conversation buffer window memory. So the next step is we want to give memory to the LLM by using conversation buffer window memory. And here we are saying the number of messages to store in buffer, right? So we are telling k is equal to 1. That means we are telling the LLM to remember only the last conversation, right? So let's say if you give k is equal to 10, then the LLM will try to remember the last 10 conversations and it will ignore the remaining, right? And inside conversation buffer window memory, we have a function called save_context, and that will be used to save the context from this conversation to buffer, right? So let me quickly go to LangChain, and from here we have a search option. So let's try to search for conversation buffer window, and if you see here we have save_context function, right? So let's try to use the function from conversation buffer window memory. We have a function called save_context, and by using this save_context, it will try to save the conversation to buffer, right? So if you notice here we have input and output. So input means the human input and output means the AI output, right? So whenever you say hi, then you want the LLM to respond as what's up, right? And similarly, let's try to add one other memory.saveContext, input as not much, you output, you want the LLM to say not much, right? And then let's try to load these memory variables, right? So this is a sample example, but let's say if you're trying to build a chatbot, right? And whenever the chatbot is conversing, we want the chatbot to remember For example, let's say the company name, right? So input is the company name and output is some ABC company, right? So you are telling the LLM to remember the company name as ABC, right? And let's say if you want the LLM to say welcome to ABC company, right? And instead of writing that ABC every time, you are just storing it here. We are saying input as company and output as ABC, right? So that the LLM will remember whenever the user says company, then the LLM will replace that with ABC, right? So you can keep the data inside this dictionary so the LLM can remember that data, right? So if you have any kind of information you want the LLM to remember, then store them by using this save_context method, right? And here input means human input, output is nothing but LLM's respond. If you are saying hi, you want LLM to respond as WhatsApp. If you are saying not much then you want the LLM to say as not much, right? For example, let's say you are building a chatbot application, right, for your human resource department. So whenever the human tells us what is the link for downloading the payslip, right, then you want the LLM to provide some URL, right? So for the payslip, you can provide the URL www.xyz.com, something like that. So you can provide the URL of your payslip, right? So that is the advantage of using this save context and save context from this conversation to buffer, right? So now let's try to create conversation chain with memory LLM, but we are using conversation buffer window memory, right? So we are telling the LLM to remember only the last conversation, that is k is equal to 1, right? And then let's try to bind the LLM with the memory by using conversation chain. Once we have the conversation chain ready, let's start the conversation with Claude Anthropic LLM, right? So our first conversation is hi, this is Mala, right? So now let's try to run this. And if you see the response here, this is our current conversation, right? Hi, this is Mala, and the LLM responded as hello Mala, it's nice to meet you, and this one, right? So here we have only one conversation so far, right? So let's ask one other question, and this is our second conversation. 2 times 2 is 4, right? And now let's save it and run the code. If you see the current conversation, this was our first question and this is the answer, second question and this is the answer, right? You are absolutely correct, Mala. 2 times 2 does indeed equal 4, right? And now we gave k is equal to 1. So that means the LLM will try to remember only the last conversation, which is 2 times 2 is 4. And it will not remember the name, that is Mala, right? So now let's try to ask the third question. What is my name, right? So now let's run the code. So if you notice here, the response of the LLM, I apologize for the confusion in my previous response. I made a mistake in addressing you as Mala. That was not correct. In fact, I don't actually know your name, right? So we have provided this and then we did the second conversation and this is the third conversation, right? So by now the LLM has forgotten because we have provided k is equal to 1. So that means the LLM only remembered the last conversation and it forgot my name, right? So k is equal to 1 means it will only remember the last conversation and rest of the conversation will not be remembered. It will be ignored, right? So here k is an user defined parameter, right? You need to define this parameter as per your need. Let's say you do not need LLM to remember any prior conversations, then you go for conversation buffer window memory, right? So at least with this, let's say if you have 100 conversations and if you don't want the LLM to remember all the prior 100 conversations, and if you want the LLM to remember only the last 5 to 7 conversations, for example, then you can define the index parameter as 5 or 7, right? So that means we are using less number of tokens, right? Even with this, at one point, it might reach the maximum LLM token limit, right? So in that case, again, we will lose the context and the LLM might ask us to initiate a new task or a new session, right? So in that case, we will lose the entire context. right? Here we only use few questions, but in real time we may have several questions, right? So at one point we might reach the maximum limit and we might lose the entire context, right? So that is another disadvantage of using conversation buffer window memory, but at least you can specify the index parameter and tell the LLM how many number of conversations you want the LLM to remember, right? I hope this is clear. So all we are doing here is we installed all the packages and loaded our required modules, and we read the key and we initialized our LLM, and then the next one is memory, right? Here we are using conversation buffer window memory, and we are telling the LLM to remember only the last conversation, and then we use the conversation chain to bind our LLM with the memory, and then we started our conversations. This was our first conversation and second conversation, and then in the final conversation we asked our LLM what is the name, and it forgot because it only remembered the last conversation because we gave the index parameter k as 1, right? So that's all about conversation buffer window memory. All right, thank you. So far we have seen what is memory and what are the different types of memory, and we have seen the implementation of providing memory to an LLM by using conversation buffer memory and conversation buffer window memory. Now let's see how we can provide an memory to an LLM by using conversation summary memory, right? So let's go to our code editor, VS Code, so we can see the implementation here, right? So we have seen conversation buffer memory, and the second one is conversation buffer window memory, right? Now let's see conversation summary memory, right? So click on memory demo, file, new file, Python file, and let's save it as conversation summary memory demo. The conversation summary memory, as the name suggests, it will try to remember the summary of the conversation and try to answer by using that summary, right? So we can retain the context by summarizing the content, and if we summarize and store, we will be using less number of texts, that means less number of tokens, and we will not lose the context like either conversation buffer memory or conversation buffer window memory, right? Because either in conversation buffer memory we are trying to store every single conversation here, and with the buffer window memory we are trying to store at least few number of conversations, right? So we are trying to store the exact conversations, but whereas with conversation summary memory, it will try to summarize the content and will try to answer from the summary, right? So at least conversation summary is better than conversation buffer or conversation buffer window, right? Now let's see the implementation part. So let me copy the same code until LLM initialization, right? So I'm copying the same code, and instead of conversation buffer window memory, we will be using conversation summary memory, right? So here we installed all the required packages, and then we imported the modules, and then here we are trying to load the environment variable and read the API key and store it in environment variable Anthropic API key. Here we are using Anthropic LLM, right? And this is the model we are using. So this is clear so far. So now let's try to create a long string and see if the LLM can summarize the text, right? So this is our text, and we are assigning this to a variable called schedule. And our text says there is a meeting at 8 a.m. with your product team. You will need your PowerPoint presentation prepared. 9 to 12 p.m. have time to work on your LangChain project, which will go quickly because LangChain is such a powerful tool. At noon, lunch at the Italian restaurant with a customer who is driving from over an hour away to meet you to understand the latest in AI. Be sure to bring your laptop to show the latest LLM demo, right? So this is our text. Now, next step is we want to give memory to the LLM, right? By using conversation summary memory. So we used conversation summary memory and we passed the LLM. We already initialized the LLM, and the max token limit is equal to 100. And then inside conversation summary memory, we have a method called save underscore context, which we have seen already with conversation buffer window memory, right? Memory dot save context, input is equal to hello, output is equal to WhatsApp. If user says hello, you want the LLM to say as WhatsApp, right? And similarly, let's add one more. Input is not much, just hanging. If the user says this, you want the LLM to say cool, right? Now let's try to add one more. If the user says what is on the schedule today, then you want the LLM to respond from this schedule, right? So the schedule is we have already defined with this text, right? Now let's try to load these variables by using inside conversation summary memory. We have a method called load memory variables, right? So here this schedule, it is a long text, right? And the max token limit is 100. And if you do not specify this limit, then it will take the limit of the LLM, right? We know each LLM has its own maximum token limit, right? So in this case, it is Claude Anthropic. Whatever the token limit is there, it will try to take that one. Otherwise, here we are trying to specify the maximum token limit as 100. So in this case, it will consider 100, right? And inside conversation summary memory, we have a function called save_context, right? So inside save_context, you can try to save the question answers that do not change, right? For example, let's say you can give the URL for onboarding document, or maybe payslip URL, or your company's 10K report, right? That is what is onboarding URL, and then you specify the URL. And what is the URL for payslip, and here you specify the URL. Or if the user says how can I download our organization 10K report, then you specify the URL here, right? So for any question, if the answer is not changing, then in that case you can just try to save. You can use save_context and try to save that, right? So what we did here, we installed the required packages and then we loaded the modules, we read the key and stored here, and this is how we initialized our Claude Anthropic model, and then we created a long text. This is our long text, and we are using conversation summary memory, and here we are passing our LLM and we are assigning the max token limit as 100, and by using save_context we are trying to store these variables, right? This is a dictionary, right? So if the user says hello, we want the LLM to say WhatsApp. Not much, just hanging, then you want the LLM to say cool. What is on the schedule today? Then it has to summarize from this context, right? So now let's try to print this and see. So let's run the code. So now you can see here is the new summary incorporating the additional lines of conversation, right? So what is it trying to say? This is the response from AI, right? So here is the new summary incorporating the additional lines of conversation. The human greets the AI and the AI responds casually, right? So what does that mean? The human says hello, the AI says what's up, right? The human indicates they are not doing much, just hanging out. So this one, and the AI acknowledges this with a brief, cool response, right? The human then asks about the day's schedule, right? So that is what we are trying to ask. The AI provides a detailed itinerary, including an 8 a.m. meeting with the product team requiring a PowerPoint presentation. So that means this schedule, right? So it is trying to summarize this text. Time allocated for working on a LangChain project from 9 to 12, right? So that is what we are doing from 9 to 12, right? And a lunch meeting at an Italian restaurant with a customer interested in AI, right? So that is what we are trying to do at noon. Advising to bring a laptop for an LLM demo, right? So this is our long text, and this is how our Claude Anthropic LLM summarized, right? You can see it summarized the lengthy conversations, right? So here you can replace this text with any other text and see how the LLM is summarizing, right? Now let's try to use this conversation chain. So let me minimize this. So now by using this conversation chain, let's try to bind both memory and LLM, right? Which we have seen already. So use the conversation chain for memory, assign memory variable, and for LLM we have already initialized. So assign that and verbose is equal to true, right? So once we have the conversation chain ready, let's try to ask another question by using predict, and here we are trying to pass 9 to 12. what will you do, right? So it should answer based on the summary from the long text, right, which is stored inside schedule variable. And we have already seen it already summarized, right? So now let's see if the LLM will be able to answer for this question from this summary, right? So now let's rerun the code. So you can see the current conversation, and this is the updated summary. Then human, we asked 9 to 12 p.m. what will you do, right? So that is our question. And what is the response from AI? According to the summary provided, from 9 to 12, I will be working on a LangChain project, right? So that is what we have provided here. 9 to 12 p.m. have time to work on your LangChain project, right? And it's trying to give more information here. It's a substantial 3-hour block of time dedicated to this task, right? So for our question 9 to 12, what will you do? This is what our LLM is trying to respond, right? So the LLM was able to answer the question from the summary, right? So it summarized first, and then from this summary it tried to answer the question that we asked, right? Okay. So now let's try to ask more questions, right? So let's ask, what is deep learning, right? Now let's run the code. So you can see the answer from the LLM, right? Now let's try to ask one other question, right? What is AI? And then now let's try to, or let me kill this terminal, and then let me try to rerun the code. So let me scroll up. So if you notice here, this is the conversation, right? And then it tried to summarize, and then we asked a question and the AI responded. And then again we asked another question, what is deep learning? Here it tried to summarize about deep learning. And then if you scroll down, we asked, what is AI? Before this, it says the human then asks about deep learning, right? So what it did, it tried to summarize here, right? That is the advantage of using conversation summary memory, right? So for every single conversation, it is trying to summarize and try to append it to the answer, right? And the next question is, we asked what is AI, and then it tried to provide the answer. And if you ask one other question, then it will try to summarize the previous conversations as well, right? So by using this conversation summary memory, the conversation will be summarized and stored instead of the entire response, right? So that means it indicates less text, right? Which is nothing but less tokens. So this conversation summary memory, this is better than conversation buffer memory or conversation buffer window memory, right? Because in these two cases, we have seen it is trying to store every single conversation entire context, right? But whereas with conversation summary memory, the LLM is trying to summarize and then store, right? So that means less text, so less tokens, right? Even by using conversation summary memory, let's say if you keep asking more questions, it may fail at some point because we know each LLM has context window or token limitation, right? Here we specified the max token limit as 100. Once it uses all the tokens, then it may not be able to answer any further, right? But at least this conversation summary memory is better than the other two types that we have seen. So that's all about memory. So we have seen conversation buffer memory and conversation buffer window memory and conversation summary memory. You can try exploring other memories depending on your requirement, right? But you get the idea of memory, right? Memory is nothing but trying to give power to the LLM so that the LLM can remember the context, right? Now, if you want, you can deep dive other memory types which we have inside this LangChain, right? So LangChain supports these other memory types as well. So this is the official documentation, and depending on your requirement, you can try to deep dive, right? All right. That's all about memory. Thank you. So when a user asks any question to LLM, we know the LLM has been trained with some publicly available data, right? So the LLM can answer with its generic intelligence. Otherwise, if the LLM cannot answer with its generic intelligence, then we need to train this LLM with your organization's domain specific data by loading your documents using document loaders and then chunk the document. We have already learned different chunking methods in the previous lectures, right? And then we have seen how to create embeddings for these chunks, right? Because the LLM cannot understand text and it can only understand numbers, right? And then we have seen how to store these embeddings inside a vector database and provide access to this vector database to the LLM so the LLM can answer for any domain specific user question, right? And this process is called RAG, Retrieval Augmented Generation, and we have seen this already, right? And then we have seen different prompt engineering techniques, that is how to ask a right question to get the right answer from the LLM, right? And then we have seen how to provide memory to an LLM so it can remember the context for any sequential questions, right? And tools and agents we will cover in the upcoming lectures. And now let's see chains, right? So what is a chain? We know LLM can do a single task, right? And chain is a wrapper. So by using chain, LLM can do different complex tasks together, right? So you can use just an LLM alone for simple applications, right? But for more complex applications, we need chaining LLMs, that is either with each other or with other components. We need to chain in order to build complex applications, right? So LangChain provides chain interface to build complex chained applications, right? And we define a chain as a sequence of calls to components, which can include other chains as well. So the objective of chain is it will make complex tasks simpler. That is, a chain can do a few simple tasks together. And we have several built-in chains available inside LangChain, which we will go through. Okay. So chain will allow us to combine multiple components together to create a single coherent application, right? And LangChain has 4 foundational chain types: LLM chain, router chain, sequential chain, transform chain. So LLM chain is nothing but a simple chain with a prompt template and that can process multiple inputs, right? And router chain, it is a gateway that uses the large language model, that is LLM, to select the most suitable processing chain. So depending on your input, it will try to route accordingly, right? And sequential chain, that is a family of chains which processes input in a sequential manner. That means the output of the first chain will be passed as the input to the second chain, and the output of the second chain will be passed as the input to the third chain, right? And so on. And transform chain, this is used to apply data transformations or data processing. For example, let's say if you want to do string manipulation, right? So that's when we use this transform chain. And these chains provide core building blocks for constructing complex workflows with large language models, LLMs, and other tools as well, right? And in the upcoming lectures, we will see implementing different scenarios or projects by using these chains. So we will cover how to implement a single chain, simple sequential chain, math chain, RAG chain, router chain, LLMRouter chain, SQL chain, and we will also see how to deep dive other different chain types depending on your requirements by going to the LangChain documentation. So we will cover how to implement different scenarios by using these different chain types. Alright, thank you. So far we learned about what is chain and what are the different types of chains available, right? So what is chain? Chain will allow us to combine multiple components together to create a single coherent application, right? And we have several chain types available, and we will see the implementation of these chain types one by one, right? The first one is single chain. So let's go to VS Code and see the implementation of single chain, right? So you can create a chain that takes user input, formats it with a prompt template, and we have already seen this in our prompt engineering demo already. So let me go to prompt engineering demo and let's try to open one of the prompt engineering type. So here you can see we have used LLM chain, right? And if you go to this basic chain, we are trying to bind both LLM and prompt together by using this LLM chain, right? So you can build more complex chains by combining multiple chains also together. So this chain is not new to you. We have already seen another chain, that is conversation chain, when we did our different types of memory implementations, right? For example, if you come here, we have seen conversation chain, right? So if you see this chain, we are trying to bind LLM with memory, right? So that is the advantage of using chain. So similar to conversation chain, we have several other chain types available. So now the first one is simple chain, right? So let me close these, and similar to how we have done before, I have created an empty folder which is called chains demo. So let's try to add this folder to our build generative AI applications workspace, right? So come to this explorer, right click, add folder to workspace, and select chains demo and add an S, right? So this is an empty folder, we do not have anything here, right? So let's try to create an Python file. So we are starting with a simple chain, so let's try to save this inside our chains demo, and let's save this as single chain demo and save it. And here we will be using OpenAI as our LLM. So let me try to create an environment file here, .env, where we can store our API key, right? I've already shown how to get the API key from OpenAI, right? So make sure you get your key and store it here. Store your API key here, okay? So once you store your API key here, first thing is let's try to install all the required packages and then import all the modules that are required, right? So make sure you install LangChain OpenAI. Whenever you get any message that the module is not found, then make sure you install the corresponding package by using pip install. So all you have to do is go to the terminal and then type here. For example, let's say if you do not have LangChain OpenAI package installed on your machine, then just type pip install LangChain OpenAI and hit enter. Then LangChain OpenAI package will be installed on your machine, right? I have already installed, so I'm not installing again. And then we are trying to load chat OpenAI from LangChain OpenAI, and then chart prompt template from LangChain prompts chat, and human message prompt templates again from LangChain prompts and chat. And this is to load the environment variable where we stored our API key, right? What we did so far, we have installed all the required packages and then we loaded our modules and save it. And the first thing is let's try to load the environment variables from .env file by using load_.env function, right? And then once we load the environment file, next thing is let's try to read the API key by using this OS module and use the getEnv function, and this is the name we have given inside our env file, right? So this is where we try to store our API key. So we are trying to read the API key and assign this to API_key. So once we read the API key, let's try to assign this API key to environment variable which is called OpenAI API key. So once we have the API key, if you notice here we have human message prompt template. So let's try to create a simple prompt by using this human message prompt template which is imported from LangChain prompts chat, right? So we are trying to create a simple prompt by using human message prompt template. and inside this we have a method called from template, and here you can pass the message. Make a funny company name for a company that produces this product, and this product is a dynamic variable, right? So instead of hard coding the value, we are just trying to use a dynamic variable, and we will pass the value to this variable when we invoke the method, right? So instead of hard coding the value, we are using a dynamic variable, right? So the next thing is we have chat prompt template, right? So let's try to create a chat prompt template by using this chat prompt template. So we have already created the prompt, which is nothing but human message prompt, and let's pass this to our chat prompt template, right? So we are using chat prompt template, which is inside LangChain prompts chat, and inside that we have a method called from messages, and we are passing this simple prompt, right? So we have the prompt ready. This chat prompt template has the prompt, that is the question that we will be asking to our LLM, which is nothing but OpenAI, right? So what we are trying to ask, make up a funny company for a company that produces the corresponding product. We will pass the product and it will give us the funny company name, right? So our prompt template is ready. So before we use our chain, we need an LLM, right? So now let's try to initialize our OpenAI LLM by using chat OpenAI, which is from LangChain OpenAI. So this is our chat prompt template. Next thing is let's initialize LLM. So we know we can initialize LLM by using this chat OpenAI, and I'm assigning to a variable called LLM. So we have our chat prompt template ready, and we also have our LLM ready. Now once we have both LLM and prompt template ready, so let's try to bind our LLM with this chat prompt template by using chain, right? Bind LLM and chat prompt template. So always remember, this pipeline is a representation of a chain. So here we are trying to bind LLM with the prompt template by using this chain, okay? And we are assigning to a variable called chain. So this is a single chain, right? So we have created the chain by binding LLM with the chat prompt template. So this chain is nothing but combining multiple components, and here the components are LLM with chat prompt template, okay? So once we have the chain ready, inside the chain we have a method called invoke, which we have already used in our previous implementations, right? So let's try to call the invoke method and pass the product name, right? So inside the chain we have the method called invoke, and for the input attribute we are trying to pass the topic name and call the content attribute and assign this to a variable called funny company name. So here we have to pass the value to this dynamic variable product, and we are passing by using input is equal to topic. So we have to initialize the variable by assigning the value to this, right? So for example, let's say the topic name is travel. So this travel will be passed here. So when we invoke, this travel name will be replaced here, and then it will try to give us a funny company name for a company that produces travel, right? Now let's try to see what we have inside this funny company name, and here you can replace this topic with any other product. Instead of travel, you can replace with any other product and see what is the funny company name that our LLM is trying to give us, right? So now let me try to print and see what we have inside the funny company name, right? So let's try to run the code. So you can see this is the funny company name for a company that produces travel, right? So Wanderlust RS, your one-stop shop for slightly off-centered adventures. So this is one of the funny company name, and let me just try to format this, right? Instead of just printing this way, let's just try to comment this. We've already seen this, so I'm commenting this as well. So what we are doing here, I'm just trying to bold it here. So this is a new line, /n is a new line, and this is just for making this text bold. I'm just giving this, and this is the topic, make a funny company name for the topic travel. So this will come as bold because we are giving this, and then I'm just trying to print 50 times this hyphen, and then this is, we are trying to make it not bold, and then it will give the value of the funny company name, right? So let's try to kill this and then rerun the code. So now you can see, make a funny company name for the topic travel, right? So this travel is passed here. So I'm just trying to bold it here, and then we are trying to print 50 times this, and then this is to make it not bold, and then we are trying to print the value funny company name. So this is the funny company name our LLM OpenAI is trying to give us, right? So let's say instead of travel, if you are interested in tennis, right? So let's replace this and rerun the code. So now you can see, make a funny company name for the topic tennis, smash hits rocket go, right? This is the funny company name it has given us. And then now instead of tennis, let's replace this with chess, right? And let's rerun the code. So now you can see, checkmate comedy chess go, where every move is a funny one, right? Or instead of chess, let's give dance and rerun the code. So for dance, this is the funny company name it has given us. So now you get the idea of how to use chain to bind one or more than one components together. You can bind multiple chains, or you can bind LLM with either template or memory, right? So you can try to bind LLM with multiple components by using this chain. So that is the objective of using chain. So what we have done here, we have installed all the required packages, that is LangChain OpenAI, by using pip install LangChain OpenAI, and then we have imported all the required modules. Here we are using these modules, chat OpenAI to chat with our OpenAI LLM, and then prompts, we have used chat prompt template to create this template, and also human message prompt template. And then by using this load_.env, here we have created the environment variable. Inside that we have stored OpenAI API key. So we are trying to load that by using load_.env, and then we try to read the key, and we stored this key inside our environment variable OpenAI API key, right? So let me close this. So once we have the key ready, next thing what we did, we tried to create a simple prompt by using this human message prompt template. Inside that we have a method called from template, and we passed our template. We're trying to give, make a funny company name for a company that produces this product, and this product we will be passing when we try to invoke the chain here, right? And then here we are trying to create a chat prompt template by using chat prompt template, which is inside LangChain prompts chat, and inside that we have a method called from messages, and we are passing this prompt, right? And then we got our chat prompt template. So we got the template ready. Next thing is LLM. This is how we can initialize our LLM, which is nothing but OpenAI, right? So inside LangChain OpenAI, we have this chat OpenAI. So by using that, we are trying to initialize our LLM. And once we have the LLM and the template ready, we are trying to bind our LLM with the chat prompt template by using this chain. So this pipeline is a representation of chain. So once we have the chain ready, inside chain, we have the method called invoke. And for input attribute, we are trying to pass the topic, which is nothing but our product, right? Dot content, and this will give us the funny company name, and we are trying to print it. So we are passing the product, and it will give us the funny company name, right? So the objective of chain is to bind LLM with any other component, right? It can be template or memory or any other component, right? So this is a single chain where we passed our product name, and it gave us a funny company name for that product. All right, thank you. So we have seen single chain. The next one is simple sequential chain. So let's go to VS Code and see how we can implement simple sequential chain. Okay. So this is our build generative AI workspace. So inside this, we have created chains demo folder, and underneath we have single chain demo. So what we have done in single chain, we have used human message prompt template, and we created a simple prompt, and then we passed that to chat prompt template from messages, and we created the chat prompt template, and we initialized our LLM by using chat OpenAI, And once we have the LLM and the chart prompt template ready, we try to bind LLM with the chart prompt template by using chains, right? And we have provided the topic, and the OpenAI tried to give us the funny company name, right? So here we try to call the invoke method and get the results, right? So this is single chain. Now let's try to see simple sequential chain. So let's go to chains demo, file, new file, Python file, and let's try to save this as simple sequential chain demo underneath chains demo folder, right? So save it. So the first thing is we have to install all the required packages by using pip install LangChain OpenAI. This is the package we need because we will be using the modules that are present inside LangChain to see simple sequential chain implementation, right? So make sure you install LangChain OpenAI package in case if you haven't installed already. We have used the same package here as well when we are implementing single chain, right? So now let's try to import all the required modules. So here we will be using OpenAI. So we are importing chart OpenAI to initialize our OpenAI LLM, and then chart prompt template to create a prompt, and then this is to load the environment variable, right? So inside our chains demo, we created an environment variable and we stored our OpenAI API key here. So let's try to load the environment variables from this environment file by using load_.env, right? So once we load the environment file, the next thing is read the API key by using getEnv function and pass the key name. So we will get the API key value, and we are storing inside this variable API underscore key. And now let's assign this API underscore key to an environment variable which is called OpenAI API key. So we installed all the required packages, we try to load the modules that are required, and then we try to load the environment variables from this environment file, and we read the key, and then we stored our OpenAI API key inside OpenAI API key environment variable, right? So what is sequential chain? Sequential chain means one after another, right? So that is the output of first chain will be passed as the input to the second chain, and the output of second chain will be passed as input to the third chain, right? So it will be executed one after another, right? So the next step is let's initialize our LLM by using this chat OpenAI, which is from LangChain OpenAI package, right? Let me close this. So we can initialize OpenAI LLM by using this chat OpenAI, which is inside LangChain OpenAI package, right? So once we initialize the LLM, the next thing is let's try to create a prompt template by using this chat prompt template. Again, this is from LangChain prompts, right? So the first thing is let's try to define a prompt template, and here we are creating a prompt template and assigning to a variable called template. Give me a simple bullet point outline for a blog post on the topic, right? So whatever topic we pass, it will try to give a simple bullet point outline, right? And now let's say the topic is travel, right? So let me define the topic as well. Here you can replace this travel with any other topic and see if the LLM is returning the bullet points for this topic or not, right? And this prompt is nothing but the question that we are asking to the OpenAI LLM, right? And here we are telling the LLM to create a blog post on the topic travel, right? That is, I will provide a topic and the LLM will provide me with a bullet point outline on that particular topic, right? So this is the task, and we already created the template, right? So now let's pass this template to chart prompt template and create our prompt. So we are using chart prompt template, which is inside LangChain prompts. Inside that we have a method called from template, and for this we are passing the prompt template which we have defined before, right? So this is how we created our prompt. Now once we have the prompt and also the LLM ready, the next thing is let's try to bind this LLM with this prompt by using chain, right? So let's try to create a chain. So we are trying to bind the LLM with the prompt, by using this chain, right? So always remember this pipeline represents a chain, right? So this is single chain because we are trying to bind LLM with the prompt, right? So let's call it chain 1, right? So this is first prompt and this is chain 1. Now let me just try to print what we have inside this chain 1, right? So let's run the code and see if it is working so far. So you can see chain 1, we have the prompt template and we also have the LLM, right? This is the chat prompt template and the template that we are passing is this, and we also have the LLM details, right? So far we are good, right? So this is the first task. So we have provided the topic, which is nothing but travel, and we are asking our LLM to give us a simple bullet point outline for a blog post on the topic travel, right? So this is the first task, right? Now similarly, let's try to do another task, that is second chain or task, right? So first of all, why do we need a chain? To bind simple tasks together to create a complex task, right? Remember, chain is not an LLM, right? Chain is kind of a process that helps us to solve tasks by binding different components together, right? So let's try to create another prompt by using this chat prompt template, just like how we have done before. Let me copy the same code, and instead of this template, let's replace this with write a blog post using this outline, right? So when we invoke first chain, that will give us a blog post, right? And the output of the first chain we are passing as an input to our second chain, right? So for this outline, we are asking to write a blog post using this outline, right? So we don't have to define the topic again. And here we are trying to create the prompt. So let's name it second prompt. And again, we are using chat prompt template and we are calling the function from template and we are passing this template, right? And then let's try to create chain 2, right? And bind the LLM with the second prompt, and this is our second chain, right? So what we did so far, this is our first task, right? We are passing the topic as travel, and that will give us a bullet point outline for a blog post on travel. And once we get the bullet point outline, we are creating a second task. For this second task, whatever the output we get from the first chain execution, we will pass that as input to the second chain, and we are asking the LLM to write a blog post using the outline that we got from our first task. So far we have created 2 tasks. And now let's try to combine this chain 1 and chain 2 by using another chain. So full chain is equal to chain 1, and again we are trying to chain, right? So you can chain 2 chains together by using chain. So either you can bind LLM with a prompt or LLM with a memory, or we can also bind 2 chains by using chain, right? So here we are trying to bind 2 chains and we are assigning to full chain, right? So full chain will do 2 tasks together. That is, we created a complex task which is nothing but a full chain by combining 2 simple tasks. One is chain 1, the other one is chain 2, right? That is task 1. We will provide a topic and the LLM will provide us with a bullet point outline on that particular topic. And task 2 is we will be passing the outline, which is the output from chain 1, as an input to chain 2, and the LLM will give us the complete blog post, right? So the output of first chain is input to second chain, and we will get the output, right? So here this ABC will be replaced with first chain output, which is nothing but the topic outline, right? So we will pass the topic and we will get the outline for a blog post, and that outline will be replaced here and we will get a blog post for that outline, right? Once we have the full chain ready, let's try to call the invoke method, right? So inside chain we have a method called invoke, and let's try to pass the topic as travel, right? So we got our result. Now let's try to print the result and see what we have inside this result variable, right? So here what we're trying to do, slash n means this is a new line, and this is, I'm just trying to bold this text, write a blog post using outline. I'm just trying to bold that text by using this, and then we are trying to just print 50 times this, right? And then this one to not make it bold, and inside the result we are just trying to get the value of content, right? So let's try to save this and run the code. So if you see here, we are trying to print chain 1 and chain 2, and here we are trying to get a blog post using the outline, right? That is our full task, and the topic is travel, right? So this is the blog post it has given us, right? So let me close this. So what we have done here, we created two tasks. The first one is this one, and then the second one is this, and then we try to combine these two tasks together by using another chain, and we try to invoke it, right? Let's say if you are confused, let's try to print just the output of chain 1, right? So let me comment this chain 1 and chain 2, and then chain 1 dot invoke and pass the topic, that is the input for chain 1, and we will get the chain 1 result, right? Let's try to print the value inside the result, right? Result dot content, and what we are trying to tell, for the first chain, give me a simple bullet point outline for a blog post, and we are passing the topic as the input, and we will get the result dot content, that will give us the first chain output, right? So this is our task 1, and whatever the value we get from task 1, that will be replaced here. So this dynamic variable will be replaced with this value, whatever the output we get from first task, right? And that will be passed here, and this will try to execute and give us the complete blog post, right? So let's try to rerun the code. So now let's try to understand this output. So the first one is give me a simple bullet point, right? So it tried to give us the bullet points and try to outline for the topic travel, right? Introduction to the joys of travel, right? Benefits of traveling, tips for planning a trip, right? So it gave us few bullet points, and then this entire value will be passed here as an input to second chain, right? So write a blog post using this outline, whatever outline we got from task 1, that will be passed here, and then here again we are trying to invoke, right, by combining these two tasks. So that will be passed, and then we will get the complete blog post, right? You can pass a topic, it will give you an outline, and then it will also give us a complete blog post, right? So instead of the topic travel, let's try to give AI, right? So we are asking the LLM to give us a bullet point outline and also give a complete blog post on the topic AI, right? So let me kill this and then run the code again. So let me scroll up. Now you can see the first task is, it is giving us a few bullet point outlines for the blog post. The topic is AI, right? Introduction to AI, the history of AI, applications of AI, right? What are the benefits, challenges, future of AI, and conclusion, right? So it tried to give us a few bullet points outline on AI, and then we will pass this as the input to the second one. So we will get a complete blog post, right? So this is our complete blog post, right? So similarly, you can replace this topic with any other topic. So this is sequential chain. Sequential chain means output of first one will be passed as input to the second one. And let's say if you have chain 3, the output of chain 2 will be passed as input to the chain 3, right? So that's how this sequential chain works. So let's quickly review what we have done here. So we have installed all the required packages. In case if you have already installed, you don't have to install it again. Otherwise, make sure you install LangChain OpenAI package, because we are using the modules which are inside LangChain OpenAI, right? And then we try to import the modules. This chat OpenAI module is to initialize our LLM, and this is to create a prompt template, right? And the next thing is we try to load the environment variable, we read the key, and we stored our OpenAI API key inside this environment variable. And then we initialized our LLM by using chat OpenAI, which is inside LangChain OpenAI package. And here we created a simple prompt template, right? Give me a bullet point outline for a blog post on topic. Here topic is a dynamic variable. You can replace this topic with any value, right? And then first thing is we try to create a prompt by using chart prompt template, which is inside LangChain prompts. And we have a method called from template, and we passed this prompt template which we defined here. That is our first prompt. And once we have the prompt and LLM ready, we try to bind our LLM with the prompt by using chain, right? So we got our first chain. And inside chain, we have a method called invoke. So you can call that and pass the topic as our input. So you will get a bullet point outline on the topic that we have provided, right? So that is our first task, and we try to print here. Similarly, we try to define the second template, write a blog post using this outline. Whatever the value we get here, this will be passed to this dynamic variable ABC, and then we created a second prompt by using this chart prompt template. Inside that we have from template and we passed our template, right? So we got the second prompt, and we try to bind our LLM with the second prompt by using the chain. So we created chain 2, right? And we try to combine chain 1 and chain 2 together by using another chain, and we named it full chain. So when we invoke this by passing the topic, then first it will try to execute chain 1, and whatever the output we get from chain 1 will be passed as input to chain 2, and it will try to execute. And we got a complete blog post by using the outline which we got from chain 1, right? So that's how you can implement a sequential chain and execute multiple complex tasks one by one, right? And another example can be, here you can write a prompt, go to a website and download the content. And the second prompt can be, whatever the content you downloaded from first one, just try to summarize it, right? So that is another example. Or another example could be, task 1 can be web crawling, right? So go to a website and try to get the content, and the second task can be summarizing the content, right? So you can use sequential chain in these scenarios, right? So now you get the idea. So whenever you have multiple tasks and one task is dependent on another task, then you can use this sequential chain and try to chain and get the results. So that's how you can use sequential chain. Thank you. So far we have seen how to use single chain, simple sequential chain, and now let's see sequential chain, right? So simple sequential chain, this is the output of the first chain will be passed as input to the second chain, right? Whereas the sequential chain, this will allow for more complex relationships between different tasks. For example, let's say if you have multiple inputs or outputs for each task, then we use sequential chain, right? So now let's go to VS Code and see the implementation of sequential chain. Okay. So we have seen single chain and also simple sequential chain. In single chain, we have given the topic, and then the LLM gave us a funny company name for that topic, right? By using this simple chain. And then in simple sequential chain, we created two tasks and we try to execute one task after another, right? Now let's see the third one, file, new file, Python file, and let's save this as sequential chain demo and save, right? So now let's see sequential chain demo, right? So the first thing is, we have to install all the required packages, and the package is LangChain OpenAI. In case if you haven't installed, make sure you go to the terminal and execute pip install LangChain OpenAI command, right? And the next thing is we have to load all our required modules. This chat OpenAI chat prompt template, and this is for loading the environment variables, right? So we've already seen this code. The first thing is, by using load underscore .env function, we are trying to load the environment variables from this environment file, and we are trying to read the key and trying to store that key inside OpenAI API key. environment variable. And the next thing is, let's try to initialize our LLM by using chat OpenAI, which is inside LangChain OpenAI package, right? So let me close this. So we got our LLM initialized. And now the task number 1. For example, let's say you have an employee review and your employee name is Joe Smith and the position is software engineer, and the employee strengths. Joe is highly skilled software engineer and collaborative nature, that is another strength, right? So these are some of the strengths, right? And the next one is weaknesses, right? So Joe has some weaknesses, right? So here we listed a long text with Joe's strengths and weaknesses, right? So this is our employee review. Now once we have the review ready, now let's try to create a prompt template for task 1. So let's try to define our first template. Give a summary of this employee's performance review, and we are passing this review. This review is stored inside this employee review, right? So we are passing our input as employee review, and we are asking our LLM to provide us a summary of this employee's performance review, right? So we are passing a long text to our LLM and we are asking our LLM to give us a summary, right? So that is the first task. And now let's use this chat prompt template and pass this template, right? So this is our template. This is how we want the LLM to execute, right? So by using the chat prompt template, we have a function called from template and we are passing our template. This is our first prompt. Now we have our LLM ready and we also have our prompt ready, right? Now let's try to bind both these components by using chain. So let's try to create a chain by binding both LLM and prompt. This is the chain representation, right? So we got our first chain. Now let's try to call the invoke method inside this chain 1 and see if the LLM is actually giving us the summary of this employee performance review, right? So let's try to print the results and see. So what we are trying to do here, /n is a new line. I'm just trying to bold this text, summary of employees performance review, so you can see better in the terminal, right? And then we are trying to print 50 times this hyphen, and then here I'm just trying to not bold it, and the result is inside the chain we have a method called invoke and we are passing our employee review, which is the input to our first chain, and we are getting the content, right? So let me save this and run the code. So now you can see the summary of employees performance review, right? So we gave a long text. We gave a long text of employee review and our LLM OpenAI summarized this entire content, right? Overall, Joe Smith is a highly skilled software engineer with a strong technical expertise, collaborative nature, self-motivation, adaptability, and so on, right? So this is the summary. So that is our task number 1. We gave employee review as input to our OpenAI LLM and it gave us the summary, right? This is task number 1. That is to generate a summary of employees performance review by using sequential chain, right? Now let's try to create another template, right? So the second template, this is our second template. Identify key employee weaknesses in this review summary. So this one has the summary, right? By using this summary, try to identify employee weaknesses, right? So that is our task number 2. So again, let's try to create the prompt by using this chat prompt template. We have a function called from template and pass this second template. So we will get the prompt 2. And once we have our prompt ready, and we also initialized our LLM here. So let's try to bind both of them by using chain, right? So we got our chain 2. Now let's try to print this chain 2 and see if our LLM is actually returning us the weaknesses from chain 1's result, which is nothing but the summary, right? So let's try to print the result. Here what we are trying to do, identify key employee weaknesses in the performance review summary. 50 times I'm printing this and then not trying to bold this. So here what we are doing, chain 1 and chain 2, we are trying to bind again by using chain, which is nothing but full chain. We have seen this in simple sequential chain, right? So chain 1 and chain 2, we are binding them together and then calling the invoke method by passing employee review, and we are trying to get the content, right? So this is our task number 2. So the second task is to identify key employee weaknesses from the output of first chain, which is nothing but summary, right? So the output of first chain will be passed as input to the second chain. So let's see the terminal and kill this and let's try to run again, right? So what we have done so far, we gave this long text of employee review as input to the first chain and then it summarized it, right? And the second task is by passing this summary as input to our second chain and it gave us the employee weaknesses, right? Time management, written communication skills, delegation abilities, right? So these are some of Joe's weaknesses, right? So this is task 1 to summarize. Task 2 is to identify the weaknesses, right? So we have done 2 tasks here. And now let's create another task, right? So first thing is, let me try to define a template, create a personalized plan to help address and fix these weaknesses, right? So we have identified all the key weaknesses from task 2, right? So we are passing output of second chain to input for the third chain, and then let's try to create the prompt by using chart prompt template. Inside that we have from template function and we are passing template 3, and once we got the template, let's try to bind both LLM and prompt by using chain, right? So we got chain number 3. Now let's define the sequential chain by using all these 3 chains, right? So sequential chain is equal to chain 1, chain 2 and chain 3. We are just trying to bind all these chains together. Once we bind them, let's try to call the invoke method which is inside chain, right? So results is equal to sequential chain dot invoke, and we are passing employee review as the input. So we will get the summary, and then once we get the summary, here we'll get the weaknesses, and here we will pass the weakness, and then finally we will get personalized plan, right? So we have task 1 give us the summary, task 2 to give us the key weaknesses, and task 3 is to give us the personalized plan to help address these weaknesses, right? So total we have 3 tasks. And now let's try to print the results, right? So create a personalized plan to help address and fix these weaknesses. 50 times we are just printing this, and then results.content, right? So the third task is to create a personalized plan. So now let's kill this and then run again. So if you see here, this is our task number 1. Give us a summary. We provided a long text of employees performance review and it gave us the summary. And task number 2 is it identified the key weaknesses of employee Joe, right? And then finally it created a personalized plan to help address and fix these weaknesses, right? So we got these weaknesses from task 2. Task number 3 is provided a personalized plan to fix these issues for time management, for written communication and delegation of tasks. So this is how it is trying to give us a plan, right? So let's quickly go through what we have done here by using this sequential chain. The first thing is we installed all the required packages, and then we tried to load the modules, and then we tried to load the environment variables from the environment file, and we tried to read the key, and we stored the OpenAI API key inside this OpenAI API key environment variable, and then we initialized our LLM by using chat OpenAI, and then here this is our input, right? So instead of hard coding here, you can try to read it from any other data source, right? So let's say you have a long text of employee review. Here the employee name is Joe Smith and this is Joe's review, right? And then what we are trying to do here, we are trying to create a template. Give a summary of this employee's performance review. So this is the employee's performance review So we are trying to ask our LLM to give us a summary, and we are creating our first template, and then we created our chain by binding both prompt and LLM. So first thing is we got our summary, and then similarly we defined our second template, right? So here we defined our template, we created the prompt, and then we tried to bind both LLM and prompt, and we got the key weaknesses, right? So we tried to bind both chain 1 and chain 2 and call the invoke method by passing the employee review. So we got the key weaknesses, right? And then these key weaknesses again we passed as input to third one. So here we are trying to create a personalized plan, right? And then we created the prompt, tried to bind both LLM and prompt, and we created a sequential chain by chaining all these chains together. And then inside the sequential chain we have a method called invoke and pass the employee review as the input. Finally we are getting the personalized plan, right? So that is how you can use a chain to bind LLM with a prompt, or you can also chain multiple chains together. Alright, so that's about sequential chain. Thank you. So far we have seen single chain, simple sequential chain, and sequential chain. In sequential chain we have already seen one of the application. Now let's go to VS Code and see one other application as well by using sequential chain. So let's go to VS Code. So we have seen one of the application by using sequential chain. So what we did here, we passed our employee review and we created the first chain and we got the summary, and whatever the summary we got from the first chain we passed that to second chain and we got the employee weaknesses, right? And then finally we passed that weaknesses to third one and we got the personalized plan to help address and fix these weaknesses, right? So this is how we implemented by using sequential chain. Now let me create one other file and let's save this as sequential chain demo. We already have that, so let me give 2. So the first thing is we have to install LangChain OpenAI package. In case if you haven't installed already, go to the terminal and then type pip install LangChain OpenAI and hit enter. So that way LangChain OpenAI package will be installed on your machine, right? Now the next thing is we need to import all the required modules from LangChain package, right? So here we are trying to import chat OpenAI from LangChain OpenAI and chat prompt template from LangChain prompts, string output parser from LangChain core output parsers, right? So this is used to parse the results, right? And then runnable pass through, this is from LangChain core's runnables, right? And then we are also using item getter from operator. I will explain all this in detail when we are trying to use them, right? So the first thing is like we did before, inside the environment variable we stored our OpenAI API key. Now let's try to load the environment variables from .env file by using load_.env function. And then the next thing is let's try to read the API key, and we are using os module .getenv function and we are passing the key name, so we will get the value, and whatever the value we get it, we are trying to store that inside OpenAI API key environment variable, right? So far we installed all the required packages, we loaded the modules, and then we read the API key from our environment file, right? Now in order to chat with our LLM we need to initialize our OpenAI LLM by using chat OpenAI, which is from LangChain OpenAI package, right? Once we have the LLM ready, the next thing is let's try to define a prompt. So here we are using chat prompt template, which is from LangChain prompts. Inside that we have a method called from messages, and here this is our prompt. What we are doing here, system, you are a helpful assistant who generates interesting topics. User, generate a random academic topic for discussion. Okay, so this is our prompt. And then let's try to create a chain, because now we have our LLM and the prompt ready. Let's try to bind this LLM with the topic prompt by creating a chain. So here we are trying to create a chain by binding this LLM with the prompt and also string output parser. This is to parse the result, right? So that is our first chain. Now let's try to create another chain to generate questions about this topic, right? Because we are asking to generate random topic for discussion, right? So let's try to define another prompt. The second chain to generate questions about whatever topic we are getting here, right? So the question prompt is equal to, but again we are using chart prompt template, which is from LangChain prompts, and inside that we have a method called from messages. And system, you are a helpful assistant who generates thought-provoking topics, and user, generate 3 thought-provoking questions about this topic. So here we will get a random academic topic, and this topic will be passed to the second one. So we will get 3 thought-provoking questions about whatever the topic it selects, right? So that is our second prompt. Now we have our prompt ready. We also have our LLM ready. Let's try to bind this question prompt with LLM by using chain. So let's create question chain. We are trying to bind this LLM with the prompt that we just created, and also string output parser. So we have topic chain and also question chain ready. Here we will get a random academic topic, and then here we are passing the topic, so we will get 3 thought-provoking questions about whatever topic we selected from chain 1, right? Now let's try to create a sequential chain by using this topic chain and question chain, right? So here we are trying to create a sequential chain. What we are doing here, for topic we are assigning this topic chain and runnable pass through, and then topic item getter topic. So when I run, then you will see. And for questions we are passing question chain, right? So this is how we created our sequential chain. So once we created the chain, we know inside the chain we have a method called invoke, right? So let's call that method so we can see the results. So results is equal to sequential chain dot invoke. So that will give us the results. Now let's try to print these results, right? So you can see, generate 3 thought-provoking questions about a random academic topic, and this text we are trying to bold with this, and then 50 times we are trying to print this, and then here I'm trying to not bold this result, and then we are trying to get the 3 questions, right? So that is what we are trying to print. Now let me save this code and let's try to run this code and see. Okay, so now you can see we are trying to print generate 3 thought-provoking questions about a random academic topic, right? And those 3 questions are this one, and the topic that it selected is artificial intelligence, right? So if you see the output here, how can the integration of artificial intelligence in cybersecurity lead to more effective and proactive threat detection and response mechanisms? What ethical considerations should be taken into account when utilizing AI in cybersecurity? In what ways the use of AI in cybersecurity be balanced? So looks like the topic is artificial intelligence in cybersecurity. So that is the topic it selected, and then it is trying to generate 3 questions for us, right? So that is what we are asking our OpenAI LLM to generate. And this runnable pass through, this is a function inside LangChain. This will just pass the output as it is to the next layer, right? So whatever question we are passing, that will be passed to the next layer as it is. So that is why we are using this runnable pass through. And then topic, for topic we are passing the topic chain, that is the first chain, and this is topic number 1, 2, 3, right? So to generate the numbers, so topic 1, 2, 3, and then questions, these are the 3 questions. So here we are asking to generate 3 thought-provoking questions about whatever the topic it selected from the first chain. And if you want to see just the topic alone, you can call topic chain. Inside that we have the method called invoke, right? So you can invoke that and then see what it is returning, right? So let's try to kill this and then let's try to rerun the code and see. So if you see the questions here, it selected virtual reality technology, right? So how can virtual reality technology be effectively integrated into traditional mental health treatment methods to enhance therapeutic outcomes? So this is the second question and this is the third question, right? So again it generated 3 questions on using virtual reality technology, right? So If you want, you can just kill this and let's try to rerun the code again. So every time it is trying to generate a random topic and also generating 3 thought-provoking questions, right? So how can society ensure that the benefits of increased efficiency and productivity from AI are equitably distributed among all members of the workforce? And the second question is, what measures can be taken to retain and upskill workers whose jobs are at risk of being automated by AI? How might the rise of AI and workforce automation challenge traditional notions of work, job stability, and so on, right? So it created again 3 topics. And if you are interested, you can read in the code again and see what topic it is trying to select and what kind of questions it is trying to generate, right? So again, it generated 3 questions related to AI. So let me close this. So let's quickly review what we have developed here. So the first thing is we installed LangChain OpenAI package. We imported all the required modules and then we tried to load the environment variables from this environment file and then the API key, and then we stored the API key inside OpenAI API key, and then we initialized our LLM by using chat OpenAI, and then here we created our first prompt. So we are telling our LLM to generate a random academic topic for discussion, right? So this is our prompt. And then we are trying to bind this LLM with the prompt and also string output parser by using chain, right? And we assign that to topic chain. And similarly, we created second chain to generate questions about whatever the topic it is selecting, right? So the prompt is generate 3 thought-provoking questions about this topic, whatever the topic it is selecting, right? And now again we created another chain by binding the LLM with the prompt by using chain, and we assigned that to question chain, right? And then once we have both topic chain and question chain ready, we are creating a sequential chain. We are assigning topic to topic chain and runnable pass through, and then this is just the topic numbers, right? And then the questions, and we are assigning this question chain, and this is the sequential chain, and we are calling the invoke method, so we'll get the results and we are trying to print the results, right? So this is how you can use this sequential chain to perform a complex task by binding multiple chains together, right? So if you notice here, again we are using chain to combine multiple tasks and perform a complex task. All right, thank you. So far we have seen single chain, simple sequential chain, sequential chain, and the next one is math chain, right? So if you are building a generative AI application that involves a lot of math calculations, then we can use this math chain. So now let's go to our VS Code and see how we can implement this math chain, right? So this is our VS Code. So we have seen single chain, simple sequential chain, right? Now let's create a new Python file and let's save this as MathChain demo. And now let's try to ask a simple math question and see how the LLM responds. The first thing is we need to install all the required packages, right? I'm trying to install LangChain OpenAI package. So this is one other package. So make sure you install these packages if you haven't installed already, right? And then the next thing is we need to load all the required modules, right? So here we are trying to load chat OpenAI from LangChain OpenAI, LLM MathChain from LangChain Chains, and human message from LangChain schema, and load.env from .env, right? And this is the OS module. Now the first thing is let's try to read the environment variable from this environment file, right, by using load_.env function. So that is our step number 1. So we are trying to load the environment variables from this .env file. In case if your environment file is stored in some other directory, then you have to navigate to that directory and then try to read the key, okay? And then we are trying to store the API key inside this environment variable OpenAI API key. And once we have the key, the next thing is let's use this chat OpenAI from LangChain OpenAI and then try to initialize the LLM. So this is our LLM. Now let's try to ask few math questions to our LLM OpenAI and see how it responds. So this is our LLM. Inside the LLM we have a function called invoke, and then we are passing this human message which is from LangChain schema, and we are passing this question: what is 17 raised to the power of 11, right? So this is our math question. And now let's try to see what we have inside this result, right? So let's try to print the results. So here we are just trying to bold this text. What is 17 raised to the power of 11? We are just trying to bold that text, and then 50 times we are printing this hyphen, and then we are trying to get the value of the content from this result, right? So now let me save this code and let's run the code and see. So you can see what is 17 raised to the power of 11. It is giving 17 to the power of 11 is equal to this value, right? So what we did here, we haven't used LLM math chain yet. Here we are directly passing the question and trying to get the answer. We installed all the required packages, we imported the modules, and then we read the key. We stored inside OpenAI API key, and then we initialized our LLM, and then we passed this question and we try to call the method invoke, and we are trying to print the results, right? And then let's try to ask one other question. So what we are trying to ask here, the question is, give me the Python formula that represents what is 17 raised to the power of 11. Only reply with the formula, nothing else. Okay, so we do not want the result. We want the formula to represent in this format, right? Now let's try to print the results and see what we have inside this content, right? So let's kill this terminal and then let's rerun the code. So now you can see it only gave the formula, right? Because the question that we are asking the LLM is, give me the formula that represents this. Give me the Python formula that represents what is 17 raised to the power of 11. Only reply with the formula, nothing else, right? So that is what we asked the LLM, and the LLM gave the formula, right? So you can see the difference here. So here we are directly asking what is 17 raised to the power of 11. So we want the value here. So that's why we got the value. And then here we are asking just the formula, right? So that is why we got the formula here. Now let's try to use this LLM math chain and see how we can solve a math question, right? So by using this LLM math chain, which is inside LangChain Chains, let's try to use LLM math chain. Inside LLM math chain we have from LLM, and we have to pass this LLM. So we will get LLM math model, right? So once we have the LLM math chain model is ready, now let's try to ask another question, right? So here I'm just trying to print what is 17 raised to the power of 11, and then let's print 50 times this hyphen, and then this is, I'm just trying to make this text bold, and this one I'm just trying to not make the text bold. And then let's try to ask a question. So inside the chain we have a function called invoke, and then we are passing the math question. What is 17 raised to the power of 11, right? So this is by using LLM math chain, right? Let's try to. So let me just kill this, and then now let's try to rerun the code. So you can see by using LLM math chain, question what is 17 raised to the power of 11, answer, this is the value, right? You can try any way, right? Okay, so this is how you can implement any math question, right? So what we did here, we installed all the required packages, and then we tried to load the modules, and then we read the API key, we initialized the LLM, and then here we are trying to call the invoke method, and we are trying to pass the math question and trying to get the results, right? And the second question is, we are asking the LLM to just give only the formula, nothing else, right? So that is why it gave us the formula alone. And then finally we are using LLM math chain, which is from LangChain Chains, and then here we are passing the LLM to from underscore LLM function, and then we are calling the invoke method and passing the question, so we are getting the answer, right? So that is how you can use LLM math chain. So whenever you are trying to implement any generative AI application that involves math, right, then in that case you can use LLM math chain and try to make use of this, right? Thank you. So in the previous lecture we have seen how to use LLM math chain, right? Now let's see one other application by using this math chain. So let's go to VS Code and see one other application. So this is our chains demo. Inside that we are trying to create a new Python file, And let me try to save this as MathChain demo 2, right? And you already know, first thing is we have to install all the required packages. Here we are using LangChain OpenAI and this one too. Now let me try to load all the required modules. So we are using OpenAI LLM. So we are trying to import chat OpenAI from LangChain OpenAI, and then chat prompt template from LangChain prompts, and LLM math chain from LangChain chains, and load.env from .env and OS module, right? We have already seen this numerous times. The first thing is we have to load our environment variables from the environment file by using load_.env function, and then we are trying to get the API key by using os.getEnv function, and then we are trying to store that inside OpenAI API key. Okay, now the next thing is let's try to initialize this OpenAI by using chat OpenAI and assign it to a variable called LLM. That is how we initialized our LLM. Now by using this chat prompt template, let's try to create a custom prompt template for the math chain, right? So what is our math prompt? Here we are trying to define our math prompt, right? So we are using chat prompt template, which is inside LangChain prompts, and we know inside that we have a method called from messages, and here we are trying to pass the prompt. So our prompt is system, you are a mathematical assistant that helps solve math problems. Given a math problem, respond only a Python expression that can be evaluated to solve it. You must start your response with answer followed by the expression. Do not include any other text or explanations, right? And here we are trying to provide the examples. For example, question, what is 2 plus 2? You provide the answer as 2 plus 2. And if the user asks, if I have 3 apples and multiply them by 4, how many do I have? And you want the LLM to respond as 3 times 4 as an expression. And then if user asks what is 25 times 4, you want the LLM to respond as 25 times 4 as an expression, right? So this is the prompt that we defined, right? So if you notice here, we are guiding the LLM with few examples, right? This prompt is nothing but few shot, which we have seen already. If you go to prompt engineering demo and go to few shot, so here you can see we are guiding the LLM in this way. So if the customer says this, you want the LLM to respond this way. If the customer says this, you want the LLM to respond this way. So we are guiding the LLM by providing some examples, and we are trying to provide the context so it can respond accordingly, right? Which is nothing but few shot. So here we used few shot prompt engineering technique, and then we created a math prompt, right? So this is always better to give some examples when we are trying to solve math based questions, right? So we are trying to provide the LLM more context by guiding it with some examples. Now let's try to create a math chain by using this LLM math chain, right? So we are using LLM math chain. Inside that we have from LLM, and for LLM attribute we are passing our LLM which we initialized before, and then for prompt attribute we are passing our math prompt which we just defined, right? So we try to bind the LLM with the prompt by using this LLM math chain. So we got the math chain ready. Now we know inside math chain we have a function called invoke, right? So now let's try to ask a question. What is the question? What is 25 times 4, right? And let's try to see if the LLM is responding, right? Math result is equal to, inside the LLM chain we have a function called invoke, and then for question we are passing this question, right? Now let's try to print both the question and also the answer, right? So let me try to save this code and run the code. So you can see what we asked, what is 25 times 4, and the answer is 25 times 4. So you want the LLM to respond this way, right? Now let's change this to 100 and see if the LLM is responding correctly. So now you can see the answer is, you want the LLM to respond in this way. answer colon 100 times 4, right? So here we are using only simple math question, but you can also replace this question with some complex math questions, right? With the complex math questions, the LLM may not be able to answer without this math chain, right? So this LLM math chain is more beneficial when you are trying to solve more complex math problems, right? With simple questions, you may not be able to see the difference with or without math chain, but you will see the difference when you're trying to solve some complex math questions, right? So that is the benefit of using this LLM math chain, right? Because what we are telling, the objective of this prompt is to respond only in this way, right? If this is the question, you respond this way. If this is the question, you respond this way. If the user asks in this way, then you respond this way, right? But if you want the answer in a different format, then you can change the prompt here, right? So the LLM will answer based on how we provided our prompt, right? So let's quickly review. We tried to install all the required packages and we loaded all the required modules, and then we tried to load the environment variables from this environment file, and we read the key we stored inside OpenAI API key. And then next thing is we initialized our LLM, and then here we created a prompt. This is nothing but few short because we are giving the examples, right? So this is how we defined our prompt by using chat prompt template from messages. And we used LLM math chain, and inside LLM math chain we have a function called from LLM, and for LLM attribute we passed this LLM, and for prompt we passed the prompt that we created. And then this is the question we are trying to ask the LLM. What is 100 times 4? And inside the chain we have a function called invoke, and we are passing the question, and we are trying to print both question and answer, right? So this is how we are getting the answer, because here we gave answer, so that is why this answer, and then the result is this one, answer in this format, answer colon whatever the expression, right? So depending on the prompt, the LLM will try to understand the context, and then it will try to solve the math question. Here we are using LLM math chain. Instead of this simple math question, you can try to solve some complex math problems as well, right? So that is the objective of using LLM math chain. All right, thank you. So far we have seen single chain, simple sequential chain, sequential chain, math chain, right? Now let's see RAG chain. Let's go to our VS Code and try to implement RAG chain, right? So this is our VS Code. So let me create a new Python file, and let's save this as RAG chain demo. And like you know, the first thing is we have to install all the required packages. So here we are using LangChain OpenAI package. So make sure you install this package. And then the next step is try to load all the required modules from this LangChain OpenAI, right? So here we are trying to get all the modules that are required to implement RAG chain, right? So once we install all the required packages, and then once we load the modules, the next step is here we are using OpenAI as our LLM. So we stored our OpenAI API key inside this environment variable. So let's try to load the environment variables from this environment file by using load_.env function. And then here we are trying to read the key, and we are trying to store the API key inside OpenAI API key environment variable, right? And now let's use this chat OpenAI and try to initialize our LLM. Okay, and then we already know RAG flow because we have already seen the RAG demo. So what we do with RAG, we try to create our domain specific input document, and then here we are hard coding, but you can use document loaders and then try to load the input document and then chunk the document, and these chunks are in text format and the LLM cannot understand text. So the next step is we are creating the embeddings, right? And then once we have the embeddings, we are trying to store them inside a vector database, right? So which is nothing but RAG flow. Now let's see how we can implement the same here, right? So first thing is let's try to define our input document. So this is our input document. We have HP printer sales are up by 30% in 2011 Q4. Lenovo laptop sales are down by 10% in 2012. A3 printer sales is 5% more in Middle East as compared to A4 total, right? So this is our sample document. Here you can replace this and load this document from any other data source by using our document loaders, right? Which we have seen already. But for our demo, I'm just hard coding the values here, right? So this is our input document. Now the next thing is we have to split this input document. So this entire text will be divided into multiple chunks, right? So let's try to create text splitter and split the input document, right? Here we have imported recursive character text splitter, which is inside LangChain text splitter, right? So let's use this recursive character text splitter and split our input document. So we are using recursive character text splitter and we are saying the chunk size as 100 characters and chunk overlap is 20. So that means this 20 characters will be overlapped with the following chunk, right? So once we have this text splitter, we know inside this we have a method called create documents, which will give us the splits, right? So inside the recursive character text splitter, we have a method called create documents and we are passing our input document. So we will get the splits, right? So now if you want to see what we have inside the splits, let's try to print it, okay? So document has been split into, we are using the function length and passing this splits. How many splits, right? So this document has been split into these many chunks, right? And then let's try to print them. Example chunks. I'm just trying to bold this text and then just trying to print 50 times the hyphen, and then now let's print the values, right? So this is a list. So I'm just trying to loop in and trying to print each chunk value, right? So chunk 1, what is the value? Chunk 2, what is the value? Chunk 3, what is the value, right? So here we have 3 values. So it will create 3 chunks, right? So depending on your input, it will try to create the chunks. And to create the chunks, we are using recursive character text splitter, right? And once we have these chunks are in text format. But OpenAI LLM cannot understand text. So we know we have to convert this text into numbers, which is nothing but embeddings, right? So let's define our embedding model. Here we are using OpenAI embeddings, right? Which is from LangChain OpenAI. So let's use that and then define our embeddings. We are using OpenAI embeddings, right? So once we have our embeddings ready, the next thing is let's create a vector store so we can store these embeddings. So let's try to create a vector store using the initialized embeddings model, right? So make sure you install this ChromaDB in case if you haven't installed already, right? So let me add that as well. Pip install ChromaDB. Make sure you install this in case if you haven't installed already. So you can use this ChromaDB. Inside that we have a method called from documents, and for documents attribute we are passing our splits, that is our chunks, and for embedding we are passing our OpenAI embeddings model, right? So we created our Chroma database where we can store our embeddings, right? Now next thing is let's try to create the retriever. So inside this vector store we have a function called as retriever. So that will create a retriever, right? So we created our retriever. So we already know the rack flow, right? We are converting these chunks into embeddings and we are trying to store those embeddings inside our vector database, which is nothing but a Chroma database, right? This Chroma database will store these embeddings inside your local memory, right? Instead of Chroma database, you can use any other vector database also. We have seen different types of vector databases already, right? Now we have imported chat prompt template, which is from LangChain prompts. So let's use this and try to create a prompt so we can chat with our LLM and see if our LLM is trying to retrieve the results from this input document, right? So let's try to create a template, create a RAG template, and this is our template. Answer the following question based on the provided context. The context is we are storing inside this question is this, and we want the LLM to respond in this way. So this is just a template, right? Now let's create a prompt by using chat prompt template. Inside that we have a method called from template, and let's pass this template, right? So we got our prompt ready. And now the next thing is let's create the chain, because we have our prompt and we also have our LLM ready. Let's try to bind both these by using the chain. So let's create a RAG chain. So this is our RAG chain. What we are doing here for context, we are passing retriever where we stored all our embeddings, question, runnable pass-through, right? So this runnable pass-through is a function inside LangChain. It will pass the output as it is to the next layer, right? So whatever question we are passing, that will be passed to the next layer as it is. In case if you want to learn more about this, you can go to LangChain documentation and learn more about it, right? And then we are trying to bind prompt, LLM and string output parser by using the chain, right? So always remember this pipeline represents a chain, right? Now we have our chain ready. So we try to bind our prompt, LLM and the output parser and the embeddings, everything we try to bind all of them by using this chain, and we created our RAG chain, right? Now once we have the chain ready, inside the chain we have a method called invoke. So let's try to call the invoke method on this chain and then see if our LLM is trying to give us the answers, right? So this is our text, right? So this is about HP printer, Lenovo laptop and A3 printer, right? So let's try to ask one question regarding this HP printer. What is HP printer sales in 2011 quarter 4, right? So what we have given, HP printer sales are up by 30% in 2011 quarter 4. So that is our question. And how do we get the answer? We have to call the invoke method which is inside this chain and pass our question, so we will get the answer, right? Now let's try to print the results. So this is the question. I'm just trying to bold this by using this, and then let's also print answer. Here I'm not trying to bold this answer, only the question I'm trying to bold with this one, right? And the answer is stored inside this answer variable, right? So we are trying to print both question and answer. That is, you have to remember the question that we asked is specific to our input document, right? So here you can replace with any of your domain specific, that is your organization domain specific input document. So this is nothing but a RAG application, right? So let's try to save this code, run and see if our LLM is able to answer to this question. So let's run the code and see. So this is the answer it has given. So now let's verify if it is correct. So you can see HP printer sales are up by 30% in 2011 quarter 4, right? So that is the question we asked, and the LLM was able to predict the right answer, right? And it also printed this one. So we are trying to print the chunks also, right? So it divided into 3 chunks. This is the first chunk and this is the second chunk. This is the third chunk, right? So this is nothing but RAG chain, right? Let's try to ask another question which is not inside this document and see what our LLM is going to do, right? So instead of this question, so what we have inside this, we have HP, Lenovo and A3 printer, right? So instead of HP, let's try to give Apple and see how the LLM is going to respond. So I'm going to kill this session and then rerun the code and see. So the question that we asked is, what is Apple printer sales in 2011 quarter 4? The given context doesn't contain any information about Apple printer sales, so it is not possible to determine Apple printer sales in 2011 quarter 4 based on the provided information, right? Because if you see our input document, we did not specify any information related to Apple printer, right? So the LLM was not able to give us the answer, right? So you can experiment, right? You can try to change this input document and try to use the RAG chain and then see if the LLM is trying to retrieve the results, right? So you can replace this input document. Let's say if your document is in a PDF file or a text file or any other document or any other data source. So you can try to load them by using document loaders, and you can do the same, right? So this is how you can build RAG chain. So what we have done here, let's quickly review. Let me close this. We try to install all the required packages, and then we try to load the modules that are required, and then we load the environment variables from this environment file where we stored our API key, and then we read the key we stored inside our OpenAI API key environment variable, and then we initialized our LLM. So once we have the LLM ready, the next thing is here we are trying to store our input document inside this documents variable. This is nothing but a list. Instead of this hard-coded values, you can replace with any of your domain specific data. You can load them by using document loaders, right? And once we have your input document ready, we are using recursive character text splitter to split our input document. We are using chunk size as 100, so we are telling it to divide by 100 characters and also try to overlap 20 characters from each chunk so that we can preserve the context. So you have to choose these user defined parameters depending on your input document, right? And then we have our text splitter. Inside that we have a method called create document. So we passed our input document. So we got our splits, and these splits are in text formats. Here we are just trying to print them. So we have to convert these text chunks into embeddings by using OpenAI embeddings, which is inside LangChain OpenAI. Next thing is, once we have these embeddings ready, we have to store them inside a vector database. Here we are using Chroma database. Inside that we have from documents method, we are passing our splits to documents and embeddings to embedding attribute, right? So we got our vector store. And now let's retrieve them by using as_retriever function. So we are storing them inside a retriever variable. Now let's create a RAG template. So this is our template and this is our prompt. We are using chat prompt template. Inside that we have a function called from template, and we are passing our template, right? So once we have our embeddings, LLM and prompt, all of them are ready. Let's try to bind them by using this chain. So here we are trying to create a RAG chain, and we are passing the context as retriever where we have our embeddings and question runnable pass through, and this is our prompt, LLM and string output parser to parse the results, right? Now here we are just trying to print the question and answer. This is the question we asked, and we are trying to call the invoke function which is inside the chain. So we are passing the question, so we are getting the value of the answer, and we are just trying to print them here, right? So this is how you can create a RAG chain. Instead of this input document, you can replace this with any other input document and try to experiment this, right? So this is how you can create a RAG chain. All right, thank you. So far we have seen single chain, simple sequential chain, MathChain, RAG chain, right? Now let's see router chain. Okay, so what we did in sequential chain, we can only run sequential tasks, that is tasks that are dependent on each other, one task after another, right? So for example, let's say your task is to create a research report, right? So one task is it finds the data with a markdown file first, and then the output of the first task will be passed again to the second, and the second task is to summarize, and the third task is to create the report, right? That is, first thing is to identify the file, second one is to summarize the data, third one is to prepare the report, right? And all these tasks are dependent on each other. That is, we will do one task after another. This is nothing but a sequential chain. Here every task is executed one after another. Whereas if you use router chain, this will help you to route the question to the correct one, so the LLM can respond accordingly, right? So for example, let's say you are building a generative AI application and we don't know what kind of the question the user asks, right? So the user can ask either a science question or a history question or a math question, right? So in this case, we will define prompts for all the different types of questions, right? If the user asks only a math question, then you can just simply use MathChain, right? Which we have seen already. But we need to build a generic application. So user can ask any kind of question. It can be math or science or history, right? Not just math related question, right? So the objective of router chain is based on the prompt or based on the question, the LLM will be able to route the question to the correct prompt and answer accordingly, right? So now let's go to VS Code and see the implementation of this router chain, right? So far we have seen these different kinds of chains. Now let me create a new Python file and let's name this as router chain demo. Inside the chains demo, I am creating a new Python file and naming it as router chain demo. And the first thing is, like we have done before, make sure you install LangChain OpenAI package, right? So once you install all the required packages, in this case it is LangChain OpenAI package, right? If you haven't installed already, make sure to go to the terminal and install it. And then next step is try to load all the required modules from LangChain package. And then the first step is, let's try to load the environment variables from .env file. Inside this .env file, we stored our OpenAI API key. That is the LLM we are using to demonstrate router chain. Okay. So the first thing is, let's try to use load_.env function to load the environment variables from this environment file. And the next step is read the API key. By using this OS module, we have a getEnv function and pass the API key name. So we will get the value of OpenAI API key. Once we get the value, let's try to store this API key inside OpenAI API key environment variable, right? So far we have installed all the required packages, we loaded the modules and we read the key and we stored inside our OpenAI API key environment variable. Okay. Now by using this chat OpenAI, let's try to initialize our OpenAI LLM. So we are assigning that to LLM variable. Now the next step is, let me close this. Let's try to define prompts for different types of user questions. So user can ask a science question or a history question or a math question, right? So user can ask any kind of question. So let's try to define different prompts for different types of user questions. Okay. For example, let's say if user asks a science question, you are a scientific expert, answer the following question, and we are passing the dynamic variable, this is input, and we will pass this value when we are invoking. So similar to science prompt, let's define a history prompt as well. So inside the prompt template, which is from LangChain prompts, we have a method called FromTemplate and we are passing the prompt here. You are a historical expert, answer the following question. So based on the input, you have to answer the question. Again, this input is a dynamic variable. So similar to how we have defined science prompt, history prompt, let's try to define one other prompt. And this is math prompt, FromTemplate.FromTemplate, and we are passing the prompt here. You are a mathematics expert, answer the following question, and we are passing the dynamic variable input. Okay, so far we have initialized our LLM and we defined 3 prompts: science prompt, history prompt, math prompt by using prompt template, and inside that we have FromTemplate function. To that we passed our prompt. Okay, now for each of these prompts, let's try to create 3 separate chains by binding the LLM with each prompt, right? Science prompt, history prompt, and math prompt. Okay, so now let's try to create the destination chains. So for the science chain, what we are doing, science prompt, LLM, and the string output parser, right? So we are trying to bind all these 3 by using chain, and we created a science chain, right? So here we are trying to bind the LLM, which is the brain, and then the prompt, which is nothing but the question, and the string output parser. All together we are trying to bind and create a science chain, right? So similarly, let's try to bind history prompt with the LLM and the output and create history chain. Okay, so history prompt, LLM, and string output parser. And similarly for the last one, math prompt, let's try to create math chain by binding LLM, math prompt, and the output. So we created 3 chains here, one for science, the other one for history, and the last one for math. Now let's try to create the router prompt where it can route accordingly, right? So we are trying to create a router prompt by using prompt template, which is again from LangChain prompts. We have from underscore template function, and this is the prompt we are giving. Given a question, determine which category it belongs to, science, history or math. Only respond with the category name. So we are trying to guide the LLM. This router prompt will return the category, whether it is science or math or history, right? So the output of this router prompt is the category name, right? Now, once we have the router prompt ready, now let's try to create a router chain by binding our LLM with this prompt. So that will be the fourth chain. So far we have created these three categories chains. Now let's create the router chain by binding this router prompt with the LLM and the output. So we got our router chain. Now we have to route them based on the category and execute accordingly, right? So now let's try to define a small function. So we are trying to define the routing logic by creating a function by using the def keyword, and we are creating the function name as route chain, and we are passing this input text, and category is equal to router chain dot invoke, and we are passing the input text. So here this will give us the category name in lowercase, okay, by calling the router chain dot invoke, and we are passing the value, so we will get the category name. And if the category name is science, then return science chain, okay. Elif, if the category name is history, then return history chain, okay. Otherwise the last one, return math chain, right? Unexpected indentation, okay. So we defined a routing logic here. So this will give us the category name in lowercase. If the category is in science, then return science chain. Otherwise, if it is history, return history chain. Otherwise, return math chain, right? So here we are defining the routing logic manually, right? So this will return either science or history or math, and according to the category, we are trying to route to the corresponding chain. So that's all this function does. Now let's define the questions, right? So let's define three different questions, one for science, one for history, and one for math. Okay, so one is science question, history question, and math question. So we defined three questions, and now let's try to print the answer by invoking each chain, right? So this questions is a list. We have three questions inside this. For each question, we are trying to print the question, and we are calling this function and passing that question, right? So what will happen? Route chain of what is the question? The question is what causes photosynthesis. So that will be replaced here. And then if we pass what causes photosynthesis here, then it will try to invoke and pass the input as what causes photosynthesis, right? And then this logic will return science. And then again chain dot invoke. Which chain will be called here? Since it is a science question, it will call science chain, right? So that will be our answer. So now let's try to save this, and now let's try to execute this code and see. So you can see what causes photosynthesis, and the answer is this. Who was the first president of the United States? And the answer is this, George Washington. And what is the square root of 100? The answer is 10, right? So we asked one science question, one history question, and one math question, and we defined the logic here, and based on the question that we pass, it is trying to give us the category name, and based on the category, we are trying to route accordingly and call the corresponding chain, right? So what we did here, first we installed all the required packages, and then we loaded the modules, and we read the key, and we stored inside our OpenAI API key, and here we initialized our LLM by using chat OpenAI, and here we defined three prompts, science prompt, history prompt, and math prompt by using prompt template dot from template, and we passed our question, right? You are a scientific expert, answer the following question. You are a historical expert, answer the following question. And you are a mathematics expert, answer the following question, and we passed our input, right? This input is nothing but the question that we will be passing, right? So this input will be replaced with the question. And then again we created our destination chains. For each prompt we try to bind that with the LLM, and then here we created the router prompt. So given a question, determine which category it belongs to, whether it is science or history or math. Only respond with the category name, right? So your task is to give me only the category name. Accordingly I will route, and we have 3 different chains. Those 3 chains will execute and it will give us the answer, right? Once we have the router prompt, we are trying to bind the LLM with the prompt and the string output parser, which will give us the router chain. Here we are trying to invoke by passing this question. So we have 3 questions, right? So that will be passed here. So what is our prompt? Given a question, determine which category, right? So we are passing the question and it will give us the category, right? So 3 questions, 3 categories. Accordingly, it will return the corresponding chain. And where are we calling this router chain here? For each question. So we have 3 questions. For each question, we are trying to print the question, and also the chain is equal to router chain of question, right? So we will be passing the question for each question. This will give us the category. And once we have the chain ready, we are trying to invoke it by passing the question as the input. So we will get the answer, right? So for science question, it executed the science prompt and it gave us the answer. For historical question, it executed this prompt and it gave us the answer. Similarly for math, right? And we are trying to print what is the question and what is the answer for each question, right? If you notice here, we are defining this routing logic manually, right? So depending on the category, route to the corresponding chain and execute the corresponding prompt and then respond, right? But you don't have to define this routing logic manually. The objective of router chain is based on the prompt or question, the LLM is smart enough to route the question to the corresponding prompt, right? So here we defined based on the category we are trying to route, right? So we are defining the logic here manually, but the objective of router chain is to route accordingly depending on the question or prompt that we pass, right? So we have another chain called LLMRouter Chain, right? So let's see another example where it can dynamically route to the correct prompt or question. So we have a direct function available that can do this routing logic dynamically. So the objective of router chain is based on the prompt or question. The LLM will be smart enough to route the question to the correct prompt. We do not have to define this logic manually and route them accordingly, right? So instead of defining this logic manually, let's use LLMRouter Chain and see how our LLM will be able to answer the question according to the prompt that we provide, right? Thank you. So far we have seen all these chains, right? So in the router chain, we have defined the logic manually and then routed accordingly, right? But now let's try to use LLMRouter Chain, and the objective is based on the prompt or question that we provide, the LLM will be smart enough to route the question to the correct prompt and answer accordingly, right? So let's see how we can implement that by using LLMRouter Chain. Okay, so let's go to VS Code and see the implementation part. So if you notice here, with router chain, we have defined this routing logic manually. But now let's see LLMRouter Chain. So let me try to create a new Python file and let's save this as LLMRouter Chain demo. And the first thing is we have to install the required packages, and the package is nothing but LangChain OpenAI. So make sure you install it if you haven't installed already. Okay. And the next thing is we have to load all the required modules. So here we are using OpenAI LLM. So that's why we are importing chat OpenAI from LangChain OpenAI. And the prompt that we'll be using is multi-prompt chain, which is from LangChain Chains router. And this is to load the environment variables from the environment file, right? So we can use load_.env to load the environment variables from the environment file. And once we load the file, let's read the key. And once we have the key, let's store that key inside OpenAI API key. inside this environment variable, we stored our OpenAI LLM API key. So once we read the API key, the next thing is let's try to initialize the LLM by using this chat OpenAI, which is from LangChain OpenAI package, right? So once we initialized our LLM, for example, let's say you have different templates. One is beginner template, the other one is expert template, right? So let's define our templates. The first template is beginner template. You are a physics teacher who is really focused on beginners and explaining complex topics in simple to understand terms. You assume no prior knowledge. Here is the question and we will pass the question. Okay. So this is our beginner template. This is how we defined our template. Now let's define one other template. Let me close this so you can see better. Expert template. You are a world expert physics professor who explains physics topics to advanced audience members. You can assume anyone you answer has a PhD level understanding of physics. Here is the question and we will pass the question. This is a dynamic variable, right? So one is for beginners and the other one is for advanced audience members and they are PhD level members, right? So we have defined one beginner template and the other one is expert template. Okay. And if you want, you can add your own templates as well, right? So let me define an empty template. Here you can fill in with your own template. So here I have created one for beginner and the other one for expert. Instead of these two, you can add your own templates as well. Okay. So once we have the templates ready, now let's define the prompts, right? So let's create a list of prompts. So what we are doing here, inside the list, we are defining 3 prompts. One is for empty prompt. Name is equal to empty and description is equal to replies to empty questions. For the prompt template attribute, we are passing the empty template. And the second one is for expert template, right? Name is equal to advanced physics. Description answers advanced physics questions. And the prompt template is expert template. Similarly for the beginner template. Name, beginner physics. Description, answers basic beginner physics questions. Prompt template, whatever the prompt template we have created before for beginner template, we are assigning that to prompt template, right? So we have created a list of prompts. One is for empty template, the other one is for expert template, and the last one is for beginner template. Okay. Once we have all these prompts ready, we also have our LLM ready. Now let's try to bind them by using chain. Okay. So here we are using multi-prompt chain, which is from LangChain Chains router, right? To bind the LLM with the prompts. So let's try to create our routing chain call. By using multi-prompt chain, we have a function called from prompts. So we are passing our LLM, which we have initialized here, and also all the prompts. This is the list that we have created. We are passing that, and verbose is equal to true, right? Now, once we have the chain, inside chain we have a function called invoke, and to that, let's try to pass the question. How do magnets work? Explain, right? So inside the chain, we have function called invoke and we are passing the question and we're trying to print the answer, right? So one beginner question and one advanced level question, right? So we asked 2 questions here and we did not define any logic where it has to route to the corresponding chain, right? Because in the router chain, if you see, we have defined the logic manually. So according to the category, you execute and give us the answer, right? Here we have defined the logic manually. But whereas with the LLMRouter chain, we are using multi-prompt chain and we are passing all the prompts. So the OpenAI LLM will be smart enough to understand this question and route to the corresponding prompt and give us the answer, right? So based on the question, it will route to the correct prompt and give us the answer. Okay, so that is the objective of using LLMRouter chain. So now let's try to run this code. So now you can see it understood how do magnets work explain as beginner physics question, and how do Feynman diagrams work, it understood as a advanced physics question, right? So for this question, it used beginner template prompt, right? And then it try to give us the answer. So this is the question input and the answer is this. And the second question, the input is how do Feynman diagrams work, and it understood as advanced physics question. So this is the input and this is the answer, right? So what we understood here, we installed all the packages and we loaded the modules, and please note we are using multi-prompt chain here, right? You can see the description here, a multi-route chain that uses an LLMRouter chain to choose amongst the prompts, right? So depending on the prompt it will try to route, right? So here we are trying to load the environment variables. We read the key and we stored inside the API key, and then we initialized our OpenAI LLM, and here we created 3 templates. One is for the beginner template, expert template, and the empty template. Here you can define your own templates and replace here. So we have our templates. Next thing is we created a prompts list. The first one is for the empty template, and the second one is for the expert template, and the third one is for the beginner template. We created 3 prompts inside a list. And once we have the prompt list, we are using multi-prompt chain to bind the LLM prompts together, right? And inside the chain we have the function called invoke. So you do not have to define the routing logic like how we did before manually, right? Based on the question, the LLM is smart enough to understand the context and route accordingly and then give us the answer, right? So nowhere we have defined the logic, but the LLM understood the context and it was able to give us the right answer by identifying the correct prompt, right? If it is beginner physics, then you use this template. If it is advanced physics, then you use this template, right? So it routed accordingly and then gave us the answer. Okay, so now you get the idea, right? So you can replace these questions with any other questions, or you can replace these templates, right? According to your business need, you can try to define these templates and route them accordingly, and based on the question, the LLM will try to route the correct one and then give us the right answer, right? So that is the objective of using LLMRouter chain. All right, thank you. So far we have seen different kinds of chains: single chain, sequential chain, MathChain, LangChain, router chain, LLMRouter chain, right? Now the next one is SQL chain, right? So let's go to our VS Code and see how we can implement this SQL chain, right? So this is our VS Code. Inside the chains demo, I'm trying to create a new Python file, and let's try to save this as SQL chain demo. And you know, the first thing is make sure you install LangChain OpenAI package. Once you install the package, the next thing is let's try to load all the required modules. We are using OpenAI as our LLM, so we'll be chatting with that. So that's why we imported chat OpenAI from LangChain OpenAI and create SQL query chain. This is from LangChain Chains. So this is the chain that we will be using, and SQL database I will explain, right? Now the first thing is let's try to load the environment variables from this .env file by using load_.env, right? And the next thing is let's try to read the API key and store it inside API key variable. And now let's try to assign this API key to the OpenAI API key environment variable, right? So once we have the key, now the next step is let's try to initialize our LLM by using this chat OpenAI, which is from LangChain OpenAI, right? And by using this SQL database, we have a sample database available for SQL Server, which is nothing but Chinook, right? So let's try to use this SQL database, which is from LangChain Community Utilities package. So we are using SQL database, and inside that we have a function called from URI, and we are passing the URI here, SQLite Chinook database, right? So we got our database, and now once we have our LLM and database, let's try to bind both the components by using this create SQL query chain from LangChain Chains. Okay, so for create SQL query chain, we are passing our LLM and the Chinook database, right? So inside the chain, we have a function called invoke, and let's try to pass the question. How many employees are there, right? So we are asking a question. So this create SQL query chain will create an SQL query from this NLP text, right? How many employees are there? For this question, it will give us a SQL query, right? So let's try to print the response and see what we have inside the response, right? So let's try to run this code. So now you can see select count of employee ID as number of employees from employees table, right? So it gave us a SQL query for this question. How many employees are there? Select count of this employee ID as number of employees from employees, right? So this is your SQL query. So once you get the SQL query, you try to create another chain, right? So first chain is we got the SQL query. You create another chain and try to execute this SQL query, right? So now you get the idea. So instead of just the select, you can try to replace the prompt for delete or insert or update, right? And then accordingly it will create the SQL queries and you can execute depending on your requirement, right? So what we have done here, we installed the required packages and we loaded the modules, we read the API key, and then we initialized our LLM, and then we got the Chinook database, which is a sample database available for SQL Server by using SQL database. Inside that we have the function called from URI and we passed that URI and we got the database. And then the next thing is we try to bind both LLM and database by using create SQL query chain, which is from LangChain Chains, and we got the chain. Inside that we have a function called invoke and we passed the question, and by using this create SQL query chain we got our SQL query, right? So that is how you can use SQL chain. So far we have seen different kinds of chains from LangChain Chains package, right? And by now I hope you got a pretty good understanding on how to initialize your LLMs and create the prompt and how to use different kinds of chains, right? So if you want to deep dive more, there are many other chains available and you can explore more depending on your requirement, right? So this is the official LangChain Chains documentation. All right, thank you. So when a user asks any question to an LLM, we know LLM has been trained with some publicly available data, so the LLM can answer with its generic intelligence. Otherwise, if the LLM cannot answer with its generic intelligence, then we need to train the LLM with your organization's domain-specific data by loading your documents using document loaders and then chunk the input document. We've already learned different chunking methods in the previous lectures, right? And then we have seen how to create embeddings because LLM cannot understand text and it can only understand numbers, right? And then we learned how to store these embeddings inside a vector database and provide LLM access to this vector database so that the LLM can answer for any domain specific user question. And this process is called RAG, Retrieval Augmented Generation. We have seen this already. And we have also learned different prompt engineering techniques, that is how to ask a right question to get the right answer from the LLM. And then we have seen how to provide memory to an LLM, and we also learned how to bind different LangChain components with LLM by using chains, right? Now let's learn about tools and agents. Okay, so by using LangChain we can create agents too, but the limitation with LangChain is it is limited to one particular task, meaning only single agent. That's why we will be learning CrewAI, which is a multi-agentic framework, right? So what is multi-agentic framework? In the context of language models and AI, a multi-agent system involves multiple independent actors, each powered by language models collaborating in a specific way. So that is nothing but multi-agent system. So the term agent is not new to you. When you power an LLM, with tools. Tools meaning providing external world access to LLM, that is web search or web scraping or web crawling or Microsoft product access or Slack access or WhatsApp access, etc. Right? And when LLM can remember the context, right, that is the memory. And when you ask a right question by using different prompt engineering techniques, then LLM will be able to predict the right answers, right? So multiple agent means every single agent is different than every other agent, and each agent will do a specific task. That is, more than one agent can perform a task. For example, let's say you have multiple agents here, and one agent can summarize the text of a content. For example, you want to use GPT 4.0 to perform this task. And another agent, agent 2, you can use as market research analyst, and this agent can perform a task. For example, let's go to the internet and search the web, convert that to a Markdown format. And you already know LLMs are Markdown friendly, right? So for example, let's say we want to use an open source model like Mistral to do this task. And let's say another agent, agent 3, which can write SQL query. Maybe we want to use another open source model like Qwen to do this task, right? So what we are doing here, we are using multiple agents and assigning each agent to a different LLM, and we are assigning different tasks. So every agent can have a different LLM assigned to do a particular task, or every agent can have its own memory, or every agent can have its own tools to access the external world. So this is nothing but a multi-agent system, right? So what are multi-agentic frameworks? We already learned all the concepts. We need to learn a framework which will support this multi-agent, right? And we have different multi-agentic frameworks available. For example, CrewAI, AutoGen, LangGraph, and we have several other frameworks available. CrewAI is used to streamline workflows across industries with powerful AI agents, and it is used to build and deploy automated workflows using any LLM and cloud platform, right? So this CrewAI is a popular one. It's user-friendly framework and it is easy to understand. And this is the official documentation of CrewAI. So let me take you there. So CrewAI.com, right? So this is the official CrewAI documentation. So you can go through this when you have some time. And this framework is used to build multi-agentic generative AI applications, right? And the next one is AutoGen. AutoGen is a framework for building AI agents and applications. And this AutoGen framework is developed by Microsoft. And when it comes to AutoGen, we have streaming kind of live feature available with AutoGen, and that feature is not available with CrewAI. So depending on your requirement, you have to pick the right framework. And the next one is LangGraph. This is a framework for building AI agents that can handle complex tasks, right? And LangGraph is developed by LangChain. And by using these frameworks, we can build multi-agentic applications. And there are other multi-agentic frameworks available too, but these are some of the famous ones. So let me take you to AutoGen as well. So like I said, this is developed by Microsoft, a framework for building AI agents and applications. So this is the official page of AutoGen, right? And let me show you LangGraph as well. So you can see by using LangGraph, we can build multi-agentic frameworks and solve complex tasks, right? So this is the official page of LangGraph. So by using these multi-agentic frameworks, we can build multi-agentic applications. And there are other multi-agentic frameworks available too, but these are some of the famous ones. Okay. And we will learn CrewAI multi-agentic frameworks in this course, so we can build multi-agentic generative AI applications. Alright, thank you. So we will learn CrewAI multi-agent framework in this course, so we can build multi-agentic generative AI applications, right? So CrewAI is built on top of LangChain, and this is a multi-agent framework. It supports agents working together. In layman terms, an agent is like a human being, right? And each agent will be assigned with LLM, tools, memory, etc. And each agent will perform a task. And these agents can work either sequentially, that is one after another, or they can also work in parallel and perform the assigned task. That is either sequential or parallel. These agents will generate the final outcome when they are done with their tasks. And CrewAI has very good documentation. So let me take you there. So this is the official page of CrewAI, where you can see all the different components of CrewAI, and I will talk about all these in detail in the coming lectures. But if you are interested, you can go through this documentation as well. Okay. So why are we learning this CrewAI framework? So that we can perform complex tasks which have multiple steps involved. For example, assume you are a database developer and assume someone has given you a CSV file which has some data in it, and your task is to load the CSV file to a SQL table, generate a report and send an email. And let's say if the user is asking you to generate the same report every single quarter based on the data you imported from a CSV file to a table, and this is nothing but a repetitive task, right? So in this case, you can try to automate this task, right? For example, you have different tasks here. That is to log into a database, write a SQL query and run it, extract the results, and then generate the report and send an email, right? And here each task is dependent on the previous task output. And we know an agent is like a team member who can perform a specific task. So you can assign each task to an agent, right? So to perform all these tasks, each agent can work in sequence and generate the output. So one agent can log into the database and run the SQL query and extract the results. So that is task number 1. And we can assign this task 1 to one agent. And another agent can help you to generate the report out of the extracted results from the SQL. So it will take the output of the first agent and generate the report, right? And let's say you have another agent here, and this agent which has integration with Outlook to send an email. So it will take the output of the second agent, that is the generated report, and send an email, right? So you have 3 agents who are working for you, and they are working in sequence, one after another. Each agent is dependent on another agent. So the second agent will take the output of the first agent and generate the report, and the third agent will take the output of the second agent, that is the generated report, and send an email, right? So now you get the basic idea on how multi-agent applications look, right? And we will come to the implementation part in the coming lectures. All right, thank you. So before we build multi-agentic generative AI applications by using CrewAI, first let's learn all the components of Crew, right? So we have process, agent, task, tool, and memory system. So what is process? Let me zoom in. Process defines how agents will work with specific tasks assigned to get the work done. For example, in our example, process is the whole architecture. That is, the process is sequential in our example. We cannot send an email until the report is generated, and the report cannot be generated until and unless we get the data, right? So this is a sequential process. That is, the process defines how the agents are working. That is, are the agents working in sequential or in parallel or hierarchical, right? So that is nothing but process. So This process object is the workflow or strategy the crew follows to complete the tasks. And we have two strategies, like I said, defined by the CrewAI framework: sequential and hierarchical. Sequential means the output of one agent will be input to the another agent and they wait for each other. And this sequential strategy executes the given tasks in sequence and in a particular defined order, right? And this sequential strategy is ideal for any pipeline type of work where each agent performs a specific task and passes it to the next agent. And you will understand better when we implement the project, right? And the second one is hierarchical. And hierarchical strategy organizes tasks in a hierarchy. And these tasks are delegated in a hierarchical fashion and executed based on a chain of command. And this hierarchical strategy is like a manager assigning the work to various agents and validating the results before completing the work. And when we use this hierarchical strategy, we need to configure a manager LLM, and that will help to take the right decision. Okay, and you will understand about this sequential or hierarchical strategy when we implement the applications, right? And the next one is agent. So an agent is like a team member with a specific role and goal to perform various tasks and will have access to various tools to execute these tasks, right? So an agent is nothing but an LLM which has its own intelligence because it has been trained, it has tool access, it has domain data, that is RAG, and it has memory which will do a specific task that we assign. And agents interacting with each other is called a process. So an agent is like a team member in the crew with a specific role, background story, goal, and memory. And the agent is the core performer of the tasks assigned within the framework, right? And each CrewAI agent is a LangChain agent because this CrewAI is built on top of LangChain, right? And the next one is task. So task defines the specific work task that needs to be executed. So task, as the name suggests, is the specific task that needs to be executed by an agent. And an agent will perform the task that is assigned. We provide various tools that are required to execute a task. For example, fire crawl, get the API key and crawl the web page, or go to Microsoft and download an email, etc. Right? So those are different tasks. And what is tool? Tool defines an external utility or tool that can be used to integrate with external system to execute a task. These are LangChain tools. So a tool object is a utility or equipment that the agents use to perform a specific task efficiently. For example, searching the web or loading the documents and reading them, etc. Right? And like I said, CrewAI is built on top of LangChain. So we can use any existing ones from LangChain, or we can write our own custom tools as well. So tool is nothing but providing third-party tool access to an LLM. And what is memory system? Memory is nothing but being able to remember the context by an LLM. And what is crew? Think of the crew as a team of agents working together to achieve a particular goal. And these agents have a clearly defined way to collaborate to achieve the set of tasks that are assigned. Crew means combining multiple agents, and each agent will be assigned to do a particular task. And this is for single agent, right? And multi-agent means every single agent will have all these components. Each agent will be assigned to do a particular task, and each agent will be provided by tool access. It will have its own LLM, and each agent will have its own memory, right? So that is nothing but multi-agent. And if you want to go through the documentation in detail, let me take you to the CrewAI documentation. So this is the official CrewAI documentation where you can see different core concepts here: agents, what is an agent, what is a task, what are crews, flows, knowledge, LLMs, processes, memory, planning, testing, etc. Right? So they have very good documentation here. So if you are interested, you can go through this official CrewAI documentation. All right. Thank you. So we have seen different components of crew, process, agent, task, tool, memory system. So these are different components inside a crew. And now let me show the tools that CrewAI offers, right? So let's go to the official documentation page of CrewAI tools. So this is the official CrewAI tools documentation. And if you see here, you can learn more about tools, right? We have what is a tool, what are the key characteristics of tool, and using CrewAI tools. So here you can see the detailed explanation of each tool. So these are different tools provided by CrewAI. Apify Actors tool, a tool that integrates Apify actors with your workflows for web scraping and automation tasks, right? So you can use Apify and you can do the web scraping and you can also automate tasks. And the next one is browser-based load tool, a tool for interacting with and extracting data from web browsers. And code docs search tool, this is a RAG tool. And code interpreter tool, right? CVS search tool, DALI tool, file read, file crawl. So you can see we have several RAG tools available. JSON search tool, PDF search tool, vision tool, RAG tool, YouTube channel search tool, a RAG tool for searching within YouTube channels, useful for video content analysis. YouTube video search tool, a RAG tool aimed at searching within YouTube videos, ideal for video data extraction. So you can see these are the different tools provided by CrewAI, right? And if you want to create your own tools, you can do that as well by subclassing with base tool, and we will see the implementation. Then you will understand much better. And conclusion, right? So this is the official CrewAI tools documentation. And you know CrewAI is built on top of LangChain, right? So any tool that's provided by LangChain, you can use it in CrewAI too. For example, let me take you to the official LangChain tools documentation. So if you see here, this is from LangChain, right? And you can go through all the different tools that are provided by LangChain, right? For example, Bing search, and this is a paid tool. Brave search, this is a free tool. And DuckDuckGo search, this is also free, right? And Google search is paid, Google Serper is free. By using Serper API, you can do 100 free searches per month and it will give you the answer as the response, right? So these are the different tools that are provided by LangChain. And you can see the tool or toolkits for code interpreter, right? The following table shows tools that can be used as code interpreters. And these are some of the productivity tools and web browsing tools. And these are used to automate tasks in databases and finance. And these are all the different tools. For example, if you see Apify actors are cloud programs designed for a wide range of web scraping, right? So let's go here. So you can go to Apify actors. So you can see here, you can learn how to develop, run and share serverless cloud programs. Create your own web scraping and automation tools and publish them on the Apify platform, right? So if you go to the store, you can see, so these are the different actors: website content crawler, Google Maps scraper, Instagram scraper, scrape and download Instagram posts, profiles, places, hashtags, photos and comments, right? So these are the different tools that are provided by Apify, right? So there are so many tools that are provided by LangChain. Bing search, Brave search, ChatGPT plugins, and so on. So you have so many tools available inside this LangChain tools documentation. So you can go through at your convenience. So here every single tool has been explained with examples. So depending on your requirement, you can go through these tools to incorporate them when building generative AI applications, right? And we have so many tools, so you just get the key and make use of them depending on your requirement, right? So we went through different components of Crew, that is process, agent, task, tool, and memory system, right? And next thing is, let's see how we can build generative AI multi-agentic applications by using these different CrewAI components. All right, thank you. So we have learned different components of Crew, that is process, agent, task, tool, and memory system, right? So these are the different components of Crew. Now let's build a generative AI application by using CrewAI, and we will use these different components of Crew, right? So let's go to VS Code and try to build an agentic application by using CrewAI framework. All right. So this is our VS Code build generative AI applications workspace, and we have seen RAG demo, that is how to build a RAG application, and we have seen different chunking methods, and then we have seen prompt engineering techniques and how to load the documents by using document loaders, and we have also learned how to give memory to an LLM so it can remember the context, and chains, how to bind an LLM with different LangChain components by using chains, right? So we have seen all these different LangChain components, and now let's see tools and agents. So if you notice here inside the C drive, I have created an empty folder, tools and agents demo. So now let's add this tools and agents demo folder to our VS Code workspace. So right click, add folder to workspace, and select the folder that we have created and click add, click S. Now inside the tools and agents demo, let's create a new Python file, and we will be scraping a website. So let's go to tools and agents demo, and inside that CrewAI use case 1, and we are building a web scraping application, and click save. Okay, so in order to use CrewAI framework and also CrewAI tools, first thing is we have to install all the required packages, right? So we know by using pip install CrewAI and pip install CrewAI tools. So if you don't know the exact package name, you can always go to Apify and get the exact package name, right? So you have to install CrewAI and CrewAI tools. So copy this and go to the terminal and execute this one, pip install CrewAI. In my case, I've already installed, so that's why it is showing requirement already satisfied. And similarly, copy this and hit enter, right? So that way these two packages will be installed. So make sure you install CrewAI and CrewAI tools. So once you install these required packages, the next thing is we have to import the required modules. So let me close this and also this. So what we are doing here, we are trying to import scrape website tool and text search tool, these two modules from CrewAI tools, and also we are trying to import agent, task, and crew, these three from CrewAI, and OS module. Now let's use this scrape website tool and try to scrape a Wikipedia page. So here we are trying to use scrape website tool, and inside that we have website underscore URL parameter, and we are trying to pass the Wikipedia page. Instead of this, you can replace with any other website, and this tool will scrape the data and it will give us the data, right? So that is the intent of using this scrape website tool. So let me add that comment here. We are trying to scrape Wikipedia website by using CrewAI tool, which is nothing but scrape website tool. And inside this scrape website tool, we have a function called run. So let's try to extract the text by calling the run method, which is inside scrape website tool. So we are calling the run method and we are extracting the text. So let me save this and let's go to the terminal. So now let's try to run this code. So if you notice here, this is the entire content that the tool scraped from this Wikipedia website. Okay, so which is stored inside this text variable. So once you have the data, you can try building different agents and you can assign different tasks. For example, one agent you can assign sentiment analysis, or another agent you can ask to do translation, that is which can translate from one language to another, or another agent can send an email of some of the results, right? So once you have the data, you can try to create different tasks and assign them to different agents, right? Now let's try to store this scraped data inside a text file. So let me close the terminal. So by using this OS module, I am trying to go to the directory. This is ch directory. So this function is used to change the directory. From this directory, I'm going to my documents data folder. So from the current directory, we are going to the documents data directory. So if you see here, this folder is empty. I do not have anything currently. So let's try to save this text by creating a file and store the data inside it. So let's write the content by using file write and store this Wikipedia content, artificial intelligence. So I'm storing as ai.text and we are writing the content. So whatever the text we extracted by using scrape website tool, which is from CrewAI tools, we are trying to store that content inside ai.txt. That's the text file. Okay. So what we did here, we're trying to store the scraped data into a text file ai.txt. And now we also have this text search tool. By using this text search tool, which is from CrewAI tools, let's retrieve the specific context that we want. Okay, so text search tool, and we are passing for the text attribute, I'm passing this file name. Inside this file we have our extracted data, and let's pass a question. Inside this text search tool we have a method called run, and for that we are passing what is natural language processing, right? NLP. So this is the desired content that we want. So what we did here, we are trying to use text search tool and trying to retrieve the specific context that we want from this ai.text file, right? Out of this artificial intelligence content, we only want natural language processing context, right? So we got our context, which is saved inside a context variable. So what we have done so far, we have installed all the required packages. First one is CrewAI and the next one is CrewAI tools. From CrewAI tools, we imported scrape website tool and text search tool, and from CrewAI we imported agent, task and crew. And this is the OS module. And the first thing is we used scrape website tool, and for website URL parameter we passed our website. Here instead of Wikipedia page, you can replace with any other website. And by using this scrape website tool, we scraped the website, and inside scrape website tool we have a method called run, and we called that method and we extracted the text and we stored inside a variable called text. And next thing is we changed our directory to documents data, and we wrote the content from this variable to a file. And then once we wrote the content inside this text file, next thing is we used text search tool and we passed our file name to this text attribute. And inside the text search tool we have a function called run, and here we are passing a specific context that we want. Out of this artificial intelligence text, we only want the context that is related to NLP, natural language processing, and we are storing our context inside a variable called context. Okay, so this is our desired context. So now we got the data which is stored inside our context variable. So once you have the data, the next step is, let's see how to build a multi-agentic framework by using this CrewAI, right? So we imported agent, task and crew. So in order to build a multi-agentic framework by using CrewAI, we need to define agents, task, and crew. So inside the agent, we will have role, goal, and backstory. And let me show the detailed description of agents. So this is the official agents documentation from CrewAI. This is the overview of an agent and what are the agent attributes. So you can see the complete attributes list inside an agent, right? So if you go here, role, goal, and backstory, these are the required parameters. So what is role? Defines the agent's function and expertise within the crew. Goal means the individual objective that guides the agent's decision making. Backstory means provides context and personality to the agent, enriching interactions, right? So that is role means what the agent will do. Goal means more descriptive on what the agent will do. Backstory means complete description, right? And the LLM, which model the agent will use. So that is nothing but the LLM, and this is optional. And tools is also optional. And tools means if agent needs any tool access, right? And similarly, function calling LLM and max iterations, max RPM. RPM means request per minute, right? This is to avoid the rate limit, and this is also optional. And max execution time, this is also optional. And memory is also optional, right? So by default, agent will have some memory. So the next thing is verbose. Verbose is also optional. We've already seen this verbose is equal to true. That means it will give us the complete or detailed execution logs whenever we specify verbose is equal to true, so that we can see the complete output in the terminal, right? And allow delegation, by default it is optional. And if you give allow delegation is equal to true, it will try to delegate the tasks among different agents, right? And step callback, cache, allow code execution, max retry limit, by default it is optional. That is how many times the LLM should try. For example, let's say if you're trying to do the web crawling, right? How many attempts the LLM should try before it exits, right? And respect context window, code execution mode, use system prompt, etc., right? So you can go through all other parameters depending on your requirement. So this is how we have to create an agent. So total 3 steps. So the first step is creating agents. Second step is creating the task so that we can assign a task to an agent. And then we have to create the crew. So these are the 3 steps in order to build a multi-agentic framework by using CrewAI. Okay. So let's try to create one by one. The first step is create an agent. So we are trying to create an agent. So if you notice here, we are using agent which we imported from CrewAI, right? So inside this agent, we are passing these parameters. Role as educator, goal based on the context provided. We have already stored our context inside this context variable. So based on the context provided, answer the question, what is natural language processing context? And we are passing this dynamic variable. And backstory is you are a data expert. Verbose is equal to true. So that means it will give us the complete execution log in the terminal. And allow delegation is equal to false, because we will be creating only one agent. So that's why we give allow delegation is equal to false. And let's say if you have multiple agents, then you can give allow delegation is equal to true. So that way one agent can communicate with another agent. And for tools, we are passing this list, the tools list, which we have already defined before. So this is how you can create an agent. So that is step number 1. So if you notice here, this role, goal, and backstory, this is nothing but prompt engineering, right? We have already seen this before. So this is how you can create an agent. And the next step is creating the task. Okay. So how do we define a task? By using task, which we have imported from CrewAI, right? So inside the task, we have to pass these parameters. Description, what this task will do, understand the topic and give the correct response. And tools, we are passing the tool list. And agent, we have to assign this task to an agent, right? And the agent we have already created, and we assigned a variable name data analyst, right? So this is our agent. So we are assigning this task to an agent, and the expected output is give a correct response, right? So you try to understand the context and you answer the question, what is natural language processing, right? So far we have created an agent, data analyst agent, and we created a task and we assigned this task to data analyst agent. So step number 1, creating agent. Step number 2, creating the task. And the next step is creating the crew. So let's create the crew. So how do we create the crew? We have already imported this crew, which is inside CrewAI. So let's use crew and pass both agent and task. If you have multiple agents, you have to pass them inside this list. And similarly for tasks, if you have multiple tasks, you have to pass them as a list. Okay, so that is how we created our crew. So we have created the agent and then task and then crew. So once you have the crew ready, the next step is we have to run the crew. Okay, so inside the crew, we have a method called kickoff. So by using that, we will run the crew. And we are trying to store the results inside a variable called output. And now let's try to print the results, output.raw. Okay, now let's save this file and let's try to execute the code. So let me comment this print statement. And now either you can kill the terminal or you can just clear the session. And now let's try to rerun the code. Okay, so let's see the output and try to understand what it has given for us. So this is the complete output. We are seeing this complete output because we gave verbose is equal to true, right? So that is why it is trying to give us the detailed execution log. So you can see here thought, I now can have a great answer. Your final answer must be the great and the most complete as possible. It must be outcome described, and this is the educator agent. So that is what we have created here, right? And what is the thought? I need to conduct a search for the definition and explanation of NLP in the provided context and using the tool. This is the tool I'm using, and for that tool I'm passing this as the input and I'm trying to search, right? So it is trying to search, and you can see the complete detailed execution log here, and finally it reached the maximum iterations. So if you scroll down all the way, you can see maximum iterations reached, requesting the final answer, and the final answer is natural language processing. NLP is a subfield of artificial intelligence that focuses on the interaction between computers and humans through natural language, right? So it gave us the complete answer. So here we are trying to print this output and also we are trying to print this, so that's why we are seeing it twice. So let me close this and let me try to explain real quick what we did here. So the first thing is we try to install the required packages CrewAI and also CrewAI tools. So from CrewAI tools we try to import scrape website tool and text search tool, and from CrewAI we imported agent, task and crew, and we also imported OS module. And the first one is we used scrape website tool and we passed our website that we want our tool to scrape. And inside the scrape website tool, we have a method called run, and we call the run method, and we stored our scraped data inside a variable called text. Whatever the data we extracted, we are trying to write that to a file called AI, and we are trying to store that inside documents data folder. And then the next step is we are using this text search tool, and we are passing this file name so that we can get our desired context. Here, out of artificial intelligence, we are only interested in NLP, natural language processing. So that is our context. So inside the text search tool, we have a method called run, and we are passing this so that we will get the context, and we are storing that inside a variable called context. And in order to build a multi-agentic framework by using CrewAI, we have to create agent, task, and crew. So how do we create an agent? By using this, we have to pass all these parameters: role, goal, and backstory. So this is nothing but prompt engineering. Verbose is equal to true means it will give us the complete execution log. Allow delegation is equal to false. If you want multiple agents to delegate the work to each other, then you give allow delegation is equal to true, and the tools which we have defined already. So we have created our agent. And the next step is creating the task. How do we create the task? By using this task, we are passing these values. For description, understand the topic and give the correct response. And then for tool, whatever the tool we have defined, we are assigning that to tools. And the agent, we have already created an agent, we assign that to an agent. And the expected output is give a correct response. And the next step is creating the crew. Once we created the agent and the task, the next step is creating the crew and assigning the agents. This is the agent list. For task, we are assigning the task list. And once we have the crew, next step is running the crew by calling the kickoff method, which is inside crew. So that will give us the output of the specific task, right? So this is how you can build an agentic framework by using CrewAI, right? So we only have like 3 steps here: creating an agent, creating a task, creating the crew, and then running the crew. Here we have only created one agent, but in the next lecture we will see how we can create multiple agents and multiple tasks, and how we can assign multiple tasks to multiple agents, and how we can build a multi-agentic framework by using this CrewAI. Alright, thank you. So far we learned different components of crew, that is process, agent, task, tool, and memory. Right? So these are the different components of crew, and we built an agentic framework by using this CrewAI. So let's go to VS Code and see another use case. So in the previous lecture, we learned how to build this use case by using CrewAI. So we scraped this Wikipedia website by using scrape website tool, which is from CrewAI tools. And then the next thing is we extracted the text, and we were interested in natural language processing. So we extracted the text and we stored inside the context variable. And in order to build a agentic framework by using CrewAI, first thing is we created an agent by instantiating this agent class and passed all these parameters: role, goal, and backstory. These are nothing but prompt engineering, right? And the next thing is we created the task by instantiating this task class, which is again from CrewAI. And then the next thing is we created the crew by instantiating crew class, which is again from CrewAI. And then we ran the crew by calling the kickoff method, which is inside this crew class, right? So that is how we were able to build an agentic framework by using CrewAI. And here, if you notice, we have only created one agent. So now let's see another use case where we can build multiple agents by using CrewAI. Okay, so let me click on this and create a new Python file. And let me save this as CrewAI use case 2, personalized email drafts, and click save. So here we are trying to build a multi-agentic framework for personalized email drafts by using CrewAI. So the first thing is make sure you install all the required packages, that is CrewAI and also CrewAI tools. In case if you haven't installed already, make sure you install them by going to the terminal and executing these commands. Okay. And the next thing is we have to import all the required modules from CrewAI and also CrewAI tools. And if you notice here, we are importing agent, task and crew from CrewAI, and directory read tool, file read tool and SerperDev tool. These three tools from CrewAI tools, and also base tool again from CrewAI tools, and load.env and OS modules. So I will explain all these in detail when we are trying to use them. So here we will be using SerperDev tool as our search tool. So let me show you first how to get the API key from SerperDev and how we can store that inside an environment file. So this is the website where you have to go, serper.dev, and click on sign up, and make sure you create an account here. Provide your first name, last name, email, password, and click on create account. Okay. So once you create an account, then click on login, and you will see a page similar to this. So here you have dashboard, playground, API key, logs, billing, right? So click on API key and copy this key. So that is how you can get the SerperDev API key. Okay. So SerperDev offers free credits when you create an account. So make sure you use the free credits before you buy more credits, right? So in case if you want to buy credits, you can click on billing and provide your details and you can buy more credits. Okay, so that is how you will get the key. And inside our tools and agents demo folder, let me create a new file and let's save this as .env, and let's try to save this as Serper API key, and here you have to store your API key. Okay, so make sure you get the key and replace here. And we will be using OpenAI as our LLM. So we have already seen how to get the API key from OpenAI, right? So make sure you store your Serper API key here, and also for OpenAI API key here. Replace Serper API key here and also replace OpenAI API key here. Okay. And in case if you do not want to pay for Serper, once you use all the free credits, then you can always choose any other open source search tool. For example, if you see DuckDuckGo, so this is a open source search tool. Instead of Serper tool, you can always use a open source search tool like DuckDuckGo. Okay. So once you get both SerperDev and also OpenAI API keys, make sure you save them inside this environment file. And now let's try to set the API keys. So the first thing is, by using this load_.env function, let's try to load the environment variables from this .env file by using this load_.env function, which is from .env. And then the next thing is, let's try to read the API keys. So inside OS module, we have a function called getEnv, and we are calling this function and passing the name, right? So once you pass the name, we will get the value. That is our OpenAI API key. Similarly, for Serper API key, we are passing the name and we will get the value. So we stored our API keys with these names inside this env file. And now once you get the API keys, let's try to store them inside the environment variable OpenAI API key and also Serper API key. So in order to build a multi-agentic framework by using CrewAI, we know we have to create an agent, task and crew. So first thing is, let's try to create an agent. So let me close this. So the first thing is, let's try to create an agent by instantiating this agent class, which is from CrewAI, right? And here we are passing these parameters: role, goal, backstory. This is nothing but prompt engineering, and allow delegation is equal to false. We do not want to delegate the tasks among agents, and verbose is equal to true. You know, if we give verbose is equal to true, we can see the complete execution log. And what is the role of this agent? It is a sales representative agent. And what is the goal of this agent? Identify high value leads that match our ideal customer profile. And what is the backstory? As a part of the dynamic sales team at ABC company, your mission is to score the digital landscape for potential leads. Armed with cutting edge tools and a strategic mindset, you analyze data, trends, and interactions to unearth opportunities that others might overlook. Your work is crucial in paving the way for meaningful engagements and driving the company's growth, right? So this is the context we are providing inside backstory. So that is how we created our sales representative agent. So that is agent number 1. And now let's create one other agent, and this is lead sales representative, right? Again, we are setting these parameters: role, goal, backstory, allow delegation, and verbose. And role is lead sales representative. Your goal is, as a lead sales representative, your goal is to nurture leads with personalized, compelling communications. And what is the backstory? We are providing some context. Within the vibrant ecosystem of ABC's sales department, you stand out as the bridge between potential clients and the solutions they need. By creating engaging, personalized messages, you not only inform leads about our offerings but also make them feel seen and heard. Your role is pivotal in converting interest into action, guiding leads through the journey from curiosity to commitment. So that is the role of this lead sales representative agent. So we have created two agents. One is sales rep agent, the other one is lead sales rep agent. And now let's create the tools. So here we have imported the tools from CrewAI tools, directory read tool, file read tool, and Serper dev tool, right? So let's make use of them. So the first one is we are using directory read tool. So we instantiated this class and we passed the directory name. And the next one is file read tool, right? So by using this we can read the file. And then let's instantiate Serper dev tool as well. This is our search tool. All these three tools are from CrewAI tools. Okay. And now, in addition to these CrewAI tools, in case if you want to create your own custom tool, you can do that as well by extending the base tool class. So how can we create a custom tool? So let's see how we can create a custom tool by using CrewAI's base tool, which is again from CrewAI tools. Okay, so let me create a custom tool, which is nothing but sentiment analysis tool, and we are extending with base tool, which is again from CrewAI tools, right? And every tool needs to have a name and a description. Okay, here we are giving the name as sentiment analysis tool, and description analyzes the sentiment of text, that is either positive or negative, to ensure positive and engaging communication. And here goes your any business logic that you want to implement. So this is how you can create a custom tool, by extending this base tool. So now let's instantiate this custom tool as well. Sentiment analysis tool, right? So that is how you can create a custom tool. And now once we have these agents, let's assign tasks to these agents. So let's create the tasks. The first task is so this is our task number 1. And we are assigning this task to sales rep agent. And we are instantiating this task class, and we are creating this task by setting these parameters, right? So description, expected output, tools, and agent. So what is the description of this task? Conduct an in-depth analysis of lead name. We will pass this lead name when we call a company in the industry. This is again a dynamic variable in the industry sector that recently showed interest in our solutions. Utilize all available data sources to compile a detailed profile focusing on key decision makers, recent business developments, and potential needs that align with our offerings. This task is crucial for tailoring our engagement strategy effectively. Don't make assumptions and only use information you are absolutely sure about. Okay. And what is the expected output out of this task? A comprehensive report on lead name, including company background, key personnel, recent milestones, and identified needs. Highlight potential areas where our solutions can provide value and suggest personalized engagement strategies. And what are the tools that this task can utilize? Directory read tool, file read tool, and search tool. All these tools we have already defined here. To whom we are assigning this task? To sales rep agent, which we have already created, right? So that is how we created our task number 1 and we assigned that task to sales rep agent. And now let's try to create another task. So here personalized outreach task, and we are instantiating the task class, and here we are setting these parameters: description, expected output, tools, and agent. If you notice under tools, we are passing sentiment analysis tool, which is nothing but the custom tool that we have created by extending base tool, right? So this is our sentiment analysis tool which we have created by extending base tool. So the personalized outreach task is using our custom tool, which is nothing but sentiment analysis tool, as well as CrewAI tool. This is SerperDev tool, right? So let me add that comment here. And then again we are setting these parameters: brief description on what this task should do and what is the expected output and what are the tools to use in order to perform the task and what is the agent, right? So what is the description here for the personalized outreach task? Using the insights gathered from the lead profiling report on lead name, craft a personalized outreach campaign aimed at key decision maker, the position of lead name. So all these parameters are dynamic variables, right? So we will pass these values when we call them. The campaign should address their recent milestone and how our solutions can support their goals. Your communication must resonate with lead name's company culture and values, demonstrating a deep understanding of their business and needs. Don't make assumptions and only use the information you are absolutely sure about. And what is the expected output? A series of personalized email drafts tailored to lead name, specifically targeting key decision maker. Each draft should include a compelling narrative that connects our solutions with their recent achievements and future goals. Ensure the tone is engaging, professional, and aligned with lead name's corporate identity. Okay, so this is the expected output. So we are trying to generate personalized email drafts. And these are the tools that we are passing. Sentiment analysis tool, this is our custom tool that we have created by extending the base tool. And this search tool is nothing but the SerperDev tool. And we assigned this task to lead sales representative agent. So far we have created the agents, and then we created the custom tool, and we also created the tasks, right? And now let's create the crew. Okay, so we can create a crew by instantiating this crew class, which is from CrewAI, right? And here we are setting these parameters. For agents, we are passing the agent list. So we created two agents, sales rep agent and also lead sales rep agent. So we are passing this list. And for tasks, we are passing this list: lead profiling task and also personalized outreach task. And verbose is equal to true. So that means give the complete execution log, and memory is equal to true. So make sure you remember the context. And the next thing is, once we created the crew, let's try to run this crew. So if you notice here, we are using all these dynamic variables, right? So we need to set values to all these variables. So first let's try to set values to all these dynamic variables, right? So lead name, wherever it says lead name, it will replace with AI with Mala. And industry is online learning platform. Key decision maker Mala H, and position is CEO, and milestone is product launch, right? So we have set our input data. Now once we have the data ready, let's try to run the crew by calling kickoff method, which is inside crew, right? And for the inputs attribute, we are passing whatever the inputs that we set here. So once you run the crew, now we have the results here. Let's try to display the final result as the markdown. So here we are trying to display the final result as markdown. So from IPython display, we are trying to import markdown module. So let me put that here. And then here we are trying to print the results as markdown, right? So let's try to save this code and run it. So you can see crew execution started and the agents are trying to perform different tasks. And the sales representative task is to provide a comprehensive report on the specified lead name, right? And then once we have the report ready, the next step is creating the personalized email draft by another task, that is personalized outreach task. So both sales rep agent and lead sales rep agent, they both are trying to perform the task, and let's see if we will get the personalized email draft at the end. So let's try to understand this output. So this is the result. So if you see the output, this is the personalized email draft that is generated by this lead sales representative. So what is the final answer? Hi Mala, I hope this message finds you well. Congratulations to you and your team at AI with Mala. So this is the company name, on your recent product launch. It's truly exciting to see innovative educational solutions entering the market. As the online learning environment continues to evolve, I believe our AI driven engagement solutions could greatly enhance user experiences on your platform. We focus on leveraging AI to foster learner interaction and personalization, which I feel aligns perfectly with your goals at AI with Mala. I would love to set up a brief call to discuss how we can support your mission and the success of your new offering. Would next week work for you? Looking forward to your response. Best regards, and your name, right? So this is our personalized email that is generated by this lead sales representative, right? So here you can see the complete detailed execution log, because we have given verbose is equal to true. So that is the reason it is trying to give us the complete execution log. So here you can see the crew execution started, and it is trying to perform these tasks. And first thing is, the sales representative agent is trying to conduct an in-depth analysis on this company AI with Mala, and it is trying to generate the report by gathering all the information about that company. And once we have the report ready, the next step is lead sales representative is trying to draft a personalized email, right? So that is the intent of using this multi-agentic framework. So instead of these tasks, you can replace with your own project scenarios and see if you are getting the desired output or not. For example, let's say if you want to send a broadcast messages to all your contacts, right? Then you replace this description and expected output accordingly, right? So you can use your own scenarios or applications as well, right? Instead of these tasks, try to replace these tasks with your own project scenarios and see how it is working, right? So let's quickly go through what we have learned here. So we are trying to build a multi-agentic framework by using CrewAI. The first thing is we try to install CrewAI and also CrewAI tools. We imported agent, task and crew. In order to build a multi-agentic framework, we need these classes which are imported from CrewAI. And then the next thing is we imported all the tools that are required from CrewAI tools, and also the base tool again from CrewAI tools, and load environment variable. And this is to display the results in Markdown format. We imported this, and the OS module. The first thing is we try to set the API keys. In our application, we are not using OpenAI API key, so you don't have to set this. We are only using Serper API key. So make sure you set this API key. We are creating the agents. We created sales rep agent and also lead sales rep agent, and we are instantiating the agent class, and we are setting these parameters: role, goal, backstory, allow delegation and verbose, right? So this is nothing but your prompt engineering. So what is the role of this agent, what is the goal of this agent, and what is the short description that the agent should do, right? And the allow delegation, if you want to delegate the task to different agents, then you set this to true. Otherwise, you can set this as false. And verbose is equal to true means it will give the complete execution log whenever this agent is trying to execute. And then we created another agent, lead sales rep agent. And again, we are setting these parameters: role, goal, backstory, and the allow delegation is equal to false and verbose is equal to true. And then we created our own custom tool by extending CrewAI tools base tool, right? And this is the class name, and we have to set these parameters: name and description. And here you can define your own custom logic inside this method, right? And here we are trying to instantiate our custom tool, right? So this is how you can create your custom tool. And if you notice, we are using CrewAI tools as well: directory read tool, file read tool, and SerperDev tool. This is the search tool, this is for file reading, and this is the directory read tool. And then the next step is we created the tasks. We created 2 agents and we need to assign task for those 2 agents. The first one is lead profiling task, and we assigned this to sales rep agent. And this is the description of the task and what is the expected output of the task. And the tools that the agent should do when performing these tasks are directory read tool, file read tool, and search tool. And we assigned that to sales rep agent. And then we created another task, personalized outreach task. And what is the expected output of this task? To generate a report on the company name, right? And then we created another task, personalized outreach task, and we passed again these parameters: description, the short description on this task, and what is the expected output. The expected output is to generate a personalized email draft. So instead of these, you can replace with your own project scenarios and see how it is generating, right? And for tools, you can use sentiment analysis tools. So this is the custom tool that we have created, and also SerperDev tool, which is the search tool, right? And we assigned this task to lead sales rep agent. So far we have created the agents, tools, and then tasks. Next step is creating the crew by instantiating crew class, and we are setting these parameters. For agents, we are passing the agents list. For task, we are passing the task list, and verbose is equal to true. We want to see the complete execution log whenever this crew runs, and memory is equal to true. And here we are trying to set the input data. So what is the lead name, industry, key decision maker, position, and milestone. Once we set the input data, the next step is we are trying to run the crew by calling the kickoff method and passing our input data. So here we are trying to print the final results as Markdown, right? So that is how you can create a multi-agentic framework. So instead of these scenarios, you can try to replace with your own project scenarios and see how you can build different multi-agentic frameworks by using this CrewAI. Alright. And I also want to show you one other thing here. In case if you want to stay updated on the AI news, so you can go to Alpha Signal, right? And then provide your email here and click on Get My Summary. This is free. So you will get all the updated news from AI, right? So instead of you going through different emails or different websites and trying to understand what is happening in the AI world, so you can just provide your email and click on Get My Summary. So this will give you a daily 5-minute email summary of the latest breakthrough news, models, papers, and repos, right? So this is free. You can make use of this Alpha Signal, right? So that's all about creating a multi-agentic framework by using CrewAI. So far we have seen web scraping and also how to do personalized email draft. All right, thank you. So we have seen different components of Crew, that is process, agent, task, tool, and memory, right? And we built multi-agentic applications by using this CrewAI, right? Now let's go to VS Code and see another application. So far we have seen one of the scenario, web scraping and extracting the text, and then creating the agent and task and running the crew and retrieving the desired results. And then we have seen another application where the agents were able to generate the personalized email drafts, right? So now let's see another use case number 3. So let me go to tools and agents demo and file, new file, and Python file, and let me save this as CrewAI use case 3 trading platform and click save. So let's see how we can build the complete stock trading platform project demo by using CrewAI. Okay, so the first thing is we need to install all the required packages before we start building the application. And we know we have to install CrewAI and also CrewAI tools in case if you haven't installed already. make sure you install these two packages by going to the terminal and giving this command and hit enter. So that way these two packages will be installed. And for this application we also need tokenizers. This is the latest version of tokenizers we need. In case if you haven't installed already, make sure to install this latest version of the tokenizers as well. So I will explain why we need these packages, right, when we start using them. And the next step is we have to import all the required modules from these packages. So here we are trying to import agent, task and crew classes from CrewAI package, and then scrape website tool, Serper dev tool from CrewAI tools, and crew and process from CrewAI, and then chat OpenAI from LangChain OpenAI. We will be using OpenAI as our LLM, and then load.env from .env and OS module. So these are the required modules that we need. And once we imported all the modules, now let's try to set the API keys, and you need to store these API keys inside this environment file and read that inside our code. I've already shown you how to store the environment variables inside this environment file. So let's try to load the environment variables from this .env file by using load_.env function, which is from .env package. And the next thing is, let's try to read the API keys once we load the environment variables from this environment file. So we have stored our OpenAI API key and also Serper API key. These two are stored inside this environment file. So this is the name and the value we have stored inside this. So by using this OS module and using the getEnv function, we are passing the name, so we will get the value. So that is how we read both OpenAI API key and also Serper API key. Let's try to store these two API keys inside the environment variables, OpenAI API key and also Serper API key. And here we will be using both scrape website tool and Serper dev tool. So let's try to instantiate both these tools. So Serper dev tool is our search tool, and to scrape the website we will be using scrape website tool. So let's instantiate that as well. So here Serper dev tool is the search tool, so we are assigning to this variable, and scrape website tool is used to scrape the website. So these two tools we are using them from the CrewAI tools. One is the search tool and the other one is a scrape tool. We have already seen how to get the API key for Serper dev tool in the previous lecture. So make sure you get the key and store it inside the environment variables and then read the API keys here. Okay. Instead of using Serper dev as our search tool, in case if you want to use any other open source tool like DuckDuckGo, you are welcome to use that as well, right? So you don't have to use just the Serper dev tool. You can explore any other tools also. And let me close this. So far we have installed all the required packages, and then we loaded the modules, and then we read the API keys, and then we stored inside our environment variables both OpenAI API key and also Serper API key. And then we instantiated both tools from CrewAI tools. One is the Serper dev tool, that is the search tool, and then the next one is the scrape website tool, right? And now by using this agent, task and crew classes, let's try to create agent, task and crew, right? So the first thing is, in order to build the multi-agentic framework, we need to create the agents. So let's try to define an agent by instantiating this agent class, which is from CrewAI. So here we are trying to define the data analyst agent. Here we are instantiating this agent class and we are setting these parameters. For role, we are setting as data analyst. And what is the goal of this agent? Monitor and analyze market data in real time to identify trends and predict market movements. And what is the backstory? Specializing in financial markets, this agent uses statistical modeling and machine learning to provide crucial insights. With a knack for data, the data analyst agent is the cornerstone for informing trading decisions, and verbose is equal to true. So that means we want to see the complete execution log whenever this agent is trying to perform any task, and allow delegation is equal to true. So that means the agent's will try to delegate the task with another agents, and tools is equal to, here we're passing the tools as a list, so we are using both scrape tool and also search tool. So this is how we created data analyst agent. So that is our agent number 1. So you know, role, goal and backstory, these three are nothing but prompt engineering, right? So here we are trying to provide the context, right? So we are saying, as a data analyst, your goal is this and this is your backstory, right? So that is, we are trying to provide more backstory or context, right? So these three things, role, goal and backstory, are mandatory whenever we are trying to create an agent, and verbose is optional, and allow delegation, that is to delegate to other agents, and the default value is false, and but we are trying to set it as true. So the agents can delegate the tasks to another agents, right? And we haven't written memory here, but the default value of memory is true, right? But the objective of this agent is just to collect the data. We don't need memory anyways here, right? And we have specified these tools as well, both scrape and search tool. So with this agent, the data analyst agent, has tools, memory, and we will assign the task as well, right? So the agent will know what to do. So this is one agent which does data collection, right? And now let's create another agent, agent number 2. So this is the trading strategy developer. The first one is data analyst. The second one is trading strategy developer. And what is the goal? Develop and test various trading strategies based on insights from the data analyst agent. So the data analyst will give you the report, and based on the insights, you give us the trading strategies. So this one will give us the insights and this one will give us the trading strategies. And what is the backstory? Equipped with a deep understanding of financial markets and quantitative analysis, this agent devises and refines trading strategies. It evaluates the performance of different approaches to determine the most profitable and risk averse options. And verbose is equal to true, allow delegation is equal to true. And again, we are passing scrape tool and search tool as our tools, right? So this is the trading strategy developer agent. So far we have created 2 agents, and this trading strategy agent is dependent on data analyst agent, because first the data analyst agent has to analyze the data and identify the trends, and then the role of trading strategy developer is to develop the trading strategies based on the insights from data analyst agent. So this agent is dependent on this agent, right? So these 2 agents have to work in sequential order. That is, the output of data analyst agent will be the input to trading strategy agent, right? And this process is nothing but sequential. So the objective of data analyst agent is to identify trends and predict market movements, and the objective of trading strategy agent is to create the strategy, right? So far we have created 2 agents, and now let's create another agent. So let's try to define the third agent. This is trade advisor agent. So what is the role, goal and backstory of this advisor agent? The role is trade advisor. What is the goal? Suggest optimal trade execution strategies based on approved trading strategies. So we will get these trading strategies from trading strategy agent. So once we get the trading strategies, the role of this trade advisor agent is, this agent specializes in analyzing the timing, price, and logistical details of potential trades. By evaluating these factors, it provides well-founded suggestions for when and how trades should be executed to maximize efficiency and adherence to strategy. And verbose is equal to true. We want to see the complete execution log, and also allow delegation is equal to true, and we will be using these 2 tools when executing this task, right? So far we have created 3 agents. Agent number 1 is for the data collection, and agent number 2 is to develop the trading strategy, and agent number 3 acts as a trading advisor, that is to recommend when and how to trade, right? So far we have created 3 agents, and now let's try to create the 4th agent. that is the risk assessment agent. So this is our agent number 4. And what is the role? Risk advisor. And what is the goal? Evaluate and provide insights on the risks associated with the potential trading activities. And what is the backstory? Armed with a deep understanding of risk assessment models and market dynamics, this agent scrutinizes the potential risks of proposed trades. It offers a detailed analysis of risk exposure and suggests safeguards to ensure that trading activities align with the firm's risk tolerance. And verbose is equal to true, allow delegation is equal to true, and again tools, we are using scrape tool and search tool. So far we have defined 4 agents, starting from collecting the real-time data to getting suggestions of which stock to buy and analyzing the risk in case if you buy those stocks, right? The next thing is we have to assign tasks to all these 4 agents, right? So let's try to create the tasks. Okay. And now for these 4 agents, the first one is data analyst agent. So let's try to create the task for this data analyst agent. So we are instantiating this task class, which is from CrewAI, and we are setting these parameters. For description, continuously monitor and analyze market data for the selected stock. This is the dynamic variable. We will be passing the stock name, so that will be replaced here. Use statistical modeling and machine learning to identify trends and predict market movements. So that is the description of this task. And what is the expected output? Insights and alerts about significant market opportunities or threats for the particular stock name, right? And we are assigning this task to data analyst agent, right? So that is our task number 1, which is assigned to data analyst agent. Okay. So here we are not hard coding the stock name. Instead, we are trying to just build a generic trading framework. So you can use this for any stock. It is not just for one stock. You can assign any stock value to this stock selection variable, right? And instead of these prompts, you can replace with any other prompts as well. So you can see the desired output. And also make sure you are providing the correct agent name. Whatever you have defined here, you have to provide the same name for this agent parameter. All right. So now similarly, what is the second agent? Trading strategy agent. So now let's try to create a task for this agent and assign it to this. So that is our task number 2. So here we again instantiated this task class and we are setting these parameters. And what is the description of this strategy development task? Develop and refine trading strategies based on the insights from the data analyst, right? And user defined risk tolerance. We will pass these value, and this is a dynamic variable again. Consider trading preferences. So we will pass the trading strategy preference as well. And what is the expected output of this task? A set of potential trading strategies for the stock name that aligns with the user's risk tolerance. And what is the agent? We want trading strategy agent to perform this task and give us the expected output. Okay. And similarly for the third agent, which is nothing but execution agent. So that is the trade advisor. We need to assign the task. So let's try to create the task and assign that to execution agent. So here again we instantiated this task class and we are setting these values. And what is the description of this task? Analyze approved trading strategies to determine the best execution methods. So we will get these trading strategies from the second agent, right? The output of the second agent is trading strategies. The output of the first agent is to provide the insights. The output of the second agent is to give us the trading strategies. So what is this task doing? Analyze approved trading strategies to determine the best execution methods for the stock. Consider current market conditions and optimal pricing. And what is the output we want? Detailed execution plans suggesting how and when to execute trades for this stock, right? And we are assigning this to execution agent, that is agent number 3. And this is the task number 3. So similarly, for the last agent, which is risk advisor agent, let's try to create a task. So that is our task number 4. And what is the description? Evaluate the risks associated with proposed trading strategies and execution plans for the stock. Provide a detailed analysis of potential risks and suggest mitigation strategies, right? And what is the expected output of this task? A comprehensive risk analysis report detailing potential risks and mitigation recommendations for the corresponding stock. And we are assigning this to risk management agent. So far we have created 4 agents and we defined 4 tasks. And we assigned these 4 tasks to 4 agents, right? And the next step is creating the crew. So let's try to define the crew with these 4 agents and 4 tasks, right? So this is our crew. We are instantiating this crew class and we are setting agents, tasks, manager LLM, process and verbose. For agents, we are passing these 4 agents that we have created as a list: data analyst agent, trading strategy agent, execution agent and risk management agent, right? So this is the agents list. And the next one is tasks list. Whatever the tasks that we have created, we are passing them as a list. And this is the manager LLM. So for the LLM, we are using OpenAI, and this is the model we are using, GPT 3.5 Turbo, and temperature is equal to 0.7, and process is equal to, we are following the hierarchical process. So that means it is not sequential, right? So the manager LLM that will need to approve before you buy any stock, right? And all the agent results will be approved by this LLM. So that is why we are using this manager LLM. And the process class, this one, we have imported from CrewAI, right? So this process class helps to delegate the workflow to the agents. So it is kind of a manager at work, right? So in this example, it is hierarchical process. So we have created the crew. And now, before we run the crew, here we are setting few dynamic variables, right? The stock selection and risk tolerance, trading strategy preference. For all these dynamic variables, let's try to set the input data. So this is our example data for kicking off the process, right? Financial trading inputs, these are the values, name value pair. For the stock selection, we are using Apple as our stock. Here, instead of this, you can replace with any other values. And this is the initial capital, and risk tolerance is medium, and the trading strategy preference is day trading, and news impact consideration is true, right? So this is our input data. And now let's run the crew. So to run the crew, we know inside this crew we have a method called kickoff. So let's try to run the crew by calling the kickoff method and passing this input value. And the inputs is equal to financial trading inputs, which we have defined here. Now let's try to print the results. The final result is equal to, which is stored inside this result variable. So we are just trying to print the results here, right? And in case if you want to display the final result as Markdown, so we can do that as well. So we are just trying to give the file name as output.md. So this is the name of the Markdown file. So we are trying to store inside this downloads folder, and the file name is output.md. That is a Markdown file, and we are just trying to store this result and writing that to this file, right? So with this, you are able to see the results in the terminal, and also we are writing the content to this output.md, that is a Markdown file. Okay, and let's just try to print. The Markdown content has been saved to this file name. And what is the file name? Output.md, and we are storing that inside downloads folder. So now with this, we built the multi-agentic framework. Now let's try to run this code and see if it is generating the output. So let's click on run. So you can see the crew execution started, and the crew manager started as well, and the agent also started the task, and the agent data analyst agent is trying to perform the task. So it is trying to analyze the market data. So it is trying to crawl different websites and trying to give us the real-time data. And then the next one is trading strategy developer, that is in progress. That is the agent number 2, and it is completed. And now the crew manager is evaluating the risks, and the crew manager is in progress. The execution completed, and this is the final result. Apple faces significant regulatory and legal risks threatening its high margin services segment, with potential commission cuts impacting profitability. The China heavy supply chain and political pressure to move manufacturing to the US create major macro headwinds and margin risks for Apple. Lack of innovation, slow R&D growth, and delayed AI adoption further weaken Apple's investment case compared to other mega cap techs. Despite a lower share price, Apple's valuation and growth outlook do not justify a buy. A selling rate is maintained for Apple. Markdown content has been saved to this file, right? So we are trying to store the result inside this downloads folder. So this is our output.md, which is nothing but the same result we are storing inside this file, right? Let's try to go through this output. Since we gave where pose is equal to true, we are trying to see the complete execution log. So here you can see the crew execution started and the crew manager is in progress. And the first agent is data analyst. It is trying to gather current market data for the Apple stock, including historical prices, trading volume, and financial reports. So it is trying to crawl different websites, for example, Yahoo Finance, right? And it crawled hundreds of websites here. So you can see investor.apple.com, wsj.com, that is the Wall Street Journal. It is trying to crawl different websites and gather the real-time data. So that is our data analyst agent, and it is giving the final answer. And this is the analysis that it has provided. And then the crew manager is trying to ensure that the team gathers the necessary market data, right? So the crew manager is kind of a manager where it checks the output of each agent before it approves, right? So the agent started and it crawled to different websites and it collected the real-time data. So the output generated by the agents will be evaluated by the crew manager, right? And once the data analyst completes the execution, the next one is preparing the trading strategy by using trading strategy developer, right? I need to gather the most recent data and analysis for Apple to provide a comprehensive assessment of significant market opportunities or threats, right? So that is the task of trading strategy developer, to develop a trading strategy, and it is trying to execute, and this is the final answer for trading strategy developer. So it provided this strategy, right? And then again the crew manager is trying to evaluate, and then the task is completed. And it also analyzed the risk, and it is finally giving us the output, right? So here you can see risks of trading strategies for Apple. So it is trying to evaluate the risks also. Once it analyzed everything, it is trying to give us the final answer whether to buy Apple stock or not, right? And the crew execution completed, and it is giving the final output, and we are also storing that inside this output as markdown file. So you can see, instead of we searching hundreds of pages and trying to analyze the data and understand the risks, we built a multi-agentic framework and we were able to get the final insight, right? So if you want to go through these websites and trying to understand the results, it might take time, right? So instead of that, we built an agent and we provided the context and we got the analysis of the stock, right? So you do not have to do these tasks manually, right? And the agents are doing it for us. So this is how you can build a stock trading project by using CrewAI, right? So we want suggestions and risks as the output, and which we got from this CrewAI, right? So agents are searching hundreds of pages and providing you with trading insights, right? So which is cool. So now let me close this and let's quickly review what we have learned here. So the first thing is we installed the required packages, that is CrewAI, CrewAI tools and tokenizers. And the next thing is we imported these modules from CrewAI, CrewAI tools and LangChain OpenAI. Here we are using OpenAI as our LLM, and these are to load the environment variables, right? So we read the API keys and we stored inside these environment variables. And then the next step is here we instantiated our search tool. We are using SerperDev as our search tool and Scrape website tool as our scrape tool, because it is trying to crawl different websites. As we saw in the output, it tried to crawl hundreds of websites and provide us the results for Apple stock, right? So that is why we are using this search tool also. And then here we defined 4 agents. The first one is data analyst agent to identify market trends, right? And then the next agent is trading strategy agent to develop the trading strategy based on the insights from this data analyst agent. And then the third agent is trade advisor agent. It is to advise the trades based on the trading strategy that the agent developed before. And the fourth agent is risk advisor. So this will provide any insights on the risks with the trading activities, right? And then for these 4 agents, we have defined the 4 tasks, what each agent should do. So this is nothing but prompt engineering, right? So we have defined 4 tasks and assigned to each agent, right? So once we created the tasks and agents, the next step is creating the crew. So here we created the crew by instantiating this crew class, and we passed agents, tasks and manager LLM. For the LLM, we are using OpenAI GPT 3.5 Turbo, and the process is hierarchical, right? Because the manager LLM has to approve, right? So that is why we are using this hierarchical process, and verbose is equal to true. We want to see the complete execution log, and here we define the input data. Instead of Apple, you can replace this with any other stock, right? And then inside crew, we have the method called kickoff. For this method, we are passing our input data as value to this inputs attribute, and we get the final result, right? And here we are trying to just write the content from this result to this file. This is the markdown file, right? So this is how we are able to build a multi-agentic stock trading platform project by using CrewAI. All right. Thank you. So far we learned different components of LangChain, that is prompt engineering, chains, memory, agents. Now we also have tools. That is, we can provide different tool access to LLM so that the LLM can access outside world, right? So now let's go to VS Code, and inside our tools and agents demo, let me create a new Python file, and here we will be using Apify, and by using Apify, let's try to scrape a website. Okay, so that is the project we will be implementing now. So let's save this file as web scraping using Apify. So we will be scraping a website by using Apify. In order to use the Apify, first thing is you need to get the API key, right? So let me take you to the Apify official web page. So this is how it looks. Scrape TikTok profiles, extract places from Google Maps, download Instagram posts, crawl website to feed AI, extract products from Amazon, right? This Apify is your full stack platform for web scraping, right? So this is one of the web scraping tool. So if you notice here, we have different actors which you can use to do various activities, right? So you can do the TikTok data extraction, or you can scrape Instagram or Google Maps extractor, or website content crawler. This is the one we will be using now to scrape a website. And you can also scrape Amazon, right? Or you can build your own actor also. Instead of using the existing actors, you can build your own actor also. So this is the official Apify platform. So here you can click on login and then click on sign up, and you can sign up with your Gmail account here. So you can continue with your Google account and click on sign up, right? So once you create an Apify account, then click on login and provide your email address and password and click on login. So this is how it looks once you log into Apify. So once you create an account, Apify will provide you some free credits. So before you recharge your account, make sure you use your free credits, right? So once you log into Apify, click on settings, API and integrations, and here you can see your personal API token. So click on this to copy your API key and then store this inside your environment variable. So that is how you can create an Apify account and then get your API key. So we use this Apify to scrape websites, right? So here, let's try to create API key for Apify also, Apify API key, and then whatever the key that you get from your Apify account, make sure you replace here, right? So that is how you will store your API key inside this environment file. And now, first thing is we know we have to install all the required packages. So I have already installed these packages, that is LangChain Apify. So we are using a LangChain package, that is LangChain-Apify, and we are also installing LangChain community and then Apify client, right? So make sure you install these three packages in order to scrape a website by using Apify, right? And once you install all the required packages, the next thing is we have to load the required modules. So we are trying to import vector store index creator. This is from LangChain indexes, and then Apify wrapper. We got this one from LangChain Apify package, right? So we have to install this to use Apify wrapper, and also this document from LangChain core documents, OpenAI embeddings. You know this already, in order to create the embeddings, and we are using OpenAI as our LLM, and this is to load the environment variables, right? Now, first thing is let's try to load the environment variables by using load underscore dot env function, right? And then the next thing is let's try to read the API keys. So we are reading OpenAI API key and also Apify API key, right? So make sure you give the same name inside this environment file, okay? Whatever name you are providing inside this environment file, you have to give the same name so that you will get the key, right? So once you read the API keys, the next step is store these inside the environment variables, right? So OpenAI API key and also Apify API token. Now, the first thing is let's try to instantiate Apify wrapper. So this is the Apify wrapper class. And if you want to read more about Apify wrapper, so this is the official documentation from LangChain. So you can go through this and see what kind of parameters or functions that this class supports, right? So once you instantiated this class, now let's try to call the method call underscore actor to crawl a website, right? So let's try to print call website content crawler. So inside Apify wrapper, we have a method called call underscore actor. And if you notice here, we have different parameters inside this method. So we are passing actor ID as Apify slash website content crawler. So this is the actor that we are using. And in case if you are using different actors, for example, Amazon or Instagram, right? So then you have to replace this actor. And here we are trying to crawl a Wikipedia website. Instead of this website, you can replace with any other website and see if you're able to scrape the content, right? And this is nothing but the document page content is equal to item of text and metadata is equal to source item of URL. We are trying to provide the source also, right? From where this content has been scraped, right? So that is what we are giving here. So by using this call underscore actor method, we can pass the website that we want to crawl, right? So now once we get the data, we have to convert that into embeddings, right? Because we know LLM cannot understand text and it can only understand numbers, right? So let's try to define the embedding model. Here we will be using OpenAI embeddings. So we created our embeddings. Now the next step is let's try to compute the embeddings by initializing the vector index from the crawled documents, right? So we stored our document inside this loader. So here we are trying to initialize the vector index, which is from vector store index creator, which we have imported from LangChain indexes. For the embedding, we are giving our embeddings model, which we have defined before, that is OpenAI embeddings. And inside this vector store index creator, we have a method called from underscore loaders, from where we want to load this, right? We stored our scrape data inside this loader variable, right? So that is what we are trying to pass here. And once we created the vector index for our crawled document, the next step is let's try to initialize the LLM. So here we are using OpenAI, which we have imported from LangChain community LLMs. So here we initialized our LLM and we are using OpenAI as our LLM, right? So now this is nothing but a RAG application, right? So we scraped a website, which is nothing but our Wikipedia website, and we scraped this website content and we stored inside this loader variable, and we created the embeddings and we initialized the vector index and we stored inside this index variable, right? Once you convert the content into embeddings and stored inside a vector database, meaning you can ask any questions from this website, right? So now this is nothing but a RAG application, right? Because we scraped the content. This content is from a Wikipedia website. We scraped the content by using Apify website content crawler actor and we stored inside this loader. And then we created the embeddings. We are using OpenAI embeddings. And then we created the vector index by using vector store index creator and we passed our data, right? So now once you have this, you can ask any question. So now let's try to ask any question and see if it is trying to answer or not. So the query is, what is generative artificial intelligence, right? Now let's see if our LLM is able to answer. Index, this is where we created our vector index. Inside that we have a method called query with sources and we have to pass our input, that is the query, and also the LLM, which we have initialized before, right? That is our OpenAI LLM. And once we get the results, let's try to get both the answer and also the source, right? So let's print the result and also the answer as well as the source from where it is trying to get the answer for us, right? So it is kind of a chatbot, right? So you can read the content from a PDF instead of this website, right? And you can try to implement different scenarios here, right? So let me save this code and let's try to click on run and see if we are able to see the results or not, right? So let's click on the run. So you can see it is trying to create the embeddings and then it is able to scrape the website. And what is the question that we asked? What is artificial intelligence? That is the question and this is the answer, right? So let's quickly review what we learned here. So here our intent is to scrape a website by using Apify, right? So the first thing is we have to install all the required packages. So let me close this. And let's minimize this as well. So the first thing is we installed all the required packages, that is LangChain Apify and LangChain Community and Apify Client, right? So these three are the required packages. And once you install the packages, and the next step is loading all the required modules, right? And here we are trying to load the environment variables from this .env file where we stored our Apify API key, right? And here we are trying to read the API keys. One is OpenAI API key and also Apify API token, and we are storing those two inside these environment variables. And then we instantiated this Apify wrapper class, which is from LangChain Apify. And then here we are trying to pass the website that we want to scrape, right? And then the actor that we are using is website content crawler. And inside this Apify wrapper, we have a method called call_actor, and we are setting these parameters. And then we initialized our OpenAI embeddings because we know LLM cannot understand text. So we are trying to create the embeddings. And then here we are initializing the vector index for this crawled documents, right? And then here we are trying to initialize the LLM. And then next thing is inside this vector store index creator, we have a method called query with sources. So we are passing both our query, what is our input, and also the LLM, which is nothing but OpenAI LLM. And it is able to scrape this website and was able to answer the question, what is generative artificial intelligence, right? So from this website, okay? So that is how you can use Apify to scrape any website, and you can build different scenarios here, right? So here, instead of this website, you try to replace with your own content. For example, let's say read your content from different data sources, for example, PDF or Word doc or different data sources, and try to store this here. And this is kind of a RAG application. So once you create this vector store, the next step is you can try to ask different questions, right? So that is how you can use Apify to scrape a website. All right. Thank you. So far we have seen different components of LangChain, that is prompt engineering, chains, memory, agents, and tools. And we have also seen RAG, right? So how to build RAG applications as well. And now let's see how we can empower an LLM by providing access to different tools. Now let's go to VS Code and try to build an application around these tools, right? So this is our tools and agents demo folder. So inside this file, new file, Python file, and let's save this as math tools agents use case, right? So we will be using math tool, which is inside LangChain Chains. So the first thing is we have to make sure we install LangChain OpenAI, right? So in order to use the OpenAI LLM, so we will be using OpenAI as our LLM. And once you install LangChain OpenAI package, the next thing is we have to import all the required modules. And in case if you do not want to use this paid LLM OpenAI, you can also choose any other open source models too, right? For example, you can replace this OpenAI with Ollama or any other open source models from Hugging Face, right? So you don't have to just rely on this OpenAI. Okay, so here we are trying to import LLM MathChain from LangChain Chains, and tool from LangChain Agents, and OpenAI from LangChain LLMs, and load.env from .env and OS module, right? So the first thing is we have to load the environment variables from .env file. So this is where we stored all our environment variables. Inside this environment file, we stored our OpenAI API key. So now first thing is we used this load_.env function from .env, and by using this we are trying to load the environment variables, right? And then the next thing is let's try to read the API keys. So we are trying to read OpenAI API key and storing that inside OpenAI API key variable. Okay, and now let's try to store this OpenAI API key inside this environment variable, right? And let me close this. And the next thing is let's try to initialize OpenAI LLM, right? By using OpenAI, which is from LangChain LLMs, right? Now here we are using LLM MathChain, right? So let's try to initialize LLM MathChain as well. This is from LangChain Chains. So that is our next step. So far we have initialized our LLM, which is nothing but OpenAI, and then we also have LLM MathChain to bind this LLM with the tool, right? So that is why we initialized our LLM MathChain. And the next one is let's use this tool class, which is from LangChain Agents, and initialize our math tool. Okay, initialize this tool class, which is from LangChain Agents. Here we are trying to set the parameters, name as calculator, and function is inside this LLM MathChain we have a function called run. So that is what we are telling this tool to use, and what is the description useful for when you need to answer questions about math, right? So this is the math tool. So that is how you can create a tool. Okay. So far we have initialized our LLM, and we also have our math chain, which is LLM math chain. And inside that we have a function called run. So that is the function we are telling it to use. And we also initialized our tool. Okay. Now, when giving this tool to LLM, we must pass this tool as a list. Okay. So here we are trying to give this math tool to our LLM OpenAI. Okay. And we must pass this as a list. So remember that. And now inside this LangChain agents, we also have another module called load_tools. So let's try to load that module as well, load_tool. So this is another function which is inside LangChain agents. Let's use that load_tools function, which is from LangChain agents. So load tools based on their name. Tools allow agents to interact with various resources and services like APIs, databases, file systems, etc. So that is the intent of using tools, right? And here we are giving the tool name as a list, and we are assigning the LLM, right? So far we have initialized our LLM and then LLM math chain, and we created our math tool as well. Now let's initialize the agent, which is again from LangChain agents. So we have a function called initialize agent. So by using that, let's try to initialize an agent. So our agent is 0-shot React description, and for the tools we are passing whatever tools we have created, that is our math tool, and this is the OpenAI LLM, and verbose is equal to true and max iterations is equal to 3. So once we have the agent ready, for this agent we assign tools, we also assign LLM, and now let's try to ask a math question and see if this agent is able to perform or not. Okay. So for this 0-shot agent, let's try to ask a math question. What is 4.5 times 2.1 to the power of 2.2? So this is our question, and also let's try to print this so we can see in the terminal. Let me try to execute this. So you can see this is the output our agent has given us. Okay. So now let's see if it is actually correct or not, right? So let's try to cross verify this. So let's try to just print this value. So let me create this session and rerun the code. So now you can see both are giving the same result, right? So that means our agent is trying to calculate the correct value for the math question that we have asked, right? Let's try to ask another math question. 0-shot agent. If Mary has 4 apples and Tom brings 2.5 apple boxes and each apple box contains 8 apples, how many apples do we have? So this is a math question that we are asking to our agent. So now let's clear this, and also I'm commenting this print statement, and now let's rerun the code. So let's try to understand the output first. So for the previous question, we asked what is the value of this math question. So entering new agent execution chain, I should calculate the expression using a calculator, and the action is calculator. Action input is, this is the input, and the observation answer is this. And what is the thought? I now know the final answer, and it gave the final answer, right? So this is how the agent performed the task. And then we also asked another question. Entering new agent executor chain, we need to calculate the total number of apples. So it understood it need to calculate the total number of apples for this question, right? So what is the input? First, Mary has 4 apples, and Tom brought 2.5 apple boxes and each box contained 8 apples, right? So 2.5 times 8 and the total answer is 24. And the thought is we have 24 apples in total. So the final answer is 24 apples, right? So that is how it is able to calculate the math questions, right? And now let's try to ask another question. What is the capital of the United States of America, right? So this question is not a math question. So now let me kill this and then rerun the code and see if it is able to answer this generic question, right? So you can see raised error, variable node, object is not callable. Please try again with a valid numerical expression. Is this a numerical expression? No. Unfortunately, we end up hitting an error. This is because the agent is enforcing the use of a tool because we are trying to use the math tool. So what is the workaround? We have created math tool. So we have to add another tool that can answer this generic question, right? So far whenever we asked any math question, it is able to understand and give us the answer. But when we ask this generic question, it is not able to answer. So we have to create another tool so that the agent will be able to answer this general knowledge question, right? So we just need to link it to an LLM tool, right? So let me comment this and now let's close this as well. And let's see how we can add another tool. So the first thing is, let me try to import prompt template from LangChain prompts and then LLM chain from LangChain chains. Before we used LLM math chain and now let's use LLM chain instead of LLM math chain. Now we are using LLM chain because it is able to answer only questions that is related to math, right? So that is why we are using LLM chain now. So we can create a generic tool and now let's try to initialize the prompt template. So this prompt template is from LangChain prompts and we are passing input variables query and the template is equal to query. And instead of LLM math chain, let's try to initialize LLM chain, right? So this again we imported from LangChain chains, right? So when we created this math tool, here we used LLM math chain. Instead of this LLM math chain, let's try to use LLM chain and let's create an LLM tool. So notice here, this is the LLM chain dot run and here we used LLM math chain dot run, right? So that is the difference. You can see the description here. Use this tool for general purpose queries and logic. If it is math related questions, then use this math tool. If it is general purpose questions, then use this tool, right? So now let's try to append this LLM tool to math tool, okay? So we have stored this inside tools, right? So let's try to append tools dot append and we are appending this LLM tool as well. So now we have both math tool and also LLM tool. So once we have the tool ready, now let's try to initialize an agent. So this is our agent, 0 shot React description, and for the tools we assign the tools. This tools contains both math and general LLM tool as well, and for the LLM we set this LLM and verbose is equal to true, max iterations is equal to 3, right? So with this we should be able to ask either math question or any other generic question as well, right? Because we have provided both math tool as well as this LLM tool because we are using LLM chain here, right? So let's try to ask this generic question now. Okay, so save it. And also let's try to ask another math question as well. So here we are asking both generic question and also math question. So let me save this code and rerun the code. So this is the first one. And then the apples question. And then if you notice here, this is the generic question we asked after adding the LLM chain, right? So what is the capital of the United States of America? In the observation, the capital of the United States of America is Washington, DC, right? So it is able to answer now. And we've also asked math question as well. So it is able to answer both generic question as well as math question, right? So that is how you should be able to provide different tool access to LLM, right? So let's quickly review what we learned here. So the first thing is we try to install all the required packages. So we have already installed this package when implementing the previous applications, right? So in case if you haven't installed already, make sure you copy this pip install LangChain OpenAI and go to the terminal and give this command and hit enter. So that way this package will be installed. And once you install the package, the next step is we are trying to load all the required modules from LangChain. And also we are importing load_.env function from .env module. And by using load_.env function, we are trying to load the environment variables from .env file. So inside this, we stored our OpenAI API key and we are trying to read that key and we are storing inside this OpenAI API key environment variable. And the next step is we initialized our OpenAI LLM. And here we are trying to initialize LLM math chain. So this is specific to math related, right? And once we have the LLM and the LLM math chain ready, next thing is we are trying to create a tool. Here we initialized this tool class which is from LangChain Agents and the name is calculator. Function is inside this LLM math chain we have a method called run. So that is the function we are assigning to this, and the description is useful for when you need to answer questions about math, right? So this is how we created the math tool. And remember, whenever we are trying to give tools to LLM, we must pass this as a list, right? And then we use this load_tools function from LangChain Agents and we are giving the description and we assigned our LLM which we initialized before, right? And once we have the LLM and tools ready, the next thing is we initialize the agent and we passed the tools LLM to our agent. And the next thing is we asked a math question and the agent was able to get the answer for us. And then we cross verified and it was able to give us the correct answer. And then we asked another math question, it was able to give us the answer. And then we asked a generic question and it was not able to answer because it is not related to math. So that's why we created a LLM tool. Instead of just math tool, we created another generic purpose tool and we appended both, right? Here notice we are using LLM chain instead of LLM math chain and we are calling the run function and assigning this to this parameter, right? And here again we initialized the agent and here notice we are assigning tools. This tools contains both math tool as well as this LLM tool, right? So that is why it is able to answer both the questions. Either it is general purpose question or math question. So that is how you can provide different tool access to an LLM so that it can perform different tasks for us. All right. Thank you. So far we have seen how to create multi-agentic applications by using CrewAI. And then we also learned how to provide different tool access to LLM like math tool. And also we learned how to use Apify and scrape a website, right? And now let's see how to provide an LLM access to tools like SQL database toolkit and also how to use SQLAlchemy and how to create an SQL agent and perform different SQL operations, right? So let's try to create a new Python file and let's save it as SQL database tool SQL agent and click on save. And before we start anything, make sure you install LangChain OpenAI package in case if you haven't installed already. That way we will be able to communicate with our OpenAI LLM. Okay. And now once you install the package, the next thing is let's try to load the required modules. So here we are using OpenAI, which is from LangChain LLMs. This is to communicate with our OpenAI LLM. That is the one we will be using as our LLM. And then get OpenAI callback. So this is from LangChain callbacks. So here you can see the description. This is used to get the token and the cost information, right? So that is why we are using this function. And then the next one is load underscore dot env. This is from dot env and also the OS module, right? Now inside this dot env file, we stored our OpenAI API key. I've already shown you how to get the OpenAI API key in the previous lectures. So make sure you get the OpenAI API key and store it inside this environment file. And once you store the API key inside this environment file, now the first thing is let's try to load the environment variables from this environment file by using load underscore dot env function. And then the next thing is let's try to read the API keys by using OS module dot get env function, and this is the key name, right? So whatever the name we stored inside this dot env file, we are giving that name so that we will get the API value. Okay, and once you read the API key, next thing is let's try to store this inside this environment variable OpenAI underscore API underscore key. And now let's try to initialize our OpenAI LLM. So we imported this OpenAI from LangChain LLMs. So we are using OpenAI as our LLM. And now let's try to define a user defined function that can return the total number of tokens spent. Okay, so this is a function that is count underscore tokens. This is our own function. This is not built in. And here we are calling this function, which is from LangChain callbacks. And by using this, we are trying to get the token information. That is the total number of tokens spent. By using this function, we are trying to get the attribute value. That is total number of tokens. And we will call this function to get the total number of tokens spent. Okay. And in case if you want to learn more about this, you can always go to LangChain and try to read more information, right? So let me quickly show you. This is the LangChain official documentation for get underscore OpenAI callback function. So you can always go here and see what are the parameters and how to implement this function, right? So you can see the example also. And then the next thing is we are trying to import metadata from SQLAlchemy. Okay, so this is the official web page of SQLAlchemy. So SQLAlchemy is the Python SQL toolkit and object relational mapper that gives application developers the full power and flexibility of SQL. So by using this SQLAlchemy, we can map database tables to Python classes. So that is the intent of using SQLAlchemy. Okay, that is what we are trying to use here, and we are trying to import metadata class which is from SQLAlchemy. And now let's try to initialize metadata and assign that to metadata object variable. Okay, so this metadata, this is a container object that keeps together many different features of a database. So if you want to see the documentation, let me take you there. So this is the complete documentation of metadata class which is from SQLAlchemy. So here you can go through how to import and how to create an object and how you can create a table and utilize it, right? So you have the complete documentation here. So you can go through if you want to explore more. Okay. So we have initialized our metadata object. And now the next thing is let's try to import column, integer, string, table, date and float. So we are trying to import different classes again from SQLAlchemy. So our intent is to create a table. So let's try to create a table. So we are trying to initialize this table which is from SQLAlchemy, right? So we initialized our table class and we assigned that to stocks variable, and the table name is stocks, and the metadata object which we have created before. And then here we are trying to create 4 columns. The first column name is observations. So in short, we are giving OBS underscore ID. The data type of this column is integer and the primary key is equal to true. So that means this is the primary key. And the second column is stock underscore ticker and it is of type string and we are allowing 4 characters. Nullable is equal to false. So that means we have to provide the value for this. It is not null. And then price, that is the third column. It is of type float and again nullable is equal to false. And again the fourth column is date. It is of type date and nullable is equal to false. So with this we created this table and named it as stocks, right? And now let's try to import create engine. This is a function again from SQLAlchemy, right? Let me take you to the official page. So if you want to go through this, you have a complete documentation here inside this SQLAlchemy. So the intent of this engine is the starting point for any SQLAlchemy application, right? So this is how it starts: the engine, pool, dialect, DB API and the database. So it's home base for the actual database and its DB API delivered to the SQLAlchemy application through a connection pool and a dialect, which describes how to talk to a specific kind of database or DB API combination, right? So this is the starting point for any SQLAlchemy application, right? So here you have the complete documentation. So you can see here we have to provide the URL in order to create an engine object, right? So here they have given some examples as well, which you can go through, like how to connect to different databases: MySQL, Oracle, Microsoft SQL Server, and SQLite. This is the one we will be using, right? And others. And this is for the API, right? So depending on your requirement, you can implement. And now let's try to create the engine object. So we have imported this create engine function from SQLAlchemy. So let's try to use that function and pass the URL, which is nothing but SQLite. So SQLite is an open source relational database, right? So by using this create engine function, we are passing this and we are getting the engine object. And inside this metadata class, we have a function called create underscore all. And for that, we can pass the engine object that we have created. So let's try to call the create all and then pass this engine object. Okay, we have created our table. So here you can see the description of this method. It will create all tables stored in this metadata, right? So with this, we created our table. And now we have to insert the values for these 4 columns. And one of them is of type date, right? So in order to insert date time value, we are trying to import date time class from date time module. And now let's try to insert around 10 values. So the column number 1 is observations ID, which is nothing but the primary key and is of type integer. So that is what we are giving. And stock underscore ticker, that is the stock name is ABC. And the column number 3 is price. We are giving as 200. And date, so here we are trying to create a date, 2050 January 1st, right? And again for the second column, 2 ABC, 208 is the price and 2025 January 2nd. So similarly, we are trying to create the column values for the remaining. So we have a total of 10 column values. So now let's try to insert these values to our stocks table. So in order to insert, so this is for the create and now we are trying to insert. So here we are trying to import the function called insert, which is from SQLAlchemy. So by using that, let's try to create a function called insert underscore OBS. So here we are trying to define a function called insert underscore OBS. So that is all the observations. So we will pass each observation one by one. So we have a total of 10. We will pass one by one. And here we are trying to call this insert function, which is from SQLAlchemy, which we just imported. And we are trying to insert each value. So the first one is whatever we get from these observations. So the 0th index value is the ID. So that is what we are assigning. And then here it is OPS of 1 means it will give us the stock underscore ticker. So that is what ABC. And then index value of 2 is 200. So that is the price. And this is the date, right? So that is what we are setting here. So we defined a insert underscore observations function so that we will pass each observation. We have a total of 10 and we will insert inside our stocks table. And also let's execute this statement, right? So this is our connection object. So we are trying to begin the engine and then execute the insert statement one by one, right? So now let's try to pass these values and call this function insert underscore observations. So inside observations, this is a list of lists. So we have a total of 10 and for 10 times we are calling this function and we are passing one by one observation. So for each observation we are getting each one by one and then passing here to this function and we are trying to insert the value. Okay. And now let's try to import SQL database. So which is from LangChain utilities. Okay, so we are trying to import SQL database class and also let's try to import SQL database chain class which is from LangChain experimental SQL. Okay, let's try to create this SQL database object. So that is the database we will be using and we are passing the engine object, right, which we have created before by using create underscore engine. And now let's use this SQL database chain and create an object. So that is the SQL chain, and to this chain we are trying to bind LLM and the database object that we have created and verbose is equal to true. That is, we are providing SQL database access to our LLM by using this SQL database chain, and verbose is equal to true means we will see the complete execution log in the terminal. And now we have to create the agent. So that is the next step so that we can assign this task, right? So let's try to import this create underscore SQL underscore agent function from LangChain agents, and also from LangChain agents let's try to import SQL database toolkit class from LangChain agents agent underscore toolkits. Okay, and we also need the agent type. So this class is again from LangChain agents agent types. So once we imported all these classes, now the next thing is let's try to create a SQL agent by using create underscore SQL agent which we just imported from LangChain agents. So by using this create underscore SQL underscore agent, let's try to create an agent, and to this agent we are setting these values. For LLM we are setting the LLM which we initialized before, which is nothing but our OpenAI LLM, and we are trying to give the tool access which is nothing but SQL database toolkit, and here we are setting the database which is nothing but our SQL database and the LLM which is nothing but our OpenAI LLM verbose is equal to true, and agent type it is of type 0-shot React description. So this is a 0-shot agent that does a reasoning step before acting, right? And the max iterations is equal to 3. So now once we created our agent, let's give a task to our agent. So we have provided LLM SQL database toolkit access to our agent. So let's assign a task so that our agent will perform the task by accessing SQL database, right? So here we are trying to call count underscore tokens which we have defined here. So here we are passing agent and the input query, and we are trying to get the total number of tokens spent for this query, right? So the agent executor is whatever the agent that we have created before. And what do you want our agent to do? This is the query. What is the multiplication of the ratio between stock prices for ABC and XYZ in January 3rd and the ratio between the same stock prices on January the 4th, right? So if you see here, we have January 3rd and January 4th, we have ABC, and we also have XYZ stocks, right? So we are asking what is the multiplication of the ratio between stock prices for ABC and XYZ on January 3rd and 4th, and also the ratio between the same stock prices on January 4th also, between 3rd and 4th for those two stocks, right? So let's try to print the results. So let me save this code and let's run the code and see if our agent is able to execute and give us the answer. So it is trying to enter new SQL agent executor chain. Okay, so this is our input, that is the query that we gave, and the output is agent stopped due to iteration limit or time limit. Okay, but it understood whatever the query we gave, so it formed the query, right? So select price from stocks where stock ticker is equal to ABC and date is equal to either 3rd or 4th, ordered by date in ascending order. It is trying to sort it. So since we reached the maximum iteration limit, so let's try to increase the iteration limits to, I'm just giving 30. So either we can kill or clear the session. So let's rerun the code. So now you can see the final output, right? So for the stock ABC, this is the January 3rd value 232 and 225 is the January 4th value. So that is what we have created here. So January 3rd for ABC it is 232 and 225 is for January 4th, right? So that is what we are trying to get the ratio. And similarly for the stock XYZ, right? The next thing is what is the multiplication of the ratio, right? So that is what we are trying to get the multiplication value. So it is trying to multiply them and the final answer is this, right? So it is trying to give us the final answer here, output, right? So you can see the complete execution log because we gave purpose is equal to true, right? So here you can see entering new SQL agent executor chain, and this is the action it is trying to perform. SQL database list tables and action input is stocks. I should query the schema of the stocks table to see what columns I can use, and the action is SQL database schema. Action input is stocks, so it created this table with these 4 columns, right? So create table stocks. So these are the values, and I should query the stock prices for ABC and XYZ on January 3rd and January 4th. So it understood the context. And now action is equal to SQL DB query and action input is equal to, this is the SQL query that it needs to execute. And again it is trying to calculate the ratio, and the next one is for the stock ticker XYZ, and then it is trying to get the ratio and then again multiplication, and finally it is trying to give us the answer, right? So that is how we can ask our agent by providing access to our LLM and also SQL database and execute the queries, right? So instead of this, you can try to replace with different questions and see if it is able to give us the desired output, right? So let's quickly see what we learned here. So the first thing is we installed all the required packages. Here we are using OpenAI as our LLM. So instead of OpenAI paid LLM, you can also use any other open source model as well. That is any model from Hugging Face, or you can also use Olama, right? And here we are trying to import different modules from LangChain and also SQLAlchemy. And here we loaded the environment variables from this environment file. So inside this we stored our OpenAI API key. So that is what we are trying to read, and then we assign that to OpenAI API key environment variable. So either you can set here or you can also pass here as well when you are initializing the OpenAI LLM, right? Here we defined a function called count underscore tokens. which will return us the total number of tokens spent. And here we are using the function called get underscore OpenAI callback to get the total number of tokens spent. And then we created the metadata object, and the next one is we created this table, and here we instantiated the stocks table with 4 columns: observation ID, stock ticker, price, and date. And the next one is we created our engine object. This is the SQLite. So SQLite is the open source relational database, right? And then we are trying to create the table by using create underscore all, and we are passing the engine object, and these are the column values we want for all our columns, the 4 columns, and we are trying to insert 10 different values. And again here we created a user defined function insert underscore observations, and for that we are passing the observations one by one here. So for each value we are trying to insert and then execute the statement. And here we are trying to create the SQL database object, and to that we are passing our engine object. Then the next one is we are using SQL database chain to bind our LLM to the SQL database, and purpose is equal to true to see the complete execution log. And once we have the chain, the next thing is we are trying to create the agent. For this agent we are setting the LLM, and we are also providing tool access, that is SQL database toolkit. And for this we are setting our database and also LLM, and purpose is equal to true. Agent type is equal to 0 short React description, so that is the agent type we are using, and max iterations. And then here we are trying to give a task to our agent so that it can perform by using the LLM and also toolkit access. So we are calling this user defined function count underscore tokens. Here we need to pass the agent and also the input query. So agent is whatever the agent we created, we are passing that, and also the query is what is the multiplication of the ratio between stock prices for ABC and XYZ in January 3rd and the ratio between the same stock prices on January 4th, right? So we are getting the result. So that is how you can create an agent and try to perform different database operations. And instead of this SQLite, you can try to connect to different databases like MySQL or Oracle, and try to execute different SQL operations and see if it is meeting your business requirement. Alright, thank you. So in this lecture, let's talk about Hugging Face. So what is Hugging Face? Hugging Face is the platform where the machine learning community collaborates on models, datasets, and applications. Okay, so this is the official Hugging Face website. We will go there and see how we can create an account and how to get the access token. And we will also implement these use cases by using the models from Hugging Face, and we will also learn other open source models like LM Studio and Olama. Okay, so first let me take you to this Hugging Face website. So this is the Hugging Face website. You can see here, this is the AI community building the future, the platform where the machine learning community collaborates on models, datasets, and applications. You can see here we have 1 million plus models available inside this Hugging Face. So where we can see these models? So you have to go here and click on models, and here you can see these many models are available inside Hugging Face. Okay, so these are all open source models. So we can use these models instead of paid models. For example, OpenAI or any other paid models. Instead of those models, you can use these open source models from Hugging Face, right? I will show you how to use these models, but before that, let's create Hugging Face account and see how we can get the access token. Okay, so once you are on the Hugging Face website, click on this sign up, and then let's confirm you are human, right? So click on begin and then try to answer these. Click all the clocks. Whatever the question they ask, just try to confirm, and then you will be navigated to this huggingface.co/join. Then you have to provide your email address and password and click next. Okay, and then it will ask you to complete your profile, where you have to provide your username and your full name, and if you want to upload any avatar, that is optional. And then there are few optionals, your Twitter username or GitHub username, and then your LinkedIn profile or your home page, or what are your AI and machine learning interests, right? So all these you can just enter if you want, but otherwise those are optional. And make sure you check the terms of service checkbox and then click on create account. Once you click on create account, then you will get an email to confirm your email address. So make sure you confirm it, okay? And then you will be able to log in and continue with your Hugging Face account. The instructions are pretty straightforward. You should be able to create a Hugging Face account, okay? So once you create the account, click on login, and then here enter your username and password and click on login, okay? So this is how it looks once you log into Hugging Face account. Once you log in, make sure you click on billing, and then here you can see access tokens, right? So click on this access tokens, and then here click on create new token, and then here provide any token name. You can give any name. So I am giving Hugging Face demo, and you can just leave these options by default and just click on create token, or you can select depending on your requirement. Okay, you can go through this and click on create token. So here you can see save your token value somewhere safe. You will not be able to see it again after you close this model. If you lose it, you will have to create a new one, right? So make sure you copy this token and then save it in your environment file or somewhere, right? Somewhere safe, right? Because you will not be able to get the same token again. So once you save this inside an environment file, you can access this token and make API calls from your project. Let me close this. So if you go to models, we have 1 million plus models, right? Remember, not all these models require access token. Access tokens are needed only by some models, and this is completely free, right? This is open source and it is completely free to use. You can use any model from this Hugging Face, right? And if you see here, we have 1 million plus open source models available inside Hugging Face, and this list keeps growing. And we don't need all these models, right? We can filter the models based on your task or requirement. Here you can see tasks, multimodal, computer vision, natural language processing, NLP, audio, tabular, reinforcement learning, and other, right? So depending on your requirement, you have to filter these models. So let me show you a few examples so you will be comfortable to use these models from Hugging Face based on your business requirements, okay? And you can easily explore all these other models that are available inside this Hugging Face. And you can see it's an ocean with tons of models, right? This is very easy. You just have to copy paste the code after selecting the right model depending on your task. For example, let's see, you want a NLP model, natural language processing. This is all about text, right? So let's say you want to do text classification. So let's click on text classification, and then here you can see we have 94,650 models available just for text classification. So you can pick any of these models if your task is to do text classification. And let's say if you want to do text summarization, then you have to click on summarization, and you can see we have 2,351 models available, right? Just for text summarization. And from here you can pick the model that fits your requirement. And here you can filter the models by trending, most likes, most downloads, recently created, recently updated, right? So you have different sorting options available, and by default it is sorting by trending. In general, we go either by trending or most downloads, and depending on your requirement, you try to choose the best model from here. And it's open source platform, so some models are maintained with very well proper documentation. So now let's see how to navigate and see the model, right? For example, let's select this model, Facebook Bart Large CNN model. Click on this. Once you click on the model, you can see model card, files and versions, and community. Inside this model card, you can see the model description and how to use this model. And you also have this GitHub link, right? So you can go and see the code as well, right? So now let's try to understand how to use this model. So if you notice here, we have the code available here. Here we are trying to import pipeline from transformers. So transformers is a very important component or wrapper of Hugging Face. This transformers will allow you to interact with the LLM. And this pipeline is a function of transformers, right? And you know transformers is for language models. So if you notice here, we have the copy option available. So you can just copy this code and make use of this code, right? So in order to use Hugging Face, the first thing is you need to install this transformers, and transformers has dependency on PyTorch. And once all the packages are installed, then you can use this model. If you notice here, the task is summarization, right? That is what we are trying to achieve here. And our objective is to summarize this text by using this Facebook BART model. Okay. So you can see the task as summarization and the model name. All these are parameters. And let's say if you want to try this model, you just have to click on copy and paste in your editor. Either Jupyter Notebook or VS Code, whatever the code editor that you are using, you can just copy paste there. And here we are asking the model to summarize this article. So let me click on copy, and then now let's go to VS Code and paste there and see if this code is working or not. Okay. So this is the build generative AI applications workspace that we have used before, and inside my C drive I have created Hugging Face demo empty folder. So now let me add this folder to the workspace. So right click, add folder to workspace, and here I'm selecting Hugging Face demo and click on add and click S. So you can see Hugging Face demo folder has been added to our build generative AI applications workspace. Now let's try to create a new Python file, and let's save this as, go to Hugging Face demo, and then let's try to save this as sentence summarization, right? So that is the task we are trying to perform by using the model from Hugging Face. So this is the code and this is the model that we are trying to use from Hugging Face. So let's click on copy, and then now let's go back to VS Code and paste this code. Okay, and now click on save. And if you notice here, this code is very simple, right? So let me remove this output. And what we are doing here, from transformers module, we are trying to import pipeline function, right? So you can see all the parameters that are available inside this pipeline function. And the first one is task. So for the task, we are passing summarization. And for the model, we are using Facebook BART large CNN model. And rest of the parameters you can pass depending on your requirement. So let me use word wrap so you can see the entire article here, right? So this is the entire article that we have, and this is what we are trying to summarize by using this model. And we are trying to print that here, and we are using the summarizer, and we are passing article, and the maximum length that we want is 130 and minimum length is at least 30. Okay, so let's try to click on run. So before we try to use the pipeline, first thing is we have to install transformers, right? So make sure you install transformers by using pip install transformers. Okay, so now let's rerun the code. Okay, so now you can see this is the summarized text. So we are able to use the model from Hugging Face and we are able to summarize the text, right? So let me close this. So what we did here, before we import, make sure first you install the required package, right? So we have to install this transformers module before we try to import this pipeline function, right? And once you import this, we are passing the task as summarization and model as Facebook BART large CNN, And this is the article. Here, instead of this article, you can try to replace with any other content and then see if you are able to summarize or not, right? And here it is trying to use CPU, and instead of this CPU you can enable GPU and try there, right? Some models are memory intensive, so for learning purpose you can try to use small model and see if it is working on your machine, right? So you can see Hugging Face is very easy to use, right? And as per your need, you have to pick the right model and make use of the code. And if any code is deprecated, then you may have to upgrade your package version, that is transformers or PyTorch, right? And update your code accordingly. So now let me take you back to the Hugging Face website, and you can try exploring these different other models and see if it meets your requirement, right? And let me show you one other example. Let's say you want to convert text to image, right? So we have text to image option inside computer vision, right? So click on text to image, and if you see here we have around 76k models available just for text to image, right? And for example, let's say if you want to use any of these models, by default it is sorting by trending, right? So click on this model, and here you can see the model card, right? So it will explain what this model is about, what are the key features and how to use this model, and what are the API endpoints. And for this you have to install diffusers first in order to use this code. So like we saw before, you just have to click on copy and go to your editor and paste this code, and see if you are able to convert this text to image, right? And sometimes you may get memory errors also. Let's say if your machine doesn't have enough memory, then you might end up getting memory errors. So in that case, try to pick the small models and experiment, right? So now you understood how to pick the model depending on your requirement, right? Because for some organizations, security matters a lot, right? For example, healthcare or financial domains. In that case, paid models may not work. OpenAI or Claude Anthropic, right? So you can try to pick any open source model from this Hugging Face in that case. And these models are free to use, and you can implement your business logic by picking any of these models, right? So when using open source, think about accuracy, cost, and security. And then you have to pick your right model that meets your business requirement, right? So now you get the idea, right? How to pick a right model that meets your task. So depending on your task, you have to pick the model and try to experiment and see if it meets your requirement, right? And let's say if you want to do any courses, you can click on learn, and here you can see these are the free courses available, right? So you can explore more if you're interested. Okay. So let's quickly review what we learned so far. We understood what is Hugging Face and why we use Hugging Face, right? And how to create a Hugging Face account. And then we learned about how to get the access token from Hugging Face, right? And then we understood how to navigate around Hugging Face models and pick the right model depending on our requirement. And we also saw how to access the code from Hugging Face, and we executed text summarization scenario, and we were able to summarize the text, right? And we will see these remaining use cases in the coming lectures. Okay. So far we understood what is Hugging Face and how to create Hugging Face account and how to get the access token. And not all the models require access token to use. Only some of the models require access token. So depending on your model, you have to see if you need this access token or not. And we have also seen how to summarize a text by using the model from Hugging Face, right? Now let's see another use case, that is image understanding. That is, we will provide an image to the model and we will ask the model to explain us about the image, right? So that is image understanding project. So let's go to VS Code and see how we can implement image understanding, right? So let me go to VS Code, and inside our Hugging Face demo, let's click on file, new Python file, and let's save this as image understanding. the first thing is make sure you install transformers in case if you haven't installed already, right? Because we will be importing the functions that are available inside this transformers. Make sure you install that in case if you haven't installed already. So the first thing is, let's try to import all the required modules. That is, we are trying to import this request. This module is for request HTTP library, and then image from PIL, which is nothing but Python image library, right? And then we are trying to import blip processor class from transformers. So you can see the description here. And in case if you want to learn more about these classes, you can go to the documentation and try to explore more, right? So this is the constructs a blip processor, which wraps a BERT tokenizer and blip image processor into a single processor. So that is the intent of using blip processor. And then blip for question answering, right? Again, this is from transformers. So we are trying to import these two from transformers. And then the next step is, by using this blip processor, inside that we have a function called from underscore pre-trained. So let's use that. We will get the processor, and now let's try to get the model too. So this is the model that we will be using from blip for question answering, and inside that we have a method called from underscore pre-train, and we are using the model Salesforce blip VQA base. This is the model that we are using for image understanding, right? And let's say we have an image. So this is the image that we are using from Google APIs, right? So let's try to use this image and try to understand this image. So let's store that image inside image underscore URL variable, right? And now by using this image, let's try to open the image. So here we are using request dot get, and we are passing the image URL and stream is equal to true and convert RGB, right? So we will get the raw image, and once we get the image, we can try to ask different questions and see if this model is able to answer or not. So let's try to ask the question. So this is the image, right? So now let's try to ask, what is the color of the dog, right? So our question is, what is the color of the dog? And we already got the processor. So we are passing the image, and then what is the question? And now inside the model, we have a method called generate, overrides generate function to be able to use the model as a conditional generator, right? So here you are passing the input and we are trying to get the output, right? So now let's try to print the output and see if you are able to get the answer. Okay, so print processor dot decode, and we are trying to read the output value. So let's try to save this code and run the code and see if it is working. So here you can see 10, right? So it is able to give us the answer for what is the color of the dog, right? So the dog color is 10. So the model was able to understand our question and it is able to give us the answer 10, right? Now let's try to ask another question. What is the color of this girl's shirt, right? Copy this same code, and instead of color of the dog, let's try to ask what is the color of the girl's shirt, right? So let me replace this question with what is the color of the girl's shirt, and then again for processor we are setting the raw image and the question that we are asking, and we are getting the output, and once we get the output we are trying to print it, right? So let me save it and rerun the code. So now you can see it is able to answer plate, right? So that is the color of the girl's shirt, and this is the color of the dog, right? So let me close this. So instead of this image, you try to replace with something else and see if the model is able to answer the questions or not, right? And where is this useful? for example, let's say if you want to buy the same color watch. Let's say if your friend has this watch, and if you want the same color watch that your friend has, so take a picture and upload it to the model, and the model will understand the image and it will provide the recommendations for you to buy, right? So maybe a similar watch or an exact watch, right? So first the model should understand what is this image that we are uploading, and the image will be converted to text, and from that text the model will go to the vector and then search, and it will retrieve the answers for us, right? So instead of these questions, you can try to ask different questions. The model will predict the answers. For example, color of dog or color of girl's hair, right? And for example, let's say if you're not satisfied with this model's results, then you can always go to Hugging Face and try to explore different models and try to implement and see if it is meeting your requirement, right? And all these models are pre-trained models. If you want to know more about these blip models, you can go to Google and type blip model. So let me take you there. So this is the official documentation of blip models, right? So if you want to understand the model's architecture, how it was implemented, so you can see this is again transformers. You already know the transformers architecture: self-attention, feed forward, and the image encoder. And again here we're asking what is the dog wearing, and you can see cross attention, and then how it is finally generating the answer, right? So you can try to see the code behind this and try to understand how it is implemented, right? So all these are pre-trained models. Okay, so now you understood how we are providing an image to a model, and then we are asking different questions, and how the model is able to answer for these different questions. So the model understood the image and then it is able to answer the questions for us, right? So what we did here, first thing is we imported all the required modules. This is the model that we are using here, and this is the URL. Instead of these models and URL, you can try to replace with something else and see if it is working or not, right? And then here first thing is we are trying to get the image, and here we are framing the question, and then we are passing the raw image that we got here, and then we are trying to get the output, right? And here we are trying to print it. So similarly for the second question, right? So this is how you can try to understand the image, right? So that is, we are providing the image to the model, and then the model will try to interpret the image and answer the questions that we ask about that image. Okay, thank you. So far we understood what is Hugging Face and how to use different models that are available inside Hugging Face, and how to create an account, and then how to get the access token. And we also saw sentence summarization, that is how to summarize a text by using the model from Hugging Face. And also we understood image understanding, that is we provided an image to the model, and then we asked different questions to the model, and the model was able to understand the image and answer the questions about that image, right? And then now let's see how to build the sentence translation pipeline using transformers library, right? That is, we will provide a sentence to the model, and then the model will translate the sentence to different languages. Okay, so let's go to VS Code and let's see how we can build the sentence translation pipeline using transformers library. So let's go to Hugging Face demo, file, new file, Python file, and let's save this as sentence translation and click save. So like we did before, in case if you haven't installed already, make sure you install this transformer package. And once you install the required packages, the first thing is, let's try to use the code that will suppress the warning messages. Inside the transformers utils, we are trying to import the logging, and then we are trying to set the error level here. So that will suppress the warning messages. Now let's try to build the translation pipeline using transformers library. So first thing is, let's try to import the pipeline from transformers. So this is the function from transformers, right? So we also have to import torch. So here you can see the description. The torch package contains data structures for multidimensional tensors and defines mathematical operations over these tensors. And then let's try to define the model that we will be using. By using this pipeline function, here we are defining the task as the translation, and the model is Facebook model. This is the model that we are using, and the torch data we are setting to float, right? So that is how we define the translator. So here what we are doing, we are trying to load this model, that is NLLB, that is no language left behind. And if you want to learn more about this model, this is the model description, right? So you can go to Hugging Face and go to that model. So here you can see the model card, and this will explain you the complete description of this model, right? And you can click on files and versions. This will take you to the code in case if you want to explore more, right? So let's try to define the input text which we want to translate. My puppy is adorable. Your kitten is cute. Her panda is friendly. His llama is thoughtful. We all have nice pets, right? So this is the text that we want to translate to different language. Okay. Now let's try to translate this English text to Spanish. Here we are giving the source language as English and the target language as Spanish, right? And we are passing that to the translator, whatever the input text, and then the source language and the target language. And then now let's try to print this translated output. So let's save this code and run the code and see if this is working. So you can see the translated text is, this is the Spanish text. Whatever the text that we have given in English, it is able to convert to Spanish, right? And in case if you want to translate to different languages, so they have provided the documentation here. You can see the README file, and these are the different languages, right? What is the language and what is the code that we have to use, right? We have seen Spanish, right? So for Spanish, SPA_LATN. And similarly, depending on your requirement, you can try to convert English to different languages, right? So there are tons of languages supported by this model, right? So depending on your requirement, you try to change this target language, right? So what we did here, the first thing is we install the required package, and then here we are just trying to suppress the warning messages. And then we imported pipeline from transformers and also torch. And the next thing is we created the translator by using this pipeline. The task is translation, and this is the model that we are using. And the torch D type is float. And this is our input text. This is the text that we want to convert to Spanish. So we are using the translator and we are passing the input text, source language and the target language. And then the model is able to convert this English text to Spanish, right? And in case if you have to change to different language, you can change this target language and see if you are able to convert this text to different languages, right? Whenever you use any model, the problem is it uses the memory, right? So try releasing the memory so you can load other models, right? In order to have enough free memory, let's try to import the garbage collector, and then let's try to delete this translator, and then let's call the function from garbage collector, right? So this will run the garbage collector and it will free up the memory. So that way you will get free memory and you can run remaining models. So this is how you can clear the memory. All right. Thank you. So far we learned what is Hugging Face and what are the different models that are available inside Hugging Face, and how to create an account and how to get the access token. And also we have seen these use cases: sentence summarization, image understanding, and how to build the sentence translation pipeline using transformers library. And now let's see another sentence summarization pipeline using transformers library. Okay, so let's go to VS Code. We have already seen sentence summarization, so let's do one other project. So file, new file, Python file, and let's save this as sentence summarization 2. So the first thing is make sure you install the transformers package in case if you haven't installed already. And then let's try to import this pipeline from transformers and also torch module, right? And now by using this pipeline function, let's pass the values for task as summarization And the model that we are using is Facebook BART large CNN, and torch D type is equal to float. And now if you want to know more about this model, so let me take you there. So we have already used this model, and we have implemented this sentence summarization, right? So this is the same model again we are using. Okay, so let's prepare the input text that you want to summarize. So this is our input text. We want to summarize this text by using pipeline function, which is from transformers, right? So we already know we have a summarizer function. For this we are passing our input text, and we want minimum length at least 10 and maximum length 100, right? So this summarizer will summarize this text. So let's print the summary, and now let's run the code and see. Okay, so the model is able to summarize this text. So the device is set to use CPU, but in case if you want to use GPU, you can change it and rerun the code. Okay, so what we have done here, we install the transformers package, and once we install the package, we are trying to import pipeline function from transformers and then torch. The first thing is we are using this pipeline function, and we are setting the task, model, and torch D type. And then this is the input text that we want to summarize, and we are using the summarizer function, and we are setting the input text and what is the minimum length and maximum length that we want to summarize this text, and we are trying to print the summarized text, right? So this is how you can build the summarization pipeline by using transformers library. All right, thank you. So far we learned what is Hugging Face and how to access different models that are available inside Hugging Face, and how to create an Hugging Face account, and how to get the access token. And we have also seen these use cases, how to do the sentence summarization, and how to understand the image, and how to build a sentence translation pipeline using transformers library. And we have also seen another sentence summarization project by using transformers library, right? Now let's see how to do sentence embeddings by using an embeddings model from Hugging Face. Okay, so let's go to VS Code. Instead of VS Code, you can use any other editor as well. So click on Hugging Face demo, file, new file, Python file, and let's save this as sentence embeddings and click on save. Okay, so you know embeddings is converting to numbers. We know LLM cannot understand text, so we convert into embeddings. We have seen how to use embeddings model to create embeddings in our previous lectures, right? For example, when we implemented the RAG application, we have used Hugging Face embeddings, right? So by using these embeddings, we have created the embeddings, and we used this model. Okay, so let's come back to our project, and there are already a ton of models available inside Hugging Face. Let me take you to the model that we will be using. So this is the model that we will be using to create the sentence embeddings. Okay, so this is the model card. In case if you want to explore more, you can come here and see the detailed description. Okay, how it was pre-trained, fine-tuning, and what are the hyperparameters, and what is the training data, and everything is documented here, right? So the first thing is make sure you install this sentence transformers. Okay, in case if you haven't installed already, make sure you install this sentence transformer. And then here we are using logging module from transformers utils. So by using this, we are trying to suppress the warning messages, right? We are setting the level as error. And now let me try to import this sentence transformer class from sentence transformers module, right? We have already installed this sentence transformers. In case if you haven't installed already, copy this and go to the terminal and paste this and click enter. So that way you will be able to install this package, right? And the model that we will be using is all mini LM L6 V2, right? So this is the sentence transformer model. And now let's define a sentence that we want to create embeddings. Okay, so here we are taking a list. The cat sits outside, a man is playing guitar, the movies are awesome. So this is a list of 3 sentences, right? And now let's create the embeddings. Inside this sentence transformer, we have a function called encode. So we are calling this function and we are passing the sentence that we want to create the embeddings for, and then we are setting this parameter to true, right? So let's try to print these embeddings. So let me close this here. So let's see if this code is working so far. So let's try to run the code and see. Okay, so it is able to create the embeddings. Now let's try to define one other sentence. So this is sentences 2. This is a list of sentences again. The dog plays in the garden. A woman watches TV. The new movie is so great, right? So again we created another sentence list. Now let's try to call the encode function to create the embeddings, right? So again we are calling this function and passing the second sentence list. Okay, now let's try to print this embeddings too. Okay, so we have created this sentence list embeddings and then second sentences list embedding. So we have created these embeddings so far. Now we need to calculate the cosine similarity between these 2 sentences list as a measure of how they are similar to each other, right? So we converted the sentences to embeddings and now we want to understand which sentence is similar to which other sentence. So in order to understand the sentence similarity, we need to use cosine scores. Okay, so let's try to import util from sentence transformers, and inside this util we have a function called cos_sim, right? So this is the cosine similarity function. You can see the description here. It will compute the cosine similarity between 2 tensors, right? So we have tensor 1 and tensor 2. Now we are trying to compute the cosine similarity between these 2 tensors, right? So once you got the cosine score, let me try to print this cosine scores so we can see in the terminal, and then let's try to loop through. So here we are trying to get the length of sentence 1 list, and then we are trying to loop through and then trying to get the cosine score, that is first sentence from sentence 1 and then first sentence from sentence 2 list, and we are trying to get the similarity score, that is cosine score, right? So that is the cat sits outside and the dog plays in the garden. What is the similarity between these 2 sentences? And then similarly, what is the similarity between this and this sentence, and the similarity between this and this sentence, right? By using this cosine similarity function, we are trying to compute the similarity between these 2 sentences, and then we are trying to print the score here, right? So let's save this code and then let's rerun the code. So you can see the output here. The cat sits outside, the dog plays in the garden. What is the score here? 28, right? And a man is playing guitar, a woman watches TV. It is 3, right? And the movies are awesome. The new movie is so great. These 2 have highest score, that is 65. So that means these 2 sentences are similar to each other. So that's why we got the highest score here, right? Instead of these 2 sentences, you can try to replace with different other sentences and see if you are able to get the similarities or not, right? So let's quickly review what we learned here. The first thing is we installed sentence transformers. So make sure you install this in case if you haven't installed already. And then here we are trying to suppress the warnings, and we imported this sentence transformer class from sentence transformers module, and then util from sentence transformers. And here we are using this sentence transformer model, and here we define the first sentence list, and we are creating the embeddings by calling the function encode from sentence transformer, right? And then here we are trying to print the embeddings. And then here we are defining the second sentence list. And again, we are calling the encode function from sentence transformers. And then we are creating the embeddings. So we are trying to print the embeddings. And then here we are trying to compute the cosine similarity between embeddings 1 and an embeddings 2, right? And here we are trying to print the cosine scores. And here we are trying to print cosine score between these two sentences. That is the first sentence from sentence 1 and first sentence from sentence 2. What is the cosine score between these two sentences, right? So similarly for the rest of the sentences. And we saw the movies are awesome, the new movie is so great. These two have the highest cosine score. So that means these two are similar to each other, right? So this is how you can calculate the sentence embeddings and then use this cosine similarity function to calculate the cosine similarity between two tensors, right? So now you get the idea. We have seen different use cases, that is how to summarize the sentence and how to translate a sentence, how to create the sentence embeddings, how to understand the image by using different models from Hugging Face. Now you can explore more because all these models from Hugging Face are open source. So depending on your requirement, you select the model and try to experiment and see if it is meeting your requirement. Okay. So you can see we have 1 million plus open source models available inside this Hugging Face. We have seen few models and now you can explore more and see if these models are able to satisfy your requirement, right? So depending on your task, you try to sort these models and pick the right model and see, right? And we have the data sets also available here. So in case if you want to experiment any of these data sets, you can use them. And we also have spaces. So if you go here, you can host your own developed model if you want to contribute and make it available to others, right? So you can come here and try to upload those inside this spaces. And once it is deployed, then others can make use of your model, right? So this is the place if you want to contribute your own developed model, right? You can click on new space and then you can make it available to everybody. And we also have the docs. So here you can go through different documentations and we have enterprise and pricing. So that's all about Hugging Face. So now you get the idea. That is how to pick a right model depending on the task that we are implementing and how to implement the code from Hugging Face and how to read the model description and how to see the code, right? So that's all about Hugging Face. All right. Thank you.